Hi there, welcome to Simplilearn's YouTube channel. In today's technology landscapes, Python has become one of the most popular and versatile programming languages. Its simplicity and readability makes it beginner-friendly, while its powerful libraries and frameworks make it suitable for building everything from web applications to AI-driven systems. In this complete Python developer course, you will learn how to build applications from scratch using Python. We will begin with fundamentals of programming and gradually move into advanced concepts such as object-oriented programming, file handling, error handling, and working with libraries. As you progress, you will also explore web development using framework, working with databases, and building real-world applications. This course is designed to provide both strong conceptual understanding and practical experience. By the end of this course, you will have a strong understanding of Python programming and skills required to become a Python developer. Whether you're a beginner starting your coding journey or a professional looking to transition into software development, this course will give you the knowledge and confidence to succeed. Having said that, let's take a look at today's agenda for this course. We will start off with Module 1, which is Introduction to Python and Programming Basics. Module 2 is Setting up Python Environment and Tools. Module 3 is Variables, Data Types, and Operators. Module 4 is Control Flow, Loops, and Conditional Statements. Module 5 is Functions and Modules. Module 6 is Object-Oriented Programming in Python. Module 7 is File Handling and Exception Handling. Module 8 is Working with Python libraries like NumPy, Pandas, Basics. Module 9 is Data Structures in Python like list, tuple, sets, and dictionaries. Module 10 is Working with APIs and JSON data. Module 11 is Web Development with Flask or Django Basics. Module 12 is Database Connectivity with Python along with SQL Basics. Module 13 is Building Real-World Python Projects. Module 14 is Python Interview Questions and Answers. Hope I made myself clear with this agenda. That's it. If these are the type of videos you'd like to watch, then hit that subscribe button with the bell icon to get notified whenever we host. Also, just so that you know, if you want to upskill yourself, master data science and data analytics skills, and land your dream job or even grow in your career, then you must explore Simplilearn's cohort of various data science and data analytics program. Simplilearn offers a variety of master's, certification, and postgraduate programs in collaboration with some of the world's leading universities. Through our courses, you will gain knowledge and work-ready expertise in skills like Python, Tableau, Power BI, Generative AI, and over a dozen others. And that's not all, you'll also get an opportunity to work on multiple projects led by industry experts working on top-tier data and product companies. After completing these courses, thousands of learners have transitioned into data science or data analytics roles as a fresher or moved on to a higher-paying job and profile. If you're passionate about making your career in this field, then make sure to check out the link in the pinned comments and in the description box to find the data science and data analytics program that fits your experience and areas of interest. So let's get started with our Python developer full course with a small quiz. Which keyword is used to define a function in Python? Is it option A, function, option B, def, option C, func, and option D, define? Please let us know your answers in the comment section below. Now over to our training experts.
So guys, let us try to install Python. So for this tutorial, I'm using Windows as operating system to install Python. Go to the official website of Python and you can see Python downloads will be there. Just click all over here and you will be directed to this URL. Now click on download Python install manager and you can see this is going to get downloaded. After this, click on all over here and let's maximize this. So guys, since I have already installed Python, so it's showing me reinstall Python, but for you, it is going to show install Python. So you have to click all over here. Since I won't be doing it, so I'll be directly launching my Python. Now you can see you're going to get some terminal like this. So you can click on yes and start it. But I won't be doing it because I have already installed Python. And the next step that you need to do is go to your given command prompt. And here you need to type Python-version. And you can see all over here, you're going to get the required Python version. Now guys, I hope so you have got a brief idea like how we have installed Python. Now let us try to run some of the given code in Python. Now for running the given Python code, I would suggest you to install PyCharm, which is an amazing IDE for the Python based projects. So go all over here and type PyCharm download. and this is powered by JetBrains. So all you can do all over here, click on download. So accept all, click on download, and it is going to be downloaded for you. Very amazing IDE, guys. Do try this out and let us know how do you feel about this IDE in the comment section. Now guys, let us create one folder all over here. Click this folder and let's say it's a Python folder. So Python demo you can type. Okay. Now open this folder and let us try to create one file. Let's go to new and create a file. And you can give this name as a hello.py. Okay. Now open this given file in the terminal. So now guys, after that you need to type python hello.py. So we have created hello world from the command prompt only. Now just click all over here and you are going to see a hello world.
We can start by having a quick walk around of how to install Python. So I've already got the Python installed, but in case if you're new to this, then you can just pause the video and go to this link where you will understand how to download Python. But also I'll also give you a quick briefing. You can just navigate to python.org, and here you can just download Python and get it installed. And then we have another option as well. So we can also install Anaconda. And if you just download and just go through the basic protocols and recommended settings by Anaconda, you'll have everything installed in your PC. You can also check in every other box that the installer shows you. You can add the Python path file to your environment variables, etc. And you'll have a quick briefing in the tutorial I've linked in the description box below. So once Python is installed, you can just open up or fire up Anaconda or Jupyter Notebook, or you can also go with PyCharm, any of the online compilers, or any of the IDE which is comfortable for you to use Python. So I'm going with the Jupyter Notebook here. So I've already got the entire workbook on this particular Python tutorial. So we'll be going stage by stage or module by module. So let me quickly fire up a new terminal or a new notebook, and I'll name it as select kernel, and I'll name it as Python basics, so that we can execute each and every command in our modules here, stage by stage. And for safe side, I've also got this code saved in my notebook as well, notepad as well, so you can run them. So let's begin with the basics. So here I'll execute this particular one. So Python is one of the most popular programming languages for software development, AI, machine learning, all those things. And we can quickly start. You can just command these anyways. I missed to command them. There you go, with the basics having. So now we will start with module 1. So here you have two sections, code and markdown. So I'll enter markdown. So wherever I have some module headings or titles, I'll use this particular section as a markdown, and then we'll switch to code. So if you are familiar with any of the basic programming languages like C or C++, then you already know you have a lot of boilerplate code. Like you might have to import the studio.io input-output operations or any of the extra libraries that you need. But in this case, the syntax is really simple. Let's say I want to print something like welcome to Simplilearn, and done. That's all. You will get the code executed. So it's just a basic understanding of how simple the syntax of Python is. Now we will dive into the next module where we'll understand the fundamentals like data types and all those things. So we'll quickly switch to module 2, and I'll like to place the same code here, and I'll name it as data types variables, and I'll deem it as markdown and execute the code. Now let's start with the first data type, which is integer. So I'll call it as roll number is equals to 10, and the next would be I can give float, it is equals to 57, and the next can be a name, which could be a string type, and it would be Alice. Is student, this could be a boolean, and I'll name it as true. There you go. So we have created a profile for a candidate, and now let's say I want to check the data type, and it's really simple. You can just print of and the variable names. So I've got roll number here, I've got height, and I've got name, and also a boolean value which says a student or not. Let's quickly run this cell, and there you go. So you have integer, float, string, and boolean. So just like any other programming language, Python also supports a wide variety of data types. So these are the basic data types and variables that you will be coming across in Python programming. And now let's proceed with some naming conventions. So naming convention, basic or best practices. So try to avoid any blank spaces in variables. So whenever you're naming a variable, try to avoid any of the blank spaces. You can take an example of student underscore name in place of student name, right? So this avoids a lot of confusion if you're dealing with the data frames or any of the real-time analytics or any of the real-time programming situations. Now that we have a basic understanding of the data types, variables, and the best practices, we can now dive into the third module, which will be about the data structures in Python, or data collections as well. And here we will be having all those collections, which will be the set, tuple, and all those things. We can start with list. So what is a list? So list is an ordered set of elements or collection of elements of different data types or unique data types as well, unique or similar data types. For example, let's say I want to create a list of fruits, and it will start with a square bracket. Remember the square bracket. So apple, orange. Now I want to print fruits. Now let's understand something. So we have four different collections here. We have list, we have a set, we have dictionary, and we have a tuple. So all of these will have similarities, but they also differ in few situations. Now a list and a set are similar. They also are capable of storing different data types and all those things, right? Let's say I want to include a collection of data types like name, which is a character data type or a string data type, and then I want to include the float data type, which could be 10 point with decimal value, and then I want to include roll number, which could be an integer. They all store all those things. Now how they differ is the type of execution in the end. Let's say I entered some fruit names here, apple, orange, grapes, etc. And if I want to append a new name, I can also append a new name. If I want to delete something, I can delete something. And when I print, it stores the order. Let's say I entered apple in the first place. So apple will be coming in the first place, orange in the first place, and grapes in the first place. This happens in list. But when you come across set, that particular order cannot be executed. It might miss the order. It might go with orange in the first place or grapes in the first place, and then comes the next, the names. And when it comes to set, let's say I have a duplicated element here. Let's say I type apple for 2 times, apple, apple, orange, grapes. The set will not print apple twice. It will only print it once. Now, this is one peculiar difference between a set and a list. And when it comes to tuple, tuple is also same. It can also store different data types in one particular tuple. But the problem is tuple will not allow you to change anything. It is immutable. Now, this is the second difference. Both set and list are mutable, but tuple is not mutable. You might also face an interview question where an interviewer will ask you to change something in a tuple, which can be done with a little trick. So that's have it executed using the inclusion of list inside a tuple. So this is possible. Tuple will include a list inside itself, and vice versa. A list can also include a tuple in itself. So we'll go through all those things. Now, first we have created a small list with names apple, orange, and grapes, and we are able to print that particular list here. And we can also go through some simple operations. Let's say I want to append mango to this particular list. So I can simply use it as fruits append function, and the name of the fruit that I want to add will be mango. There you go. And I'll execute this. Now let's say I want to print fruits again. There you go. I have mango added to this particular list. And now let's say I want to remove something. So I'll simply use fruits dot remove function. And let's say I want to remove grapes. So I'll type down grapes, close the function, execute this. And now let's say I want to print again. There you go. So we have successfully removed grapes. Now this was the basic fundamental operation of adding or removing any element from a list. Now let's go through another example where we try to store different types of elements. Let's say I want to go ahead with Alice example once again here. Alice is the string type, and let's say her height is 5.7 feet and her roll number is 10. And is she a student? Yes. There you go. Close the list. And now I want to print the items here. So you can just casually print items, and there you go. Now let's say I want to also understand the data types here. So I can just use the same print command, print type. And since we're using list here, so I can go ahead with items, which is the list name, and I can give the cell address. There you go. And we can also make some modifications to it. So it's quite understandable. So the cell address 0 represents the first element in the list, 1 will be the second element, second will be the third element, and third will be the fourth element. So the addresses start from 0 in list, and when we execute, we can understand it can also store string, float, integer, and boolean data types in one single list. So now let me give out a single clue to you to understand list. So it might also be an interview question for you in future. They can just give you an input and say, identify if it is a list or tuple or a set or a dictionary. Then if you see the array or any data type, data structure starting with a square bracket, then understand it's a list. Now, so far with our understanding, let's give a quick definition to list. So I have mentioned the definitions here. Let's quickly enter them here as well. So a list is a heterogeneous data structure, meaning it can store multiple data types, such as integers, floats, strings, and booleans within the same list. Although Python allows mixed data types, in real applications, developers usually keep list constraints for better readability and processing. Let's say in real time you're using list, then most recommended best practice is use a single data type so that you may not face any confusions with that. Now with that, let's move on to tuples. So I'll mark it down as module 3. Here the list, and now here we'll start with tuple. Now let's start with the second data structure here, which is tuple. So to define, a tuple is an ordered collection of elements, but it is not changeable, or you can also term it as immutable, and it is completely similar to list, but there are some differences. If you want to add a new element to an existing tuple, you may not. And if you want to delete something from an existing tuple, you may not. And if you want to make any kind of modifications to it, you cannot. That's the difference with separates tuples from list or any other data structure in the upcoming modules. Now, another best way to identify if it is tuple or not is it will always start with an open bracket or parenthesis and closes with a parenthesis. Now, swapping elements, inserting any elements, removing, reordering is not possible in this particular data structure. And you can also use any type of append or delete operations. Now, let's go with the same example. Let's say I want to add fruits. So the only different what happens here is you can just change the type of bracket, and there you go. Now it's a tuple. Now let's say I want to print this particular tuple, and there you go. It retains the order as well. Now apart from that, let's say I want to add different data types inside a tuple. I can also do that, and I can also type to repeat, and I can also try to extract the data types as well. Now remember that interview question that we discussed, changing an element inside a tuple? It is possible when you try to include a list inside the tuple. So let's go through an example of that as well. I will take an example of the same list that we have here, or we can also create a new variable IQ, which is interview question, or a question is equals to, let's say I try to enter some elements 1, 2, 3, and the last element will be a list. Let's say I want to enter 4 and 5 inside the list and close the bracket. Now let's print the question, and now you have the tuple printed. Now let's say I want to change one of the element inside this particular tuple, which is inside a list. Let's say I want to change 4, 5 to 5, 6. Now what you can do is you can simply type down the same question here, and you can say question. Remember the cell addressing that we did here, this particular one. the same, we can try to address the elements here. So we have the 1, 2, 3, right? The third element is 4, 5. So it starts from 0. I want to allocate this particular list with 3, 0 is equals to, let's say, 6. And now if I print this particular question, then I have 6, right? So there you go. We have now successfully changed the element inside a tuple. Now we can proceed with our next data type, which would be a set. Now let's quickly go through the definition of a set. Now, so far we have understood what a tuple is and what a list is. Now, to understand set, you might have to go through the similarities that we had with list first, right? So the only difference what separates a list and a set is the type of parenthesis we use. So here, or the bracket we use. In the list, we used a square bracket. In tuples, we used a rounded bracket. In the set, we will use a flower bracket. That's the only difference. And apart from that, if you want to include any kind of duplications inside a set, that is not possible. So for that, let me go through an example. Let's say I want to create a new set here, and the set could be named as numbers is equals to, and it starts with a flower bracket, 1, comma 2, comma 2, comma 3, comma 3. See, I'm deliberately trying to enter some duplicate entries here. Now, let's say I want to print numbers. So these particular duplicate entries will be eliminated, and only the unique values will be printed inside the set. Now I can also go through the same example that we used before, which is this one, fruit's name. And if I want to print fruits, sometimes the order may exist and sometimes the order may change. That's the difference between a list and a tuple. The orders might change here. So you can see grapes took the first position, orange to the second, and apple to the third. And if you want to add or remove any elements to this particular fruits set, you can also do that by a simple add method. Let's say I want to add some berries. There you go. If I print fruits again, I will have the new element added. Let's say I want to remove an element, so I can also do that by just using the remove method or remove function. And let's say I want to remove apple, I can do that. And if I print fruits again, the element will be removed from the list. With that, let me also drop a quick comment here. The best way to identify a set is it always starts with a flower bracket. Now, a set will also be capable of storing multiple data types as well. So we'll use the same example. And here we have two different items, but it is showing one once because it is considering the integer value of 1 as a unique element and the float value of 1 as a duplicate element of 1, including the Boolean value of true here. That's the one reason why we just get 1 repeated once and the name is shown once, right? That's the reason why we have it here. But in case if you really want to find out the data types of all elements here, you can just go through a for loop here, and here you have the 1 value which is integer, name value as string, 1.5 which is the class, and this particular one is called as float here. And with that, now we enter into the fourth collection or data type, which is dictionary in Python. So dictionary is nothing but a key value pair. Let's say you wanted to store some elements inside a dictionary. The only difference which separates dictionary from all the other three data types is it stores the elements in a key value pair. Now let's go through the examples for that as well. Before that, let me add up the definition. This is the definition. Dictionary stores data in key value pairs. A dictionary is ordered in modern Python versions. It is changeable. It stores data as key value pairs and keys must be unique, which means you cannot use one key for different type of elements. Let's say I try to add a key name as ABC and I store some value inside it. And again, I reuse the same ABC key and store a different value in it. Here, what happens is Python will save the latest entry into ABC and it will remove or eliminate the previous entry. You can also go through that example, no worry. Now let's create a new dictionary as student. And here I'll use name of the student. We can use the same name, which is Alice. and let's say age is equals to 20. Let's add a course for Alice, which could be Python. And now you can close the dictionary. Since it is key value pairs, we were supposed to use colon, not equals to. And we need to separate them by comma. There you go. Now let's print student. There you go. Now we can make some mild changes to this particular code segment and try to identify the data type as well. Now let's go through this particular element, which is defines the dictionary as changeable. So I'll use the same code segment and I'll try to change the name or course of Alice. Let's say I want to change the course from Python to data science. So we have successfully changed the course name from Python to data science. And now if I print student again, the course will be changed here. Now let's say I want to add a new element to this particular dictionary. Let's say I want to add the location. So student. So I've added a new element to this particular dictionary, which is location of Alice. Now let's try to print student details. And now we have the city name, New York. And now let's say I want to remove an element. So I can use simply the delete command. I can simply use the delete command and the element that I want to remove. We can remove the city, which we have recently added. And then now there you go. So city was not included in this particular code segment. So that's why I did not recognize. Now let's say if I want to print student once again, there you go. City has been successfully eliminated. Now let's discuss about the duplication of keys. Let's say I try to store data, or I'll name it as duplication, create a set, create a dictionary, and then I'll use name is equals to XYZ. Similarly, I'll try to reuse the same code segment. I'll create a duplicate entry and name it as ABC, close the list. And now let's say I want to print, yeah, we missed a comma. Let's say I want to print this particular dictionary. Now what happens is it will save the latest entry alone, not the previous entry. Now that we are done with the data structures or collections in Python, which were set, list, and dictionaries and tuples, we can now dive into the string operations so we can understand string data structures in a much better way. Let's start with some most commonly asked interview questions like string slicing or string matching, etc. Such type of examples will help us understand what is the basic functionality of strings and how to implement them in real time. So we can start with string functions or strings from here. So let's say I want to concatenate two strings. Let's say I have two strings here and I want to combine those two strings. Now let me give the string first one as first name. Remember the declaration best practices that we discussed, right? So we will have the underscore separating the variable names so that we don't have any blank space, or you can also go with this type of representation, but I'd like to go with this one. So first name, let's say we will give John, and second name is equals to Pranav. Now let's say I want to combine this together and save it in a new variable which says full name. So what I could do is I'll just copy this and I'll paste this over here, and then I'll use the concatenation, which is the plus symbol, and then we will also use double quotes to save a space there, and then another concatenation symbol which is plus, and I'll copy paste second name and I'll place it over here, and then I can just go ahead and write the print command and copy this full name and paste it over here. And you can also add a text saying the combined string result is equals to the first name or the full name. There you go. Run the code and there you go. So you have combined string right here. Now another most commonly asked interview question is you might have to find the length of the string. They might give you some random text and they will ask you to find the string length of this particular thing. So let's try that as well. So I'll write down a text which says let's go with Python programming. This will be our string, and let's imagine that this is your question and they will say find out the length of this character or length of this string. So let's declare another variable which says length is equals to, we will save the string length in this particular variable. Now we will use the length function and we will copy paste this text here inside the length function. Now we will use the print command, and we will type down length of the given string is length. There you go. The length of the string is 19. Similarly, you can also face another question which says convert to uppercase or lowercase, right? Convert to upper or lowercase. So it's really simple. We can use the same string that we have used in the previous example. So you can write down here, and then you can directly write down the text as well, which says print text in uppercase, print text in lowercase. So mild functionalities will be, you can copy paste this one and change this part, and you can paste text right here, and you can call the upper function. So dot, since we are in lower, we'll call lower function first, lower function, and close the bracket. Similarly, you can copy this and paste it over here. You can see how simple the context and syntax is in case of Python. You can just see it, you can just call it as upper, and Python will automatically understand that the user wants to print some text in lowercase and uppercase. And there is no complexity here as well. There you go. So the text was Python programming, and we have, I think we have missed an O there. There you go. So let's run the case again. Python programming in uppercase and Python programming in lowercase. So far we have converted the text into uppercase and lowercase, and we've covered three interview questions and answers to understand the functionality of strings. Now we can go ahead and understand string slicing as well. So let's say this is the string slicing question, and they give you some text. Let's consider text is equals to learn Python with Simplilearn. This is my text. I'll enter the text in double quotes. Now I want to split a part of this text. Let's say I want to print the first 1, 2, 3, 4, 5, 6 and another 6. So let's say I want to print the first 12 characters, right? I want to slice the string into two halves, and I want to print the first 12 characters, which is learn Python. So the first 5 is learn, space is the 6th, what I feel, and next is the 6th, which is Python. Learn space Python are the first 12 characters. Now I want to print these first 12 characters. So I can just copy this print command here, and I can say the first 12 are, and now here I want to make slight changes. So here I want to make slight changes. So I'll take the text and I'll use a double quote and I'll place a colon, and then I want to count the number of characters. So I want 12, right? So I'll just write down 12 and close the square bracket and close the bracket over here again. Now if I print this, I will have the first 12 characters. Now let's say somebody asks you to print the rest of the string. Let's say I don't want the first n elements of the string. I just want to print the next elements of the string. You can also do that. So the only change is you will replace the colon in the first place to the next place, and the number of elements that you want to omit. I want to omit the first 12 characters here, and then the rest of the characters which are with Simplilearn, I want to print them here. So just a mild replacement of colon from left to right, and then that's done. If you execute this, we have the rest of the characters which is with Simplilearn. Now we can go with the next interview question, which is can be considered as text matching, or you can also consider as text replacement. So first you need to match the text and then replace the text, right? So both in one shot, text matching and replacing. So the text can be, let's consider I like programming. Let's say I like programming in Java is my text. So let's encode this inside double quotes. And now I want to replace this particular text, which is Java, with Python. So it is really simple. Let us take a new text variable. This is my new text variable, and here I want to use the text replace function. So I'll just take this particular variable text and I'll paste it here, and I'll call the replace function. And now I need to provide what needs to be replaced by what. So I want to replace term Java with Python. So I'll separate that with colon and mention the new term, which is Python, and there you go. And now we can just print the new text here. So I'll copy paste the print command, and then I'll just call print new text, and that should be done. So there is a small error. Okay, I did not write the spelling correctly. So replace, there you go. Now we have replaced Java with Python. So simple, right? You can just identify and then replace the text. Now let's go with another interview question. And let's say here I want to find out if a given text element is present or not. We can consider the same text here as well. So let's say I like programming in Java. Check if a specific part of string is present. So now this is my text, right? I like programming in, let's say I'll go with not Java, I'll go with Python. So I'll replace Java with Python. Now I want to identify if Python is available in this particular text or not. So this is a little bit early for conditional statement, but it's not a big deal. It's really simple. So we will be using conditional statement. Again, we will be learning a lot of other conditional statements as well, or loops as well. So we will be having if, elif, and else if, a lot of those. But this is a little bit early, but not too complicated. So we will be using if text here or if condition here. If this particular element is present in the text, then we can print yes, this is present in the text, else no, this is not identified, it's not present in the text. So we will go with a simple if condition. So if the term Python is available, which is in text, so this is our text, right? I'll copy paste this one here. If it is available in text and colon, then print text is, or text is found, or element is found, else element is not found. So since we are printing the text form of output, we will encode this inside double quotes, and then we will have L here. So else double quotes, we will use the same print statement, element is not found. As simple as that. Now let's execute this. There you go. Since we have Python, we have found the element or text. If we replace this with Java and try to execute this, element is not there, so element is not found. Now this was a most common interview question that we dealt with. Next module, which is about operators in Python. So let me name it as module 4, which is operators in Python. And since this is a markdown, I'll make this L as markdown and save it. Now, operators are nothing but the mathematical operators or arithmetic operators that you most commonly use in any of the programming language, which could be plus, minus, division, multiplication, floor division, modulus, etc. Or even sometimes exponents in a very rare case. So let's go through all those examples in one shot. And most of the times you might also face this interview question where the interviewer might ask you that prepare me some function or something like that which takes the input from my end. Here we will go through an example where we give the input, but interviewer may ask you to provide a program that can take the input from the user and then execute the output. So we'll go through all those things in one shot. So let me declare a few variables. Let's say a is equals to 10 and b is equals to 20, or 2, let's go with 2, and then we can directly start with writing the print statement. So I'll write down the print statement, addition of two numbers is equals to a plus b. There you go. Now we can just copy paste this and simply paste a couple of times, and difference of two numbers is a minus b, multiplication of two numbers is a star b, division of two numbers is a divided by b, floor division of two numbers is double slash, and exponent of two numbers, exponent value of two numbers is, just replace the star with double star, and there you go. I can execute the code and you have all the outputs in one shot. There must be an error somewhere. Yeah, we messed out this one. Let's execute again. There you go. So you have addition, difference, multiplication, floor division, exponent, all those things in one shot. Now coming to the interview question where you might have to go with user input. So it's really simple again. You just have to declare a couple of variables which take the input along with the input command. So let's say I want to take two inputs. So I'll declare num1 is equals to, I just want to go with a data type here as well. So let's go with float for the safe side. I want to go with float, and I want to go with the input command or input function where it takes the input from the user. So we can give it a text message as well. Enter the first number and close the bracket. There you go. You can copy paste the same code here and paste it, and again we will call it as num2, enter the second number. So far so good. Now we can have a third variable which says result, and you can name it as prediction. So we can use the same codes from here as well. Instead of a plus b, we will replace that with result and close the brackets, and result will have num1 plus num2. Let's execute this function. So our first number could be 10, second number could be 2, and the result is there you see. Now you can copy paste the same command or same code and try to perform some subtraction as well. So you can just replace plus with minus and difference of two numbers. There you go, 10 to 8. Now for division, there you go. Now for multiplication, plus will be replaced by a star. There you go. And you can also go with floor division. So I think you already know what is a floor division. So floor division is something where you give an odd number to an even number, and it will give you just the remainder part without decimal values. Let's say if you try to divide 10 by 3, the actual result will be 333 point something like that, right? But you'll just get 3 here. And apart from that, you can, okay, we did not give a complete floor division, we just gave a regular division. So let's go with 10 again and 3. So that's the value. You'll just get the whole number. That's like a rounded value of so that's what the floor division is. And you can also go ahead with exponent value as well. Let's say you just replace the forward slashes with double stars, and you can give exponent value and run. You can give 3 cube is 27. So that's how you go with the user input related mathematical operations in Python. And let me also give you a small assignment here. The assignment would be prepare me, let's consider this as an interview question. You might face this, who knows. Prepare a small calculator that takes user input and also has an operation that asks for what kind of operation it needs to be done. So let's say the user might ask, give me the sum of two numbers, and might give the input, or he might ask you multiplication of two numbers and give the operation as multiplication, right? That's the kind of output that we want. So this is your assignment. Consider this, and do let us know if you want the answer, or do let us know if you already found the answer. You can paste that in the comment section below. Now we will enter into the module 5, which will be conditional statements, and you can also combine loops as well. So this is a module 5 and loops, conditional statements and loops. Since this is a markdown cell, I'll replace this to markdown and execute the cell, and there you go. So we will be having if statement, and we will also have if else statement, and we will also have nested if, or in this condition we will call it as elif. And apart from that, we will go through a couple of more like for loop, while loop, etc. For loop statement, while loop, and all those things. If we have missed out anything, we'll go for it on the go. So far so good. This is our quick agenda for module 5. Correct. So these are the common conditional statements or loops that we will be facing. But we will also learn these in a perspective where we are trying to question something. Let's say if you want to go with the if statement, we can go with theory. If functions like this, you'll have a condition. If this satisfies, then that. But instead of that, the theoretical approach, we can go with a practical approach so that you can understand in a much better way. Let's say we consider an example. We have a variable which takes the input from the user, which is a numerical value. And if that particular numerical value is negative, then that is a negative number. If it is equals to or greater than 0, then it should be a positive number. So you are kind of understanding how it goes, right? So let's try that example with if condition. So let me take an example, or we can take this particular code from here and just try to place it here, and we will name it as num, and we'll take integer type of input and the enter the number. This would be my condition, and this would be my message to the user. And now comes my condition. If number is greater than or equals to 0, basically it should be greater than 0, not equals to 0. But in case if somebody gives 0, that could be, we can go with that in an else if condition, but for now it's okay. Print the text as, so this is my condition. Now print number is positive and close this. So since it's a text type of output, so I'll enter it in double quotes. So we didn't mention an else condition just for the sake of understanding how an if works. Now I'll press some number is positive. Now we'll go with the if else statement here so that we understand what happens if somebody gives me a negative input, right? So I'll copy paste the same code, and now we will proceed with an else statement here. Else print, we can use the same code as well, number is negative, right? Let's enter, and now let me enter some number as minus 19. So the number is negative. So that's how an if and else statement works. Now we can proceed with another statement where you can have nested if statement, or in common terms we can also call it in terms of Python as elif statements. So let's copy paste the same command here and paste it over here, and instead of numbers, let's mark it as marks in an exam, and you can go with the float data type and enter the marks. If marks are greater than equals to 90, I would say class as distinction, and L marks are greater than equals to 65, I'll deem it as first class. Marks are greater than equals to 45, then we can deem as second class. Another LF 35, then pass. And the last option where this particular loop should close, or the conditional statement should close, is where comes the else part, and here I can print fail. There you go. Now we can quickly execute this statement. Let me give some marks which are fail. So there you go, fail. And if I execute again, and if I give about 91 marks, then I got distinction. So this is how the multiple else if statement, or the nested else if statement, or LF, works in Python. Now we come across the rest of the two conditional statements, which is a while loop and a for loop. So let's go with for loop first and while loop next. So I'll go with for loop. We need a small, let's go with list. I want to add the same fruits example, and I want to enter a couple of fruits. Let's say apple, then I want to use grapes, then we can go with the mango. So these are the couple of elements which I want to have in my list, and now I want to print these elements. So for that, we can directly go ahead with the print statement. But in case if I want to print them one after the other, then I need a counter variable. And using that counter variable, the control flows through this particular loop one time at a time until all the elements are printed out. So for that, let me assign a counter variable. So in normal terms, we can use any counter variable. So let me name it as I as my counter variable. Let me comment this. I here in this code is a counter variable, which basically maintains the count of the number of times the control went through the loop. Now let me write down the for loop for this. So for I in the list fruits, print I. There you go. So I missed a colon here, indentation problem, I guess. There you go. So we have printed apple, grapes, and mango. So whenever you're writing a loop, make sure that you don't miss this particular part, which is a colon and the indentation. So if you miss the indentation and colon, sometimes the error may pop up. Now with that, let's dive into the while loop. So you can use the same condition here. We can also make use of another example. Let's say somebody asks you a question to print 5 numbers using a loop statement. So you can use while loop there. So while loop, so I mentioned that in a comment. Let's go with our counter variable. So I'll mention it as count is equals to 0, and while count is less than 5, again I missed the colon there, count, and count should be, it should be increasing every once it goes through a loop statement, so equals to +1. So count is equals to count +1 basically. Every time a loop runs, you need to increase the value of count by 1. So 0 becomes 1 after the first loop, then 2, and so on. So I want this loop to run for 5 times. So I will have 5 elements. So once you execute this while loop, we have the first 5 elements printed here. And if we had declared some other variable to this count, then we might have got the 5 count from there. So it's how it goes. Now, we have also a couple of common interview questions based on conditional loops and loop statements here as well. You can go through this. We can share this particular workbook in the comment section below. And let's say if we wanted to find out a number is even or odd, you can also do that. Let's say I want to provide a number which is odd. So if the modulus of the number is resulting in 0, then that particular number is even. If not, it is an odd number. And you can also print some couple of numbers. Let's say start from 1 to 10, then you have it here. The only thing is you need to declare the variables range here. Let's say I wanted to print from 10 to 110, or let's say 20, and I have to change the input variables here, and I'll have 10 to 20 or 19 variables or numbers resulted in this particular section right here. And let's say if you wanted to find out the largest number of 3, which we already done with the elif statement, kind of resulting in Mars, what's the output? So here you just change that particular instance here. You can declare 3 different variables, and it takes 3 different inputs, and based on that, you will get the output. So let's say I give the first number as 10, second number as 20, and the third number as 30. So the same elif statement works here. The nested else if statement works here. If A is greater than B, then B is greater. If B is greater than A or C, something like that. So there you go. Largest number here is 30. Now here we have print multiplication table using a loop, right? And here you need to provide the number. Let's say I want to go with 5, and the 5 table is right in front of my eyes. And count numbers greater than 50 in a list. So there you go. And now we have the list here, and based on the any element which is greater than 50 is 55 and 60. So we have 89 as well. So we have 3 elements which are greater than 50 in this particular list. Let's say if I add another number or 2, then I run this command again, and I want to find out how many number of elements are there in this list which are greater than 50. Then I'll get the result as 5. So we have about 55, 60, 89, 90, and 67. The 5 numbers which are greater than the given number, which is 50. So these are a couple of more interview questions we can go ahead with in the form of conditional statements and loops. So this particular workbook will be shared with you. And apart from that, now we enter in our last module, which is object-oriented programming. So object-oriented programming is usually the next step in Python fundamentals because it teaches you how to organize code into reusable and scalable components. So the core components of object-oriented programming are classes and objects. And apart from that, we have encapsulation, inheritance, and polymorphism. First, let's go with classes and objects. So a class is a blueprint for creating any object, and an object is the instance of a class. Let's consider it in this way. A class, let's go with the blueprint example. Let's say you build a very nice blueprint to create a device or a mobile for a computing device like a laptop or something like that. And once you have a finalized blueprint, you can create n number of devices out of it. In the same way, if you have a completely structured class for you, then you can create n number of objects out of it. So in our case, we have a class with state student, and the object that we yield out of this class student is this one, S1, right? S1 is the first object that we're creating here, and student is the class, and S1 is the object created around the class. So first we were supposed to create the class first, and then if we run the object, then we have the object created, which is John, age 22. Now comes the important part, the init constructor. So the init method is the constructor used to initialize object properties. Whenever you declare a class, and then if you want to create an object out of the class, you need something to initiate the process of building an object. So that is the init constructor here. And let's run this code so that we have created a class and use the init process and assign the object which is Alice, age 21. Now comes the encapsulation, which is one of the fundamental pillars of object-oriented programming. Encapsulation, as the name speaks for itself, encapsulation means restricting the direct access to some variables. In Python, this is commonly done using private variables. So here we have the bank account class, and inside the bank account class, we have the init method, deposit method, and the show balance method. So we will be calling these methods and executing our outputs. So let's execute this code and see the output. So there you go. So the initial balance was 1000 rupees or 1000 INR. And then we are trying to call the deposit function and add the balance to it, which is right here. Balance is equals to plus the amount was 500, and the final balance is 1500, as you can see here. And now we come into the inheritance, which is the next pillar in object-oriented programming. Inheritance allows one class to reuse the properties of another class. And here we have two classes, which is employee class and the manager class, and then we have the developer class as well. So here we will be using the properties of the employee class and display the employee details and their salaries. So let's run this code and call the output. There you go. So the employee is Alice and her salary is 90,000. Alice approved the leave request and the employee was Bob and his salary is 70,000, and Bob is writing the Python code. Basically, he's a Python developer. Now we come across polymorphism, and polymorphism allows different classes to use the same method name with different behavior. So here you can see we have a method definition which is named as pay, but the classes are credit card payment, PayPal payment, and UPI payment. All these three classes have the same method which is pay, and the name of the method is also the same, but based on the function call, the method will be initiated. Let's say I want to call payment from a specific class. So if I call the credit card payment class, then this particular payment method will be activated or called. And if I call from PayPal class, this particular payment method will be activated, and same goes for UPI. So let's try to call all those three in one go. There you go. So you see certain amount was paid using credit card, certain amount was paid using PayPal, and certain amount was paid using UPI. So this is how you can go through the object-oriented programming in Python. Now don't worry, we will have this complete Python tutorial notebook saved for you from starting to the beginning, right? So this is where we started and this is where we ended. All these code documentations and the code segments will be saved. We will download this and we will share it with you so that you can have access to it, and this particular file will be mentioned in the description box below, so you can download it and run it through your Jupyter notebook and follow along with us. And with that, we have come to an end of this session on Python tutorial.
Let's see what operators are in Python. Now, operators are generally used to perform operations on values and variables in Python. These are standard symbols used for logical and arithmetic operations. The value that the operator operates on is called the operand. So here on your screens, you can see the different types of operators available in Python. First, we have arithmetic operators. So arithmetic operators are used to perform mathematical operations. It returns either true or false according to the condition. So these are the comparison operators. You have less than, greater than, less than equal to, greater than equal to. We have not equal to, and we have equal to equal to. Third, we have assignment operators. So assignment operators are used in Python to assign values to variables. So these are the assignment operators. You have equal to, you have plus equal to. So for example, you have a variable called x, and if you say x plus equal to 7, this means it is x equal to x plus 7. Similarly, if you say x minus equal to 7, this means x equal to x minus 7. And similarly, you can see the other assignment operators here. Next up, we have the logical operators. So logical operators are used in the expression evaluation to make a decision. If both the expressions are true, then the condition will be true for an AND operator. For an OR operator, if one of the expressions is true, then the OR condition will be true. Now for NOT, if an expression A is true, then NOT A will be false. We also have bitwise operators. So bitwise operators act on operands as if they were strings of binary digits. It acts on bits and performs bit by bit operation. So hence it is called bitwise operator. So here each value is evaluated as zeros and ones. Then we have identity operators. So identity operators are used to check if two values are located on the same part of the memory. Two variables that are equal does not imply that they are identical. We'll understand each of these operators in the demo session on the Jupyter Notebook. And finally we have membership operators. So membership operators are used to test whether a value or variable is in a sequence. So you have is and is not as identity operators. In membership operators we have in and not in. Now let's head over to our Jupyter Notebook and we'll see and explore all these operators one by one. So I am on my Jupyter Notebook, operators in Python. So let's first start with arithmetic operators. I'll just give a comment here saying arithmetic operators. Okay. First up, we'll see the addition operator. For that, let me assign two variables. So I have assigned a variable x to a value 10, and let's say we have the second variable y equal to 4. Now if I say print x plus y, it will perform an arithmetic operation, that is addition, and will sum the result of x and y and gives me 14, because 10 plus 4 is 14. Then let's say I'll write print x minus y, that gives me 6 because 10 minus 4 is 6. Similarly, you can have multiplication as well. So I'll write x asterisk y, that gives me 40 because 10 multiplied by 4 is 40. Similarly, let's say x divided by y. It gives me 2.5, which is basically the quotient of these two operands. Alright. Now if you were to find the remainder, you can use the modulus operator. So I'll write x modulo y. It gives me 2. So you divide 10 by 4, the remainder is 2. Now you can use the double asterisk operator, which is basically known as power. So the left operand is raised to the power of right. I'll write print x, give 2 asterisks, and then say y. It gives me 10,000. So what basically Python does is it will raise 10 to the power of 4. So 10 is multiplied 4 times and the result is 10,000. You can also try out another example. Let's say 2 raised to the power of 4. This gives me 16. If I say 2 raised to the power of 3, that is 2 cube, and the result is 8. You can also perform floor division. So floor division results into whole number adjusted to the left in the number line. So if I write print x, and floor division is given by 2 forward slash, then I'll write y, that gives me 2. So it returns a whole number. A generic division gives me 2.5, that has the floating point value, but a floor division will give me a whole number adjusted to the left on the number line. Alright, so these are some of the basic arithmetic operators that are very popular in Python. Next, we'll move on to assignment operators. I'll give a comment as assignment operators. Okay. Let's assign a value x equal to 7. So here we are assigning the value of 7 to x, and your equal to is an example of assignment operator. Now if I print x, it will give me 7. Now let's say I'll again write x equal to 7, and in the next line I'll write x plus equal to 3, and will print x. So what Python does is it adds 3 to my original value that x holds, that is 7. So here x plus equal to 3 means x equal to x plus 3. So x equal to x plus 3 can be written as x plus equal to 3. Similarly, you can also write x minus equal to something. Say x equal to 7 and then I write x minus equal to 3. Then we'll print x. This gives me 4 because we are subtracting the original value of x by 3. So here x minus equal to 3 means x equal to x minus 3. Okay. Similarly, let's say I'll write x asterisk equal to 3. If I run it and print the value of x, it gives me 12 because our previous x value was 4 and now we have multiplied x by 3. So x value now becomes 12. Let's say I'll write x divided by 3 and I'll print x. It gives me 4.0. This is a floating point number. So we are dividing 12 by 3 and the result is 4.0. Cool. If you want, you can also perform an exponent operation or a power operation. So let's say I have x equal to 7 and then I write x double asterisk equal to say 2 and then we'll print x. Okay, there is an error here. Let's debug the error. I have put a space here. Let's delete that space. You have to keep this in mind. Now let's run it. There you go. So 7 raised to the power of 2, which is basically 7 square, is 49. You can change the values and run other examples. Let's say 10 raised to the power of 3. We have 1000 as the result. Okay. Now moving ahead. Now we'll understand about comparison operators. So I'll give a comment as comparison operators. Okay. Let's say I have x equal to 7 and then I have y equal to 3. If I print x equal to y, it will give me false. The reason being the value that x holds is not equal to the value present in y. These are two different values that x and y hold. So x is not equal to y, and if we print x equal to y, it will give us false. Now I'll just copy this code. I'll print it here, and instead of equal to, I'll give not equal to. So not equal to is represented by an exclamation mark followed by an equal to. If I write x not equal to y, this gives us true because x and y are two different values and they are not equal. I'll print my code again, and this time let's say I'll write x greater than y. It gives us true because 7 is greater than 3. If I write x less than y and hit shift enter, that gives me false because 7 is not less than 3. I'll print the code again. This time we'll see if x is greater than equal to 3. If I run it, it is true because 7 is greater than equal to 3. And now let's check for less than equal to. This is false because 7 is not less than equal to 3. Okay, so these are some of the basic comparison operators that are available in Python. Now moving ahead, we'll see how logical operators work in Python. Okay. First, we'll look at the AND operator in Python. Suppose I have a value of 7 stored in X, and then I have a value of 12 stored in Y. If I write print X greater than 2 and Y less than 10, let's run it and see the result. It gives us false. Now AND logical operators will return true if both the conditions are true, and it will return false even if one of the condition is false. So here X is greater than 2, which means 7 is greater than 2 is true, but Y less than 10, which is 12 less than 10, is false, and hence our entire expression becomes false. Next, let's say I have X equal to 5, and then I'll print X greater than 3 or X less than 10. If I run this, it returns us true. The reason being X greater than 3 is true, which means 5 is greater than 3, that is true, but 5 is not less than 10. But since one of the conditions is true, so the OR operation in Python returns us true. Now let's see another example. I'll write X equal to 5 and Y equal to 10. I'll print X greater than 10 or Y less than 20. If I run this, it returns true. So let's see our expression. X greater than 10, that is 5 greater than 10, is false, but Y less than 20, so 10 is less than 20 is true. So our OR operation will give us true since one of the condition is true. Now moving to the next logical operator, we have NOT. I'll give an comment here as OR, and now we'll see NOT. Let's say I have X equal to 5, and then I'll print X greater than 3 and X less than 10. This should ideally give us true. The reason being X is greater than 3 and X is less than 10. Let's run and verify. Okay, so this is true. Now let me copy this and I'll paste it in the next cell. Now I'll replace my above print statement with a NOT operator, and we'll close our print function with another bracket. Now let's run it. So this will give us false because my expression evaluates to true, but not true is false. Okay, now moving ahead, let's discuss identity operators in Python. Alright, so we'll start by assigning a value of, let's say, 505 to X, and then in Y I'll have 500 plus 5, so which is also 505. So X and Y hold the same value of 505. Now I'll print X comma Y. So you can see here both the values are same, 505 for X and Y. Now I'll use the logical operator, that is double equal to or equal to. I'll write X equal to Y. This will give us true because X and Y hold the same value of 505. But let's check with the identity operator. So I'll write X is Y. If I run this, it gives me false. The reason being X and Y both refer to objects whose value is 505. They are equal, but they are not referencing to the same object. Now this you can verify using the id function in Python. if I write id of x, this will give me the memory location that x has. You can see this is the memory location of x. Now if I write id of y, there you go. So this is a separate memory location in which y is holding the value of 505, and hence x is y is different, and hence it is false. Now suppose I write x equal to 100 and I have y equal to 200. If I write x is not y, this gives us true. The reason being x and y both are holding different values, so x is not y is true. Let's see another example. This time we'll define two lists. So I have a list called A that has value, let's say 5, 6, 3, 7, 1, let's say 9. And then I'll have another list that will also have the same elements. I'll copy this and I'll paste it here. Okay, if I write C equal to A and then we'll print A is C. If I run this, it gives us true because we are assigning the variable A to C, and hence the memory locations are the same for both, and hence A is C gives us true. What if I write A is B? Now this gives us false. So here A and B are both less. They are equal but not identical. It is because the interpreter in Python allocates them separately in memory although they are equal. Okay, now let's talk about membership operators in Python. I'll give a comment as membership operators. Okay, let's say I have a list A that has the above values 5, 6, 3, 7, 1 and 9. I'll copy this and I'll paste it here. Okay, I have another list B that has different types of elements. We have 4, next element is Python, then we have 2, 7, let's say Simplilearn, and then I have 9. I'll run this first. So I have my two lists A and B. I have printed them. Let's explore how the membership operator works. So we saw in the slides in and not in are two membership operators. If I write 5 in A and run it, it returns me true because you see here 5 is present in A and hence 5 in A will return true. What if I write 55 in A? This gives us false because you see here in the list A we don't have an item 55 in A, so it gives us false. What if I write 4 in B? This gives me true. You see here in B we have the element 4, so 4 in B is true. One thing I wanted to show you is what if I write Python in B? You see here it gives us false. Though we have Python in our list B, but the Python I'm trying to check is not present in B. The reason being here Python is written in lowercase, but what I am checking, Python P is in uppercase, so it is case sensitive, and hence this gives me false. Let's say I'll declare a dictionary y equal to, and within curly braces I'll give my key A and I'll assign the value of India. Let's say I have another key B and that has a value, let's say USA. Now if I check A in Y, it gives me true because your key A is present in Y. Now what if I check India in Y? Now this gives me false. So here the membership operator won't work on the values, it only works on keys in a dictionary. Now let me go ahead and change the keys to numbers. I'll give 1 that has India and the second key I'll have 2. Now if I change A to 1, it will work fine, it gives me India. But if I write USA in Y, it gives me false. As I said, the membership operator won't work on the values, it only works on the keys in a dictionary. Cool. Now coming to the final section of our demo, we'll explore about bitwise operator. Okay. So Python bitwise AND operator returns 1 if both the bits are 1, otherwise it will return 0. So first let's see 7 ampersand 2. If I run it, it gives me the value of 2. So what Python does is, it will first convert the numbers 7 and 2 to their binary equivalents, that is in the form of zeros and ones, and then it will perform the bitwise AND operation. So 7 ampersand 2, the value is 2. If I write 3 ampersand 5, the value is 1. Again, it will first convert 3 and 5 to binary equivalents in the form of zeros and ones, and then it will perform the AND operation, the bitwise AND operation. Now the Python bitwise OR operator returns 1 if any of the bits is 1. If both the bits are 0, it will return 0. So if I write 10 or 5, it gives me 15. So first it will convert 10 and 5 to binary equivalents, and then it will perform the bitwise OR operation. Let's see another example. I'll write 4 or 8. I'll run it. So the bitwise OR operation gives us 12 as the result. Alright. Conditional statements in Python perform specific operations and take actions depending on whether a specific Boolean constant evaluates to true or false. Conditional statements are handled by blocks of if statements in Python. Now, conditional statements are also known as decision-making statements. So Python provides different types of conditional statements that you can use to make decisions. We have the simple if statement, then we have if-else statement, elif statement, the nested if statement, as well as nested if-else statement. We will learn them one by one with the help of their syntax and code examples. So this is how the syntax of if statement looks like. So you pass in the if condition, and then we have a set of statements inside the if condition. So on the right side you can see the flow diagram, how the if statement gets evaluated. So first we have the test expression, that is the if condition. Now if this expression evaluates to true, then we go inside the body of the if statement. So this is basically the body of the if statement that contains a list of statements or blocks of statements. Now if the test expression evaluates to false, we execute the statements that are present after the if condition. Alright. Now let me take you to my Jupyter notebook where we'll understand if statement with an example. Okay, so here I am on my Jupyter notebook. I'll just rename this to conditional statements. I'll see it as demo and we'll rename it. Okay, I'll just expand the screen size. Alright, okay, so first of all, let's write a simple if statement. I have given a comment here. Suppose we have a variable called grade and the value of grade is 80. Then I'll write my if statement as if grade is greater than equal to 50. Then I'll give a colon. Then I'll write a print statement, print passed in the exam. Now this is how you write a simple if statement. So you have the if keyword followed by the condition. So here my condition is I'm checking whether the grade is greater than equal to 50. Now here I have already defined my grade to 80. So this if statement or the if condition will check whether 80 is greater than equal to 50. Now this is true. Then my print statement gets executed. Let me run it and show you the result. There you go. Here you can see we have our printed message as passed in the exam because 80 is greater than equal to 50. Now what if I change this to, let's say, 30? If I run this, there is no output here. The reason being 30 is greater than equal to 50 is false. So my print statement did not execute. Okay. Now if you want, you can also print another statement outside the if condition. I'll give the message as execute statement after if. Now one thing to remember that this print statement is outside the if condition. So if I run it, only my last print statement gets executed, which is outside the if condition. Okay, now let's write another simple if statement. Now this time we are not going to define the grade value or predefine the grade value. Here we are going to take the grade value as an input, that is a user input. So I'll write grade equal to, now the way to take a user input is by using the input function. So first of all we need to convert our entry into an integer. So I'll write int function and inside that I'll pass in my input function. Then I'll give my message as enter the number. Alright, so this statement will take the number from the user. Now I'll write my if statement if grade is greater than equal to 50. Then it won't give a space here. Let's delete the space. Then I'll write print you have passed in the exam. Okay, let's run it. You see here my program is asking for the user input. It says enter the number. I'll give my number as, let's say, 60. If I hit enter, that gives me the result passed in the exam. Now let's run it again. This time I'm going to give as, let's say, 35. If I run it, there is no output here. The reason being our grade 35 is not greater than equal to 50. So our print statement did not execute. Alright. Okay, now let me give a space here. We'll run it again and this time we'll pass our grade as, let's say, 75. Let me run it. You can see here it gives me the message passed in the exam. Now moving to our next statement, we have the if-else statement. So this is how the syntax of if-else statement looks like. So first you have the if condition followed by a colon. If this condition evaluates to true, then we execute the list of statements that are present inside this if condition. Else, we have the else block here. If this condition returns false, then we execute the list of else statements. So here is the flow of how the if else statement executes the different statements. So first we check the test expression. If that evaluates to true, then we have the body of if, and if it is false, then we have the body of else. And later, if there are any statements that are present outside the if else block, we'll execute those statements. Now let's head over to our Jupyter notebook and we'll see how the if else statement works by example. Okay, so here I'll show you another example of using two if statements. So I'll define my grade as 40. I'll write if grade is greater than equal to 50, then we'll print, let's say, pass. Then I'll write another if statement. I'll say if grade is less than 50, then we'll print fail. Now here I'm using two if statements. Let me run it. You see here I have my result as fail. The reason being our grade 40 is less than 50 and hence it has printed fail. Now instead of using two if statements, you can use the if else statement. So in this case, we'll have our if statement checked for if grade is greater than equal to 50. If this is true, then we'll print whatever is there inside the if statement. But in case this evaluates to false, we have another else block that we are going to write. Let me show you how to write the if else statement. So I'll give a comment as if else. Okay, I'll say grade equal to 40, then we'll check if grade is greater than equal to 50, print pass. Then instead of using the if statement again, I'll write else followed by a colon, and then I'll write print fail. Make sure this fail is inside double quotations. If I run it, it gives me the result fail. The reason being 40 is not less than, repeat, 40 is not greater than equal to 50, so hence it has printed fail. Now instead of taking the value as 40, we can have the user give the input. So we'll use the input function. I'll say enter the grade. Let's run it again. You see here my program is asking for the user input. Let's say I'll give 80. We'll run it. It says pass because 80 is greater than equal to 50. Let me run it again. This time let's say I'll pass my grade as 45. We'll run it. It gives us fail. Alright. Now moving to our next conditional statement, we have the elif statement. Now this is how the syntax of elif statement looks like. So here first we have the if condition. Now if the if condition evaluates to true, we have the body of if. That is basically a set of statements. Now if the first test expression or the if condition evaluates to false, then our elif condition gets executed. Now if our elif condition is true, then we have the body of elif. So this is the elif statement body. Finally, if the elif condition also evaluates to false, then we have the block of else statements. You can see here we have body of else, and later if there are any statements outside this if, elif and else block, then those statements get executed. Now we'll see this with the help of examples. Okay, So here on my cell I'll give my comment as elif statement. Okay, suppose I have a variable called score and this take the value as integer from the user, so I'm using the input function. I'll say enter the score, I'll give a space, then I'll write my if condition. I'll say if score is, let's say, greater than equal to 90, give a colon, then we'll print our message as passed the exam with, let's say, A grade. I'll just copy this statement because we are going to print similar statement below as well. And now I'll have my elif condition. I'll write elif is actually else if score is greater than equal to, let's say, 75. I'll give a colon, will print passed the exam with B grade. Then I'll again have my elif statement. I'll write if score is greater than equal to, let's say, 60, will print pass the exam with C grade. Next, let's write another elif condition. I'll write elif if score is greater than, this should be greater than equal to, okay, is greater than equal to, let's say, 40, then we'll print pass the exam with D grade. And finally we'll have the else condition. I'll write print, let me just scroll down, failed in the exam. Okay, so this is how you write a elif conditional statement. So first I'm taking the user input of the score, then I'm checking if score is greater than equal to 90. I'm displaying my message as pass the exam with A grade. Then I have a list of elif statements to check for different scores. If all these evaluates to false, I am having my else statement printed. Let's run it. Okay, so we'll try out different scores. Let's say someone scored 95. If I run it, so that candidate has passed the exam with E grade, because if you see the condition, my score 95 is greater than equal to 90, and hence we have passed the exam with A grade as the message. We'll run it again. Let's say I have 80. If I run it, it says pass the exam with B grade. The reason being 80 is greater than equal to 75, and hence we have this message printed. Let's run it again. Suppose someone scored, let's say, 25. If I run it, okay, it throws me an error. It says name score not defined. Okay, so this should be score actually. Here there was a spelling mistake. I'll run it. I'll pass my score as 25. It gives me failed in the exam. The reason being my score 25 is less than equal to 40, and hence we have failed in the exam. Cool. Now you can also use a for loop and then have a list of if else block or if else statements. Let me show you how to do it. Suppose I write for x in, I'll use the range function. I'll go till 10, which means from 0 to 9. Then I'm checking if my x is less than equal to 3. I'll print x is less than or equal to 3. Okay, now we have the elif statement. If elif x greater than 5, I'll print x is greater than 5. Then we have the else condition. Will print, let me just scroll down, I'll print x must be 4 or 5. Okay, so here I have used a for loop and I am checking for each iteration from 0 to 9, and then we have a set of if, elif and else statements. Let's run it. There you go. You can see the output here. So first, in my range I have 0, so it will check if 0 is less than equal to 3, which is true, so it has printed 0 is less than or equal to 3. So it will go till 3, and then when 4 comes, it will check if 4 is greater than 5. Now this is also false, so it will skip executing the elif statement and it will print whatever is there in the else block, which is 4 must be 4 or 5. So you can see the message here, 4 must be 4 and 5. Similarly for 5 also the same message will be printed, the reason being 5 is not greater than 5. And then for the rest of the numbers from 6 to 9, we have 6 is greater than 5, 7 is greater than 5, 8 is greater than 5, and 9 is greater than 5. Alright. Now moving ahead, next we have the nested if statement. So here is the syntax of nested if. So you have the if condition, and inside the if condition you have another if condition, and hence it becomes the nested if condition statement. And inside this condition you have the list of statements or the blocks of statements. So here is how the flowchart or the flow diagram looks like. So first we are evaluating the expression 1, which is this condition. If it is true, we are going inside and checking the second condition. If that is also true, then we are running the body of if, which is this part of the syntax. And later, if there are any statements that are present outside the if condition, we are executing those. So in case the first test expression evaluates to false, we are coming outside and directly printing whatever is there outside the if condition. Let's see this with the help of an example. Okay, so I'll give my comment here as nested if. Cool. So first of all, I'll declare a variable called num. Now this num will have a user input value. So I'll write input, enter the number, then I'll have my first if condition. I'll say if number or num is less than 250, I'll give a colon, then we'll use the print statement num is smaller than 250. I'll write my second if statement and we'll check if num is less than 180 and we'll print num is smaller than 180 as well. Finally, I'll have my else statement as print number is greater than 180. Alright, let's run this, and first we'll check with the number 100. Okay, there you go. So here I'm checking whether 100 is less than 250, which is true. So we have printed 100 is smaller than 250. Again, we are checking if 100 is less than 180, which is true again. So we are printing 100 is smaller than 180 as well. There's a spelling mistake. Okay. Now let's see for, let's say, 150. Again, we have 150 is smaller than 250, 150 also smaller than 180. Let's run it. This time, let's say we'll pass 300. Okay, you can see our result here. 300 is less than 250 is false, so we'll skip printing this. Again, we'll check whether 300 is less than 180, which is false again, so we'll skip printing this statement as well. We'll only have our else block printed, which is 300 is greater than 180. Okay, now coming to the final section where we'll see about nested if else. So here you can see we have the syntax for nested if else statement. So we have an outer if condition, and inside that we have another if condition. Then we have the list of statements or the body of the if condition. If this is false, then we execute the else part, and after that we also have an outer else statement. So this is how the flow diagram looks like. We'll check for the test expression 1. If that is true, then we'll go inside and see the test expression 2, and if that is true, we'll execute the body of if statement, which is this part of the syntax. Then if these are false, then we'll see the body of else 1. If the second expression is false, then we go to the body of else 2, and after that, if there are any more statements, we'll execute them as well. Alright, we'll see an example here. So I'll give my comment as nested if else. Okay, so I'll declare a variable a which will take a user input of type integer. I'll say enter the number. I'll write if a is less than 50. So this is my first if condition. If this is true, this should be less than 50. Okay, so if my first if statement is true, then we'll check for the second if statement, which is, let's say, if a modulus 3 equal to 0, which means if the remainder of the division is 0, then we say print a is divisible by 3 and is less than 50. Okay, then we have our else statement as else print my number a is not divisible by 3 but is less than 50. Finally, I'll have my last else statement where I'll print my number a is greater than 50. Okay, so this is how you write a nested if else statement. So I'm taking my number as a user input. First I'm checking if that number is less than 50. If that is true, I'm again checking if that number is divisible by 3. If it is divisible, I'm printing my message as the number e is divisible by 3 and is less than 50. If this is false, I'm saying the number e is not divisible by 3 but it is less than 50, else I'm saying the number is greater than 50. Let's run this and we'll try out different examples. Let's say I'll say my number is 12. My message is 12 is divisible by 3 and is less than 50, which is this part of the code. So my number 12 is less than 50. This is true. Then I'm again checking whether 12 is divisible by 3. It evaluates to true, and hence we have this result printed. Okay, let's say this time I'll say 30. So I have my message 30 is divisible by 3 and is less than 50. Let's run it again, and this time let's say we'll say 72. So here I have my message 72 is greater than 50. The reason being 72 less than 50 is false. Hence this part of the code is not executed. It will directly come to the else part, which says 72 is greater than 50. Okay. So that brings us to the end of this demo session on conditional statements in Python. So first we learned how to write simple if statement. You saw how to take inputs from the user. We also learned how to write if-else statement. Then you learned about elif statement. You also saw how to use a for loop, and inside that you can use your if statement, your elif, your else. Later on we saw how to write nested if statements, and finally we learned how to write nested if-else statements.
Let's glance at the topics. Object-oriented programming in Python, some major principles of object-oriented programming, and then we will touch upon topics like class in Python, objects, methods, inheritance, the concepts of inheritance, the different type of inheritance, then the definition and examples of polymorphism, encapsulation, and abstraction. So all these topics will be supported with examples and the relevant terminologies and definitions. Now, what is object-oriented programming? Python is an object-oriented language like any other programming language like Java, C++, and the object-oriented programming language concept is not new, and each and every mature programming language has these concepts imbibed in it. Now, the concept of object-oriented programming in Python focuses primarily on creating objects and making reusable codes. So whenever we start programming at a large scale or for a big project, it is very important to identify the objects within that particular project which you want to define. Now, for example, in this presentation, what you are seeing is that we are covered with full of objects like car, dog, tiger, tree, or a balloon. So these are typical examples of objects which you encounter in day-to-day life. Now, what are the major principles of object-oriented programming? So these are the different kind of terminologies. Classes are there. There are objects. There are methods. Then on these classes and objects, you apply inheritance, polymorphism, encapsulation, and abstraction. Now, what is a class? Class is nothing but a collection of objects, or we can say a user-defined data type, right? So basically, it's a complex data type which has a collection of objects, and within the objects, you have primitive data types like int, string, float, etc. So a class also holds the methods, the functions which basically perform operations on these objects, right? And also it also holds on to the attributes of the objects. So let's see with an example, right? So if you have an employee class, then it would contain attributes and methods such as email ID, name, age, salary. These are the attributes. And on the methods like, perform task, give presentation, increase salary, etc., etc. These will be the methods. Now let's talk about what are objects in Python. Now, object is known as instantiation of a class, right? An object is a group of interrelated variables and methods. So when a class is defined, only the description for the object is defined. Therefore, no memory or storage is allocated at that point. So for example, if you see in this, motorbike is a class, but the different objects of that class are different kind of bikes by different brands like BMW, Suzuki, Royal Enfield. So they all have inherited the attributes of the class motorbike, and then on top of it defined certain variables, additional variables and methods on top of it to enhance the motorbike and make it look different or function differently. Now, what are methods in Python? Methods are functions defined inside the body of a class, right? So basically, methods are something which you perform on a attributes of a class, right? Method is a function that is associated with an object. So you create an object of a class, and on that object, then you can execute those functions. In Python, a method is not unique to class instances. Any object type can have methods. And the methods define the behavior of an object. So that's why a BMW motorbike will be different from Royal Enfield, because the behavior is different. The methods are different. So if you see the example over here, you have a class bike, and in that there is an init function which will get invoked when you initialize the object of class bike, and then you can set the brand name and the year of manufacturing for that particular object. Now, inheritance. What is inheritance? Inheritance is something which you derive from a parent. So inheritance is like creating a new class that uses all the properties and behavior of another class. Now, the new class is called the derived class or the child class, and the existing class whose properties are inherited is known as a base class or parent class. It provides, and the basic functionality, the usage of inheritance is that reusability of code. So if anything is defined in the parent class, then you don't need to rewrite that particular code in the child, you can just inherit it. So as I mentioned, let's take a look at the different types of inheritance which are available. You have single level, in which only one child is inheriting the properties and the attributes from the parent. Then you have multi-level, in which first child has inherited from the class A, class B has inherited, and then you have another class C which is inheriting from class B. So this is an example of multi-level, and we will be supporting all these concepts with an example in our Python notebook. Then there is hierarchical. Then there are two different classes which are inheriting from a single class, and then multiple inheritance, that single class is inheriting from two different parents. So these are different set varieties of inheritance basis what is the demand, what is the business requirement, you can define. Now, what is polymorphism? Polymorphism in Python, what does it means? Polymorphism consists of two words, poly and morphs. Poly means many and morph means shape. So basically it means many shapes. So it means using a familiar interface for multiple forms, right? So you can use a single name of the method, and which can perform different behavior based on the object in which it is invoked. So in simple terms, we understand that a task can be performed in various ways. Let's support it with an example. Like you have a plus operator. Now the plus operator can be used for integer data types to perform arithmetic operations, whereas when you use plus operator to in string data types, it can be used for concatenation. So it's a very typical example, very good example in terms of how an same operator can behave differently basis what data types are being used. Now let's talk about encapsulation. Using oops in Python, we can restrict access to methods and variables. So basically in Python, you can create something like as private variables, but of course you can't use a private keyword unlike Java. So in Python, we use underscore or double underscore in order to define private attributes. So basically These attributes can be only used within the class and cannot be exposed outside a particular class. So we will see this with an example. Now, what is abstraction? Data abstraction and encapsulation are often used as synonyms. Abstraction is used to hide internal details and show only functionalities. For example, you know how to turn on or off a light using a switch, but you don't know what is happening behind the socket. Similarly, an abstract class cannot be instantiated, which means you cannot create objects for this class. You can only define the methods which have to be implemented by the classes which are inheriting the abstract class. So basically, abstract class provide only the method signatures, and rest the other functionalities and the implementation has to be done by the child classes. So let's now move to the our Jupyter notebook and we will start performing certain examples. Now, as we are saying, like Python has objects. So let's create an object. We will create a class bikes over here. And within the class, we will define the init method. And in the init, we will instantiate two variables, brand name and year. Now we will create an object of bike which we are calling as BMW, and another we will create an object called Ducati. So what we are doing in this two scenarios is that we are just instantiating the bike object with variable BMW and Ducati. We are instantiating. Now let's print the year and manufacturing year, the brand name and the year for BMW and for Ducati, and let's see. Right, so what we have done is we have created an object for bikes. One we are calling BMW and one we are calling Ducati, and how we are differentiating between these two bikes is basis the brand name and the year of manufacturing. Now let's take a look at the example of methods. I'm going to rewrite my init method, and now I am creating a function, a method of top speed and a function of type now. I'm going to create an object of bike. Now this method, this object bike, can invoke methods top speed and type because they belong to the same class bikes. So initially when I created my object bikes, I'm instantiating it with BMW and the year, and then I am making a call to the method top speed, and then I'm making a call to the method type and printing. So basically I'm printing the output of the function top speed and output of the function BMW, form the object BMW which is of class bikes. Now let's take a look at an example of single level inheritance. Let's create a parent class called animal and create a method called sound, and let's create a child class cat which inherits animal, and let me just put a method over here. Here's the indentation. Okay, so now I have object parent class animal, child class cat which has inherited animal, and the parent class method is sound and the child class method is meow. So now I'll create an object called cat, and with this object I'll be able to invoke both child class method and the parent class method. And as you can see, the child class has inherited both parent and child class functions, methods. Now let's take a look at multi-level inheritance example. I'll start off with creating exactly the same parent class called animal. Then I'm already created another class. I'll create same child class cat, and now I'll create another class which will inherit cat class. So cat has inherited animal and cat child has inherited cat. Let's validate its syntax. And similarly now I'll create an object for cat child, and this cat child now can invoke the same methods which are in child, parent and the super parent. So this is an example of multi-level. This is an example of single level inheritance. Now let's take an example of polymorphism. We are going to create a class parrot and define the function fly and swim. Now we are going to create another class. Mind you, there is no inheritance here. We are just creating an independent class called penguin, and same methods now, the same name, fly and swim. Okay. Now let's make a function in which we will pass an object, and basis that what is the instance of the particular object bird, the corresponding method will get invoked. So let's see. In the method flying test, whatever instance of the bird object will be, the corresponding method will be called. So now let's create a object of parrot class, and then let's create a object of penguin class. Now in my flying test method, First, I'll send a object of instance parrot, and then I'll send the object of instance penguin. So now basis the instance type, when this bird.fly method will be called, it will be called basis the instance. So in the first case, the parrot, it will call this method, and in case of penguin, it will call this method fly. So please note what is the output. The output is a parrot can fly, but a penguin cannot fly. And it has been decided by the Python at the runtime that which particular method to be invoked basis the instance. So it's a very important concept. Now let's take an example of encapsulation. I'll make a class cars, define its init method. Now within that init method, I have created a private variable with underscore underscore max price and given a value of 9 lakh. Now I am creating another function called sell, and in that I am printing the max price. And then I am creating another function in which I am modifying the private variable set max price. So I will pass any value in the set max price and it will replace the max price which I have set during the initialization at this point. Now let's create an object of class cars and see if I sell this, then the selling price is 9 lakh, what I had set at the time of initialization. Now what I'm trying to do is I'm trying to modify a private variable directly, c underscore underscore max price, and I want to check if I'm trying to create modify a private variable, will it still show me 9 lakh or 10 lakh value? And it's still showing me the 9 lakh value. It means that I can't directly approach or access the private variable. I can only modify it if I access it through a method which is set max price. In this, now I am setting the max price to 1000, and now if I print what is my max price, it will print as 1000. So this is the concept of encapsulation. You have a private variable which is accessible within only the methods of the class. You can't access it directly. Now let's take a look at hierarchical inheritance. I'll create a class employee and create an init method. Within that, you have three variables: name, age, and salary. So an employee has name, age, and salary. Now I'm going to create a child class called child employee 1, which is inherited from employee, and child employee 2, which is also inherited from employee. So what I'm going to do is I'm going to create a object per child class and print So this is a typical example in which you have two child classes which have inherited from the single parent, hierarchical inheritance. Now let's take a look at our last concept, which is abstraction. So now I'll create a class car and define a method mileage, but I am not giving any definition to it. I'm just giving a signature mileage. The child classes which will inherit abstract class will be giving the definition. So I am creating a class BMW, which has inherited the car ABC car, but given the definition now. Similarly, I am creating another class Jaguar, which has inherited the class car, but now it is giving a different definition. It's printing mileage 25 km/h, and another class Range Rover, and another class Renault. Okay, so 4 classes which have implemented the abstract class method mileage in a different way. Now I'll create an object of first BMW and invoke method mileage. So it has invoked the method mileage on BMW car and printed mileage is 30 km. Similarly, I'll do for Renault. Jaguar and Range Rover. So if you see, the parent class, abstract parent class, has not implemented the method but just given the signature of the method, and all other classes have implemented it, and that's the concept of abstraction.
So what is a lambda function? A lambda function is one of the simplest ways to define a function in Python. A lambda function is an anonymous function defined without a name and does not have the def keyword. It can accept any number of arguments but can only have one expression. So the function is always defined using the lambda keyword, which you can see it here. So here we have the syntax for lambda function. We use the lambda keyword followed by the arguments, and then we have a colon. After that we have the expression that we want to evaluate. Cool. Now moving ahead, let's look at an example of using lambda function in Python. Now if you were to add two numbers in Python using a function, you would ideally use the def keyword followed by the function name and then pass in the arguments. You can see the arguments here, a and b. Then use the return statement to get the value of the addition. So we have return a plus b, and finally you will call the add function and pass the argument values to get the result. Now this operation can be done using the lambda function as shown here. So we have defined a variable called add, which is equal to, and then we have used the lambda function followed by the two parameters or arguments. So here a and b are the arguments, and then I have my expression a plus b. See, all this you can do it in one line. And then to call the function you use print followed by the variable which is add, and then you have the arguments 3, 8. So the addition of 3 plus 8 would be 11. Now you can see that instead of using the def keyword, we have used the lambda keyword, and there is no parenthesis required. Anything after the lambda keyword is treated as a parameter or argument. So we use a colon to separate parameters and the expression. In our case, the expression is a plus b. Now moving ahead, we'll look at the pros and cons of lambda functions. So lambda functions are suitable for simple logical operations. So when we want one expression in return, we can use the lambda function. Now lambda function is used as a parameter to different functions such as map, filter, reduce. We will see all this in our demo session. Now coming to the cons of using a lambda function. So lambda functions can only evaluate one expression, as I told you earlier. You cannot write a doc string to explain all the inputs, operations and outputs as you would do in a normal user-defined function that uses the def keyword. And finally, lambda functions are generally not preferred when you have to declare a function with multiple lines of code. Now let's head over to our Jupyter notebook where we will learn about lambda functions and how to use it in different ways. So I'm on my Jupyter notebook. Let me just go ahead and will rename the notebook as lambda functions in Python. Okay, I'll just click on rename. Cool. First of all, I'll write a general user-defined function using the def keyword. Let's say I want to add two numbers. So this example we have already seen in our slide. So the way to do is I'll use the def keyword followed by the function name, and then I'm giving my arguments or the parameters. After that, let's say I want to store the addition of a plus b in a variable called result. So I'll say result equal to a plus b, and then I want to return my output, that is result. So I'll say return result. So this is how you will normally create a function in Python. If I run it, and then I'm going to call my function using the function name, that is add, and then I'll pass in my parameters a and b. Let's say my a is 3 and b is 4. If I run this, I will get the result 7, which is fair enough. Now if I want to do the same operation using a lambda function, I would do something like this. Let's say I'll create a variable called add, and then I'm going to use the lambda function followed by the arguments a comma b. Then I'll give a colon and say a plus b. After that, I'll just say add and then pass in my parameters 3 comma 4. If I run it, you have the same result, that is 7. Now let's see another example using lambda functions to add a number. This time I'm going to pass in only one argument. So I'll say add equal to lambda, my argument is x, I'll say x colon x plus, let's say I want to add x with 100. I'll say print add, let's say I want to add 50 with 100. If I run it, I have the result 150. Alright. Now in Python, there is no need to assign a lambda to a variable. You can directly call it. Let me show you how to do it. I'll say lambda a comma b, which are my arguments. Again, this time I'm going to use a multiplication operator since I want to do a product of a and b. And after that, using another parenthesis, you can directly pass in the arguments. So there is no need to explicitly assign a lambda to a variable. So if I want to find the product of, let's say 15 comma 30, if I run it, I have the result 40. Let's change the arguments. Let's say I want to find the product of 5 comma 7. The answer is 35. So this is known as an immediately invoked function expression, or IIFE, which is often pronounced as IFE. Now you can also use keyword arguments using lambda functions. Let me show you what I mean. I'll create my lambda function and assign it to a variable called product. I'll say lambda let's say my arguments are x, y and z. After that I'll give a colon and say x multiplied by y multiplied by z. Next I'll say print my variable, that is product, and here I'm going to use keyword arguments. So I'll say, let's say z equal to 5, x equal to 10 and y equal to 4. You can see here this need not be in an order as you have defined the arguments. If I run this, I have the result, the product of 5 multiplied by 10 multiplied by 4 is 200. Now you can also use default arguments. Suppose I say add equal to, I'll use the lambda function and say x comma y, I am assigning a default value of, let's say 15, and z, let's say I'll assign a default value of 24. Then I'll give my colon followed by the expression, that is x plus y plus z. Now I'll say print add. Now here I'm going to only pass in my value for x, since I've already given a default value for argument y and z. So my function only needs one argument, that is x. So let's say I want x to be 20. If I run this, you see the result here. So 20 plus 15 plus 24 is 59. Now you can also use the asterisk args parameter or args. So this allows you to define as many arguments as you want. So I'll say addition equal to lambda, then I'll say asterisk args. So this will allow us to pass in as many arguments as you want, and I want to find the sum of args. So I'm using the inbuilt sum function in Python. Now I'll say print my variable name, that is addition, and let's say I want to find the sum for 4 values or 4 arguments, let's say 20, 2, 40 and let's say 50. If I run it, so the value is 112. So 20 plus 2 plus 40 plus 50 is 112. Cool. Now lambda functions are also used with higher order functions which take one or more functions as arguments or return one or more functions. Let me show you. So I'll define a variable called higher underscore ord underscore fun, which stands for function and ord stands for order. So I'll declare my lambda function. Suppose the parameters are x, and then I have a function, and then followed by a colon I have my expression as x plus function of x. Now I'll say higher underscore ord underscore fun, and I'll pass in my 2 arguments. Let's say my x is 20, and for this function I'll have a lambda function defined. I'll say lambda x colon x multiplied by x. Now let me just run this and I'll show you the result. Okay, so what it did was it added my value of x, that is 20, with function of x or fun of x. What is fun of x? Fun of x is x multiplied by x. So 20 multiplied by 20 is 400. So this becomes 400 plus x, which is 400 plus 20, hence the result is 420. So this is known as a higher order function. Now let me show you another example. Let's say I want to display odd or even by taking the value of x. I'll say lambda x colon. Here I am going to pass in my expression. If x mod 2, give a space here, I'll say and odd, or even. Now I'll give my argument value, let's say 30. The result is even because 30 is divisible by 2. I'll just change this to, let's say, 15. If I run it, the answer is odd because 15 is not divisible by 2. Let's say I have 150, the answer is even. Now moving ahead, so let's write a lambda function that checks if a string is a substring of the given string. So I'll create a variable called sub_string. Now I'll assign this variable with a lambda function. I'll say lambda, my argument, let's say string. I'll give the colon and pass in my expression string in. Let's say my string has this message, welcome to Python functions tutorial. Okay, so we are going to check if a string, let's say in, to, welcome, Python, Java, anything, whether it's present inside this string which is welcome to Python functions tutorial. Now let me go to the next line. I'm going to print sub_string, and let's say I want to check for my string, let's say Java. If I run it, it gives me false because the word Java is not present inside my string welcome to Python functions tutorial. Suppose I write Python. Now one thing to note here is the P is small and here the P is in capital letter. If I run it, it again gives me false because Python is case sensitive. Now if I make this as capital P, it will result in true. Let's say I want to say, instead of tutorial, let's say I have training. If I run it, it tells me false because this word training is not there in the string welcome to Python functions tutorial. I'll change this to tutorial. You see here I have my result as true. Alright. Now let's see how to use lambda functions using filter function. So we are going to filter a list of numbers using a specific condition. So I'll create a list called num. Let's say it has values 40, 10, 40, then we have 56, 27, let's say 33, 15 and 70. So this is my list. Now I am going to use my lambda function along with the filter function. So I'll pass in my variable as greater. I'll say list, then I'm going to pass in the filter function, and inside the filter function I'll use the lambda function, and I'll have my argument as num, and my expression, let's say I want to filter only those values which are greater than 30. So I'll say num greater than 30. This is my expression or the condition that we want to check. I'll give a comma and I'll have my next argument as num, and let's go ahead and print the variable greater. If I run this, there you go. You can see here we have all the values from the list or the numbers from the list that are greater than 30. So we have 40, 56, 33 and 70. So 10, 27 and 15 are less than 30, and hence those three values were not printed. Now let's say you want to filter a list of numbers that are divisible by 4. So I'll create another list called list1, and let's say I'll have the same values in the list. So I'll just copy it and I'll paste it here, and I'll create my variable, let's say divide. I'll say divide equal to list1. I'll use the filter function followed by the lambda function, I'll say x colon, then I'll have my expression x mod 4 should be equal to 0. I'll give a comma and pass in my next argument as my list 1. Now I'm going to say print divide. Okay, I'll remove the bracket here. There is no need of a bracket here. Cool. And we'll delete here as well. Now let's run it. Okay, there is one error here. This should be list 1. Let's run it again. Okay, there is some error. Let's debug it. Okay, so this should be the function list. Cool. There you go. So here you can see we have two numbers, 40 and 56, that are divisible by 4. The remaining numbers are not divisible by 4 and hence were not printed. Alright. Now let's go ahead and explore how you can use the map function along with the lambda function. So the map function accepts two arguments, a function and a list. It takes that function and applies it to every element of the list and returns the modified list. So we'll create a list called list2. I'll say equal to, and again we are going to have the same values in the list as above. So I'll just copy those values or the numbers and I'll paste it here. Okay, now let's say I want to find the value of a number multiplied by 2. So I'll say, let's say the variable name is double the num or double the number. I'm going to use the list function followed by the map function this time, and then we'll have our lambda function. I'll pass in my argument as x colon followed by the expression, so x multiplied by 2. I'll give a comma and then we'll have the list, that is list 2. There's a spelling mistake here. This should be list 2. Alright. Now I'm going to say print double underscore the underscore num. Make sure there is no space in the variable name. Now if I run it, you can see here we have multiplied every number in the list by 2. So 10 multiplied by 2 is 20, 40 multiplied by 2 is 80, similarly 30 multiplied by 2 is 66, 15 multiplied by 2 is 30, and again we have 70 multiplied by 2 is 140. So this is how you can use map function with lambda functions. Now suppose you want to find the power of a number. Let's say I want to find the power of a number raised to 3. So I'll create a list called list 3. Let's say I have values 2, 5, 10, 6, 4, and then let's say we have 12. I'll say cube. So I want to find the value of a number raised to the power 3. So for that I'm going to use the map function followed by the lambda function. I'll pass in my argument x, and then here I am going to use the inbuilt power function in Python. So POW, my argument x, and this x I want to raise it to the power of 3, and then I'll have my next argument, which is list underscore 3 or list 3. Okay, now let's print the list. So I'll say list of cube. I'll run it. You can see here, so 2 raised to the power 3 or 2 cube is 8, 5 cube is 125, 10 cube is 1000, 6 cube is 216, 4 cube is 64, and 12 cube is 1728. Now coming to the final section of the demo, where we'll see how to use the reduce function in Python along with the lambda function, and then we'll use a lambda function within a user-defined function. So first let's look at how to use reduce in Python. So reduce applies a rolling calculation to all items in a list. You can use it to calculate the total sum or to multiply all the numbers together. So reduce function is a part of functools module. So to use the reduce function, you need to import the functools module first. So I'll say from functools import my function, that is reduce, and then I'll say, let's say I have my list 4 this time. I'll create a list. I'm going to take the same values as above and I'll pass in within a list, and now I want to find the sum of all the numbers that are present inside this list called list 4. So I'll do that using my reduce function followed by the lambda function. So I'll say x comma, and I'll give my expression as y colon x plus y, give a comma and pass in my last argument, which is my list itself, which is list 4. Alright, and then I'll say print sum. Let's run it. There you go. So 2 plus 5 plus 10 plus 6 plus 4 plus 12 is 39. So this is how you can use the reduce function in Python. Suppose you wanted to find the product of all the numbers present inside the list, so you can just use the asterisk instead of the addition operator. Now if I run this, you have the product of all the numbers that were present inside the list, that is list 4. We have 28,800. Now let me show you the final demo, that is using a lambda function in a user-defined function. So first of all, I'll create a user-defined function to calculate the value of a quadratic equation. So for some of you who don't know the formula of quadratic equation, it is ax square plus bx plus c. So we are going to use that formula in our function and find the value using lambda function. So I'll create a user-defined function called quadratic, and it will have 3 arguments, a comma b comma c. I'll say return, and here in the return expression I'm going to pass in my lambda function. I'll say lambda x, which is my argument. I'll say x colon, and then I'll have my equation, which is a x square. So I'm saying a multiplied by x raised to the power 2. So I'm using double asterisk plus b multiplied by x. So this becomes ax square plus bx plus I have my constant, that is c. Now just go to the next line. I'm going to create a variable, let's say f. I'll have my user defined function name quadratic. I'll pass in the values for a, b and c. Let's say a is 2, b is 3 and c is, let's say, 5, and I'll call a of 1. The value of x is 1, the value of a is 2, the value of b is 3, and the value of c is 5. Now let's run it and see the result. So ax square plus bx plus c for a equal to 2, b equal to 3 and c equal to 5, the result is 10. Now let's change it to, let's say I want the value of x as 2. If I run it, you have the equation evaluated and the result is 19. Alright.
Now, a Python module is nothing but a simple Python file with .py extension, including the statements and the definitions. So basically, you need to prepare a module file with all the functions which you want to import into your regular Python code across all the modules. Now, it contains codes that you can reuse in several programs. So it's like saying you write once a piece of code like common utility methods, calculation methods, rounding off, addition, subtractions, or some common business rules which can be reused across your project. Then you keep it at one place. Now this helps in such a scenario where you have a large team, different set of developers are working on different modules, different specifications, but one single utility module file .py file will contains all the common and reusable functions which not each and every individual developer can will go and change. It's only few set of administrators or the senior developers can maintain and pass it on to the team. Now, for example, a file containing Python code demo.py is will be called as a module, and its module name would be demo. So you need to take care that whatever the name of the file is, that is what will get imported in your Python code. So we will see that with our certain examples on our Jupyter notebook. Now, why do we need to use, as I have reiterated, it provides flexibility to organize the code in a logical way, and it enables reusability, which is the most important factor. So one, of course, you can organize the code, you keep the reusable code at one place, or you can keep a modular approach and also reusable. So no, not all the developers have to go and rewrite that code, and it is easy to maintain and helps in debugging the code easily. So if you know that there is an error coming, there is an issue coming in one of the modules which is imported or which is lying in the common file, then it becomes easy to debug. You just have to go and check that particular function. You don't need to go and check in each and every piece of code. Now there are two types of Python modules. Definitely there are built-in modules which Python library provides, which you don't need to import explicitly. But there are certain user-defined modules which you create on yourself for your own custom development, for your own custom programming. So built-in modules are predefined modules and are part of this Python standard library. For example, random, datetime, sys. So we will take a look at these examples also. And of course, the user defined modules, which is the primary objective of this session, where we're going to show you how do you create your own defined modules and then import them. So the user creates the user defined modules to ease complex tasks in a project. So you program the complex piece of the code in a common module and give it to everyone. You can define your own functions and classes. Now, what are the different ways? There are 5 different ways you can import modules. So you can just say import module name, and all the classes and functions within that module will get imported. You can give an alias. So basically giving an alias makes it simple, and you can refer that alias throughout your code. Then if you want to import anything specific from the entire module, you don't want to import all the functions and classes, then you can just import the specific functions and classes and give their name. Then fourth is from module, you want to import any address as an alias. You can import and give an alias to the specific function name or the class name. And then of course, similar to the first syntax, you can module all everything. So first and the last syntax are almost having the same meaning to module to import everything in your module. Okay, so with this background, let's first take a look at the Python file. So what we have done is we have created a module calculations.py. So just please focus on the part where the name of the file is calculations. And in this Python file.py file, we have created a couple of functions and the relevant logic related to those functions. So very simple functions like addition, add. You pass two variables and you send the result, add the variables and send it back. Basically, we are overriding the Python internal operator add in our Python module, and we will be invoking this one. So we'll show you how to invoke. Then you will have, I have written multiplication, division, remainder. So you pass two variables, divide them and find the remainder. Then now a custom function where I'm adding 10 to both the variables which are being passed to this function and returning the result. Then there is a function which checks whether the number is a prime, and if it is not a prime number, you will get this output, and if it is, you will get a prime number. Okay. And then another function which says check anagram. So we will just sort the two strings which we will send and check both are equal or not. If both are equal, then the strings are anagrams, otherwise they are not. So these are the set of functions which we have written. Now we will see how will we use them in our code. Now, first syntax which I am writing is import calculations. So this is the name of my .py file which is residing in the same folder where I am writing this piece of code. And now if you see in my .py, I have a variable y whose value is 6. So I'm just using that value and running it and printing it. I'm just going to show you how explicitly I'm invoking the functions in the calculations class in the calculations.py file. Okay. Now let's invoke another function remainder passing 140, and then I should get 20 as an output. Okay, so this has gone back and executed this particular function. Now what I'm going to do is another example of my addition. I'm saying calculations.add. I'm going to initialize and pass two variables, and my expected output is 35. Okay, so it has gone and executed this function. Now I'm going to show you another syntax of importing. So from calculations, I'm just importing the add function. So I'll ask for user input to enter for 1 and 2 numbers, and then I'm just going to add it. Two and 5, so I got my output as 7. Now the difference to be noted over here is that in the previous syntax I was making a call like calculations.add, but now I don't need to make a calculations.add syntax invocation. I just need to say import add, and I just need to use the add function. That's all. Now let's use another syntax to import modules. So I'm using import calculations as cal. So all the modules are imported, but the alias uses cal. And similarly, like the previous example, I'm going to take two inputs and print the sum. Now the difference in this syntax and this syntax is I'm using the alias cal dot add, but my output should be same. Okay. Similarly, I can call prime, whether it's not a prime or prime number. I can call the check anagram using the same alias, and I can call the remainder function. Okay. So I hope you have noticed that the difference in importing, the way of importing the module makes a lot of difference, right? Now let's take another example of importing some functions or variables. So I'm going to I'm importing my variable y and functions multi, prime and check anagram explicitly. And I'm going to print y. Okay. And I'm going to multiply two numbers. So if you see, I'm using these aliases over here. Okay. I'm using these variables directly as I've already imported. Now I'm going to say prime 9 Now it's printing none. If you see, it's because of the statements which are not executed, right? So that's why you are seeing. Now let's check anagram. And now another thing to be noted is I'm trying to invoke a function remainder which I have not imported over here. So let's see what error Python throws. Okay, so yeah, so Python has throws an error that name remainder is not defined because I have not imported it over here. So now in order to import remainder, what I'm now doing different is importing all the functions. Now if I use remainder, it should run. Okay, I'm using divide. Okay, cool. Now I'm going to show you another function which is a utility function, directory function, which will show me all the functions, variables as part of the Python file: add, add 10, check anagram, divide, multi, prime, remainder, y. And of course, these are some inbuilt packages which are already there in the Python file as part of the Python loader. But these are the ones which I have created. So you can actually see the list of all those functions in one go. Okay. Now I'm going to show you an example of inbuilt modules. So this import math is an inbuilt module of Python, and I'm going to show you how you can see all the relevant functions within the math module. All these are the math module functions which are available for you to use. I'm going to show you one or two. So like print math 2 to the power 8 and you get the answer 256. Print math remainder. So I'm not invoking my module function. I'm invoking the math inbuilt library function remainder, and the remainder is 0. 40 divided by 2, remainder is 0. And square root of 81, 9. Then very important, another very interesting utilities of date time, which you can use, and you can print today's date and time. Then another utility is random utility, and I'm going to create a list L1 and write a piece of code which will choose a random element from this list and just print it. Okay, so if first time it has chosen Oppo, again if I run it, it will choose OnePlus. If I again run it, it might choose something else, so it will randomly pick. Okay, so with this we have seen that you can create your own utility functions, import it, write it in a piece of code .py file, import it in your code as an alias or all the modules and use them, or you can use the Python inbuilt modules, right? Today we are going to discuss how exception handling is done in Python. This concept is not new in any programming language. It is pretty prevalent in Java and other programming languages, and it's on the same lines how we can do exception handling in Python. So let's take a look what are the nuances and what are the syntaxes for exception handling in Python. So what are we going to discuss today? We are going to start with discussion of need of exception handling, what is exception handling, the types of errors you can handle in exception handling, and how exception handling works, and in the end, certain points to be remembered. And also we will support our slides with a Python Jupyter notebook examples. Now, what is the need for exception handling? Any programming language or any program you write, there is definitely a need in order to have a clean execution of the program, even if the program throws errors. So you need exception handling for cleanly logging the exceptions or throwing meaningful errors to the users. So when does exception occurs, right? Whenever the program gets terminated right? The program terminates whenever an error occurs, right? So it could happen that an error could be a fatal error and the program gets terminated in between, or there could be a sudden termination which can corrupt the program, right? So you need to handle exceptions, or there might be a data loss because of those exceptions, and you need to take care that that doesn't occur or the data loss does not happen. Or even if data loss happens, then you pass on a meaningful message, or you capture a meaningful message in the logs at the right point. Now, what is exception handling? An exception is a runtime error that terminates the execution of a program. So basically, whenever an exception occurs, the program gets terminated, you are thrown out of the running program. Exception handling means you generate a message in correspondence to the occurrence of the error and take the right step to handle it. So now an exception has occurred, but you need to handle it. Now, by handling, we mean that you need to throw a meaningful message, as I said earlier, and then you might need to navigate the program into the right direction or take some certain corrective actions in order to handle the error. So all that comes under the exception handling criteria. Now, in general, there are three types of errors: compile time errors, logical errors, and runtime errors. Now, compile time errors are the errors which any programming compiler or Python compiler will show you while you are compiling your program. So, it could be because of the syntax, spacing, indentation, or you are using wrong keywords. All those will get captured at the compile time. Logical errors, you have not used the correct syntax around logical operators like and or your if else conditions are incorrect and you are expecting an output, but it is not coming as per your expectations. So those are logical errors. And the most difficult ones to capture and track and handle are the runtime errors. So imagine your program is compiled and as per your expectation, you are expecting an output, you have written a logic, but at the runtime it does not get executed, it does not run as per your expectation, and the program gets terminated unexpectedly. So the runtime errors are the most critical and important in order to handle them. And if you talk about runtime errors handling in production scenarios, then it becomes very critical that you have handled the exceptions correctly and captured the logs correctly so that the team can point out where the error has exactly happened. Now, how exception handling works. There are certain syntaxes in Python which you need to follow. Now, you generally put the exception handling code, the code for which you want to handle the exception, under a try block. So you run that piece of code under a try block, and then you put an except keyword where you basically throw an error message. And then if there is no exception, right, then also you can handle the code. Okay, if there is no exception in my code, then how the code will behave, yeah, right? So it could be possible that there is a runtime error, but if there is no, then you might want to do some logical calculations, or you want to put something over there, you can put in the else block. And then finally is a code block which will always get executed irrespective of you had an exception in your code or not. So basically, generally, if you go by the legacy programming, if you have opened a database connection, or if you have opened a file and it is essential to close those connections from your program, then those close connection code are written generally in the finally block, irrespective of the exception coming. You need to close those connections, otherwise you will run out of your connection pools. Now it's a pretty straightforward flowchart of an exception and handling. You start with a try block, and then if an exception occurs in your code, then it will go to the except block. Otherwise, it will go in the else section. And then finally, you have the finally block where the code will finally get executed and stop. So as I said, you put that piece of code in the finally block, which is mandatory, and generally the block, the code which is essential to release the resources which the program has consumed, the CPU resources, the memory resources, hardware resources which the program is using, you have to release that in the finally block. Except block you have to use for capturing the error and throw a meaningful message or do any other logical operation, and else block if you want to continue your program as is. Now, what are the points to remember? These are very important points which you should consider. You can write a try block without any except block. So it's not essential that you put a except block always, or you can write several except blocks for a single try. You might be expecting a null pointer exception or a divide by zero exception or a incorrect variable naming exception. So you can start off with one try, but you can have different except blocks to capture these different kind of exceptions and throw a relevant meaningful error per except block. Also, you can write multiple except blocks to handle multiple exceptions. It's almost the same thing. And you can write exception as an object. You can also print or capture an exception as an object, or you can write multiple exceptions within a tuple. You can capture the multiple exceptions, add it to a tuple and throw it away. Okay, so now let's take a look at certain examples which we want to run in order for better understanding of exception handling. Now, throughout my exercise, I am going to focus on divide by zero error, which we are easily able to simulate. So I'm going to mostly show you how we can capture a divide by zero error. Okay, so I have declared a variable a and I have declared a variable b, a as 10, b as 0. Now I'm trying to divide a by b. Now I'm trying to divide a number with 0. So ideally, yes, this is not a correct mathematical operation. Divide by number 0 is not allowed. So I should get a zero division error. Now this is an unhandled exception. My program has not handled it properly, so that's why you're getting this error on the trace of the Python trace. But if I handle it properly, then I can very cleanly throw this error and capture this error. Okay, so I am going to take input in B, enter A and B, and I'm just going to print a generic except block. So 10, 0, and I have got an exception and I have printed it. Now there is no stack trace, there is no trace, but at least I am able to cleanly throw an error, a meaningful error. Now again, I'm differently going to handle the exception. I'm going to create the same exception, but going to handle it differently. Now there's a try block. Now I am writing an except block to capture the specific exception, zero division error exception. In the earlier code block, I had just written except, so any exception would have come to this block. But in this except block, only zero division error will be captured. So as you can see, I cleanly handled the exception. Of course, I gave the name except zero division error, and then my code got executed later on. Now, in another example, what I'm going to do is I'm going to show you that if my code runs cleanly, then it's not necessary my except block will get executed. Definitely, because if there is no error, then the except block will remain redundant. Now here you see what I have done is I've taken genuine two numbers, divided them, printed a new line, and then completed. So as there was no exception, the exception block did not got executed. So the point to be highlighted over here is that it is not essential that exception block will get executed always. It will only come into picture when there is a relevant exception getting generated. Now let's take an example of how we can print an exception object. So I'm going to take my previous code, and here I am capturing the exception but also printing the exception object. So what has happened is I have printed the exception of a message, a custom message, plus I have printed the exception object. Okay. Now I'm going to take the same example, but I'm not gonna generate an exception. So my exception block did not got executed, and I was able to simply print Simplilearn. Now let's take another example where I am capturing my exception in a variable. So do not divide number by 0, and in this I have captured my exception division by 0. So in the exception, the Python generated exception name is this, and I have printed over here. So division by 0 is the Python generated exception which I have appended in the print command. Now I'm going to take another example where I'm saying is that I will print exception as A, plus I'm going to also capture another exception. So it's like one try and two exceptions. So one exception is do not divide number by 0, and second exception is name Z is not defined, right? So as I said earlier, you can have one try but two except blocks, which is permissible. Now one thing is that this exception print A by Z went through both the except blocks, except this exception and this exception, though this exception is not divide by 0 error. So therefore in this A variable nothing came in, but in the B variable the name error was definitely captured because it's a name undefined, name Z is not defined error, and that's why you can see that do not divide number by 0. After that we do not have any relevant meaningful message. Okay, now let's take another example where we are going to have two except blocks, and out of these two only one will get executed. Okay, so there is no type error exception, so that except block did not got executed, but only 0 division error is there, so only that got printed. Now you can explicitly also raise an exception. It's not like you just have to wait for a runtime exception. You can also raise an exception from your code and execute it. So if you see this, what we have done is just created a variable with a negative value and just checking that if the value is less than 0, then raise an exception. So that's what we have done. Similarly, you can also raise an assertion error. It is called assert, and you can run this message. You can throw this message compatible with Linux only.
So first we'll see what are Python libraries, and before we delve into the details, let's understand about it. In Python, libraries are sets of pre-written code that provide various functionalities, making it easier for us to perform tasks without having to reinvent the wheel. They are like toolboxes filled with functions and modules designed to handle specific tasks such as data manipulation, visualization, web scraping, and much more. And now we'll see some of the essential built-in libraries. That is, Python comes with a rich collection of built-in libraries that provide fundamental functionalities. Here are some essential ones you need to know. The first is Math Library. This library is essential for mathematical operations, including complex arithmetic, trigonometry, and more. Then, Datetime Library. It allows you to work with dates, times, and time intervals, making it handy for various applications. Then we have String Library. This library offers a wide range of string manipulation functions, making working with text a breeze. Then we have Random Library. Need random number generation or shuffling? The Random Library has got you covered. Then we have Data Manipulation Libraries. Data manipulation is a crucial part of any Python project, especially in data analysis and machine learning. Here are some powerful libraries for data manipulation. The first is NumPy, short for Numerical Python. This library provides support for large multi-dimensional arrays and matrices, along with high-level mathematical functions to operate on these arrays efficiently. Then we have Pandas. Pandas is the Go library for data manipulation and analysis. It offers data structures like data frames and series, making data handling and cleaning a breeze. Then we have data visualization libraries. Presenting data visually is key to understanding patterns and insights. Here are two popular data visualization libraries. The first is Matplotlib. This library provides a flexible and comprehensive set of plotting tools for creating static, interactive, and animated visualizations in Python. Then we have Seaborn. Built on top of Matplotlib, Seaborn offers a high-level interface for creating stunning statistical graphics. Then we have web scraping libraries. Web scraping is a technique used to extract data from websites. These libraries help you gather data from the web effectively. The first is Request. This library allows you to send HTTP requests effortlessly, making it easy to fetch web pages. Then we have Beautiful Soup. Beautiful Soup helps parse HTML and XML documents, extracting valuable data from web pages. Then we have machine learning libraries. Machine learning is an exciting field and Python has some fantastic libraries for it. The first is Scikit-learn. This is a powerful library that provides simple and efficient tools for data mining and data analysis. It's great for implementing machine learning algorithms. Then we have TensorFlow and Keras. If deep learning is your thing, TensorFlow and Keras are your go-to libraries. They are widely used for building and training neural networks. And after this, we have GUI development libraries. Creating graphical user interfaces is made easier with these libraries. The first is Kinter. Kinter is Python's standard GUI library, simple to use and allows you to create basic windows, dialogues, and buttons. Then we have PyQt and PySide. These libraries offer more advanced GUI capabilities and are perfect for building complex desktop applications. And before we start with all the Python libraries, now over to our training experts.
Python is the most widely used programming language today. When it comes to solving data science tasks and challenges, Python never ceases to surprise its users. Most data scientists are already leveraging the power of Python programming every day. It's an easy to learn, easy to debug, widely used, object-oriented, open source, high-performance language. And there are many more benefits of Python programming. Python has been built with extraordinary libraries for data science that are used by programmers every day in solving problems. Master Python and other core data science topics to help you kickstart your data journey with a professional certificate program delivered in partnership with Purdue University and IBM. This data science certification features masterclasses by Purdue faculty and IBM experts, exclusive hackathons, and AMA sessions by IBM experts. This course covers tools and techniques like NumPy, Pandas, Python, and SciPy, along with industry projects like Uber Transport Service Provider, Amazon e-commerce, and retail in Walmart. Choosing this course can get you hired in renowned companies like Netflix, Amazon, Facebook, Adobe, and average salary hike of 70%. So what are you waiting for? Join the Data Science Professional Certificate Program and excel your career in data science. The link is in the description box below.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now, before talking about top Python libraries, let's take a look at what a library is. Python has produced a number of open source libraries, each with its own root source. A library is a previously combined set of code scripts that may be utilized iteratively to save time. Now, in contrast to languages such as C++ or C, Python libraries are not context specific. Now, a library in this context refers to a collection of essential components. A library is a collection of modules that can be installed with the help of a package manager such as pip. Now that we know what libraries are, let's take a closer look at some of the most popular libraries in Python. First on the list, we have NumPy. NumPy is an open source Python library used for scientific computing and data analysis. It provides powerful numerical and mathematical functions that enable efficient computation of large multi-dimensional arrays and matrices. NumPy is an essential library for data manipulation and analysis in fields such as machine learning, image processing, and scientific computing. Now, some of the key features of NumPy include multi-dimensional arrays. NumPy provides a powerful n-dimensional array object that can be used to store and manipulate large datasets. Mathematical functions. NumPy provides a wide range of mathematical functions that can be applied to arrays and matrices as well, including linear algebra, Fourier transforms, and random number generation. NumPy is widely used library in the data science and machine learning communities and is often used in conjunction with other libraries like Pandas, Scikit-learn, and TensorFlow. Second on the list, we have Pandas. Pandas is an open source data manipulation and analysis library for the Python programming language. It provides easy to use data structures and data analysis tools for handling and manipulating structured data. Pandas provides two main data structures. One is series and other one is data frame. Now, a series is a one-dimensional labeled array that can hold any data type, while a data frame is a two-dimensional labeled data structure with columns and potentially of different data types. Some of the key features of Pandas include data cleaning. Pandas provide tools for cleaning, filtering, and transforming data, such as filling missing values, removing duplicates, and replacing values. Data manipulation. Pandas provide powerful tools for manipulating data, such as grouping, merging, and reshaping data. Integration with other libraries. Pandas integrate with other popular libraries such as NumPy, SciPy, and Scikit-learn to provide a complete data analysis and machine learning environment. Pandas is widely used in data science and analysis and are particularly useful for working with tabular data such as data in CSV and Excel files. Next on the list, we have Matplotlib. Matplotlib is a Python library used for data visualization. It provides a wide range of tools for creating graphs, plots, charts, and other visual representation of data. It is a highly customizable library that allows you to control every aspect of visualization you create. You can customize the style, color, size, appearance of elements such as lines, markers, axes, titles, and legends. It also offers several types of plots including line plots, scatter plots, bar plots, histogram plots, pie chart, and many more. Matplotlib is built on top of NumPy, which makes it easy to work with arrays and other numerical data. Matplotlib also integrates well with other Python libraries such as Pandas for data manipulation, SciPy for scientific computing, and Seaborn for statistical data visualization. Fourth on the list, we have Scikit-learn. Scikit-learn, also known as sklearn, is a popular open source machine learning library for Python. It provides a wide range of algorithms and tools for building and evaluating machine learning models. Scikit-learn is built on top of NumPy, SciPy, and Matplotlib, which makes it easy to integrate with other scientific computing libraries in Python. It provides a comprehensive set of tools for various machine learning tasks such as classification, regression, clustering, dimensionality reduction, model selection, and pre-processing. It also includes popular algorithms such as decision trees, random forest, support vector machines, logistic regression, k-nearest neighbors, and many more. Scikit-learn provides a consistent API for all algorithms, making it easy to switch between different models and algorithms. Scikit-learn also provides a wide range of pre-processing tools for cleaning and transforming data, such as scaling, normalization, and feature extraction. Fifth on the list, we have Scrappy. The next known Python libraries for data science is Scrappy. Scrappy is one of the most popular, fast, open-source web crawling framework written in Python. It is commonly used to extract data from web pages with the help of selectors based on XPath. And talking about its application, Scrappy helps in building crawling programs that can retrieve structured data from the web. Scrappy is also used to gather data from APIs and follow a don't repeat yourself principle in the design of its interface, influencing users to write universal codes that can be reused for building and scaling large crawlers. Sixth on the list, we have Keras. Similar to TensorFlow, Keras is another popular library that is used extensively for deep learning and neural network modules. Keras supports both TensorFlow and Theano backends, so it is a good option if you don't want to dive into the details of TensorFlow. Talking about its features, Keras provides vast pre-labeled datasets which can be used to directly import and load. It contains various implemented layers and parameters that can be used for construction, configuration, training, and evaluation of neural networks. Next in the list of top Python libraries for data science is PyTorch, which is a Python-based scientific computing package that uses the power of graphics processing units. PyTorch is one of the most commonly used preferred deep learning research platforms built to provide maximum flexibility and speed. Talking about its application, PyTorch is famous for providing two of the most high-level features. First one is tensor computations with strong GPU acceleration support and building deep neural networks on a tape-based autograd system. Eighth on the list, we have Beautiful Soup. Beautiful Soup is the next Python library for data science. This is another popular Python library, most commonly known for web crawling and data scraping. Users can collect data that's available on some website without a proper CSV or API. And Beautiful Soup can also help them scrape it and arrange it into required format. Now, Beautiful Soup is widely used in web scraping applications and is considered as one of the most popular and powerful web scraping tool available in Python ecosystem. Next on the list, we have Pygame. Pygame is a set of Python modules designed for writing video games. It provides functionality for working with graphics, sound, and user input, as well as tools for handling events and timing. Now, Python game is built on top of the SDL library, which provides a low-level interface for accessing hardware and input devices. Some of the features provided by Pygame include support for 2D graphics, rendering, including image loading and manipulation, sprite handling, and drawing primitives. Support for playing sounds and music, including playback control and volume adjustment. Support for handling user input, including keyboard, mouse, and joystick events. Pygame is often used for prototyping and developing small to medium-sized games, as well as for educational purposes. Its ease of use and flexibility makes it a popular choice for game development beginners and hobbyists. And finally on the list, we have Theano. Theano is a Python library for numerical computation designed for deep learning and machine learning applications. It allows users to define, optimize, and gauge mathematical expressions, which includes multidimensional arrays, the fundamental building blocks of many machine learning algorithms. Now, talking about features, Theano is designed to efficiently perform numerical computations on both CPU and GPU, which can significantly speed up the training and testing of machine learning models. Theano provides automatic differentiation functionality, making it easy to compute gradients and optimize parameters while training machine learning models. And some of its applications are scientific computing, simulation, optimization, and deep learning. In addition to these top 10 Python libraries for 2023, there are many other helpful Python libraries, ones that deserve to be looked at.
If you're interested in learning and mastering data science with Python, head on to Simplilearn's professional certificate program in data science. Do explore the frequently asked data science interview questions and unlock your career as a data scientist.
Python GUI frameworks. The first question that should arise in your mind should be why to use Python GUI frameworks. Python GUI frameworks are used to create graphical user interface for applications. GUIs make it easy for users to interact with an application and they are a critical component of modern software. There are several reasons to use Python GUI frameworks for building GUI applications. The first reason is cross-platform support. Python GUI frameworks are often cross-platform, which means that they can run on multiple operating systems, including Windows, macOS, and Linux. This makes it easy to build applications that can be used by a wider audience without having to create separate versions for different platforms. Second is rapid development. Python GUI frameworks can speed up the development process of building GUI applications. Many frameworks comes with pre-built widgets such as buttons and text boxes that can be easily customized and incorporated into an application. This can reduce development time and allow developers to focus on the functionality of the application. Third, easy to learn. Python is a popular programming language that is known for its simplicity and ease of use. Many Python GUI frameworks are also easy to learn and have extensive documentation and tutorials. This makes it easy for beginners to get started with building GUI applications. And the fourth is large community. Python has a large and active community of developers who create and maintain GUI frameworks. This means that there are many resources available, such as forums and libraries that can help developers solve problems and add new features to their applications. And the next feature is integration with Python libraries. Python GUI frameworks can integrate with other Python libraries, which makes it easy to add functionality to an application. For example, a developer can use a GUI framework to create a user interface for a data analysis application and integrate it with a data analysis library like NumPy or Pandas. In summary, Python GUI frameworks provide cross-platform support, speed up development time, and easy to learn, and have a large community and can integrate with other Python libraries. These benefits make Python GUI frameworks an excellent choice for building modern applications. Now, we'll explore some of the popular GUI frameworks. There are numerous GUI frameworks available for Python, each with its own advantages and disadvantages. We will start with Kinter. Kinter is a Python library for creating graphical user interfaces that is included in the standard library. It provides a set of tools and widgets for building applications with a graphical user interface and is based on the TK GUI toolkit, which was originally developed for the TCL programming language. Kinter provides a wide range of GUI components including buttons, labels, text boxes, menus, list boxes, checkboxes, radio buttons, and more. These components can be used to build complex user interfaces with multiple windows, dialogues, and panels. One of the key features of Kinter is event-driven programming model. When a user interacts with the Kinter application, events are generated by the user's actions, such as clicking a button or selecting an item from a list. These events are then handled by the application code, which can update the user interface or perform other tasks in response. Kinter also provides support for creating custom widgets and dialogues, as well as for drawing graphics and animations using the Canvas widget. Additionally, Kinter can be extended with third-party libraries and modules, such as Matplotlib for plotting data and Pillow for image processing. And if we talk about the advantages, the first advantage is it is easy to learn and use. The second is cross-platform. And the third is it has large community and has many resources available. And now we'll talk about some of the disadvantages. So the first disadvantage is default look and feel is not modern. The second is limited set of widgets. And the third is does not support threading. Now, we have our second GUI framework, that is PyQt. PyQt is a Python binding for the Qt GUI framework, which is a popular and powerful cross-platform GUI toolkit that provides a comprehensive set of widgets and tools for creating modern and responsive desktop and mobile applications. PyQt allows developers to use Python to create Qt-based applications and user interface with ease. PyQt is distributed under the GPL and commercial licenses, which makes it suitable for both open source and commercial development. It provides a wide range of modules that cover everything from basic GUI programming to advanced multimedia, network, and database functionality. Here are some of the key features of PyQt. The first feature is cross-platform support. PyQt supports multiple platforms including Windows, Mac OS, Linux, and mobile platforms like Android and iOS. Second is easy to use. PyQt is easy to learn and use, especially for developers familiar with Python. Its API is well documented and provides a high level of abstraction that simplifies GUI development. Third is rich set of widgets. PyQt provides a wide range of widgets and tools that allows developers to create advanced and modern GUIs. Some of these widgets include buttons, labels, text boxes, tables, menus, and many more. The fourth is customizable styles. PyQt allows developers to customize the appearance and behavior of widgets using style sheets. This makes it possible to create unique and visually appealing user interfaces. Signals and slots. PyQt uses a signals and slots mechanism to handle events and communication between widgets. This mechanism allows developers to create complex interactions between widgets with minimal code. Now we'll talk about the advantages of PyQt. The first advantage is modern and customizable look and feel. And the second advantage is large set of widgets and tools. The third is well documented with many resources available. And if we talk about the disadvantages, it has the steep learning curve. And the second disadvantage is not as lightweight and fast as some other frameworks. Third is requires licensing for commercial use. And the third GUI framework is Kiwi. Kiwi is an open source Python GUI framework designed for building multi-touch applications and user interfaces. It allows developers to create cross-platform applications that can run on Windows, macOS, and Linux. Kiwi is based on a natural user interface and uses a graphic engine to render user interface that are touch-enabled. This makes it ideal for creating applications that use touch, gestures, and other forms of natural user interaction. One of the key benefits of using Kiwi is that it enables rapid development and prototyping. It has a straightforward syntax that is easy to learn, and it supports a wide range of widgets and UI elements. Developers can use Kiwi to create rich, interactive applications that incorporate multimedia, graphics, and animations. Kiwi also includes support for a wide range of input devices including touchscreen, mouse, and keyboard. It also includes support for multi-touch gestures such as pinch to zoom, swipe, and rotate. Kiwi is built on top of OpenGL, which provides hardware acceleration for the graphics engine. This means that Kiwi applications can be highly performant and responsive, even when running on low-power devices. In summary, Kiwi is a powerful GUI framework for building multi-touch applications and user interfaces. It is easy to learn, supports a wide range of input devices, and enables rapid development and prototyping. Its use of OpenGL provides hardware acceleration and high performance, making it an excellent choice for developing cross-platform applications. Now, talking about the advantages of Kiwi, the first advantage is it is designed for building modern and dynamic user interfaces. The second is easy to use with a large community. The third is cross-platform and runs on Windows, macOS, Linux, iOS, and Android. And now talking about the disadvantages. The first disadvantage is not as widely used as some other frameworks. The second disadvantage is widget set is not as extensive as some other frameworks. And the third disadvantage is some performance issues on older hardware. And our next GUI framework is PySide. PySide is a GUI framework for Python. It is a set of Python bindings for the Qt application framework and runs on all major platforms including Windows, macOS, Linux, and mobile platforms such as Android and iOS. PySide allows Python developers to create sophisticated and interactive graphical user interfaces for their applications with ease. It provides a rich set of libraries, widgets, and tools that allow developers to create applications with complex and intuitive user interfaces. The framework includes a number of features such as the first feature is cross-platform support. PySide is designed to work on all major platforms, so developers can write code once and deploy it on multiple platforms. The second is high performance. PySide applications are fast and responsive, even when dealing with large datasets or complex visualizations. And the third feature is extensive widget library. PySide provides a rich set of widgets including buttons, labels, text boxes, sliders, and many more that can be easily customized and arranged to create intuitive user interfaces. And the next is easy to use designer tools. PySide includes a visual designer tool that allows developers to drag and drop widgets onto a form and then customize their properties, styles, and behaviors. And the next feature is MVC architecture. PySide follows the Model View Controller MVC architecture, which helps developers separate the user interface from the application logic, making it easier to manage and maintain code. And the next feature is support for internationalization. PySide provides built-in support for internationalization, allowing developers to create applications that can be localized to different languages and regions. In summary, PySide is a powerful and flexible GUI framework for Python that provides a rich set of libraries, tools, and widgets for creating sophisticated and interactive user interfaces on multiple platforms. And talking about its advantages, the first advantage is it has similar set of widgets and tools as PyQt. The second is LGPL licensed, and the third is cross-platform. Now talking about the disadvantages, the first disadvantage is smaller community than PyQt. The next is less documentation and resources, and the third is some performance issues on older hardware. Now we have our next GUI framework, that is WXPython. WXPython is a popular open source GUI framework for Python programming language. It is a wrapper around the C++ based WX widgets library that provides a native look and feel to GUI applications across different platforms like Windows, Linux, and macOS. WXPython is a cross-platform toolkit, which means that you can create GUI applications that can run on different operating systems. It provides a wide range of widgets that can be used to create complex GUI applications, and some of commonly used widgets include buttons, text boxes, checkboxes, radio buttons, list boxes, and combo boxes. Additionally, it also supports creating custom widgets to suit specific needs. Now we'll talk about some of the features of WX Python. The first is native look and feel. WX Python provides a native look and feel to GUI applications across different platforms. It supports the standard look and feel of each operating system. The second feature is object-oriented. WX Python follows the object-oriented approach, which makes it easier to write and maintain code. And the next feature is event-driven. WX Python follows an event-driven programming model, which means that the code is executed in response to user events such as button clicks or key presses. The next feature is customizable. WX Python allows you to create custom widgets, dialogues, and frames to suit specific needs. And the next feature is extensive documentation. WX Python has extensive documentation including API references and tutorials. And the next feature is rich set of widgets. WX Python provides a rich set of widgets that can be used to create complex GUI applications. Now talking about the advantages of WX Python. The first advantage is native look and feel on all platforms. The next is large set of widgets and tools. And the next one is easy to use with a large community. And now we'll talk about the disadvantages of WX Python. The first is not as lightweight as some other frameworks. The next is documentation is not as extensive as other frameworks. And the third is widget set is not as modern as other frameworks. PyGTK is a Python binding for popular GUI toolkit GTK, which is used to create graphical applications for desktop environments. PyGTK provides a set of Python modules that allow developers to create GUI applications in Python programming language. GTK provides a set of widgets that can be used to create user interfaces such as buttons, labels, text boxes, sliders, and menus. These widgets can be combined to create more complex interfaces. PyGTK also includes support for event handling, which allows developers to respond to user input such as mouse clicks and key presses. Event handling is done through callbacks, which are functions that are called when an event occurs. Another important feature of PyGTK is its support for internationalization. PyGTK provides tools for translating applications into different languages and for displaying text in the appropriate language. It is based on users' locale. PyGTK also provides support for theming, which allows developers to change the look and feel of an application by changing the visual styles of the widgets. PyGTK applications can be run on multiple platforms including Linux, Windows, and macOS. The GTK toolkit and PyGTK library are both open source software and are freely available for anyone to use and modify. Overall, PyGTK is a powerful GUI framework that allows developers to create rich graphical applications with Python. Its ease of use, flexibility, and cross-platform support make it a popular choice for developers to develop desktop applications. Now we'll talk about the advantages of PyGTK. The first is native look and feel on Linux and Unix-based systems. The second is easy to use with a large community. And the third is large set of widgets and tools. Now we'll talk about the disadvantages of PyGTK library. The first disadvantage is limited cross-platform support. The second is limited set of widgets compared to some other frameworks. And the third is documentation is not as extensive as other frameworks. Now we have our next GUI framework, that is PyForms. PyForms is a Python-based GUI framework for creating desktop applications with minimal effort. It is a powerful and flexible tool that simplifies the process of creating graphical interfaces for data management and visualization. PyForms offers a range of features that make it an excellent choice for developers looking to create desktop applications quickly and efficiently. Some of these features include: the first is cross-platform support. PyForms is compatible with multiple platforms including Windows, Linux, and macOS. PyForms offer a drag-and-drop GUI builder that enables developers to create user interfaces quickly without writing code. And the third is customizable widgets. PyForms includes a wide range of customizable widgets that developers can use to create advanced graphical interfaces. And the next is MVC architecture. PyForms follows the model view controller architecture pattern, which separates the user interface logic from the data management and application logic. The next feature is data visualization tools. PyForms include powerful data visualization tools that make it easy to create charts, graphs, and other visual representation of data. And the next feature is multi-language support. PyForms support multiple language supports including English, French, and Spanish, which makes it a popular choice for international developers team. And the next feature is built-in testing tools. PyForms include built-in testing tools that enable developers to test their applications easily. And the next feature we have is active community. PyForms has an active community of developers who contribute to the framework and provide support through forums and other channels. PyForms is a great choice for developers looking to create desktop applications with minimal effort. Its cross-platform support, drag-and-drop GUI builder, customizable widgets, MVC architecture, data visualization tools, multiple language support, built-in testing tools, and active community make it a powerful and flexible tool for creating desktop applications. Now, if we talk about its advantages, the first advantage is easy to use with a modern look and feel. The second is large set of widgets and tools. The third is cross-platform. Now, if we talk about its disadvantages, the first disadvantage is smaller community than some other frameworks. The second is less documentation and resources than other frameworks. Overall, each of these libraries has its own strengths and weaknesses, so it's important to choose the one that best fits your needs and skill set. Long story short, the best GUI framework for you depends on your needs. For absolute beginners, PySimple GUI is a great starting point, while those looking for more advanced features might prefer WXPython or PyQt5. If you need a touchscreen UI, Kiwi is recommended, and for form-driven applications, PyForm is a good choice. If you are still using Python 2, you can try PyGUI, PySide2 or WXPython, but you should be aware that Python 2 is no longer supported.
This session will introduce you to the tkinter module, its widgets, and their uses. After that, using these widgets, we will create a dollar to rupee converter. I will move to C drive, and in Python projects, I will create a folder with the name tkinter tutorial, and inside I will open the command prompt and write the command code space period and press enter to open my IDE. That is, I'm using the Visual Studio Code. You can use any IDE you want or you have your hands on. So now we will make a file and name it as tt.py. You would be amazed to know that there are various GUI frameworks for Python, but only tkinter is included in the standard library. That is, if you install the Python, it would come along with that only. You don't need to install it again or write any command to install it again. And tkinter has a number of advantages. The same code runs on Windows, Mac OS, and Linux since it is cross-platform oriented. And in contrast to other frameworks, tkinter is lightweight and generally simple to use. This makes it an appealing option for creating GUI apps in Python. So starting with, first we will import tkinter module. For that we will write the command import tkinter, and we'll use an alias here and we'll import it as tk. So first we need to create a tkinter window, and we will add a single widget in that and show you guys how we'll create that window. So first you will get your Python IDE open and just import the tkinter module as we have imported here. And now to make the window, we'll write a command window equal to tk, what we have imported, and we'll write tk and enclosed circle brackets. Here window is an instance of tkinter's tk class. Now we will create a new window and assign it to the variable window. So this is the tk class. Now when we write window.main loop, so it will repeat the loop, and when we add widgets in it, it will keep on repeating and it will show you the window with all the widgets. So first we'll save this file and run it. You can see that we have the tkinter window here. So this is how you create a tkinter window. Now moving on. Now we will set the title for the tkinter window. I will show you again as it was showing tk. It's showing tk. So we will change the title for the tkinter window, and to change that we'll write a command window dot title, and in the circular brackets we will write the title we want for a tkinter window, I will write Simplilearn tkinter tutorial. So yeah, I will save this and run this file for you guys. So you can see that it has shown the title. So we'll just stretch it and you can see the title here. So we can stretch the tkinter window till we have not set the resizable method false. If we set it as false or 0, it would not be able to stretch the tkinter window as we are able to stretch it now. So this arrow, it won't be available after we set it as false. Now moving on, after setting the title, now we will set the geometry. That means the dimensions for the tkinter window. For that we'll use the geometry method, and it's a fundamental method which decides the size, position and some other attributes of the screen layout we are going to create. So for that we'll write a command window dot geometry, and inside you could write the dimensions. First we will set the width, that is x-axis. We'll set it as 600 pixels. Then we'll write small x. Then the y-axis or the height of the window, we'll set it as 500. And after that we will add plus. What this indicates is 290 pixels. That is, the window will appear on the screen 290 pixels from the x-axis. And for y-axis, we will add 10. So it would appear 10 pixels from the y-axis. So we'll save this and run it. You could see that 290 pixels from the x-axis and 10 pixels from the y-axis. And we've set the geometry, that is 600 pixels, that is the width or the x-axis, and 500, that is the y-axis, the height. So now moving on, now we have created the window. Now we'll add a widget and show you guys how we add a widget. Before that, let us know what kind of widgets we have in tkinter. So in this tutorial we will be learning around 5 widgets. So we will start with label. And label, it's a widget that is used to display text on the tkinter window or your screen. And next we would be having the button widget that can contain text and can perform an action when clicked. It could have any action or it could have just a text without any action. Then we will have the entry widget. It's used to get any entry from the user or a single line of text. It also get multi lines of text. For that we have to set other attributes. And next we would be seeing the frame. So a frame, it's a rectangular region used to group related widgets or provide padding between widgets. So these are the 5 widgets that we would be learning. So I counted you 4, but here you will learn other widgets that would be canvas, and you would see the photo image object and other things. So moving on, we'll use many widgets. First, we'll create a single widget and show you guys how we'll create it, and we'll start with the label widget. So for that, we will call the label class for that, and I will set you greeting for you guys. So greeting equal to label. So here we will use tk.label class to add some text to a window. We will create a label widget with the text hello learners, welcome to tkinter tutorial, and assign it to a variable greeting as we have started assigning it. And the window you created earlier doesn't change. you just create a label widget, but you haven't added it to the window yet. There's several ways to add widgets to a window. Right now, we can use the label widget, and then we'll use the grid method or the pack method or the place method to show that widget on your window screen or on the Tkinter window. So starting with creating the widget, now we'll set the text for it, and text that would be equal to hello learners and welcome to Tkinter tutorial. And by the way guys, some people call it as Kinter, I call it as Tkinter, and many call it as TK Inter. So you guys can pronounce it at any way. Okay, so welcome to Tkinter tutorial. Now, here we will use the place method. So for that, we'll use greeting dot place, and here we'll use tk dot label, and we will place it at here. We will assign the coordinates as we have created a window with x-axis and y-axis. Here we will assign our x coordinate as 190 and y coordinate as 210. As we have the window, and in that we have x-axis at full length of 600 and y-axis with 500. So we are placing it at 190 and at y-axis at 210. And similarly with the place widget, we have like Tkinter has 3 built-in layout managers that use geometric methods to position widgets in an application frame. First we have pack widget that organizes widgets in horizontal and vertical boxes that are limited to left, right, top, bottom positions and many other positions. Each box is offset and relative to each other. And here we are using the place. So place places widgets in a two-dimensional grid using x and y absolute coordinates. Then we have the grid. So grid method locates widgets in a two-dimensional grid using row and column absolute coordinates. One thing is important when you use this pack, place or grid, you should not be combined these all in the same master window. Instead, choose one and stick with it. Further, you will know why we should stick with one only. So here we have created a label and placed it in a variable greeting. So we'll save this and run the window. You can see that the Tkinter window has appeared, and we can see the text that is placed on a label, and the text says hello learners, welcome to the Tkinter tutorial. Now moving on, we will comment this, and now we will add some functionalities to the label widget only. So for that we will create label, and here we'll not assign it to any variable. Like we will assign it to a variable and name it as label only. Tk dot label, and this would be capital for label, and inside we'll add the text, and that would be same, that would be hello learners, welcome to Tkinter tutorial. After setting the text for our label, here we can set the foreground and the background color. So for that we will write fg, that is foreground, and that would be equal to white color. and we'll set the background for the label as green. For that, we'll write the command bg equal to green. And now to get this label showed on your Tkinter window, you have to use any of the three methods, that is pack, place or grid. So now we will use the place method only. So first we'll write the variable name, that is label, and the place method, and inside we'll set the coordinates, that is x equal to 190 and y equal to 210. Now we'll save this and run the file for you guys. You can see that the label has got the background color as green and the foreground color for text as white. So now moving on, we can add other attributes to the label widget, and that would be the width and the height. So for that, we'll write width, that would be equal to 30, and height we'll set it as 10. So now we'll save this and run the file again. You can see that it has expanded itself. So we have set the width equal to 30, that is the x-axis. It has expanded to 30 pixels and height equal to 10 pixels. So I have told you that label widgets are used to display text or images, and the text displayed by a label widget can't be edited by the user. It's for display purpose only. Label widgets display text with the default system text color and the default text background color. These are typically black and white, respectively, but you may see different colors if you have changed these settings in your operating system. And you can control label text and background colors using the foreground and background parameters, as we have seen that. So moving on, as you have set the color with the words here, you could also set them with the hexacode. So to set them with the hexacode, you could just write the hexacode for the color, and here I will use this purple color, or what there would be a specific, like the dark blue, magenta, what you call this color. So I will save this and run it for you guys. First I will close this. So here you can see that I have set the color with the hexacode, and like the text, it's coming out of the width. So for that, we'll set the width as 50. Oh, I will set it as 500. Set as 50. Close the previous window, save the file, and run it again. Here you can see that we have set the width as 50 and y-axis, that is height, as 10. So moving on, we will start with button widgets. So we'll close this Tkinter window and command down this. Now we'll start with button widget. So button widgets are used to display clickable buttons. Like there would be text and those buttons would be clickable. You can configure them to call a function whenever they are clicked. And in many ways, a button is just a label that you can click. So as we have set the height and width for the label, we can set it with the same parameters. And the difference is you can just click, and that turns out to be a button widget. So to make the button widget, We will start with variable, and to set the button we'll use tk.button, and inside we will set the text that would be click me to say hi. So when you click it, I will have to set a function to get its functionality. So click me to say hi. So this would be the text that would be displayed on the button, and then we'll set the width for the button and we'll set it as 25 pixels, and then the height, and that would be 2 pixels. So width that would be equal to 25, and height that would be equal to we'll set it as 2 pixels only, and then we'll set the background color that would be white, and we'll set the foreground color as black. Background color is white, and for foreground we'll use fg, and that would be equal to black. And now if you want to add some functionality, you can add it in the command. So first we will declare the function and add the functionality for a button, and after that we can use the command. So we'll just pack it and see how a button looks in a Tkinter window. So for that we will use, okay, we have written it here. Sorry for that. So we are set with the button. Yeah, we'll save this file and click on the run button. You can see that the button is displayed on the Tkinter window, so it's clickable. So that's what make it differentiate from the label. It's clickable. Now we'll add functionality so that we can have some text when we click on this. So for that, first we'll create a, and we'll create the function here and name it as hello. And here we will create a label in this function, and inside we will place a text, and that would be hi learners, welcome to Tkinter tutorial. And now in this function only we will set, like in the label, for the label we'll set the foreground color. Foreground color we will set it as white, and background color we will set it as green. Okay. Now we will pack it so that it gets visible on a Tkinter window. So we can also pack it here. Okay. We will just use the pack method and it will get showed up in a Tkinter window. So now we have created a method or a function, and we have that functionality. Now we have to set that this functionality to a button. So for that, we will write command, and that would be equal to the name of the function, that is hello, and it's capital H. Okay, and we have packed the button, so no need to do it again. So we'll save this and run it. So you can see that we are seeing a button here, and that says click me to say hi. That is what we have set the text for it. When we click it, we see the functionality, that is it has displayed a label with background color, that is green, and foreground color, that is white, and it displays the text as hi learners, welcome to Tkinter tutorial. So this is about the button widget. Now moving on, now we'll start with the entry widget. So for that, oh sorry, first we'll comment this, and we'll also comment this function. So now we'll start with the enter widget. So why we use enter widget? When we want to get text from a user, like a name or an email address, we use an enter widget. It's a display that display a small text box that the user can type some text into. So creating and styling an entry widget works pretty much exactly like the label and the button widgets. So we will start with the enter widget, and for that first we'll create a label only, and on that label we'll place the enter widget. So first we'll create a variable and name it as label only, and after that we will go with this, like creating a label, and then we will add some text to the label. That would be, it will ask for what is your name, or we'll just add name to it. And here we will create the enter widget. For that we will create a variable and name it as entry, and now we'll create the entry widget. So this is the simple method to create any entry widget. We have created that, and now we have to place or pack or grid it to get a display on a tick enter window. So here we will use pack label.pack, and we'll also pack the enter widget. So we are done. Now we'll save it and run it. You can see that we have created a label and placed the text there, that is name, and beneath that we have packed an enter widget, and inside we can enter anything. That's my name Abhisar Ahuja, and you can enter anything. So these are the basic functionalities for the enter widget. You could see our other videos to get the hands on this enter widget and other widgets to get the other attributes and functionalities and use them in any app you want to make. So moving on, we will comment this, or I will give you another example for the entry widget. So for that, first we will create a label only, and inside we will place the master, that is the window, and assign text to it, and that would be name only. Here we will create a form, and it won't be having some functionalities to store the information, but it would be a form for name, email, password, and for that we'll use the enter widgets. So we have created a label here, and here you will, so we will use the place method to get it displayed on the tick window, and we'll set the x coordinate as 30 and y as 50 pixels. And moving on, we will set the enter widget and a label. First we'll set the label for email, so for that we'll also create a label, and inside we'll pass the master, that is window, and set the text as email only, so it get displayed on the label. Now we'll use the place method only to get it displayed on our tick window, and for this I will use x equal to 30 and y equal to 90. It would in the same x coordinates, and in y direction it would be shifted downwards, and that would be y equal to 90. Now I will create another label and store it in a variable that would be password, and to create it I will write tk dot label, sorry, and here the small l for label, and inside we will pass the master window, that is window, and set the text as password only. And now we will place this label, and we'll set the x coordinate as 30, and y will shift it downwards and set it as 130. Yeah, so these would be the labels. And now see these labels, like how they're placed. So you can see name, email, password, and now we will place enter widgets in front of them. So to get the enter widgets, first we will assign a variable, and inside that we will create an entry widget, that would be tk.entry, and inside we will pass a master window, and now we will place this at x equal to 80, like it would be sufficient, I think so. We will see when we will get the display now. Okay, so we have set the x coordinate as 80 and y as 50. Now we will make another entry widget for email and then for password. So for this we will name the variable as e2, and here we will just a second. Okay, we have to, okay, we'll do it tk.entry, and e would be capital for that, and that would be the master window, and we'll place this at x equal to 80, and y will shift it downwards, that would be same for the label email, that was 90. And now we'll create another variable, that is e3, and for that We have created an entry widget, and now we will place this and set the x coordinate as 80 only, and y coordinate that would be the same for the label, that was 130. So we will save this and run it. You could see that name, email, password, that are the labels, and we have got our enter widgets and it's overwriting. So we will set this as 100. We'll save it and run it. You could see that it has shifted 20 pixels apart from this from its previous position. So this is about the enter widget. So this is a basic tutorial. So I won't be getting into the get method, delete method, or the insert method. So there are three main operations that you can perform with entry widgets. That is retrieving text with get method, that is dot get method, and deleting text, that is with delete method, and inserting text, that is with insert method. So we will do this much only in this basic tutorial. And moving on, now we will create some frames. So frame widgets are important for organizing the layout of your widgets in an application. Like you have many widgets and you have used around 3 to 4 widgets and you want to organize them. So you have to create widget that is frame, and inside that frame widget you can organize all the other widgets. So an empty frame widget is practically invisible. You won't be able to see that if you haven't placed any widget in that. So frames are best thought of as containers for other widgets. You can assign a widget to a frame by setting the widget's master attribute, as we have set the master attribute as window in the enter widget, and in the label as we have seen in the enter widget example. So here we will start with creating frames, and for that first we will assign a variable frame underscore a, and that would be equal to tk dot frame. We will create a frame, sorry, and now we will create a label for that, and we will assign the variable as label underscore a, and that would be equal to tk dot label, and inside we would get this label fixed into the frame. So for that we will set the master as frame. So we have set the variable as master here, and this variable contains the frame. Now we will add the text to the label, and that would be, this is frame A. We will name it as A, and here we can set the background color also. So here we will use the hexacode for that. We won't write the simple name of the color, so here we will write the hexacode and have taken its inverted comma. So now we have to set the background color, and that would be in the inverted commas only. So we will start with hash, and we'll set the color as, I remember the hexacode for 468 to be 4. To color. So you will get the background color, and now we will pack this label so that it gets displayed on your Tagenta window. Okay, So for that we will write the variable and use the pack method, and now we'll create another frame and store it in a variable frame underscore b, and inside we will create a frame tk dot frame, and here we will create another label that would be label underscore b, and that would be equal to tk dot label, and here we'll set the master as frame only, as we will be setting this label into the frame. So for that we'll write frame underscore b. Now we'll set the text that would be this is frame b. Okay, now we'll set the background color, and we will set the background color different from the above so you can differentiate that. So I remember E9967A, and for the hexa code you have to use hash. So what you call this color, like light red, light orange, or anything. So just get that sorted. So we'll pack this widget. For that we'll use the variable label underscore b. We'll use the pack method, and we have packed it. Now we will save this, showing the red. Okay, we have not placed the inverted comma here, so we'll save this and run it. Okay, label is not defined, so we have written label. Okay, so sorry for my silly mistake. So we'll save this and run it again for you guys. So here we are not able to see it. So what? Oh, we have not packed the frame here, so we would not be able to see that. So we'll pack it here only. So first we'll pack frame underscore a dot pack, and then frame underscore b dot pack. Now we'll save this and run it again. You could see there is two frames displaying, that is, this is the frame a and this is the frame b, and this is the label on above the frame. And if we just swap these packs, what would happen? Let's see. We'll save this and run the file again. You could see that the frame has been shifted. So the pack method, it just pack the widgets line by line in a layer form. So you must be careful with that. Okay, so now we'll see some appearance for the frames. We have seen how to create a frame. Now we'll see how these frames can be displayed, how its appearances are. Like we have the 5 appearances. We'll discuss it, and we will adjust these frames according to their appearances, and these appearances can be called out with the method or with the attribute that is relief. So frame widgets can be configured with a relief attribute that creates a border around the frame. You can set relief to be any of the values, that is the flat value that we have seen that has no border effect, the default value. Then there is sunken, that is SUNKN in the capitals, that it creates a sunken effect. I will show you like what that effect is. Then we have the raised, then groove, and the ridge. So for that we will see a simple example. And one important thing, to apply this border effect, we must set the border width attribute to a value greater than 1. This attribute adjusts the width of the border in pixels. So for that, we will create the frames, and we will start with border, and that would be equal to, we will create a dictionary here. So for the flat keyword, we will create a, in the capital letters we have to write flat. Okay, and for the sunken, we will create tk dot sunken. Okay, and in dictionary we have to place the commas, and after sunken we have raised, groove, and ridge. So for that, we will write raised, and we will create tk. I have done a mistake above. So this would be tk dot sunken, comma, and now we will have the groove border. That is tk dot groove, comma, and after that ridge. That is tk dot ridge. Okay, so now we will run a loop for relief underscore name, comma, relief in, you set the border, and that is, we will iterate these items one by one. And now we will create a frame that would be tk dot frame, and set the master as window, and relief equal to relief, and set the border width. That's also the point, and we'll set it as 5. Okay, and now we will pack this frame. So for that we'll use the pack method, frame dot pack, and now we will create a label. That is tk dot label, and inside we'll set the master as frame, and text, we'll set the text as relief underscore name, and then we'll pack this label. Okay, now we'll save this and display it for you guys. So you could see that first we have the flat frame, then sunken, then raised, then groove, then ridge. Okay, so if you want to set these frames on the left side, for that you can use tk dot left attribute. We'll save this and run it for you guys. We have to assign it inside. Sorry, I will save this and run it for you guys. So you can see that it has shifted to left. Like all these are packed in the left direction, all the frames. So now moving on. Now we will see the frames with different colors. I will just comment this down, and now we will get the frames. We'll start with a variable and name it as frame1 and create a frame tk dot frame with capital F, and inside we'll set the master as window and width as 100 and height as 100, and background color we'll set it as red. And now we will pack this frame. So this frame would be of the red color. So to pack this, we will write frame1, that is the variable in which the frame has been stored, and we'll use the pack method. So we have packed it. Now we will use fill to fill this frame in the whole window. For that we'll write fill equal to tk dot capital S X. So it will get this frame fulfilled in the window in the X direction. And similarly we will create another frame. I will copy paste it and name the variable as frame2, and inside I will change the color, and I will set the width and height now. Okay, I will show you like how it will work. Pack this frame2 dot pack, and now we'll also set another frame and name it as frame3. Okay, and for this also we have to set another color so that we can differentiate that which frame is this. So we'll set it as blue. Now we'll save this and run it. So you can see that we have set the width and height, but we have used the fill attribute to fill it in the whole x direction. So it has got filled up. So these are the three frames we have created. Now we have seen the basics or the beginner for the tkinter module. Now using these modules, we will create a simple project that would be dollar to rupee converted, as I have told you earlier in the starting, in the introduction. For that, we will just create a new file and name it as dollar to rupee converter.py. So if like rupee, so here we will use the current value of what $1 is equal to rupee. We will set it as current value. So we will search it in the web and use it in a function. Okay, so we'll make this project a simple one, or just a simple app to get you hands on with these widgets. Okay, so starting with importing. So first we'll import tkinter, and as we have seen earlier, Here we use alias for that, and here also we'll use that. And after that we will create window that is equal to tk or tk class and window dot main loop. Okay, now we will set the geometry of the window. So for that we will write, and we will set the x-axis with 300 pixels and small x, and y-axis is 250 pixels. Okay, and we won't be adding some pixels to the x or the y direction. It will just come in the default section that this ideally would get it appear to. Okay, now we'll use the configure function and set the background color. So with configure you could set the background color and other attributes. So for that we will write window dot config, and inside we'll set the background color bg equal to, and I remember the hexa code for that. Here we will use hexa code, or you could just write the name of the color. Okay, E9N67A, we have used it previously, the light red color. Okay, now I have discussed with you that the resizable function, but we haven't used it in the former, that is the py file, but here we will use. So for that we will write window dot resizable, and inside we will set the width equal to false and height also as false. So you won't be able to adjust its width or height, and you won't be seeing any arrow for that. Okay, like if you place the cursor on the border of the window now, you won't be able to see any error to get it stretched out in the x or y direction. So we have used the resizable function for that. Now we'll set the title for this window. For that we'll write window.title, and inside we'll write the title, that would be dollar to rupee converter. Okay, now first we will start with a label, and we will add the heading as dollar to rupee converter only. So for that we will create a label and place it inside the variable L1 tk dot label, and inside we will pass the master as window and set the text as dollar to rupee converter. And we can set the font also. Okay, for that we'll just use the font attribute, and inside we have to place these in a circular braces. So for that we'll write, we have taken its inverted comma, we'll use Arial here. Okay, and set the font size as 15. Now we'll close the circular bracket. Okay, we have to close one more, and we'll set the foreground color as white. Okay, and we'll also set background color, and that we would set as hexacode BC0. Array C0. Okay, and that would be in the inverted commas, else it would be termed as the comment only. And now we'll close the circular bracket. Okay, and we will pack it at the last only. Now we will create another label, and for that we'll store it in L2 variable. For that we'll write tk dot label, and inside we'll pass window as master and text, and here we will set the label as enter dollar amount. Okay, so that will write text enter dollar amount. Okay, now we will add some functionality, and after amount we'll write the colon. Now we'll set its font. In the circular braces, and we'll set this also as Arial and set its size just smaller than the heading, that would be dollar to rupee converter. We'll set it as 10. Okay, and we'll set it as bold. This we have to place it in inverted commas, and after the font we'll set the foreground color, that would be equal to white, and then we'll set the background color. We have taken the inverted comma of the white. Now we'll set the background color, and for that we'll write the hexacode, and that would be A569BD. So we'll see this purple color, so I call it purple. I'm bad with color, so you can see what you want to call this color, or like what's the fundamental name of this color. So now we have created two labels, enter dollar amount, and now we will get another label, and that would be for amount in rupees. Like after we will execute the dollar to rupee, so that would be displayed in that label, that would be displayed just beneath this label that we will be creating, that would be L3. And for that we will write tk dot label, and inside we will pass the master as window and set the text as amount in rupees. Okay, and now we will set its font, and we'll set it same only as Arial, and with the font size 10, and we'll also set it as bold. Okay, so outside this font we will set the foreground and background color, and that would be foreground color white and background color, we'll write the hexacode for that only. And that would be same A569BD. Okay, Now we will create entry widgets. So first entry widget, that would be for entering the amount, enter dollar amount. So this enter widget would be beneath the enter dollar amount label. So for that we will create a variable even and create an entry widget tk dot entry, and we have e capital for the entry, and inside we will pass master as window, and we'll set the font as Arial, the circular braces. Okay, and set the font size as 10 and no bold for it. Okay, and in the window, first we have created the heading that was in the label, that is dollar to rupee converter. Then we have created a label enter dollar amount, and beneath that we have created an entry widget in which we will enter the dollar amount, and then we will create a button to convert this dollar amount into the rupee. So now we will be creating a button. So we will name the variable as button1. Now we will pass the window as master and set the font as Arial and font size as 10 only. No, but for button first we have to set the text now what it should display. So it should display convert to dollar. No, convert to dollar, nahi, convert to rupee. Okay, so we have set the text and we have set the font, and now we have to place a command, and in that command we have to place a function so that it should convert the dollar amount into the rupee. So we have to create a function. We will create it here. Okay, and name it as convert only. So for that we will write convert, and inside we will set a variable and integer type, and here we are using the get method to get the text that we have inputted in the entry widget that is stored in the even variable. And after that we will create a variable f, and inside we will write the dollar value against a rupee, that is 80.71 rupees is equal to $1. So that would be multiplied with the dollar amount, that would be C, but we will get it. Oh, sorry. Okay, so now we will create a text widget. So for that we will create a variable that is t1 and create a text widget tk dot text, and inside we will pass the window as master and set the state as disabled. I will tell you why. Disabled, and set its width as 15 and height as 0. Okay, so we will also configure this in the function. Okay, so we'll configure this and write as t1 dot config, and we'll set its state equal to normal. Okay, and t1 dot delete, that is, if you want to delete, you can delete it as 1 by 1 tk dot end, and t1 dot insert, and set it as its state as disabled. Okay, now we will pack all these widgets. First we'll start with labels, l1 dot pack, then l2 dot pack, then entry widget that is stored in e1 dot pack, and then button dot pack, and then l3 dot pack, and then t1 dot pack. Okay, now we'll save this and run it. Okay, so we have to create empty text, like empty labels. We will create it here, empty underscore l1, and create a label that is tk dot label. Okay, and inside we will pass window and set the background color equal to, that would be E9967, oh sorry, E9967A, that is the light red color. Okay, and here we will create an empty label that is tk dot label, and now we will pass the master as window and background color as light red only. We'll write the same hexacode E99678. Sorry, I press shift also with that. So okay, now let's save our program and run it. So we are getting an error that is very undefined at state equal to normal. Okay. Able to find any error, so we'll just run it again only. Okay, we got that. So you can see that it's not resizable. We have created the convert method to create the dollar amount. That is, we have entered the dollar amount, that is one, and we click on the button that is convert to dollar. It would reflect us to 82.71. And if we get it deleted and enter the dollar amount as 56 and click on the button that is convert to dollar, it would display us as 56 into the value that is 82.71. So this is the small project that we have created using the widgets, that is the tkinter widgets. So I hope like you code these all the widgets. So this was the basic tutorial. If you want to learn more, you can just see the other videos that is in the I button. If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
Seaborn library in Python. In today's video, we will learn how to visualize data and draw insights with different charts and graphs using the Seaborn library. These visualizations are often referred to as plots in Python. So what is Seaborn in Python? The Seaborn library in Python is a widely popular data visualization library that is commonly used for data science and machine learning tasks. It is built on top of the matplotlib data visualization library and allows you to perform exploratory data analysis. Using Seaborn, you can create interactive plots to answer specific questions about your data. It helps you find trends in your data that you can't notice just by looking at the data. Now, to understand the Seaborn library in detail and how to create different plots and know the data better, we will be using two datasets in our demo. The first one is the empty cars dataset and the second is the popular iris flower dataset. Now let's head over to our Jupyter notebook and start with our demonstration. So I am on my Jupyter notebook. Let me go ahead and rename the notebook. I'll say Seaborn demo. We'll rename it. Alright. You can see I have the first two cells already filled in. So while working on an exploratory data analysis project using Python, you will need NumPy, Pandas, Matplotlib and Seaborn libraries for data manipulation and visualization. So let's import these libraries first. So I've already written import NumPy as NP, Pandas as PD, Matplotlib.pyplot as PLT, Seaborn as SNS. Alright, so I'll hit Shift Enter to run this first cell. Alright, now using the read_CSV function that is present in the Pandas library, I am importing my dataset, that is empty cars. I'll tell you what empty cars is about. This is a CSV dataset and here I have given the location where my dataset is present. Let's run it. Alright. Now let me go ahead and print the first 5 rows of my empty cars data frame. For that I'm using the head function. If I run it, okay, you can see here it has given me the first 5 rows. The index starts from 0 till 4, so total 5 rows of information, and you can see these are the columns that are present in the empty cars dataset. The first is the model of the car. Now just let me give you a background about this dataset. So the data is taken from the 1974 Motor Trend US magazine. It has information about fuel consumption and 11 different aspects of automobile design and performance of 32 cars. Alright, so here we have the first column as the model of the car, and then we have MPG, which is miles per gallon. Then we have CYL, which stands for the number of cylinders in the vehicle or the car. Then we have DISP, which is displacement in cubic inches. So these all values are in cubic inches. After that we have HP, which is gross horsepower. Then we have something called as DRAT, which is basically the rear axle ratio. Then we have WT, which is the weight of the car in pounds. So think of it as weight multiplied by 1000 pounds. Alright, and then we have QSEC, which is 1/4 mile time. This is a measure for acceleration. Then we have something called as VS. This is the type of engine for each of the vehicles. So 0 stands for V-shaped engine and 1 stands for straight engine. Then we have AM, which is basically the mode of transmission. So 0 is for automatic transmission and 1 is for manual transmission. Then we have the number of forward gears present in the vehicle, and then we have something called as CARB or CARB. This stands for the number of carburetors. So carburetors is a device for supplying a spark ignition engine with a mixture of fuel and air. Alright, now we'll use the info function to print the summary of the data frame. So the info function returns information regarding the index data type, column data types. Then we have the information about non-null values and memory usage. So I'll write my data frame name, which is empty cars dot, I'm going to use the info function. Let's run it, and here you can see we have all the columns. There are total 32 entries from 0 to 31, so data about 32 cars. Then here you can see the data types and the memory usage. Now moving ahead, let me just print the shape of the data frame. That will give you the number of rows and columns present. I'll use the shape attribute. You can see here there are total 32 rows and 12 columns in my data set. Now the Seaborn library provides a range of plotting functions that makes the visualization and analysis of data easier. So we'll cover some of the crucial plots that are available in Seaborn. So let's start with a bar plot. I'll give a comment as bar plot. Now first understand what a bar plot is. So a bar plot gives an estimate of the central tendency of a numeric variable with the height of each rectangle. It provides some indication of the uncertainty around the estimate using error bars. Now to build this plot, you usually choose a categorical column in the x-axis and a numeric column on the y-axis. So we'll create a bar plot between the number of cylinders and the miles per gallon. So let's start. I'll declare a variable called res, which essentially stands for result. Then I'll use SNS, which is for the Seaborn library. I'll say SNS dot followed by my bar plot function, and inside the function I'll pass in my data frame name, that is empty cars, and then for x-axis within the bracket using quotation I'll give my column name as cylinder. So this is going to be my x-axis, and for y-axis I'll say my data frame name empty cars, then the square bracket followed by my y-axis column, that is miles per gallon. Now to display, I'm going to use the matplotlib function. I'll say plt.show. Let's run it and we'll see the result. There you go. So here you can see on the x-axis we have the number of cylinders. So in our data we have vehicles with 4, 6 or 8 cylinders, and on the y-axis you can see the miles per gallon. Now what essentially this graph tells us is that when the number of cylinders in the vehicle increases, my miles per gallon on MPG for the vehicles decreases. And you can see these black lines. So these lines indicate the uncertainty around the estimate using error bars. Alright. Now you can create the same bar plot using another way. Now we will exclusively define the x and y axis columns and also pass the name of the data frame using the data argument. Let me show you how to do it. I'll use the same variable name res, which stands for result. I'll say sns dot bar plot. Now inside the bar plot function, I'm going to exclusively define my x axis. I'll say x equal to, I'll pass in my column as cylinder, then I'll say y axis, which is miles per gallon, and then using the data attribute I'll pass in my data frame name, that is empty cars, and finally we'll write plt.show. Let me run it. You see here we have the exact same bar plot as the above one. So this is another way to create a bar plot. Now Python Seaborn allows the users to assign colors to the bars. So the bar chart that we are going to create will convert all the bars to a particular color. So for that I'm going to use the color argument. So I'll say res equal to sns dot my function, that is bar plot. I'll say x equal to cylinder. My y-axis will have mpg, and then I'll say data is empty cars, give a comma, and my final attribute I'll say color equal to, I'll say yellow. Close the bracket, and then I'm going to write plt.show. If I run it, you can see here all the bars have been converted to yellow color now. You can change the color argument. Let's say I'll make it to red. If I print it, you can see here all the bars have been changed to red color now. Alright. Now Seaborn library also has the palette argument, which you can use to give different colors to the bars. So if you go to Google and search for Seaborn palette, you have a nice link here. So here you have, there are different palettes provided by Seaborn. You can see here sns.color palette, and these are the names of the palette. You can use whichever palette you want. Alright. So I'll say res equal to sns dot bar plot. We'll use our first method of assigning a bar plot. So I'm using my data frame empty cars, and this time we are going to change the x and y labels. Let's say I'm using my x label as transmission, whether automatic or manual transmission, and then in my y axis I'll have miles per gallon. Then I'm going to say palette equal to, I made a spelling mistake here. Let's say our palette is set2. This is the name of the palette. I'll write plt.show. If I run it, you can see here we have the two modes of transmission. 0 is for automatic transmission of the vehicle, 1 is for manual transmission, and you can see the miles per gallon for each of the modes of transmission. If you want, you can change the palette colors. Let me just copy this. I'll paste it in my new cell, and instead of set2, let's say we'll use another palette called as rocket, and I'm also going to alter my x and y labels. Let's say in my x label I'll have gear and my y label will be horsepower. If I run it, you see here we now have a different palette and the bars are of different colors. On the x-axis you have the gears, 3 gear, 4 gear or 5 gear vehicle, and on the y-axis you have the horsepower. So from the graph you can see the horsepower is low for vehicles that have 4 gears, while it is high for the vehicles that have 5 gears. Now let's understand how to create a count plot. So the count plot function in the Python Seaborn library returns the count of total values for each category using bars. We will create a count plot that returns the total number of vehicles for each category of cylinders. I'll just give a comment here as count plot. Alright, so I'll start SNS dot, I'll use the count plot function and I'll define my x-axis as cylinders. My y-axis won't have any label or any column because y-axis will only show the count. Then I'm going to use my data parameter or the argument and pass in my data frame name, that is empty cars. Let's say I'll set the palette to set1. Let me run it. Okay, there is some error. Let's debug the error. It says str object has no attribute get. Okay, so this should be without the single quotes. Make sure the data frame name is without the single quotes. Let's run it again. There you go. So you can see here this is a nice count plot that shows the number of cylinders on the x-axis, and on the y-axis you have the count. You can see here there are more number of vehicles that have 8 cylinders and there are less number of vehicles or cars that have 6 cylinders, and actually you can count it as well. So you can see here there are 14 cars that have 8 cylinders, there are 11 cars that have 4 cylinders, and there are 7 cars that have 6 cylinders. Alright, now moving ahead, the next count plot will show the number of cars for each carburetor. So for that I'm going to say SNS dot count plot. My x-axis will now have the variable carburetor. I'll say data equal to empty cars, and my palette I'll set it to set1, or let's say set2. Now let me run it. You can see it here. On the x-axis we have the different number of carburetors, 1, 2, 3, 4, 6 and 8, and you can see we have more number of cars that have 2 and 4 carburetors, and there are very few vehicles that have 6 and 8 carburetor. Cool. Now moving ahead, so the Python Seaborn library allows you to create horizontal count plots where the feature column is on the y-axis and the count is on the x-axis. Let me show you how to create a horizontal count plot. I'll say SNS dot count plot. I'm going to define my y label or the y-axis as gear. I'll say data equal to empty cars and set my palette to, let's say, rocket. Let me run it. Okay, you see here this is a horizontal count plot, if you compare it with the above one, these were all vertical count plot, as in the bars were vertically aligned, but here you can see the bars are all horizontally aligned, and on the y-axis you have the gear column, and on the x-axis you have the count. So if you mark here properly, you can see there are 15 vehicles with 3 gears, there are 12 vehicles that have 4 gears, and there are total 5 vehicles with 5 gear. Now you can also create a grouped count plot using the hue parameter. So the hue parameter accepts the column name for color encoding. Now let's build a count plot that shows the number of cars for each category of gears grouped by the number of cylinders. So we are going to group based on the number of cylinders. Let me show you how to use the hue parameter for that. I'll say sns.count plot. In the x-axis I'll have my gear column. Then I am going to pass my hue parameter that will have the cylinder column or the number of cylinders for each vehicle. I'll pass my data frame using the data argument as empty cars and say palette. I'll set my palette to set 1. Let's run it. If I scroll down, you see here we have a count plot. On the x-axis you have 3, 4 and 5 gears of the different vehicles, and for each gear you have the bars that represent the number of cylinders. So for vehicles that have 3 gears, we have majority of the vehicles having 8 cylinders. Similarly, for vehicles that have 4 gears, we have most of the vehicles with 4 cylinders. And if you compare for the cars that have 5 gears, so we have equal number of vehicles that have 4 and 8 cylinders, and then we have one vehicle that has 6 cylinders. Cool. Now moving ahead. So the Seaborn library supports the distplot function that creates the distribution of any continuous data. Let's create the distribution of miles per gallon of the different vehicles or the cars. The MPG matrix measures the total distance the car can travel per gallon of fuel. So here I'll give a comment as distplot, which stands for distribution plot. I'll say sns.distplot. I'll pass in my data frame name, that is empty cars, give a period and say mpg, which is my column name. Then I'm going to define the number of bins that I want, let's say 10, and then I'll use the color argument and I'll say, let's say G, which is for green. Let's run it now. There you go. If I scroll down, you can see we have a nice distribution plot. So these are all histograms, and you can see we have a smoothed curve, and this shows the distribution of miles per gallon that is present in our dataset. Alright, now moving ahead, you can also create heat maps using the Seaborn library. So the heat maps will let you visualize matrix-like data. The values of the variables are contained in a matrix and are represented as colors. You can create a correlation heat map, which is a graphical representation of a correlation matrix representing the correlation between different variables. So in our example, we will create a heat map where you can find the correlation between each variable in the empty cars dataset. I'll just give a comment as heat map. I'll say SNS and I'll use the heat map function. I'll pass in my data frame name, that is empty cars, followed by my function called CORR, which is for correlation. Then I'll say C bar is equal to true. So the C bar argument is used to draw the color bar. Then I'll say line widths I'll pass it as 0.5. Let's run it. There you go. Here you can see we have a nice heat map, and on the right side you can see the color bar that starts from minus 0.8 and goes up to plus 0.8. So this ranges between -1 and +1, and the bars or the cube you can see that have a lighter color have a positive correlation, and the ones that are dark have a negative correlation. So for example, you can see here for cylinder and MPG the color is really dark, which is around this region, -0.8. This means when the number of cylinders in the car increases, your miles per gallon decreases, and this we also had seen in our first bar plot. This one you can see here, whenever the number of cylinders increased, your miles per gallon had decreased, and this is what has been depicted in our correlation map or the heat map. But if you see for cylinder and displacement, there is a positive correlation which comes around this color bar range. Similarly, there are other features in the dataset. For example, if you compare for the weight of the vehicle and the number of cylinders, there is a positive correlation, which means when the weight of the vehicle increases, the number of cylinders present in the vehicle also increases. And the others you can also compare and find out the correlation based on this color bar.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, now let's move ahead. The Seaborn scatterplot function helps you create plots that can draw relationships between two continuous variables. So to understand about scatterplots and other plotting functions, henceforth we are going to use iris flower dataset. So let's go ahead and load the iris flower dataset. I'll say iris equal to sns dot load underscore dataset. So this iris flower dataset is already inbuilt into the SNS or the Seaborn library. Now we'll go ahead and print the first 5 rows from the dataset. There you go. Here you can see here there are total 4 feature variables. You have the sepal length, sepal width, petal length and petal width of the 3 species of flower, that is Setosa, Virginica and versicolor. So using this dataset we are going to see the rest of the Seaborn plotting functions. First let me go ahead and print the different species of flower and the count for each of the species of flowers that we have in our dataset. I'll say iris, within square brackets I'll pass in the output or the target variable, that is species, and I'll use the function that is value underscore counts. Let's run it. There you go. So we have 50 flowers of Setosa type, again 50 flowers of versicolor species, and then we have another 50 flowers of type Virginica. So there are total 150 flowers present in our dataset. Alright. Now we'll create a scatter plot to show the relationship between sepal length and petal length for different species of iris flowers. So I'll say SNS dot followed by the scatterplot function. In the x-axis I'll say sepal length column, give a comma, I'll pass in my y-axis with petal length, then I'll say data equal to iris. Now let's run it. you can see here, this is my scatter plot between sepal length and petal length. Now you can classify the different species of flowers using the hue parameter as species in the function. So what I'll do is, I'm going to copy my above code. I'll just paste it here, and we are going to edit in this cell itself. I'll add a last parameter called hue, and this will have my species column. Let's run it and see the difference. There you go. Here you can see we have a nice scatter plot. The blue dots are for setosa, the orange dots are for versicolor, and for virginica you have the green dots. From this scatter plot you can see that for virginica flowers the sepal length and the petal length are higher than your versicolor and setosa, and this region is completely for setosa flowers. So you can see that the setosa flowers have lower sepal length and petal length. Alright, you can also use another parameter known as the size that will differentiate the different species of flower in terms of the size of the dots. I'll say size as species. Let's run it. You can see the result. There you go. So here you can see the virginica flowers are in green dots. The size is small, followed by versicolor with medium sized dots, and then we have setosa whose size is large. Okay. Now the Python Seaborn library lets you visualize data using pair plots that produces a matrix of relationship between each variable in the dataset. So let me show you how to create a pair plot. I'll say SNS dot pair plot, which is the function. Then I'll pass in my data frame name, that is iris. I'll put this iris data frame within double quotes and we'll run it. Okay, there is some error here. Let's debug the error. Data must be pandas data frame. Okay, what I'll do is I'll just remove the double quotes and we'll run it. This might take some time to create the pair plot, so just wait for a while. There you go. Here you can see we have a nice pair plot. On the y-axis you have the sepal length, sepal width, petal length and petal width. Similarly on the x-axis also you have the same feature columns. All the diagonal plots are histograms and the rest of the plots are scatter plots. Now you can convert the diagonal visuals to KDE or kernel density estimation plots and the rest of the scatter plots using the hue parameter. This makes the pair plot easier to classify each type of flower. So I'll just copy this cell of code, paste it here, and I'll say hue equal to species. Then I'll say palette equal to set1. Let's run it and we'll see the new pair plot now. This might take some time. There you go. So here you have the pair plot ready, and on the right side you can see the different species. The red color dots represent setosa flowers, the blue color dots represent versicolor, and the green color dots represent virginica flowers. Now if you look at this graph, you will find that your petal length is the best feature to classify the three different species of flowers. The reason being, you can see here they are very well categorized and they are separated. All the red dots present here in the petal length represent setosa flowers. Around this range, all the blue dots represent versicolor flowers, and the green dots are all virginica flowers. So out of the 4 features, petal width, petal length, sepal width and sepal length, you can take petal length as the best feature to differentiate between the 3 species of flowers. Alright, now coming to lmplot function. So the lmplot function in the Seaborn library draws a linear relationship as determined through regression for continuous variables. So let's create the plot to show the relationship between petal length and petal width of the different species of iris flowers. I'll just give a comment here as lmplot. I'll say sns dot lmplot. In the x-axis we'll have petal length, give a comma. In the y-axis I'll pass in petal width, and I'll pass in my data frame using the data argument or parameter, which is iris. Let's run it. You can see it here. We have a nice plot. The line you see here is a linear regression line. Now in this LM plot, you can use the hue parameter to differentiate between each species of flowers, and you can set markers for different species. Let me show you how to do it. I'll say sns dot LM plot. We'll say x as our petal length, give a comma. I'll write y as petal width. Then I'm going to pass the hue parameter. In hue I'll say my column as species. Then I'll give data equal to my dataset name, that is iris. And now you can pass in markers argument to differentiate the different types of flowers. Let's say I want to represent setosa with dot or O. Then my next species, which is versicolor, should be represented with a star symbol, and the final virginica species of flowers should be represented with, let's say, this arrow mark. Now let me go ahead and run it. There you go. You have 3 different linear regression lines, and the circle dots in blue color represent setosa, the orange color stars represent versicolor flowers, and the triangles represent virginica flowers. So this is how you create a linear relationship between the different types of flowers using the regression line. Alright, now let's take a look at the final plotting function, where we will create a box plot. A box plot, also known as a box and whisker plot, depicts the distribution of quantitative data. The box represents the quartiles of the dataset. The whiskers show the rest of the distribution except for the outliers. Now let's see the distribution of the 3 species of flowers based on their sepal width. I'll just give a comment as box plot is the final plot that we are going to see in our Seaborn demo. I'll say sns dot box plot. In the x-axis we'll have the species column. In the y-axis we'll have sepal width. Then I'll pass my data as iris. Let's run it. There you go. we have this box plot created. At the bottom in the x-axis you can see we have the box plot for setosa flowers, orange for versicolor flowers, and green for virginica flowers. Now this line represents median, which is inside the box. So this is also the median for versicolor flowers. You can compare the median sepal width for each of the flowers from the y-axis. This line represents the maximum sepal width value for setosa flower, and this line at the bottom represents the minimum length of the sepal width for setosa flowers. Now these dots that you see outside the box plot are called as outliers. The extended lines that are outside the box plot are known as whiskers. Alright, so that brings us to the end of this demo session on Seaborn library in Python. So first we imported our empty cars dataset. Then we saw how to create a bar plot. We learned how to use the color argument or the parameter inside bar plot. We also saw how to use the palette attribute or the palette parameter. Then we learned about creating count plots. Then we saw how to create horizontal count plot. Now moving ahead, we saw how to create distribution plot. Then we saw a correlation heat map. After that, we analyzed the other functions such as the scatter plot. Then we had the pair plot, and we had the LM plot for finding the linear relationship, and later we saw the box plot using the iris flower dataset.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
So let's start with, what is NumPy? NumPy is the core library for scientific and numerical computing in Python. It provides high-performance, multi-dimensional array object and tools for working with arrays. And I'll go a step further and say there are so many other modules in Python built on NumPy. So the fundamentals of NumPy are so important to latch onto for the Python, so that you can understand the other modules and what they're doing. NumPy's main object is a multi-dimensional array. It is a table of elements, usually numbers, all of the same type, indexed by a tuple of position integers. In NumPy, dimensions are called axes. Take a one-dimensional array, or we have, and remember dimensions are also called axes, so you can say this is the first axis, 0, 1, 2, 3, 4, 5. And you can see down here it has a shape of 6. Why? Because there's 6 different elements in it in the one-dimension array. And they usually denote that as 6 comma with an empty node on there. And then we have a two-dimensional array where you can see 0, 1, 2, 3, 4, 5, 6, 7. And in here we have 2 axes or 2 dimensions, and the shape is 2, 4. So if you were looking at this as a matrix or in other mathematical functions, you can see there's all kinds of importance on shape. We're not going to cover shape today, but we will cover that in part 2. Did you know that NumPy's array class is called NDArray for NumPy Data Array? Now we're going to take a detour here because we're working in Python, and 2 of my favorite tools in Python is the Jupyter Notebook, and then I like to use that sitting on top of Anaconda. And if you flip over to jupyter.org, that's jupyter.org, you can go in here. You can install it off of here if you don't want to use the Anaconda notebook. But this is the Jupyter setup, the documentation on the Jupyter. Jupyter opens up in your web browser. That's what makes it so nice, is it's portable. The files are saved on your computer. They do run in IPython or IronPython. And you can create all kinds of different environments in there, which I'll show you in just a minute. I myself like to use Anaconda. That's www.anaconda.com. If you install Anaconda, it will install the Jupyter Notebook with the Anaconda separate. And you can install Jupyter Notebook and it'll run completely separate from Anaconda's Jupyter Notebook. And you can see here I've now opened up my Anaconda Navigator. What I like about the Navigator, and this is a fresh install on a new computer, which is always nice. I can launch my Jupyter Notebook from in here. I can bring other tools, so the Anaconda does a lot more. And under environments, I only have the one environment, and I can open up the terminal specific to this environment. This one happens to have Python 3.7 in it, the most current version as of this tutorial. And then you open a terminal if you're going to do your pip installs and stuff like that for different modules. You can also create different environments in here. So maybe you need a Python 3.6, Python 3.5. You can see we're having a nice framework like Anaconda really helps. So you don't have to track that on your own in the Jupyter Notebook and your different Jupyter Notebook setups. We'll go ahead and launch this Jupyter Notebook. And then I've set my browser window for a default of Chrome. So it's going to open up in Chrome. And you can see here, this opens up a folder on my computer. We have a couple different options on here. Remember, I set the environment up as Python 3.7. You would install any additional modules that aren't already installed in your Python on this. And it keeps them separate, so you do have to, for each environment, install the separate modules so they match the environment on there. And in here we have a couple things where you can look up what's running. You have your different clusters. Again, I just installed this on a new machine, so I just have a couple things in here that were run on here recently. And where we go on here is we then have on the upper right, New, and from the pull-down menu you'll see Python 3, and this will open up a new window. And now we're in Jupyter Python, so this is a Python window, and we'll just do a print. And this, of course, is so hello world. And we'll run that, and it prints out hello world in the command line. There's a couple special things you have to know what we're not going to do today, which is on graphics. If you've never seen this, one of the things you can do is you can also do A equals hello world. And if you just put the A in there, now if you do a bunch of these where you have A equals hello world, B equals goodbye world, and you put A, B, A, then return B, it'll only run the last one. But you can see here, if you put the variable down here, it will show you what's in that variable. And that has to do with the Jupyter Notebook inline coding. So that's not basic Python, that's just Jupyter Notebook shorthand, which you'll see in a little bit. So back to our NumPy array versus Python list. Python list being the basic list in your Python. Why should we use NumPy array when we have Python list? Well, first, it's fast. The NumPy array has been optimized over years and years by multiple programmers, and it's usually very quick compared to the basic Python list setup. It's convenient, so it has a lot of functionality in there that's not in the basic Python list. And it also uses less memory, so it's optimized both for speed and memory use. And let's go ahead and jump into our Jupyter Notebook. Since we're coding, the best way to learn coding is to code. Just like the best way to learn how to write is write, and the best way to learn how to cook is cook. So let's do some coding here today. And just like any modules, we have to import NumPy. We almost always import it as NP. That is such a standard. So you'll see that very commonly. We can just run that. And now we have access to our NumPy module inside our Python. And then the most common thing, of course, is to go ahead and create a NumPy array. And in here, we can send it a regular list. And so we'll go ahead and send this a regular array. Let's go 1, 2, 3 to make it simple. And then I'm just going to type in A, and we'll run this. And so you can see down here, the output is an array of 1, 2, 3. And we could also do print, just a reminder that this is an inline command, so that wouldn't work if you're using a different editor. You can see that it's an array 1, 2, 3. But we'll go ahead and leave it as A. Kind of a nice feature so you can see what you're doing really quick in the Jupyter Notebook. And just like all your other standard arrays, I can go A of 0, which is going to be a value of 1. Of course, we do A of 1, you go all the way through this. A of 1 has a value of 2 in it. So whether you're using the NumPy array or the basic Python list, that's going to be the same. That should all look pretty familiar and be pretty straightforward. Remember, the first value is always 0 and when we set on there. So let's take a look why we're using NumPy, because we went over the slide a little bit, but let's just take a look and see what that actually looks like. And what we want to look at is the fact that it's fast, convenient, and uses less memory. So let's take a glance at that in code and see what that actually looks like when we're writing it in Python and what the differences are. And to do this, I'm going to go ahead and import a couple other modules. We're going to import the time module so we can time it. And we're going to import the system module so that we can take a look at how much memory it uses. And we'll go ahead and just run those so those are imported. And so we'll do b equals, range of 1,000 is fine. And so that's going to create a list of 1,000, 0 to 999. Remember, it starts at 0 and it stops right at the 1,000 without actually going to the 1,000. And let's go ahead and print. And we want system.getSize of. And we'll pick any integer, because we have, 0 to 1,000. We'll just throw one in there, 5. It doesn't matter, because it's going to, whatever integer we put in there is going to generate the same value, because we're looking at the size of how much memory it stores an integer in. And then we want to have the length of the b. That's how many integers are in there. And if we go ahead and execute this and run this at a line, we'll see, oops, I did that wrong, comma. If we multiply them together, we'll see it generates 28,000. So that's the size we're looking at, is 28,000. I believe that's bytes. That sounds about right. So let's go ahead and create this in NumPy. And we'll go C equals NP. And this is a range. So that's the NumPy command to do the same thing that we were just doing in a list. And we'll also use the same value on there, the 1,000. And then once we've created the value of C for np.arange, let's go ahead and print. And we can do that by doing c.size times c.item size. And that's very similar to what we did before. We did get the size of, so the c size is the size of the array, and each item size, just reversed. So it's the size of an integer 5, item size is going to be the integers, and c size. Now let's just take a look and see what that generates. And wow, okay, we got 4,000 versus 28,000. That's a significant difference in memory, how much memory we're using with the array. And then let's go ahead and take a look at speed. Let's do size. We tried this with lower values, and it would happen so fast that the NP array kept coming up with 0 because it just rounded it off. So size, and let's create an L1 equals range of size. And we'll do an L2. We'll just set up to the same thing. It's also range of size on there. There we go. And then we can do on A1 equals np dot arange size. And then let's do on A2 equals np dot arange. We'll keep it the same size. And what we're going to do is we're going to take these two different arrays and we're going to perform some basic functions on them. But let's go ahead, actually let's just load these up now. We'll go ahead and run this so those are all set in memory. Except for the typo here. Quickly fix that. There we go. So these are now all loaded in here. And let's do a start equals time.time. So it's just going to look at my clock time and see what time it is. And then we'll do result equals, and let's do, let's say we got an array, and we're going to say, let's do some addition here. X plus Y for X comma Y. And we'll zip it up here. Two different arrays. So here's our two different arrays. We're going to multiply each of the individual things on here. L1, L2. There we go. So that should add up each value. So L1 plus L2, each value in each array. And then we want to go ahead and print. And let's say Python list took. And then we'll do time dot time. We'll just subtract the start out of there. So time, whoops, I messed up on some of the quotation marks on there. Okay, there we go. Time minus the start. And we'll convert that to seconds. So we'll go, because that's in milliseconds, so times 1,000. And let's hit the run on there. This is kind of fun because you also get a view while we're doing this of some ways to manipulate the script. And as you can see also my bad typing. There we go. Okay, so we'll go ahead and run this. And we can see here that the Python list took 34. Actually, I have to go back and look at the conversion on there. But you can see it takes roughly 0.34 of a second. And we can go ahead and print the result in here too. Let's do that. We'll run that just so you can see what kind of data we're looking at. And we have the 0, 2, 4, 6, 8. So it's just adding them together. It looks pretty straightforward on there. And if we scroll down to the bottom of the answer, again we see Python list took 46. A little different time on there depending on what core, because this is on an 8-core computer, so it just depends on what core it's running on, what else is pulling on the computer at the time. And let's go back up here and do our start time. Paste that into here. And this time we're going to do a result equals, and this is really cool. Notice how elegant this is. It's so straightforward. This is a lot of reason people started using NumPy is because I can add the two arrays together by simply going A1 plus A2. It makes a lot of sense, both looking at it, and it's just very convenient. Remember that slide we're looking at? Fast, convenient, and less memory. So look how convenient that is. Real easy to read, real easy to see. And I don't know if we don't need to print the result again, so let's just go ahead and print the time on here. And we'll borrow this from the top part because I really am a lazy typer. And this isn't the Python list, this is the NumPy list, or NumPy array. And let's go ahead and see how that comes out. And we get 2.99. So let's take a look at these two numbers, 46 versus 2.99. So we'll just round this up to 3. That's a huge difference. That's like more than 10 times faster. That's like 15 times roughly at a quick glance. I'd have to go do the math to look at it. And it's going to vary a little bit depending on what's running in the background on the computer, obviously. So we've looked at this, and if we go back here, we found out it's much faster. Yes, there's going to be different speeds depending on what you're doing with the array. Very convenient, easy to read, and it uses less memory. So that's the core of the NumPy. That's why a lot of people base so many other modules on NumPy and why it's so widely used. So we did glance at a couple operations while we were looking at speed and size. Let's dive into a little bit more into the basic operations. And these are always nice to see. I mean, certainly you want to go get a cheat sheet if you're using it for the first time. Look things up. Google is your friend. We did this for the most basic numpy.array or np.array. And we'll go ahead and create an array. Let's do pairs, 1, 2. And then let's do 3, 4. And if we're going to do that, let's do 5, 6. There we go. And if we go ahead and take this and run this, I can go ahead and do our A down here so it's in line and it'll print that out. You can see it makes a nice array for us. So we have A, and if you look at that, we have 3 different objects, each with 2 values in them. And hopefully you're starting to think, well, how many dimensions or indexes is that? And you'll see 3 by 2. So let's go ahead and take a look, and let's go, how about A.nDimensions? Speaking of which, we'll run that, and we have 2 dimensions for each object. And then we can do the item size, so A dot. We saw this earlier, where we looked up how many items. It was up here, where we wanted to multiply item size times the actual size of the object. So the memory is being used versus the item size. And we should see 4 there. Memory is compressed down. That's always a good thing. And then the shape. The shape is so important when you're working with data science and you're moving it from one format to another. So we have our shape. We just talked about that. We have 3 by 2. 3 rows by 2 objects in each one. Generally, I don't look too much at the size, but the dimensions I'm always looking up. And this is nice, you can automate it. So you might be converting something, you might need to know how many dimensions are going into the next machine learning package so that you can automatically just have it send that information over. So we looked at A shape. Let's go ahead and create a slightly different array, np.array. Let's go ahead and just do as our original setup here. And one of the features we can do, which is really important, is we can do dtype equals, in this case, let's do np float 64. And so what we've done is we're converting all of these into a float, and we type in A. And now instead of having 1, 2, 3, 4, 5, 6, you see they're all float values. 1.0, there's no actual 0 in there, just there's a 1 dot. Or the 1 period, 2, 3 period, 4 period, 5 period, 6 period. And this, again, data science, I don't know how many times I've had to convert something from an integer to a float so this is going to work correctly in the model I'm using. So very common features to be aware of and to be able to get around and use. And we'll also do, let's just curiosity, item size. We'll go ahead and run that. And we see that it doubled in size. So it's not a huge increase. Well, doubling is always a big increase in computers. But it's not a huge increase compared to what it would be if you're running this in the Python list format. And then we did the shape earlier without having it set to the float 64. Let's go ahead and do a shape with it set to 64. And it should be the same 3, 2. So it all matches. So we've gone through, and remember, if this is all brand new to you, according to the Cambridge study at the Cambridge University, if you're learning a brand new word in a foreign language, the average person has to repeat it 163 times before it's memorized. So a lot of this, you build off of it, so hopefully you don't have to repeat it 163 times. But we did manage to repeat it at least twice here, if not a little bit more. And let's go ahead and take this. We're going to go look at one more setup on here. And let me just take this last statement here on the converting our properties of our data. And instead of float 64, let's do complex. Let's just see what that looks like. And let's go ahead and print that out and run it. And so we now have a complex data set up, and you'll see it's denoted by the 1 dot plus 0 dot j. And if we flip over here and do a basic search for NumPy data types, better to go to the original web page, but pull up a bunch of these. You can see there's a whole list of different NumPy data types. Shorthand, complex, we have complex, complex 64, complex 128. Complex number represented by 2 64-bit floats, real and imaginary components. One option on there, float 16, float 32. Float, shorthand for float 64, most commonly used. And of course all the different ones that you can possibly put into your NumPy array. So we covered a basic addition up there when we were comparing how fast it runs. But some very basic components, how to set up a NumPy array, how many dimensions it has, item size, data type, again we went to item size, and there's also the shape, probably one of the more used. I use the A shape all the time, very commonly used. And then down here you can see where we actually created a NumPy complex data type. So let's look at some other features in NumPy. One of them is you could do NumPy dot zeros, and we're going to do 3, 4. There we go. And we'll go ahead and run this, and you can see if I do np.zeros, I create a NumPy array of zeros. This is really important. I was building my own neural network, and I needed to create an array where I initialized the weights, and I wanted them all to be the same weight. In this case, I wanted them to start off as 0 for the particular project I was working on. And there's other options, like you can do NumPy1s, and we'll do the same thing, 3, 4, we'll run that. And you can see I've created an array of NumPy1s. In this case, it comes out as a float array. And then this is an interesting to note, because we have, let's go back to our Python and do L range 5, and we'll print the L, so there's our list. And if I run that, it doesn't create the range until after the fact, until you actually execute it. That's an upgrade in Python. Python 2.7 actually created the array 0, 1, 2, 3, 4. This one actually creates the script, and then once it's used, it then actually generates the array. And if we do that in NumPy A range, remember that from before, and if we do NumPy A range 5, and let's do L equals, or we can just leave it as NumPy, that's fine. There we go, just run that. You can see there we actually get an array, 0, 1, 2, 3, 4 for the value of the NumPy A range 5. It generates the actual array. And for part 1, we're going to do just one more section on basic setup, and we're going to concatenation, do a concatenation example. There we go. We're going to do strings. Let's take a look at strings and what's going on with there. And let's do, let's see, print. Let's do an NP character, something new here. And we're going to add, and then here's our brackets for what we're going to add. And let's say, let's do hello, comma, hi, and in the brackets on there, let's create another one, and this one's going to be ABC, and we'll do XYZ. So we're just creating some, randomly making some up on here. And then we'll go ahead and just print this. If we run that, you can come down here, and of course make sure all your brackets are open and closed correctly. And then you can see in here when we concatenate the example in NumPy, it takes the two different arrays that we set up in there, and it combines the hello with the ABC and the hi with XYZ. And if we can also do something like print, let's do np character dot multiply. So there's a lot of different functions in here. Again, you can look these up. It's probably good to look them all up and see what they are, but it's good to also just see them in action. And let's do hello space, comma, 3, and we'll run this one and run that without the error. And you'll see it does hello, hello, hello. So we multiplied it by 3. And we can also, and let's just take this whole thing here instead of retyping it. And we can do character center. So instead of multiply, let's do center. And over here, keep our hello going. Take the space out of there. And let's do center at 20. And fill character equals, we'll fill it with dashes. So if we run this, you can see it prints out the hello with dashes on each side. And we keep going with that. We can also, in addition to doing the fill function, we can play with capitalize, we can title, we can do lowercase, we can do uppercase, we can split, split line, strip, join. These are all the most common ones. And let's go ahead and just look at those and see what those look like, each one of them. Here we're going to do the hello world, all-time favorite of mine. I always like to say hello universe. And you can see here we did a capital H with the world, but so we want to capitalize. So capitalize is the first one in the array. So we get hello world on there. And we can also take this, and instead of capitalizing, another feature in here is title. And let's just change this to how are we doing? How are you doing? Instead of we, we'll do you. And let's run that. And you can see here, because we created it as a title, it capitalizes the first letter in each word. And in this one, we're going to do character lower. Two different examples here. We have an array. We have hello world all capitalized, and we have just hello. And you can see that one is an array and one is just a string. If we run that, you get an array with hello world lowercase and hello lowercase. And if we're going to do it that way, we can also do it the opposite way. There's also upper. And let's paste those in there. And you can see here we have character.upper opposite there, python.data, and we'll do Python is easy. Hopefully you're starting to get the picture that most of the Python and the scripting is very simple. It's when you put the bigger picture together and starts building these puzzles, and somebody asks you, hey, I need the first letter capitalized, unless it's the title, and then you start realizing that this can get really complicated. So NumPy just makes it simple, and we like that. And so in this case, we did Python data. It's all uppercase. Python is easy, like shouting in your messenger. Python is easy. And then if you're ever processing text and tokenizing it, a lot of times the first thing you do is we just split the text, and we're just going to run this np.character.split. Are you coming to the party? If we do that, it returns an array of each of the individual words. Are you coming to the party, splitting it by the spaces? And then if you're going to split it by spaces, we also need to know how to split it by lines. And just like we have the basic split command, we also have split lines. Hello, and you'll see here the scoop in for our new line. And when we run that, if you're following the split part with the words, you should see hello, how are you doing? The two different lines are now split apart. And let's just review 3 more before we wrap this up. Commonly used string variable manipulations. We have strip, and in this case we have Nina, admin, Anita, and we're going to strip A off of there. And let's see what that looks like. And then you end up with nin, demin, nate. It basically takes up all leading and trailing letters. In this case we're looking for A. More common would be a space in there, but it might also be punctuation or anything like that that you need to remove from your letters and words. And if we're going to strip and clean data, we also need to be able to reformat it or join it together. So you see here we have a character join. We'll go ahead and run this. And it has on the first one, it splits each of the letters up by the colon and the second one by the dash. And you can see how this is really useful if you're processing, in this case, a date. We have day, month, year, year, month, date. Very common things to have to always switch around and manipulate depending on what they're going into and what you're working with. And finally, let's look at one last character string. We're going to do replace. If you're doing misinformation, this is good, pulling news articles and replacing is and what. In this case, we're just doing he is a good dancer. We're going to replace is with was. And you can see here, he was a good dancer. Hopefully that's not because he had a bad fall. He just was from 1920s and has gotten old. So there we go. We've covered a lot of the basics in NumPy as far as creating an array. Very important stuff here when you're feeding it in. How do we know the shape of it, the size of it? What happens when we convert it from a regular integer into a float value as far as how much space it takes? We saw that doubled it. Item size, you have your in dimensions, and probably the most used is shape. And we'll cover more on shape in part 2. So make sure you join us on part 2 because there's a lot of important things on shape in there and setting them up. We also saw that you can create a zeros-based array. You can create one with ones. If we do a range, you can see how it is a lot easier to use to create its own range, or a range as it is in NumPy. And you saw how easy it was to add two arrays. We saw that earlier, just plus sign. Then we got into doing strings and working with strings and how to concatenate. So if you have two different arrays of strings, you can bring them together. We also saw how you can fill, so you can add a nice headline, dash, dash, dash. We saw about capitalize the first letter. We saw about turning it into a title, so all the first letters are capitalized. Doing lowercase on all the letters, upper for all the letters, just lower and upper, nice abbreviation. We also covered how to split the character set, how to strip it. So if you want to strip all the A's out from leading A's and ending A's or spaces, you can do that very easily. Also how to join the data sets. So here's a character join option for your strings. And finally we did the character replace. Now let's go ahead and dive in there since we're going right into part 2, which is getting some coding going under our belt. And here in our Jupyter notebook, we can go under New and create a new folder, Python 3. I think I forgot to do this last time, but we could just do the Control++, which in any browser enlarges a page, makes it a lot easier to see. Always a nice feature. Another beautiful benefit of using Jupyter Notebook. And let me go ahead and show you a neat thing we can do in Jupyter. This is nice if you're working with people and you're doing this as a demo on a large screen. I'm going to do the hashtag or pound symbol array manipulation, kind of a title of what we're working on. And then I'm going to call this cell type markdown as opposed to code. And you'll see it highlights it here, and then if I run it, it just turns it into array manipulation. And then we're specifically going to be working on array manipulation, changing shape to start with. And we'll go ahead and mark this cell also a markdown, so it has a nice little look there. And then it comes up, and you can see it, just like I said, it just highlights it and makes it in bold print, just making it easier to read. Not a Python thing, but a Jupyter thing that's good to know about, especially if you're working with the shareholders, since they're investing money in you. Of course, the first thing we want to do is import. We're going to import NumPy as in P, and that should be standard by now. By now, you start a Python program, you're doing some data science. NumPy is just something you bring in there. And let's go ahead and create our array. And we're going to do that as the np.arange. Remember, that's 0, well, we're going to do 0 to 9. And then we'll go print, put a little title on the original array. We'll just print that array A. Remember from the first lesson, so we have our array which is 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's add a print space in between. Let's create a second array, B, but we want this to reshape array A. And what does that mean? And the command is simply reshape. And then we have 9 items in here, and this is so important right now. So be very aware, if I did some weird numbers in here, it's not going to work. And we want multiples of 9. We know that 3 times 3 is 9. So we're going to reshape our A array by 3 by 3. And then we're going to print, well, let's give it a title. Oops, I had too many brackets in there. Modified array. And then let's go ahead and print our B. And let's see what that looks like. And as we come down here, you can see we've taken this and it's gone from 0, 1, 2, 3, 4, 5, 6, 7, 8 to an array of arrays, and we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we split this into 3 by 3. And you can guess that if I tried to reshape this, let's just do a 5 by 3, which is 15, that's going to give me an error. So it's not going to work. You're not going to be able to reshape something unless the shape, all the data in there matches correctly. So we can take this flat 9, and we call it a flat because it's just a single array. And we can reshape it into a 3 by 3 array. And first you might think matrices, which this is used for that, definitely. I use it a lot in graphing because it'll come in that I have an array that's xy, comma xy1, y1, comma x2, y2. And so the shape of it might be 2 by the length of the number of points. And I need to separate that into x flat array and a y flat array. And you can see this can be very easy to reshape the array doing that. And we can of course go back. We can do b, do a print, and we'll do b dot flatten. Remember I said it's called a flatten array? And if we run that, you'll see it just goes back to the original one. It takes this 0, 1, 2, 3, 4, 5, 6, 7, 8 and flattens it back to a single array. And then one other feature to be aware of is if we flatten it, one of the commands we can put in there is order. Let me just go ahead and do that. Order equals F. Strangely enough, F stands for Fortran. The whole Fortran days. I remember actually studying Fortran programming language. In this case, you'll see that it uses the first, like 036 is the order. So instead of flattening it like we had before, 0, 1, 2, 3, 4, 5, 6, 7, 8, it now does 0, 3, 6, 1, 4, 7, 2, 5, 8. And if you go to the NumPy array page, you can see here that they have the flatten. I just open up the NumPy ND array flatten setup to look it up. And they have 3 different options. They have C, F, and A. And it's whether to flatten in C, which was based on how the C code works for flattening, originally worked, which is row major. Fortran, which is column major, or preserve the column Fortran ordering from A. So whatever it was in, the default is the C version. So the default that you saw, you could put order equals C and it'd have the same effect as we saw there before. You could even do order equals A. That would also have the same effect because that's the default. So really the only other thing you really should change on here is to change it to C if you need it. And you can see right here, or F, I mean not C. The only thing you really want to change it to is to your F for the Fortran order, which then does it by column versus by row. And let's look at, here we go, reshape. So let's create a range of 12, and let's reshape it. And we'll do 4, 3 for this one. And remember this is NumPy. I forgot the NP there. np.arrange. And we can type in just A for print, or you can do full print A. And of course in Jupyter Notebook you even have a little extra print at the beginning. When we run this, we'll see we create a nice array of 0, 1, 2. It's reshaped it. So we have 4 rows and 3 columns, or you can call that 3 columns and 4 rows. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But this one is so important. We'll do np transpose A. Let's go ahead and run that. And it helps if I get all the S's in there and don't leave an S out. And you'll see here we've taken our array. If you remember correctly, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've swapped it. So we've gone from a 3 by 4 or a 4 by 3 to a 3 by 4. And this really helps if you're looking at like a huge number of rows and the data all comes in. Like let's say this is your features in row 1, your features in row 2, and this is X, Y, Z. Well, when you go to plot it, you send it all of X in one array, all of Y in one array, and all of Z in another array. And so it's really important that we can transpose this rather quickly. This is kind of a fun thing. I can highlight it and do brackets around it, and if you remember correctly, because we're in Jupyter, it doesn't matter where we do the print or not. It'll automatically print it for us. And you see if I hit the run button, it comes up with the same exact thing. And let's play with the reshape, and you know what, let's zoom this up a little bit here. Make that even bigger so you can really see what's going on. And let's play with the reshape just a little bit more. We'll do b equals np.arange. Let's do 8. And reshape, we'll do 2, 4. Let's go ahead and print B and then run that. And you'll see we have now the 2 rows. This is a bit more like, so we have 4, maybe 2 rows of 4 things. So this might be all of our X components and our Y components. So we can switch it back and forth real easy. Important to note here, whether we do 2, 4, or in the case of 4, 3, this has 12 elements. And so however you split it up, it's got to equal 12. So 4 times 3 equals 12. That's pretty straightforward. Same thing down here. 2 times 4 equals 8. If I change this, and let's say I do 2, 3, let's just run that in, and you'll find we get an error because you can't split 8 up into 2 rows by 3. You have to pick something that it can split up and arrange it in. So let's go ahead and run that. And just for fun, let's go reshape our B again, if I can type. Reshape our B again. And what else goes into 8? Well, we could do 2 by 2 by 2. So we can take this out to 3 different dimensions. And then, of course, if we, because this is going to come out as a variable, we can just go ahead and run it. And it'll print it. We could also do a print statement on there, just like we did before. And you'll see we have 2 different groups of 2 variables of 2 different dimensions. So 2 by 2 by 2. And let's go ahead and assign this to a variable. C equals B reshape. And let's do something a little different. Let's roll the axes. Roll axes. And we'll take our C and do 2, 1. And if we go ahead and run this, it's going to print that out. Whoops. Hit a wrong button there. Let's do that one again. And you roll the axis, and you can see that we now have, instead of 0, 1, 2, 3, 4, 5, 6, 7, we now have the 0, 2, 1, 3, 4, 6, 5, 7. So what's going on here? We're taking and we're rolling the numbers around, and let's just simplify this. We'll just do it with C, 1 and run that. And so if we roll a single axis, you got 0, 1, and then it rolled the 4, 5 up, and then we have 2, 3, 6, 7. And if we do 2, let me see what happens there. And this is one of those things you really have to play with and start feeling what it's doing. We've now taken 0, 2, 4, 6, 1, 3, 5, 7. So you can see we've now rolled by 2 digits instead of rolling the 1 setup. We now rolled 2 digits up there. And so if we go back and we do the 1, so we've rolled it up, 0, 1, 4, 5. And then we're going to take the 2 in there. And we've rolled the 0, 1, 2, 3, 4, 5, and 6, 7. So we start rolling these things around on here. There's a lot of different things you can do on this. But it's another way to manipulate the numbers on your NumPy. And finally, let's go ahead and swap axes. We'll do C. And let's just go ahead and run that. It's going to give me an error on there. That's because it requires multiple arguments. Left out the arguments. So now we can swap them. We get the 0, 2, 1, 3, 4, 6, 5, 7. So you can see everything's been swapped around. So next thing we want to go over is we want to go over NumPy arithmetic operations. How can we take these and use these? Let me just go ahead and put this cell as a markdown. There we go. We'll run that so it has a nice thing. All right, nice title on there. That's always helpful. And let's start by creating 2 arrays. We'll do A is an NP range, A range 9. And let's reshape this 3 by 3. So by now you should be seeing this reshape stuff, and this should all look pretty familiar. We have our 0, 1, 2, 3, 4, 5, 6, 7, 8 on there. And let's create a second one, B. And this time, instead of doing A range, let's do NP array. We'll just create a straight up array. And we'll do an array of 3 objects. So it's going to be 3 by 1. And if we go ahead and print B out, we run that. This is actually pretty common to have something like this, where you have a 3 by whatever it is and a 3 by 3 array. When you're doing your math, you kind of have that kind of setup on there. And what we can do is we can go np.add AB. Don't forget, we can always put a print statement on there. So if we add it, you'll see that it just comes in there and it goes, okay, we're adding 10 to everything. And we could actually do something more, make it more interesting. 10, 11, 12. So let's change B's now, 10, 11, 12, and let's run that. And you can see that we have 10, and then you had 1 plus 11 is 12, 2 plus 12 is 14. 13, so 10 plus 3 is 13. 11 plus 4 is 15. And 12 plus 5 is 17, and so on. We'll put this back, since that's how the original setup was. Let's do 10 by 10 by 10, and run that, and get the original answer. And if you're going to add them together, we need to go ahead and subtract AB. And we run that. We get minus 10, minus 9, minus 8, just like you would expect. So we have our subtraction. 0 minus 10 is minus 10, and so on. And if you're going to add and subtract, you can guess what the next one is. We're going to multiply. And we'll multiply AB. And this should be pretty straightforward. You should expect this. If we multiply 10 times 0, we got 0. 10 times 10 is 10, and so on. And finally, if you're going to multiply, what's the last one we got is divide. What happens when we do divide A by B? And we run this, and we're going to get 0. And this is 0 divided by 10 is 0, 1 divided by 10 is 0.1, 2 divided by 10 is 0.2, and so on and so on. So the math is pretty straightforward. It just makes it very easy to do the whole setup. And again, if we went this, and let's say, let's change this up here. Instead of 10, we do 100. And make this 1,000. There we go. And if we run that, and then we do the add, you can see we got 10 plus 100 plus 1,000. Same thing with the subtract. Same thing with the multiply. And then you can also see the same thing here with the divide. So a lot of control there with your array and your math. Again, let's set this back to 10. Oops, it's right up here, wrong section. There we go, 10. And we'll just go ahead and run these and get back to where we were. And this brings us to our next section, which is slicing. And let's put in our, we'll just make this a cell type markdown. And then we run that. Of course, it gives us a nice looking slicing there. And slicing means we're just going to take sections of the array. So let's create an array np a range. Let's just do 20. And if you remember, if we do A, we have a 0 to 19. And then we can do A, and remember we can always print these. This can always be put in a print, but because I'm in Jupyter, if you're doing a demo in Jupyter, it's just so great that you have all these controls on here. So we can slice 4 on, and this should look familiar because this is the same as a Python and a lot of other different scripting languages. If we do 4, it goes 0, 1, 2, 3, that's the first 4 in the thing, and it skips some and starts with this one. The first 4 are skipped, and then from there on. You can also do the opposite and go till the 4th one. If we run that, we get 0, 1, 2, 3. Quite the opposite on there. We can do a single item, so we can pick object number 5 on the list, run that, and 5 happens to be 5, because that's the order they're in. And then this one's interesting, because I can do s equals slice, and let's create a slice here, and let's do 2, 9, let's leave it 2 on there. So we'll create an s slice on here. And then if we take our array, and we do array of s, we're taking our slice in there, and let's go ahead and run that. And let's take a look and see what it generated here. First off, we started with 2, so we have 2 at the beginning. We're going to end at 9, which happens to be 8, so it stops before the 9. Remember when we're doing arrays in Python. And then we step 2, so 2, 4, 6, 8. We could do this as 3. Let me run that, and you can see how that changes, 2, 5, 8. And we could do this as, let's leave this at 3, and if we change this to 10, oops, let's make it 12. There we go. And we run that, we have 2, 5, 8, 11. So that's pretty straightforward. It's a very nice feature to have on here where you can slice it and take different parts of the series right out of the middle. So now that we've accessed the different pieces of our array, let's get into iteration. And this is interesting because my sister, who runs a college data science division, the first question she asks is, how do you go through data? And she's asking, do you know how to iterate through data? Do you know how to do a basic for loop? Do you know how to go through each piece of the data? And in NumPy, they have some cool controls for that. So put this in as a markdown. There we go, and run it. And it's called the ND-iter. I'm not sure what the ND stands for, but ND-iter for iterator. So before we do that, though, let's create an array or something we can actually iterate through. We'll call it A equals NP A range. Let's do something a little funny here, or funky. And we'll do 0, 45, 5. I'm not sure why the guys in the back picked this particular one. It's kind of a fun one. And if I run that, we do this, you can see we get 0, 5, 10, 15, 20, 25, 30, 35, 40. That's what this array looks like. And that's just from our slice. This is just a slice. That's all that is we created a slice of 0 to 45, step 5. And so we can do with this, we can also do A equals reshape. Let's go ahead and take and reshape this. And since there's 9 variables in there, we'll do a reshape it 3 by 3. So if we run that, whoops, missed something there. That is the A. That really helps. So if we do the A reshape, and we'll go ahead and print that out. We get 0, 5, 10, 15, 20, 25, 30, 35, 40. And then we simply do 4x in our NumPy indicator of A colon, and we'll just go ahead and print x. And let's see what happens here when we run through this and we print each one of those. It goes all the way through the whole array, so it's the same thing we just saw before. We got 0, 5, 10, 15, 20, 25, 30, 35, 40. So it prints out each object in the array. So you can go through and view each one of these. And certainly if you remember, you could also flatten the array and just do for A and that also and get the same result. There's a lot of ways to do this, but this is the proper way with the ND iterator because it'll minimize the amount of resources needed to go through each of the different objects in the NumPy array. And hopefully you asked this question when I just did that. And the question is, how can I change this instead of doing each object? So first of all, let's go ahead and take my cell type, and we're going to mark that down and run it. And so we're going to work on iteration order C style and F style. Remember C because it came from the C programming, and F because it came from the old Fortran programming. So let's give us a reminder. We'll do a print A, and we'll do 4x in NP iterate A. But we also want to do this in a specific order. And you know what? I'm a really lazy typer, so let's go back up here. This is the ND iterator. I knew I was missing the ND part of A. And let's do order equals C. We'll print X on there. And let's do that again. And this time order equals F. There we go. Order equals F. And let's go ahead and run this and see what happens here. And the first thing you're going to notice, our original array, 0, 5, 10, 15, 20, 25, 30, 35, 40. When we do order C, that's the default, 0, 5, 10, 15, 20, and so on. And then when you come down here, you'll see F, order F, is 0, 15, 30. So it takes the first digit of each of the subarrays, or the second dimension, and then it goes into the second one, 5, 20, 35, 10, 25, 40. So slightly different order for iterating through it if you need to do that. So we've covered reshaping, we've covered math, we've covered iteration, we've covered a number of things. The next section we want to go ahead and go over is going to be joining arrays. So we need to bring them together. Let me go ahead and take the cell and make it a markdown. Cell type markdown. There we go. And run that. So let's work on joining arrays so we can bring them together and what different options we have. And let's do, we'll do an NP array 1, 2, 3, 4. We'll go ahead and print. Let's do, oops, first. Well, these arrays aren't that big, so let's just go ahead and keep it all on one line, A. So if we run this, first array 1, 2, 3, 4. Whoops, I forgot that it automatically wraps it when you do it this way. So we'll go ahead and keep it separate and print A. There we go. And let's go ahead and do a B. And we'll do 5, 6, 7, 8. And notice I'm keeping the same shape on these two arrays. Depending on what you're doing, those shapes have to match. And let's go ahead and print second array. Do a print B. We'll go ahead and run that. Oops. Missed something up there. Let me fix that real quick. when I was reformatting it to go on separate lines, I messed that up. There we go, run. All right, so we have first array 1, 2, 3, 4, second array 5, 6, 7, 8. And we'll put a carried return on there. And the keyword we use is concatenate. And if you're familiar with Linux, it usually means you're adding it to the end on there. And we're going to do what they call along axis 0. So we have concatenate AB along axis 0. Let's go ahead and run that and see what that looks like. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have an array that is 4 by 2. Has a nice shape of 4 by 2 on here. And if we're going to do it along the axis 0, you should guess what the next one is. We're going to do it along the 1 axis. And let's see how those differ from each other. Let's just go ahead and run that. And again, all we're doing is adding in the axis equals 1. So we have our concatenate, we have AB, and then axis 1. Remember a couple things. One, these are the same shape. So we have a 2 by 2, same dimensions going in there. You're going to get an error if you're concatenating and they're not. If you have something that instead of 1, 2 is 1, 2, 3, 4, 5, 6 with a 5, 6, 7, 8. They'll give you an error on there. In fact, let's take a look and see what happens when we do that. Let me just take this. 1, 2, 3, 3, 4, 5. And let's run that. And if we come down here, we got there. It says all the input array dimensions except for the concatenation axes M must match exactly. So it will let you know if you mess up. That's always a good thing. Let's go ahead and take this back here, and let's go ahead and run that. And so we have our 0 axes, which is 1, 2, 3, 4, 5, 6, 7, 8. And we bring them together. And you'll see a very different setup here when we do it along the axis 1. We end up with, instead of 4 by 2, we end up with a 2 by 4. 1, 2, 5, 6, 3, 4, 7, 8. And that's just changing which axes we're going to go ahead and concatenate on. What I find is when you're talking about the concatenate or the joining arrays, you really got to play with these for a while to make sure you understand what you mean by the axes. It looks very intuitive when you're looking at it. Axis 0, 1, 2, 3, 4, 5, 6, 7, 8. Axis 1 is then splitting it a different way, 1, 2, 5, 6, 3, 4, 7, 8. When you're actually using real data, you start to really get a feel for what this means and what this does. So if we're going to do that, let's go ahead and look at splitting the array. And do that under Markdown and run it. There we go. So you have a nice little title there. And we'll go ahead and create an array of 9. Let's do NP split. We'll do A, and we're going to split it by 3. Let's just see what that looks like. So if we split it, we get an array 0, 1, 2, 3, 4, 5. We get 3 separate arrays on here. Now remember, we're looking at, let me just print A up here. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we can split it into 3 separate arrays. And let's take this, we're going to do this right down here, just move the A split down here. Instead of the 3, let's do 4, 5, and put that in brackets. And so when we do it this way, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. I wasn't sure what to expect on that, but we get, when you split an A by 4, 5, you get a totally different setup on here as far as the way it split the array. And to understand how this works, I'm going to change the 5 to a 7. And this will visually make this a little bit more clear. So we had 4 and 5, it went 0, 1, 2, 3, 4, 5, 6, 7, 8. And you see the markers 4 and 5. When we do 4 and 7, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what you're looking at here is the first markers, this is going to go to 4. So there's our first split at the 4, the marker at 4, and then the second split is going to be at position 7. And this is the same thing here. 4, position 5. That's why we're splitting it in those 2 sections. We could also do it 7. Let's just see what that looks like. Run. And you can see I now have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can split it in all kinds of different arrays and create a different set of multiple arrays on here and split it all kinds of different ways. And before we get into the graphs and other miscellaneous stuff, let's go ahead and look at resizing the array. We'll go ahead and take this cell and set the cell as a markdown and run it. Give us a nice title there. And we'll do an array, an NP array of 1, 2, 3, and 4, 5, 6 here. And let's go ahead and just print. Let's go print a dot shape. And we'll go ahead and run that. Whoops, hit a wrong button there. Hit the comma instead of the dot. So we have a shape of 2, 3 here. And this is important to note because when we start resizing it, it's going to mess with different aspects of the shape. And so we'll go ahead and do a print. Scoop in for a blank line. There we go. Now let's do b equals np dot resize. We're going to resize a, and let's resize it with 3 by 2. And then we'll just go ahead and print b and print b period shape, not a comma. We'll run that. Oops, forgot the quotation marks around the end. We'll go ahead and run that, and let's just see what that looks like. So we have 1, 2, 3, 4, 5, 6, our original array, with a shape of 2, 3. And then we want to go ahead and resize it by 3, 2. And we end up with 1, 2, 3, 4, 5, 6, and we end up with a shape of 3, 2. That shouldn't be too much of a surprise. You know, we got 6 elements in there. We can resize it by 2, 3 was the original one, and then we're actually just reshaping it is how that kind of comes out as when you resize it like that. But what happens if we do something a little different? And let's go ahead and just take this whole thing and copy it down here so we can see what that looks like. And instead of doing 3, 2, remember last time I did the, to reshape it, I messed with the numbers and it gave me an error. Well, when you resize it, you don't have to match the numbers. They don't have to be the same dimensions. So we can, instead of going from a 2, 3 to a 3, 2, we can resize it to a 3, 3. So let's take a look and see how it handles that. And when we come down here to 3, 3, we end up with 1, 2, 3, 4, 5, 6, and it repeats 1, 2, 3. So it actually takes the data and just adds a whole other block in there based on the original data and repeating it. All right, now at this point, we've been looking at tons of numbers and moving stuff around. What we want to go ahead and do is get a little visual here, because that certainly you can picture all the different numbers on there, but let's look at histogram. Let's put this into a histogram. Let me go ahead and run that. And to do that, we're going to use the matplot library. So from matplot library, we're going to import pyplot as PLT. And that's usually the notation you see for pyplot. So if you ever see PLT in a code, it's probably pyplot in the matplot library. And then the guys in the back did a nice job, and gals too, guys and gals back there. Our team over at Simplilearn put together a nice array for me, 20, 87, 4, 40, 53, with a bunch of numbers. That way we had something to play with. And what we want to do is we want to do plot the histogram. Now remember, a histogram says how many times different numbers come in. And then we're going to put them in bins. And we have bins 0 to 20 to 40 to 60 to 80 to 100. You might, in here with the matplot library, they call them bins. You might hear the term buckets, or they put them in buckets. That's a really common term. And then we want to give it a title. So the way it works is you do your plt.hist for histogram, your plt title, and your plt show. And we're doing just a single array in here in the NumPy array of A. And let's go ahead and run this piece of code. Taking a moment to come out there, so it's figure size, so it's generating the graph. And you can see we have, and let's just take a look at this and go down a size. There we go. Okay, so now we can see what we're taking a look at here. So between 0 and 20, we have 3 values. So we have a 20 here, we have a 4, and a 11, and a 15. 0, 1, 2, 3. It's actually 4 values, but they start at 0. So remember, we always count from 0 up. And from 20 to 40, we got 20. So it's 1, 42, 3, 4, 5, 6. And so you can see in the histogram, it shows that the most common numbers coming up is going to be between the 40 and 60 range, least common between the 80 and 100. This looks like an age demographics is what this looks like to me. And you can see where they would have put it in the buckets of different age groups, which would be a nice way of looking at this. Histograms are so important and so powerful when you're doing demos and explaining your data. So being able to quickly put a histogram up that shows what's common and how it's trending is really important. And using that with a NumPy is really easy. And you know what, let's take the same data, and I want to show you why we do bins, or why we have buckets of data. I'm used to calling it buckets. Why we have bins. Let's do it instead of by 20, let's do it by tens and see what happens. And what happens when you do it by tens is you miss out on you can see a nice curve here on the first one, and on the second one it looks like a ladder going up and a plummet, a ladder going up and a plummet, and a ladder going down. So the first would be more indicative of an age group, and the second one would be what you would get if you divided incorrectly. You wouldn't see the natural trend of, I don't know what this would be, maybe how much food they eat. Hopefully not, because I'm in 50, so I'm right in the middle there, which means I eat a ton of food compared to everybody else. But it's some kind of demographic. Maybe it's mental, maybe it's knowledge, because we hit a certain point and then we start losing, our marbles start leaking out or something. So you start off knowing something, and then as you get older you grow more. But you can see here we lose that. You lose that continuity in the thing if you split the histogram into too many bins or too many buckets. And if you actually plotted this by the individual numbers, it would just be a bunch of dots on the graph and wouldn't mean a whole lot. And we've looked at graphs. There turns out are a ton of useful functions in NumPy. I'm sure there's even new ones that aren't going to be in here. But let's just cover some important ones you really need to know about if you're using the NumPy framework. One of them is line space function. This is generating data. So you have a line space, we have 1, 3, 10, and when we do that, we end up with 10 numbers. So if you count them, there's 10 numbers. They're between 1 and 3, and they're evenly spaced. We get 1, 1.222. But these are all, there's a total of 10 here, and it's right between the 1 and 3 range. That can be, there's a lot of uses for that, but they're probably more obscure than a lot of the other common NumPy arrays set up. Then a real common one is to do summation. So we'll do summation where you do, in this case we create a NumPy array of two different arrays, 1, 2, 3, or two different dimensions, 1, 2, 3, 3, 4, 5. And we're going to sum them up under axes 0, which is your columns. And if you remember correctly, columns is the 1 plus 3, 2 plus 4, 3 plus 5, so we have 3 columns. And if we change this, we'll just flip this to 1. We get 2 numbers. So we get 1, 2, 3 all added together, which equals 6, and 3 plus 4 plus 5, which equals 12. We'll set this back to 0. There we go, since we're looking at axis 0. And these probably could have been, some of these could be with our math section. Square root and standard deviation, 2 very important tools we use throughout the machine learning process and data science. And simply we take the NP array, we have again the 1, 2, 3, 4, 5, 6, 3, 4, 5. I don't know why I need to keep recreating it, probably could have just kept it. But we can take the square root of A. So it goes through and it takes the square root of all the different terms in A. And we can also take the standard deviation, how much they deviate in value on there. And there's a rabble function. We can run that. And NP array is x, we're going to do x equals, hey, we changed it from A to x. X equals rabble. And this sets it up as columns. So we have 1, 2, 3, 4, 5. This is all columns on here. Very similar to the flatten function. So they kind of look almost identical. But we also have the option of doing a rabble by column. And then another one is log. So you can do mathematical log on your array. In this case, we have 1, 2, 3. And we'll find the log base 10 for each of those 3 numbers. And there's a couple of them. You can't just do any number here after log, but there is also log base 2. Log base 10 is pretty commonly used on here. We'll go and run that. There we go. Before we go, let's have a little fun. Let's do a little practice session here on some more challenging questions. So you start to think how this stuff fits together. Right now we just looked at all the basics and all the basic tools you have. So let's do some NumPy practice examples. And let's start by figuring out how do you plot, say, a sine wave in NumPy. What would that look like? And so in this project we wouldn't have to do this because I've already run these. But we'd want to go ahead and import our NumPy as NP, and import our matplot library pyplot as PLT. So we get our tools going here. And then we'll break it into two sections because we need our X, Y coordinates in here. So first off, let's create our X coordinates. And our X coordinates we're going to set to an A range. And we want this A range, since we're doing sine and cosine, it's going to be between 0 and 0.1. And then we use our NP, and we actually can look up NumPy stores pi. So you have the option of just pulling pi in there directly from NumPy. It has a few other variables that it stores in there that you can pull from there. But we have NumPy pi, and we generate a nice range here. And let's go ahead and run this. And just out of curiosity, let's see what X looks like. I always like to do that. So we have 0.1, 0.2, 0.3, 0.4. So we're going 0 to, in this case, 9.4, 3 times NumPy pi. Remember, pi is like 3 point something, something, something. So that makes sense. It should be about 9. And we're doing intervals of 0.1. So we create a nice range of data. And then we need to create our Y variable. And so Y is going to simply equal NP, or NumPy.sine of X. And then once we have our X and Y, and if we print, let's go ahead and just print Y. See how that, we'll do this. Let's do this so it looks print X, print Y. So we basically have two arrays of data. So we have like our x-axis and our y-axis going on there. And this is simply a plt.plot, because we're going to plot the points. And we'll do x comma y. And then we want to actually see the graph, so we'll do plot.show. And we'll go ahead and run that. And you see we get a nice sine wave. And here's our numbers 0 through 9. And here's our sine value, which oscillates between -1 and 1 like we'd expect it to. Then for the next challenge, let's create a 6x6 two-dimensional array and let 1 and 0 be placed alternatively across the diagonals. Oh, that's a little confusing. So let's think about that. We're going to create a 6x6 two-dimensional, so the shape is 6x6 two-dimensional array, and let 1 and 0 be placed alternatively across the diagonals. Now, if you remember from lesson 1, we can fill a whole NumPy array with zeros or 1s or whatever. So we're going to do NP, create a NumPy zeros, and we're going to do a 6x6, and we'll go ahead and make sure it knows it's an integer, even though it's usually the default. And just real quick, let's take a look and see what that looks like. So if I run this, you can see I get 6x6 grid, so 6x6, 0, 0, 0, 0, 0. Now, if I understand this correctly, when they say 1s and 0 placed alternatively across the diagonals, they want the center diagonal, maybe that's going to stay 0 all the way down, and then the next diagonal will be 1s all the way across diagonally, and then the next one 0s, the next one 1s, and the next one 0s, and so on. Hopefully you can see my mouse lit up there and highlighting it. So let's take a little piece of code here, and we'll do z1 : 2, comma : 2 equals 1. And wow, that's a mouthful right there. So let's go ahead and run this and see what that's doing. And so what we're doing is we're saying, hey, let's look at, in this case, row 1. There's 1. And then we're going to go every other row 2, so we're going to skip a row. So skip here, skip here, skip here. So we're going down this way, and we're going every other row going this way. It's hard to highlight columns. So you can see right here where we're not touching each row, like this row right here is not being touched. Okay, so we're going to start with row 1, and then we're going to skip a row and another one, and so we're going every 2 rows. And then in every 2 rows, we're looking at every 2, starting with the beginning. That's what this thing blank means. So we're going to start with the beginning, and we're going to look at all of them, but we're going to skip every 2. So starting with row 1, we look at all the rows, but we do it by 2 steps. So we go 1, skip 1, 1, skip 1, 1, skip 1, 1. If you left this out, it'd do every 1. This would just be 1s. In fact, let's see what this looks like. If I go like this and run it, you can see that I just get 1s. So this notation allows us to go down each row, row by row, and we're going to do every other row set up on there. And so if we're going to start with row 1, we also, Control Z, try that. There we go. We'll start with row 0. Again, we're going to go each row, step 2. So we'll start with row 0, and we'll go every other row. And this time we'll start with 1, column 1. And again, we go every other one going down. That's what that step 2 is. That's skipping every other one. We're going to set that equal to 1. So let's see what that looks like. And you can see here we get our answer. We get 0, 1, 0, 0. But it has the 1s going in diagonals on every other diagonal and 0 on every other one. A little bit of a brain teaser, that one, trying to get that one to work out. So you can see how you can arrange your rows, and here's your step and your different axis on there. And then the next one is find the total number and locations of missing values in the array. The first challenge is to create some missing numbers. So let's create our array Z. We're going to do numpy.random.rand 10, 10. And before we do the second part, let me just take this second part out. And let's just see what that looks like. So let's run that. And there we go. So we have a 10 by 10 random array. It randomly is picking out numbers. And next, we want to go ahead and take our random integer size equals 5. And then we're going to do a random 10 size equals 5. So in the Z, we're going to select a number of random spaces here and set them equal to null value. And let's go ahead and run that so you can see what that looks like. And if we look at the array, we've created 1, 2, 3, 4. There should be a fifth one in here. My eyes may be failing me. So we've created a series of, because 0 to 5, 0, 1, 2, 3, 4. So we got 5, there are different null values on here. And this is kind of a neat notation to notice that we can generate random integers, size equals 5. So this generates 5 by 5 miniature grid inside of this to tell it where to put the nans at. So that's kind of a cool little thing you can do. And then we want to look up and see how many null values are in there. And this is simply just np is nan of z. Simple. So if it is nan, then we want to sum it up. So we're going to sum up all of the different null values on there. Now let's do one more feature in here, which is really cool. Let's go ahead and print the indexes. So np argware np is nan of z. So we're going to create our own another np array. And let's run this, and we'll see here that it comes up with the 4 indexes. So we did count 4 of them up there. It tells you where they are, 1, 9, 2, 0, 4, 6, 5, 4. And then let's go ahead and run this again. Run, there we go. This time I got 5. That's what we get for random numbers. Another fun one that I always like to do is very similar, because we have np is nan z dot sum. So we're summing the number of nans. And we can get the indexes, and you can reshape the indexes. But you can also just do, we'll do an INDS where np is nan of z. And let's just print, that. Print INDS. Let's see what that looks like. And it's very similar to what we have 0, 1, 3, 0, 6, 3, 8, 6, 9, 3. But I've split it into 2 different arrays. So we have our X and our Y kind of coordinates going there. And what I can now do is I can now do Z INDS equals. And at this point, you can also, instead of getting the sum, you can get the means or all the numbers and that kind of thing, or the average as it is. So that'd be one thing you could do, and you can pick out the average. That's very common in data science, to get the average and just use that for a value. But we'll go ahead and just set it to 0, and then let's go ahead and print our Z and run that. And you can see when we come down here, we have wherever there was a null value, it is now 0. And you can set this to whatever you want. This is another way to replace data or help clean data up, depending on what it is you're doing. So, wow, we covered a lot of stuff. So quick rehash going over everything. We went into there, we looked at array manipulation, changing the shape, how to switch that around. We even had the flatten down there, which remember we have another command lower that's similar. We could change the order by F. Remember F stands for Fortran, very strange connotation, but there's C and F. C is the standard, and F switches it to a different order. To be honest, I usually have to look it up because I almost never use F. But when you need it, you're like, oh my gosh, what was the other order? Just do a quick Google. So we talked about reshape, making sure that the dimensions are the same. You don't want to have like something that has 12 objects in it and reshape it to 11 and 5 because it doesn't work. It doesn't divide into 12. We can transpose, so we can switch them. So we can go from a 4x3 to a 3x4. Oops, I did that the other way around. 3x4 to 4x3. We covered reshaping the array. We did the roll the axes. You can do some weird things with swapping and rolling axes and transposing the numbers. We dug a little bit into the arithmetic. So we talked about adding, we talked about subtracting, multiplying, dividing. And, at this point, it's so important we just look up the NumPy mathematics. And you can see here they have just about everything. Your trigonometry, your hyperbolic functions, rounding, sums, products, differences. There are so many, all your different miscellaneous mathematical connotations. So, Google it, go to the main NumPy page and look at the different setups you can do on there. So we covered that. And we did slicing, how to break it apart. We did iterating over the array. We covered joining arrays and how to concatenate. Remember, concatenate just means add on to it. So in this case, how are you adding B onto A is how you'd read that. From Linux, you should catch the concatenate because that's used regularly there. Splitting the array, we talked about how to split the array in different ways. So you can split it in array of arrays, all kinds of different ways to split the array up. How to resize it. And remember, resize does not have to have the same shape, but if you resize it, it will take the data and begin at the beginning and add new rows on if the size is bigger. If it's smaller, it truncates it. It just cuts the end off. We looked at how to do a histogram and how to plot that. We mentioned buckets or bins, as they call them in PyPlot. And then we covered a lot of other useful functions in NumPy. We talked about the line space setup for doing numbers in a series, how to sum the axes up. Again, that's part of the mathematical formulas there that we looked at. There's a sum, there's also means and median. All of those you can compute in NumPy. And you can also do the square root and standard deviation. The ravel function, very similar to the flatten. To be honest, I almost always just use the flatten, but the ravel has its own kind of functionality that it does. And then we went into some NumPy practice examples. We challenged you to create a sine wave in NumPy and how to do that. We're kind of looking for that A range. Remember how we do the A range, and you can have your beginning value, your end value, which they did as 3 times pi, NumPy pi, and we're going to do intervals of 0.1. And then y just equals the NumPy sine of x. There's our math from the math page we were just looking at. Remember that? It's right at the top. And finally, we went down here. We had this kind of a little brain teaser, how to do diagonal zeros and ones, playing with the different connotations of the NumPy array. And then we did a random size, and we played a little bit with with the null values, playing with null values. If you're doing any data science, null values are like a headache. What do you do with them? Big sets of data, you get rid of them. Small sets of data, you have to factor something in there, like figure out the average or the median there, and then replace it with that. Pandas really is a core Python module you need for doing data science and data processing. There's so many other modules that come off of it. There actually sits kind of on NumPy, so if you've already had our NumPy array, hopefully you've already gone through the NumPy tutorial 1 and 2. So today we're going to cover what is Pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is Pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about pandas, and there is some connections. There's like an interface going on with that, so there is availability, but you really should know your pandas, because if you're working in big data, you'll know there's data frames. Well, pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said it that it's a data frame. So the data structures in pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from NumPy we studied, they had to be all uniform. Not in pandas. In pandas we can do a lot more. And pandas actually kind of sits on NumPy, so you really need to know both of those if you haven't done the NumPy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just two columns, and we have a nice index label and a column label for the data. And then a data frame is a two-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this should look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel. So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows. So you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter Notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org, and then I always let mine sit on Anaconda, anaconda.com. And just real quick, we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook. In this case, jupyter.org. And when we're in our I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3. And this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial. And we'll go up to Cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import Pandas. And usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Whoops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In pandas, you just use the, in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4, and if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it. Take pieces of it, so query it. Delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series and then almost all the code. In fact, all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, let's put a, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1, and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1 and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with NumPy arrays is we can import our NumPy as NP. Remember that from our NumPy tutorials. We can go ahead and create a NumPy out of random with the random numbers of 5. And let's just see what that n looks like so we can see what our NumPy looks like. So we have some nice random float values here, 2.33, so on. And this from our last tutorial, the NumPy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create our, we'll just use S2 again. And here's our NP for NumPy, series, capital S, and N is our NP for NumPy. PD for pandas, there we go, switching my anachronisms. So we have pd.series of n, and we go and do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 is to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the NumPy array. So we used NumPy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for pandas, series, and then we want to go ahead and just do D in here. Print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integer 64 because the actual data is 1, 2, 3, 4, 5, and it's all integer 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1 the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that. And you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable, or might be representational of a larger database you're working with. So cool tools, we've covered creating a database based on a basic array, Python array. We've showed you how to reset the index. Then we showed you how to use a NumPy array. So you can put a NumPy array in there. It's all the same, pd.series, a NumPy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data. And you can pull in data from different sources and different setups and create a new series very easily in the pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing, most common thing you'll probably do on here. And we'll just do S1. This notation should start to look really familiar. Again, this is going to put an output. So it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. And we can do the same thing by not having the A in there. I'll go ahead and take that out. But it's just a reminder that it's not actually changing S1. It's just viewing S1. So simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1. And you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end. And likewise, we can do a 2 here, a CDE to the end. So it starts at the second one. And another way we can do this is we can do a -2 over here. And that looks at just the last 2 in the slice. So you can see how easy it is to slice the data. And of course, there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have A, B, C, D, E, A, B, C, D, E, 0, 1, 2, 3, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and A, B, C, D, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. All right, so we've covered all kinds of cool tools here. We have appending, we have slicing, we did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next, what we want to get into is we want to get into operations that happen on the series. Let me go ahead and change this cell to Markdown. There we go, and run that. So series operations, what can we do with the series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a panda series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same. And we'll call this S6. And we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, We'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do s5.add s6. And let's see what that generates. And just a quick thing, if you've never used Pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. And we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this, there's nothing there. So it gives us a null return. Very different than the NumPy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add s5.add s6, and likewise we can do s5.sub for subtract s6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's the null values where it can't subtract the two because there's no values there to subtract. We can also do s5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this, and you can see how they're multiplied together. And then we can also do the s5 div, 3 letters again, s6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters, because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, an R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there, and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting, because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go ahead and run that. So we have a nice title on there. It's always good to have a good title. All right, so our first data frame, we'll jump in with some stuff that looks a little complicated, but we'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or a NumPy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the pandas that you can use. And next we're going to use NumPy to go ahead and generate some random numbers. In this case we'll do the np.random.random in 6, 4. You can look at this as rows and columns as we move it into the pandas. And of course you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know what, before we do the next one, let's go ahead and just print out our NumPy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns, and we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame, and we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns. And you can see there's our columns on there. And we'll go ahead and do df1 equals pandas dot data frame. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our NumPy array, because that's what we're going to create our data frame off of, is the NumPy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. Now remember, we had all that different data that just looked like a jumble of data. We have our column names and everything else. Our NumPy array, kind of just a jumble array over there, 4 by 6. You can sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, you know, this is our date. This is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, you know, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, you know, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. You know, we have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our NumPy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, you know, np.nan, NumPy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas, data frame, and then we have our data, just like we did before, and then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like, df2. So let's go ahead and run that. Another, again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats, and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 dtypes. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head, and if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df_tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is, the tail, I love doing the tail of 1 because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. I'm looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable. It's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it, and then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it creates, just displays a nice array. A very easy way to convert this back to a NumPy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a NumPy array first, setting the columns and the index. The index is setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the NumPy array, the index dates, and the columns. And remember, in our NumPy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then of course we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up D-type. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have df2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value, 25% are in this group, 50%, 75, and your maximum value. So this will look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. And it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4x6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't do, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2 and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.52, 2.53, and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use a df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun, because remember this returns a data frame. So if I take df2 dot sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as a df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go, they have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's pick a spot. Let's go back up here where we had, let's do F age, let's see, what was I looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3 equal, and then we go ahead and print out our df3. And if we go to F and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff, we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location and iLocation is null. Making a copy, here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age, Look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375, and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and still the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. We could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, we can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying, along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, A, B, A, C, A. Popped in a null value. Cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D. And it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we use the string function, str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC. And baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. We'll go ahead and run that. And you can see we now have ACD, AAA, baka. Everything's capitalized except for the null value, which is still null. Alright, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was, it's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4, I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our df4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And then we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what df5 looks like when we do that. There we go. And there it is. D is gone and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the iris data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values or missing values. You can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file is a CSV. So we have df3 to CSV or animal. And let me just show you what the folder is going into. Right now I have some untitled and a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open it up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top. And the index, comma, then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV. And it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read_CSV. I always have to remember it's to_CSV and read_CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head. We only want to look at the first 3 lines. So if I go ahead and run this, we'll see the first 3 lines and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet1, and then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values because there's null values in here, and we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2, there we go. And let's run that. Let's make this, let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel, and one of these is a CSV on here. And so there's our 2 file types on there. And they have other formats. These are just the 2 most common ones used, and I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. So we looked at 2 different ways to bring data in and save it to files. We've looked at all kinds of different ways of manipulating our data set and slicing it and creating it for our data frame. Let's get in there for your visualization. Always the big thing at the end, because 1, it lets you check to see what you did, make sure it looks right. And then also, if you're going to show somebody else, it makes it very clear what's going on if they see something visual. So this is where a really important part of data science is. So let's go ahead and bring in our tools. We're going to do import NumPy as NP. We want to make sure we have our ampersand matplot library in line. This just lets Jupyter know that we're going to print it on this page. If you're using a different IDE, you don't really necessarily need that, but this does help it displays correctly in Jupyter Notebook. And if you remember from earlier, we could create a, we're going to call it TS. We're going to create a pandas, which are cute, cuddly creatures, versus a pandem, short for pandemonium? No. So we have TS equals PD series, and we're just going to create a random setup of 50. We'll do an index. We'll set it equal to the pandas date range today. Periods equals 50, so the 50 should match. And I want you to notice something here. I did not import the matplot library. Why? Because it's already in there. Pandas already has its built-in connection and interface with matplot library, so you don't have to import it. And we'll go ahead and do TS equals TS dot cumulative sum. We're going to do the cumulative sum. So a little reformatting there, and we'll go ahead and plot it. And let's take a look at what that looks like. So we have a nice graph here. We have the dates on the bottom. We've set this up so we have a nice range between, in this case, -4 to, looks like about 2 maybe, or 1, -4 and 1. So what we've done here, we plotted a basic series, just a single row of data, and we've set indexes on there. But we can also do the whole data frame on there, and let's see what that looks like. So first, let's go ahead and create the data frame. We have here random numbers, so we're going to do 50 by 4, and then we'll go ahead and create columns A, B, X, and Y. Just because we can. Index is a ts.index on there, so we're going to use the same index as before, just to keep it nice and uniform. We've already generated the dates to go with it. And then we can do, just like we did with the series, we can also do with the data frame, df equals df cumulative sum. So we're going to sum the whole data frame. And then we'll do simply df plot. And let's push that in, and let's go ahead and run this. And look how easy and quick that was to generate a nice graph with all the different data on there. So we have our shared index, we have the shared columns, and then we have the different data from each one that we can easily look at and compare. So very quick way of displaying data. You can imagine if you were working in, I think I mentioned stock earlier because I've been doing some analysis of stock lately. So you'd have your date down here, and then you would have stock A, stock B, stock XY, whatever it is. And you can put them all on one chart and see how what they look like next to each other. And this isn't too far off from what some of those graphs look like, and this is just randomly generated. So stock has a lot of randomness in it, which is one of the reasons I actually play with it for doing some of my models for testing them out. Now, there are a lot of features in Pandas. So we're going to show you one more thing on here. There's some of the things, like I didn't go too deep. We looked at the top two for importing data from a CSV and from an Excel spreadsheet. Showed you how to quickly plot the data. There's more settings in there you can do. We're going to do one more thing down here, and this is kind of a fun one. Change this to a markdown and run that. So how would you remove repeated data using Pandas? And this is where you have a data set that comes in, and maybe it's feeding from one location, and instead of noting that it's repeated the date, like, let's go back to stocks. That's a good visual. We have the stocks from the 23rd. And it adds another row, and it's the same row. It's importing the 23rd again and again. So now you have that data repeated 3 times, and you need to go back and figure out how to get rid of it. How do you track that down? So let's start by creating a quick database, or data frame. Not a database. I keep saying database. It's a data frame. And we'll just make this data frame using our dictionary going in. This data frame only has one data series in it, which is fine. So if we do df to print it out, you'll see A, 1, 2, 2, 2, 2, 4, 4, 4, 5, 6, 7, and so on. And so how would you remove that? Well, there is a neat feature in data frames called shift, along with another feature that lets us select just certain information. And we'll go with the location function. Put that in brackets. Remember that from above, location. And then in the location, let me just spread this out a little bit so it's real easy to read. In fact, I'm going to go upscale on that since we're doing a little bit more complicated here. What you can see on this, on the location, is I have dfa.shift. So this is going to shift up 1 by default. You can actually change this to 2 or 3. You can even do a -1 and it shifts the other way. But it's going to shift up by 1 by default. And it's going to say if that does not equal df of a, then we want that. And if you look down here, we had 1, 2, 2, 2, 2, 2. When we run this logic on here and we do the shift, it now gets rid of all the duplicates. So we went from 1, 2, 2, 2, 2, 4, 4, 5, whatever it was. Here it is, 1, 2, 2, 2, 4, 4, 4, 5, 5, 5, 6, 6, 6, to 1, 2, 4, 5, 6, 7, 8. And you'll see on the index, it just deletes them out of there so the index stays the same. Obviously, you don't want the dates to change if you're working with an index dated setup. So it just deletes those duplicates out of there. This is just a quick way to introduce you to, 1, the fact that you can add logic gates into here. And 2, the iLocation allows you to use shift. So there's the shift function, and then the iLocation selects that based on true or false. Wow, so we've actually covered a lot today in Pandas. We've really covered into the basics of selecting your different series out of your column, out of your data frame, how to index rows, how to slice, how to plot. Hopefully you'll take this beyond that and start combining these different things, and you can create long strings and really explore your data, generate some nice graphs. If you're in Jupyter Notebook, it's a great demo to show others. And I didn't know this about Jupyter Notebook. You can do this in Jupyter Notebook, and then you can download. And I never really looked too closely at all the downloads. But you can download it as an HTML and post it to your blog. So it's got a neat feature in there. But any of this is a really powerful tool. All of this is really powerful tools for doing your data science.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
And we're going to cover the scikit-learn tutorial, which has a lot of features and all kinds of API in it to explore data and do your data science with. In fact, it's probably one of the top data science packages out there. So what is the scikit-learn? It's a simple and efficient tool for data mining and data analysis. It's built on NumPy, SciPy, and Matplot library, so it interfaces very well with these other modules. And it's an open source, commercially usable BSD license. BSD originally stood for Berkeley Software Distribution License, but it means it's open source with very few restrictions as far as what you can do with it. Another reason to really like the scikit-learn setup, so you don't have to pay for it as a commercial license versus many other copyrighted platforms out there. What we can achieve using the scikit-learn, we use the two main things are classification and regression models. Classification, identifying which category an object belongs to. For one application very commonly used is spam detection. So is it a spam or is it not a spam? Yes, no. In banking, it might be, is this a good loan, bad loan? Today we'll be looking at wine. Is it going to be a good wine or a bad wine? And regression is predicting an attribute associated with an object. One example is stock prices prediction. What is going to be the next value? If the stock today sold for $23.05 a share, what do you think it's going to sell for tomorrow and the next day and the next day? So that'd be a regression model. Same thing with weather forecasting. Any of these are regression models where we're looking at one specific prediction on one attribute. Today we will be doing classification. Like I said, we're going to be looking at whether a wine's good or bad. But certainly the regression model, which is in many cases more useful because you're looking for an actual value, is also a little harder to follow sometimes. So classification is a really good place to start. We can also do clustering and model selection. Clustering is taking an automatic grouping of similar objects into sets. Customer segmentation is an example. So we have these customers like this, they'll probably also like this. Or if you like this particular kind of features on your objects, maybe you like these other objects. So a referral is a good one, especially on Amazon.com or any of your shopping networks. Model selection, comparing, validating, and choosing parameters and models. Now, this is actually a little bit deeper as far as a scikit-learn. We're looking at different models for predicting the right course or the best course or what's the best solution. Today, like I said, we're looking at wines. So it's going to be, well, how do you get the best wine out of this? So we can compare different models, and we'll look a little bit at that, and improve the model's accuracy via different parameters and fine-tuning. Now, this is only part one, so we're not going to do too much tuning on the models we're looking at, but I'll point them out as we go. Two other features: dimensionality reduction and pre-processing. Dimensionality reduction is we're reducing the number of random variables to consider. This increases the model efficiency. We won't touch that in today's tutorial, but be aware if you have, thousands of columns of data coming in, thousands of features, some of those are going to be duplicated, or some of them you can combine to form a new column. And by reducing all those different features into a smaller amount, you can increase the efficiency of your model. It can process faster, and in some cases you'll be less biased, because if you're weighing it on the same feature over and over again, it's going to be biased to that feature. And pre-processing. These are both pre-processing, but pre-processing is feature extraction and normalization. So we're going to be transforming input data such as text for use with machine learning algorithms. We'll be doing a simple scaling in this one for our pre-processing, and I'll point that out when we get to that, and we can discuss pre-processing at that point. With that, let's go ahead and roll up our sleeves and dive in and see what we got here. Now, I like to use the Jupyter Notebook, and I use it out of the Anaconda Navigator. So if you install the Anaconda Navigator, by default it will come with the Jupyter Notebook, or you can install the Jupyter Notebook by itself. This code will work in any of your Python setups. I believe I'm running an environment of 3.7 setup on there. I'd have to go in here into environments and look it up for the Python setup. But it's one of the 3X's. And we go ahead and launch this, and this will open it up in a web browser. So it's kind of nice. It keeps everything separate. And in this Anaconda, you can actually have different environments, different versions of Python, different modules installed in each environment. So it's a very powerful tool if you're doing a lot of development. And the Jupyter Notebook is just a wonderful visual display. Certainly you can use, I know Spider is another one which is installed with the Anaconda. I actually use a simple Notepad++ when I'm doing some of my Python script. Any of your IDEs will work fine. Jupyter Notebook is Iron Python because it's designed for the interface, but it's good to be aware of these different tools. And when I launch the Jupyter Notebook, it'll open up, like I said, a web page in here. And we'll go over here to New and create a new Python setup. And like I said, I believe this is Python 3.7, but any of the three, the Scikit-learn works with any of the 3X's. There's even 2.7 versions. So it's been around a long time. So it's very big on the development side. And then the guys in the back, guys and gals, they went ahead and put this together for me. And let's go ahead and import our different packages. Now, if you've been reading some of our other tutorials, you'll recognize Pandas as PD. Pandas library is pretty widely used. It's a data frame setup, so it's just like columns and rows in a spreadsheet with a lot of different features for looking stuff up. Seaborn sits on top of Matplot libraries. This is for our graphing. And we'll see that how quick it is to throw a graph out there to view in the Jupyter Notebook for demos and showing people what's going on. And then we're going to use the random forest, the SVC or support vector classifier, and also the neural network. So we're going to look at this. We're actually going to go through and look at 3 different classifiers that are most common, some of the most common classifiers, and let's show how those work in the Scikit-learn setup and how they're different. And then if you're going to do your setup on here, you'll want to go ahead and import some metrics. So the sklearn.metrics on here, and we're going to use the confusion metrics and the classification report out of that. And then we're going to use from the sklearn pre-processing the standard scalar and label encoder. Standard scalar is probably the most commonly used pre-processing. There's a lot of different pre-processing packages in the sklearn. And then model selection for splitting our data up. It's one of the many ways we can split data into different sections. And the last line here is our percentage matplot library inline. Some of the Seaborn and matplot library will go ahead and display perfectly inline without this, and some won't. It's good to always include this when you're in the Jupyter Notebook. This is Jupyter Notebook, so if you're in IDE, when you run this, it will actually open up a new window and display the graphics that way. So you only need this if you're running it in a editor like this one, with specifically Jupyter Notebook. I'm not even familiar with other editors that are like this, but I'm sure they're out there. I'm sure there's a Firefox version or something. Jupyter Notebook just happens to be the most widely used out there. And we can go ahead and hit the run button, and this now has saved all this underneath the packages. So my packages are now all loaded. I've run them, whether you run it on top or you run it to the left, and all the packages are up there, so we now have them all available to us for our project we're working on. And I'm just going to make a little side note on that. When you're playing with these and you delete something out and add something in, even if I went back and deleted this cell and just hit the scissors up here, these are still loaded in this kernel. So until I go under kernel and restart and clear or restart and run all, I'll still have access to Pandas. Important to know, because I've done that before. I've loaded up, maybe not a module here, but I've loaded up my own code and then changed my mind and wondering, why does it keep putting out the wrong output? And then I realized it's still loaded in the kernel and you have to restart the kernel. Just a quick side note for working with a Jupyter Notebook and one of the troubleshooting things that comes up. And we're going to go ahead and load up our data set. We're using the pandas, so if you haven't yet, go look at our pandas tutorial. A simple read the CSV with the separation on here. So let me go ahead and run that. And that's now loaded into the variable wine. And let's take a quick look at the actual file. I always like to look at the actual data I'm working with. In this case, we have wine quality-red. I'll just open that up. I have it in my open office setup. I'm separated by semicolons. That's important to notice. And when we open that up, you'll see we have, go all the way down here. It looks like 1,600 lines of data minus the first one, so 1,599 lines. And we have a number of features going across. The last one is quality. And right off the bat, we see the quality is has different numbers in it, 5, 6, 7. It's not really, I'm not sure how high of a level it goes, but I don't see anything over a 7. So it's kind of 5 through 7 is what I see here. 5, 6, and 7. 4, 5, 6, and 7, looking to see if there's any other values in there. Looking through the demo to begin with, I didn't realize the setup on this. So you can see there's the different quality values in there: alcohol, sulfates, pH, density, total sulfur dioxide, and so on. Those are all the features we're going to be looking at. And since this is a pandas, we'll just do wine head, and that prints the first 5 rows of data. And that's, of course, a pandas command. And we can see that looks very similar to what we were looking at before. We have everything across here. It's automatically assigned an index on the left. That's what pandas does if you don't give it an index. And for the column names, it has assigned the first row. So we have our first row of data pulled off our comma separated variable file, in this case semicolon separated. And it shows the different features going across. And we have, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 features. 12 including quality, but that's the one we want to work on and understand. And then because we're in Pandas data frame, we can also do wine.info. And let's go ahead and run that. This tells us a lot about our variables we're working with. You'll see here that there is 1,599. That's what I said from the spreadsheet, so that looks correct. Non-null float 64. This is very important information, especially the non-null. So there's no null values in here. That can really trip us up in pre-processing. And there's a number of ways to process non-null values. One is just to delete that data out of there. So if you have enough data in there, you might just delete your non-null values. Another one is to fill that information in with like the average or the most common values or other such means. But we're not going to have to worry about that. But we'll look at another way, because we can also do wine is null and sum it up. And this will give us a similar, it won't tell us that these are float values, but it will give us a summation. Oops, there we go, let me run that. It'll give us a summation on here, how many null values in each one. So if you wanted to, from here you would be able to say, okay, this is a null value, but it doesn't tell you how many are null values. This one would clearly tell you that you have maybe 5 null values here, 2 null values here. And you might just, if you had only 7 null values and all that different data, you'd probably just delete them out. Where if 90% of the data was null values, you might rethink either a different data collection setup or find a different way to deal with the null values. And we'll talk about that just a little bit in the models too, because the models themselves have some built-in features, especially the forest model, which we're going to look at. At this point, we need to make a choice. And to keep it simple, we're going to do a little pre-processing of the data, and we're going to create some bins. And bins we're going to do is 2, 6.5, 8. What this means is that we're going to take those values. If you remember up here, let me just scroll back up here. We had our quality. The quality comes out between 2 and 8 basically, or 1 and 8. We have 5, 5, 5, 6. You can see just in the first 5 lines of variation in quality. We're going to separate that into just 2 bins of quality. And so we've decided to create 2 bins. We have bad and good. It's going to be the labels on those 2 bins. We have a spread of 6.5 and an exact index of 8. The exact index is because we're doing 0 to 8 on there. The 6.5 we can change. We could actually make this smaller or greater, but we're only looking for the really good wine. We're not looking for the 0, 1, 2, 3, 4, 5, 6. We're looking for wines with 7 or 8 on them. So high quality. This is what I want to put on my dinner table at night. I want to taste the good wine, not the semi-good wine or mediocre wine. And then this is a pandas. So PD, remember, stands for pandas. Pandas cut means we're cutting out the wine quality and we're replacing it. And then we have our bins equals bins. That's the command. Bins is the actual command. And then our variable bins, 2, 6.58. So 2 different bins. And our labels, bad and good. And we can also do, let me just do it this way. Wine quality, since that's what we're working on. And let's look at unique. Another pandas command, and we'll run this. And I get this lovely error. Why did I get an error? Well, because I replaced wine quality and I did this cut here, which changes things on here. So I literally altered one of the variables that is saved in the memory. So we'll go up here to the kernel, restart and run all. That starts it from the very beginning. And we can see here that that fixes the error because I'm not cutting something that's already been cut. We have our wine quality unique, and the wine quality unique is bad or good. So we have 2 qualities objects. Bad is less than good, meaning bad's going to be 0 and good's going to be 1. And to make that happen, we need to actually encode it. So we'll use the label quality equals label encoder. And the label encoder, let me just go back there since this is part of sklearn. That was one of the things we imported, was a label encoder. You can see that right here from the sklearn.processing import standard scalar, which we're going to use in a minute, and label encoder. And that's what tells it to use bad equals 0 and good equals 1. And we'll go ahead and run that, and then we need to apply it to the data. And when we do that, we take our wine quality that we had before, and we're going to set that equal to label quality, which is our encoder. And let's look at this line right here. We have dot fit transform. And you'll see this in the pre-processing. These are the most common used is fit, transform, and fit transform. Because they're so often that you're also transforming the data when you fit it, they just combine them into one command. And we're just going to take the wine quality, feed it back into there, and put that back in our wine quality setup, and run that. And now when we do the wine and the head of the first 5 values, and we go ahead and run this, you can see right here underneath quality 0, 0, 0. Have to go down a little further to look at the better wines. Let's see if we have some that are 1s. Yeah, there we go. There's some 1s down here. So when we look at 10 of them, you can see all the way down to 0 or 1. That's our quality. And again, we're looking at high quality. We're looking at the 7 and the 8s, or 6.5 and up. And let's go ahead and grab our, where was it? Here we go, wine quality. And let's take another look at what else, more information about the wine quality itself. And we can do a simple pandas thing, value counts. Hopefully I typed that in there correctly. And we can see that we only have 217 of our wines which are going to be the higher quality. So 217, and the rest of them fall into the bad bucket, the 0, which is 1,382. So again, we're just looking for the top percentage of these. The top, what is that? It's probably about a little under 20% on there. So we're looking for our top wines, our 7 and 8s. And let's use our, let's plot this on a graph so we can take a look at this. And the SNS, if you remember correctly, that is, let me just go back to the top, that's our seaborn. Seaborn sits on top of Matplot library. It has a lot of added features, plus all the features of the Matplot library. And it also makes it quick and easy to put out a graph. And we'll do a simple bar graph. And they actually call it count plot. And then we want to just do count plot the wine quality. So let's put our wine quality in there. And let's go ahead and run this and see what that looks like. And nice inline. Remember, this is why we did the inline, so make sure it appears in here. And you can see the blue space, or the first space, represents low quality wine. And our second bar is a high quality line. And you can see that we're just looking at the top quality wine here. Most of the wine, we want to just give it away to the neighbors. No, maybe if you don't like your neighbors. Maybe give them the good quality wine, and I don't know what you do with the bad quality wine. I guess use it for cooking. There we go. But you can see here it forms a nice little graph for us with the seaborn on there, and you can see our setup on that. So now we've done some pre-processing. We've described our data a little bit. We have a picture of how much of the wine, what we expect it to be, high quality, low quality. Checked out the fact that there's none, we don't have any null values to contend with or any odd values. Some of the other things you sometimes look at these is if you have like some values that are just way off the chart. So the measurement might be off or miscalibrated equipment if you're in the scientific field. So the next step we want to go ahead and do is we want to go ahead and separate our data set or reformat our data set. And we usually use capital X. And that denotes the features we're working with. And we usually use a lowercase y. That denotes what, in this case, quality, what we're looking for. And we can take this and we can go wine It's going to be our full thing of wine. Dropping, what are we dropping? We're dropping the quality. So these are all the features minus quality. And we'll make sure we have our axes equals 1. If you left it out, it would still come out correctly just because of the way it processes on the defaults. And then our y, if we're going to remove quality for our x, that's just going to be wine, and it is just the quality that we're looking at for y. So we put that in there. And we'll go ahead and run this. So now we've separated the features that we want to use to predict the quality of the wine and the quality itself. The next step is if you're going to create a data set and a model, we got to know how good our model is. So we're going to split the data, train and test splitting data. And this is one of the packages we imported from sklearn. And the actual package was train, test, split. And we're going to do x, y, test size 0.2, random state 42. And this returns 4 variables. And most common you'll see is capital X train, that's what we're going to train our set with. Capital X test, that's the data we're going to keep on the side to test it with. Y train, Y remember stands for the quality or the answer we're looking for. So when we train it, we're going to use X train and Y train, and then Y test to see how good our X test does. And the train test split, let me just go back up to the top. That was part of the sklearn model selection, import, train, test, split. There is a lot of ways to split data up. This is, when you're first starting, you do your first model, you probably start with the basics on here. You have one test for training, one for test. Our test size is 0.2 or 20%. And random state just means we just start with it's like a random seed number, so it's not too important back there. We're randomly selecting which ones we're going to use. Since this is the most common way, this is what we're going to use today, there is, and it's not even an sklearn package yet, so someone's still putting it in there. One of the new things they do is they split the data into thirds, and then they'll run the model on they combine each of those thirds into 2 thirds for training and 1 for testing. And so you actually go through all the data and you come up with 3 different test results from it, which is pretty cool. That's a pretty cool way of doing it. You could actually do that with this by just splitting this into thirds, and then, or have a test set, one test set third, and then split the training set also into thirds, and also do that and get 3 different data sets. This works fine for most projects, especially when you're starting out. It works great. So we have our X train, our X test, our Y train, and our Y test. And then we need to go ahead and do the scalar. And let's talk about this because this is really important. Some models do not need to have scaling going on. Most models do. And so we create our scalar variable. We'll call it SC, standard scalar. And if you remember correctly, we imported that here, along with the label encoder, the standard scalar setup. So there's our scalar, and this is going to convert the values. Instead of having some values that go from 0, if you remember up here we had some values are 54, 60, 40, 59, 102. So our total sulfur dioxide would have these huge values coming into our model. And some models would look at that and they'd become very biased to sulfur dioxide. It'd have the hugest impact. And then a value that had 0.076, 0.098, or chlorides would have very little impact because it's such a small number. So when we take the scalar, we kind of level the playing field. And depending on our scalar, it sets it up between 0 and 1 a lot of times is what it does. Let's go ahead and take a look at that. And we'll go ahead and start with our X train. And our X train equals SC fit transform. We talked about that earlier. That's an sklearn setup. It's going to both fit and transform our X train into our X train variable. And if we have an X train, we also need to do that to our test. And this is important because you need to note that you don't want to refit the data. We want to use the same fit we used on the training as on the testing. Otherwise, you get different results. And so we'll do just, not fit, transform. We're only going to transform the test side of the data. So here's our X test that we want to transform. And let's go ahead and run that. And just so we have an idea, let's go ahead and take and just print out our X train. Let's do first 10 variables, very similar to the way you do the head on a data frame. You can see here our variables are now much more uniform, and they've scaled them to the same scale, so they're between certain numbers. And with the basic scalar, you can fine-tune it. I just let it do its defaults on this, and that's fine for what we're doing. In most cases, you don't really need to mess with it too much. It does look like it goes between like probably -2 to 2 or something like that. That's just looking at the train variable. We'll go ahead and cut that one out of there. So before we actually build the models and start discussing the sklearn models we're going to use, we covered a lot of ground here. Most of when you're working with these models, you put a lot of work into prepping the data. So we looked at the data, noticed that it's separated, loaded it up. We went in there, we found out there's no null values. That's hard to say, no null values. We have, there's none null value. I can't say it. And of course we sum it up. If you had a lot of null values, this would be really important coming in here. So is there a null summary? We looked at pre-processing the data as far as the quality. And we're looking at the bins. So this would be something you might start playing with. Maybe you don't want super fine wine. You don't want the 7 and 8s. Maybe you want to split this differently. So certainly you can play with the bins and get different values and make the bins smaller or lean more towards the lower quality. So you then have like medium to high quality. And we went ahead and gave it labels. Again, this is all pandas we're doing in here. Setting it up with unique labels and group names. Bad, good. Bad is less than good. That can be so important. You don't know how many times people go through these models and they have them reversed or something. And then they go back and they're like, why is this data not looking correct? So it's important to remember what you're doing up here and double check it. And we used our label encoder. So that was to set that up as quality 0, 1. Good, in this case we have bad, good, 0, 1. And we just double check that to make sure that's what came up in the quality there. And then we threw it into a graph because people like to see graphs. I don't know about you, but you start looking at all these numbers and all this text and you get down here and you say, oh, yes, you know, here, this is how much of the wine we're going to label as subpar, not good. And this is how much we're going to label as good. And then we got down here to finally separating out our data so it's ready to go into the models. And the models take X and a Y. In this case, X is all of our features minus the one we're looking for, and then Y is the features we're looking for. So in this case, we dropped quality, and in the Y case, we added quality. And then because we need to have a training set and a test set so we can see how good our models do, we went ahead and split the models up, X train, X test, Y train, Y test. And that's using the train test split, which is part of the sklearn package. And we did, as far as our testing size, 0.2 or 20%. The default is 25%, so if you leave that out, it'll do default setup. And we did a random state equals 42. If you leave that out, it'll use a random state. I believe it's default 1. I'd have to look that back up. And then finally, we scaled the data. This is so important to scale the data. Going back up to here, if you have something that's coming out as 100, it's going to really outweigh something that's 0.071. That's not in all the models. Different models handle it differently. And as we look at the different models, I'll talk a little bit about that. We're going to only look at 3 models today, 3 of the top models used for this, and see how they compare and how the numbers come out between them. So we're going to look at 3 different setups. Oh, let me change my cell here to markdown. There we go. And we're going to start with the random forest classifier. So the 3 setups we're looking at is the random forest classifier, support vector classifier, and then a neural network. Now we start with the random forest classifier because it has the least amount of parts, moving parts to fine tune. And let's go ahead and put this in here. So we're going to call it RFC for random forest classifier. And if you remember, we imported that. So let me go back up here to the top real quick. And we did an import of the random forest classifier from sklearn ensemble. And then we also, let me just point this out. Here's our SVM where we imported our support vector classifier. So SVM is support vector model, support vector classifier. And then we also have our neural network. And we're going to, from there, the multi-layered perceptron classifier. Kind of a mouthful for the P, perceptron. Don't worry too much about that name. It's a neural network. There's a lot of different options on there in setups, which is where they came up with the perceptron. So we have our 3 different models we're going to go through on here. And then we're going to weigh them. Here's our metrics. So we're going to use a confusion metrics, also from the sklearn package, to see how good our model does with our split. So let's go back down there and take a look at that. And we have our RFS equals random forest classifier, and we have n estimators equals 200. This is the only value you play with a random forest classifier. How many forests do you need? Or how many trees in the forest. So how many models are in here. That makes it pretty good as a startup model because we're only playing with one number and it's pretty clear what it is, and you can lower this number or raise it. Usually start up with a higher number and then bring it down to see if it keeps the same value. So you have less, the smaller the model, the better the fit, and it's easier to send out to somebody else if you're going to distribute it. Now the random forest classifier, everything I read says it's used for kind of a medium-sized data set. So you can run it on big data, you can run it on smaller data obviously, but it tends to work best in the mid-range. And we'll go ahead and take our RFC, and I just copied this from the other side, .fit xtrain, ytrain. So we're sending it our features and then the quality in the ytrain, what we want to predict in there. And we just do a simple fit. Now remember, this is sklearn, so everything is fit or transform. Another one is predict, which we'll do in just a second here. In fact, let's do that now. Predict RFC equals, and it's our RFC model, predict. And what are we predicting on? Well, we trained it with our train values, so now we need our test, our X test. So this has done it. This is the 3 lines of code we need to create our random forest variable, fit our training data to it. So we're programming it to fit. In this case, it's got 200 different trees it's going to build, and then we're going to predict on here. And let me go ahead and just run that. And we can actually do something like, let's do predict RFC. Just real quick, we'll look at the first 20 variables of it. Let's go ahead and run that. And in our first 20 variables, we have 3 wines that make the cut, and the other 17 don't. So the other 17 are bad quality, and 3 of them are good quality in our predicted values. And if you can remember correctly, we'll go ahead and take this out of here. This is based on our test. So these are the first 20 values in our test, and this has, as you can see, all the different features listed in there, and they've been scaled. So when you look at these, they're a little bit confusing to look at and hard to read, but there's a -0.01, so this is 0.36, -0.01, so 0.164, -0.09, or no, it's still -1, so -0.9, all between 0 and 1 on here. I think I was confused earlier and I said 0 between 2, -2, but it's between -1 and 1, which is what it should be in the scale. And we'll go ahead and just cut that out of there. Run this. We have our setup on here. So now that we've run the prediction and we have predicted values, well, one, you could publish them. But what do we do with them? Well, what we want to do with them is we want to see how well our model performed. That's the whole reason for splitting it between a training and testing model. And for that, if you remember, we imported the classification report. That was again from the sklearn. There's our confusion matrix and classification report. And the classification report actually sits on the confusion matrix, so it uses that information. And our classification report, we want to know how good our Y test, that's the actual values, versus our predicted RFC. So we'll go ahead and print this report out, and let's take a look. And we can see here we have a precision out of the 0. We had about 0.92 that were labeled as bad that were actually bad. And out of precision for the quality wines, we're running about 78%. So you kind of give us an overall 90%. And you can see our F1 score, our support set up on there, our recall. You could also do the confusion matrix on here, which gives you a little bit more information. But for this is going to be good enough for right now. We're just going to look at how good this model was, because we want to compare the random forest classifier with the other 2 models. And you know what, let's go ahead and put in the confusion matrix, just so you can see that on there, with Y-test and prediction RFC. So in the confusion matrix, we can see here that we had 266 correct and 7 wrong. These are the mislabels for bad wine, and we had a lot of mislabels for good wine. So our quality labels aren't that good. We're good at predicting bad wine, not so good at predicting whether it's a good quality wine. Important to note on there. So that is our basic random forest classifier. And let me go ahead, change cell type to markdown and run that so we have a nice label. Let's look at our SVM classifier, our support vector model. And this should look familiar. We have our CLF we're going to create. We'll call it, just like we called this an RFC. And then we'll have our CLF.fit. And this should be identical to up above. X train, Y train. And just like we did before, let's go ahead and do the prediction. And here is our CLF predict. And it's going to equal the CLF.predict. And we want to go ahead and use X underscore test. And right about now you can realize that you can create these different models and actually just create a loop to go through your different models and put the data in. And that's how they designed it. They designed it to have that ability. Let's go ahead and run this, and then let's go ahead and do our classification report. And I'm just going to copy this right off of here. They say you shouldn't copy and paste your code, and the reason is when you go in here and edit it, you invariably will miss something. We only have 2 lines, so I think I'm safe to do it today. And let's go ahead and run this. And let's take a look how the SVM classifier came out. So up here we had a 90%. And down here we're running about an 86%. So it's not doing as good. Now remember, we randomly split the data. So if I run this a bunch of times, you'll see some changes down here. So these numbers, this size of data, if I ran it 100 times, it would probably be within plus or minus 3 or 4 on here. In fact, if I ran this 100 times, you'd probably see these come out almost the same as far as how well they do in classification. And then on the confusion matrix, let's take a look at this one. This had 22 by 25. This one has 35 by 12. So it's doing not quite as good. That shows up here 71% versus 78%. And then if we're going to do a SVM classifier, we also want to show you one more. And before I do that, kind of tease you a little bit here, before we jump into neural networks, the big save all deep learning, because everything else must be shallow learning, that's a joke. Let's just talk a little bit about the SVM versus the random forest classifier. The SVM tends to work better on smaller numbers. It also works really good on, because a lot of times you convert things into numbers and bins and things like that. The random forest tends to do better with those. At least that's my brief experience with it. Where if you have just a lot of raw data coming in, the SVM is usually the fastest and easiest to apply model on there. So they each have their own benefits. You'll find though again that when you run these like 100 times, the difference between these two on a data set like this is going to just go away. There's randomness involved depending on which data we took and how they classify them. The big one is the neural networks, and this is what makes the neural networks nice is they can look into huge amounts of data. So for a project like this, you probably don't need a neural network on this, but it's important to see how they work differently and how they come up differently. So you can work with huge amounts of data. You can also, in many respects, they work really good with text analysis, especially if it's time sensitive. More and more you have an order of text, and they've just come out with different ways of feeding that data in, where the series and the order of the words is really important. Same thing with starting to predict in the stock market. If you have tons of data coming in from different sources, the neural network can really process that in a powerful way to pull up things that aren't seen before. And when I say lots of data coming in, I'm not talking about just the high lows that you can run an SVM on real easily. I'm talking about the data that comes in where you have maybe you pulled off the Twitter feeds and have word counts going on, and you've pulled off the different news feeds that business are looking at, and the different releases when they release the different reports. So you have all this different data coming in, and the neural network does really good with that. Pictures. Picture processing now is really moving heavily into the neural network. If you have a Pixel 2 or Pixel 3 phone put out by Google, it has a neural network for doing, it's kind of goofy, but you can put little Star Wars androids dancing around your pictures and things like that. That's all done with the neural network. So it has a lot of different uses, but it's also requires a lot of data and is a little heavy-handed for something like this. And this should now look familiar because we've done it twice before. We have our multi-layered perceptron classifier. We'll call it an MLPC, and it's just as what we imported, MLPC classifier. There's a lot of settings in here. The first one is the hidden layers. You have to have the hidden layers in there. We're going to do 3 layers of 11 each. So that's how many nodes are in each layer as it comes in. And that was based on the fact we have 11 features coming in. Then I went ahead and just did 3 layers. Probably get by with a lot less on this. But I didn't want to sit and play with it all afternoon. Again, this is one of those things you play with a lot because the more hidden layers you have, the more resources you're using. You can also run into problems with overfitting, with too many layers. And you also have to run higher iterations. The max iteration we have is set to 500. The default's 200. Because I use 3 layers of 11 each, which is, by the way, kind of a default I use. I realized that usually you have about 3 layers going down and the number of features going across. You'll see that's pretty common for the first classifier when you're working in neural networks. But it also means you have to do higher iterations. So we up the iterations to 500. So that means it's going through the data 500 times to program those different layers and carefully adjust them. And we do have a full tutorials you can go look up on neural networks and understand the neural network settings a lot more. And of course we have, you're looking over here where we had our previous model where we fit it. Same thing here, MLPC, fit, X-train, Y-train. And then we're going to create our prediction. So let's do our predict and MLPC, and it's going to equal the MLPC. And we'll just take the same thing here, predict X test. Let's just put that down here, .predict X test. And if I run that, we've now programmed it. We now have our prediction here, same as before. And we'll go ahead and do the copy print again. Always be careful with the copy paste, because you always run the chance of missing one of these variables. So if you're doing a lot of coding, you might want to skip that copy and paste and just type it in. And let's go ahead and run this and see what that looks like. And we came up with an 88%. We're going to compare that with the 86 from our tree, our SVM classifier, and our 90 from the random forest classifier. And keep in mind, random forest classifiers, they do good on mid-sized data. The SVM on smaller amounts of data, although to be honest, I don't think that's necessarily the split between the two. And these things will actually come together if you ran them a number of times. And we can see down here the amount of good wines mislabeled with setup on there. It's on par with our random forest. So it had 22, 25. Shouldn't be a surprise, it's identical. It just didn't do as good with the bad wines labeling, what's a bad wine and what's not. Let's see, yeah, because they had 266 and 7. We had down here 260 and 13. So it mislabeled a couple of the bad wines as good wines. So we've explored 3 of these basic classifiers. These are probably the 3 most widely used right now. I might even throw in the random tree. If we open up their website and we go under supervised learning, there's a linear model. We didn't do that. Most of the data usually just start with a linear model because it's going to process the quickest and use the least amount of resources. But you can see they have linear quadratic, they have kernel ridge. There's our support vector, stochastic gradient, nearest neighbors. Nearest neighbors is another common one that's used a lot. Very similar to the SVM. Gaussian process, cross decomposition, naive Bayes. This is more of an intellectual one that I don't see used a lot, but it's like the basis of a lot of other things. Decision tree, there's another one that's used a lot. Ensemble methods, not as much. Multi-class and multi-label algorithms, feature selection, neural networks, that's the other one we use down here, and of course the forest. So you can see there's in sklearn there are so many different options, and they've just developed them over the years. We covered 3 of the most commonly used ones in here and went over a little bit over why they're different. Neural network, just because it's fun to work in deep learning and not in shallow learning, as I told you. That doesn't mean that the SVM is actually shallow. It covers a lot of things, and same thing with the decision tree, the random forest classifier. And we notice that there's a number of other different classifier options in there. These are just the 3 most common ones, and I'd probably throw the nearest neighbor in there and the decision tree, which is usually part of the decision forest depending on what the backend you're using. And since, as human beings, if I was in the shareholder's office, I wouldn't want to leave them with a confusion matrix. They need that information for making decisions, but we want to give them just one particular score. And so I would go ahead and we have our sklearn metrics. We're going to import the accuracy score. And I'm just going to do this on the random forest, since that was our best model. And we have our CM accuracy score, and I forgot to print it. If you remember in Jupyter Notebook, we can just do the last variable we leave out there, it'll print. And so our CM accuracy score we get is 90%. And that matches up here. We should already see that up here in precision. So you can either quote that, but a lot of times people like to see it highlighted at the very end. This is our precision on this model. And then the final stage is we would like to use this for future. So let's go ahead and take our wine. If you remember correctly, we'll do wine head of 10. We'll run that. Remember our original data set? We've gone through so many steps. Now we're going to go back to the original data. And we can see here we have our top 10 on the list. Only 2 of them make it as having high enough quality wine for us to be interested in them. And then let's go ahead and create some data here. We'll call it x new equals, and this is important. This data has to be, we just kind of randomly selected some data. It looks an awful lot like some of the other numbers on here, which is what it should look like. And so we have our x new equals 7.3, 0.58, and so on. And then it is so important. This is where people forget this step. X new equals sc. Remember sc? That was our standard scalar variable we created. If we go right back up here, before we did anything else, we created an sc, we fit it, and we transformed it. And then we need to do what? Transform the data we're going to feed in. So we're going to go back down here, and we're going to transform our x new. And then we were going to go ahead and use the, where are we at? Here we go. Our random forest, and if you remember, all it is our RFC predict model. right there. Let's go ahead and just grab that down here. And so our y new equals, here's our RFC predict. We're going to do our x new in, and then it's kind of nice to know what it actually puts out. So according to this, it should print out what our prediction is for this wine. And, oh, it's a bad wine. Okay, so we didn't pick out a good wine for our X new. And that should be expected. Most of the wine, if you remember correctly, only a small percentage of the wine met our quality requirements. So we can look at this and say, oh, we'll have to try another wine out, which is fine by me because I like to try out new wines, and I certainly have a collection of old wine bottles, and very few of them match. But you can see here we've gone through the whole process. Just a quick rehash. We had our imports. We touched a lot on the sklearn, our random forest, our SVM, and our MLP classifier. So we had our support vector classifier, we had our random forest, and we have our neural network, three of the top used classifiers in the sklearn system. And we also have our confusion matrix and our classification report, which we used, our standard scaler for scaling it, and our label encoder. And of course we needed to go ahead and split our data up in our mplot line train. And we explored the data in here for null values. We set up our quality into bins. We took a look at the data and what we actually have and put a nice little plot to show our quality, what we're looking at. And then we went through our three different models. And it's always interesting because you spend so much time getting to these models, and then you kind of go through the models and play with them until you get the best training on there without becoming biased. That's always a challenge, is to not overtrain your data to the point where you're training it to fit the test value. And finally, we went ahead and actually used it and applied it to a new wine, which unfortunately didn't make the cut. It's going to be the one that we drink a glass out of and save the rest for cooking. Of course, that's according to the random forest on there because we used the best model that it came up with.
If you are one of the aspiring Python enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in Python by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in AI and machine learning in collaboration with Purdue University and IBM. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
In this video on Pygame, we will teach you how to develop games using the Python module called Pygame. So, let's get started. Before we dive into the video, let's get a general overview of what you can expect to learn from it, what's in it for you, and what will you know by the end of this video. The first thing that we will teach you is what exactly is Pygame. You will understand what exactly the Pygame module is and the various ways that you can use it to develop games. Next, we will teach you how to install Pygame on your system. Then, we will take a look at the basic components of Pygame. And finally, we will be using the Pygame module and Python programming to develop a Flappy Bird game, which you can play in real life on your own system. So, let's get started. So what exactly is Pygame? Pygame is a cross-platform Python software which was made specifically for video game designing. It includes graphics, visuals, and sounds which can be used to enhance the game which is being designed by you. Officially written by Pete Shiners to replace PySTL, Pygame is suitable to create client-side applications that can be potentially wrapped in a standalone executable. To learn Pygame, it is required to have a basic knowledge of Python. Now, how do you go about installing Pygame on your system? To install Pygame, you can use the standard pip install command in your command prompt. Then, you can import it into your program with the import command prompt in Python itself. Before installing Pygame, Python should be installed in the system. It is good to have Python 3.6.1 or above versions because it is much friendlier to beginners and additionally runs way faster. Now, what are the basic components of Pygame? The first and most important component of Pygame is the pygame.init module. This is used to initialize all imported Pygame modules. Using this, you can call all Pygame modules at once into your program. Before you can do much with Pygame, you need to initialize it. The most common way to do this is to use pygame.init. This will initialize all the modules in Pygame with just one single command. Not all Pygame modules need to be initialized, but this will automatically initialize the ones that are important and the ones that have to be initialized. You can also easily initialize each Pygame module by hand. The next thing that you need to know about is the display surface. The display surface is a black screen which acts as a canvas for you to design your games on. All the game components will appear on this very screen. Now, Pygame has a single display surface that is either contained in a window or runs full screen. Once you create the display, you can treat it as a regular surface. Changes are not immediately visible on screen. You must choose one of the two flipping functions to update the actual display. The Pygame display can actually be initialized by one of several modes. By default, the display is a basic software-driven frame buffer. You can request special modules like hardware acceleration and OpenGL support. Now, Pygame can only have a single display active at any time. Creating a new display will close the previous display. Once the display surface is created, the functions from this module affect the single existing display. The surface becomes invalid if the module is uninitialized. If a new display mode is set, the existing surface will automatically switch to operate on the new display. The next concept is the game loop. The game loop is a piece of code that does three things. It will handle events, update game events, and draw game state to the screen. The game loop will basically run until a condition is met or until the game ends. And finally, you have pygame.quit. The pygame.quit function does the opposite of the init function and completely deactivates the pygame library. It will automatically uninitialize all Pygame modules that have previously been initialized. When the Python interpreter shuts down, this method is called regardless, so your program does not always need it, except when it wants to terminate its Pygame resources and continue. It is safe to call this function more than once, as repeated calls have no effect whatsoever. Now please do note that calling pygame.quit will not exit your program. Consider letting your program end in the same way a normal Python program will end. It will just help you break out of the game loop. Now let's see how we can create a Flappy Bird game with the help of the Python pygame module. So the first thing that you're going to need is to call all of your required modules. So over here, we have imported the random and the sys module. We've imported the pygame module, and we've also imported all the modules which are present in pygame.locals. So let's run this so all the modules get imported into our program. There we go. Now all of our pygame modules have been imported. Now the first thing that we're doing is that we're setting global variables for the game. The window width and the window height basically determine how big our surface is going to be. After that, we're going to display our window. Now you can call or create a window by using pygame.display.setMode. And within set mode, you set your window parameters. So you set your window width and your window height. So here we will be creating a window of width 600 and of height 499. The elevation will basically tell you how far up from the bottom of your screen the window is going to be. We're going to be creating an empty tuple of your game images, and we're going to be having an FPS of 32. You can obviously change your FPS speed. Now all of these images that we're importing have already been downloaded onto your system. So all of these images are already here, and they're in the same folder that we've stored our Flappy Bird game in, which is why to call them you simply have to write the name of the image and initialize it to a variable. So because we're creating Flappy Bird, we're going to have a pipe image, a background image, a bird, and obviously a base which is going to be a sea level and which you have to prevent the bird from touching. So let's run this and create nothing but our Pygame window. So here, as you can see, a new window has come up. This so far is just a Pygame window. Nothing has been shown on it because we haven't initialized any of these parameters into our window as of yet. So far, the only thing we've done is create a basic window which doesn't have any of the parameters on it, with a width of 600 and a height of 499. Now here we are going to be coming into our Python game loop. So the first thing that we talk about in our Python game is that you have to have some initialized variables, right? And you have to create some important components of the game. So the first thing that you have is the Flappy game, which is the game itself. The next thing that we have here is to check if our game is over. This is going to happen under two conditions. One is that the bird hits the pipe, and the second condition is that the bird falls into the sea. And finally, we will have a module to create pipes of random height as and when a bird goes further into the screen. So basically, the pipes will be created as the user keeps going and not beforehand. And finally, here we have our main game loop, which is going to be calling all of these various functions that we've created and just going to terminate their runtime the second that the game gets over. And then following this, we're going to be exiting the Flappy Bird game. So here pygame.quit, as you can see, as we've already told you, will close all of the pygame modules that you've already initialized in your program and will uninitialize all of these modules, while sys.exit will exit the program itself. Now, as we said, the pygame.quit doesn't quit the program, it only uninitializes all the pygame modules, which is exactly why we're using sys.exit to close our window and exit our program. Now, the first thing that we're going to be looking at is the Flappy Bird game itself. The main things that are happening in our Flappy game is, first of all, we're initializing variables and creating two pipes by calling the createPipe function. So at any given point, we know that we want our bird to fly in between two pipes. That is the main challenge here, which is exactly why we're initializing two pipes here, the first pipe and the second pipe. And this is done by calling the createPipe function. Now after this, we're going to be creating two lists. One is of the lower pipes and the other is of the upper pipes. Now, as we already talked about, we are going to have two pipes consecutively. Yeah, the first pipe is going to be on top and the second pipe is going to be at the bottom. So that's exactly what these two lists contain. They contain the height at which the down pipes and the up pipes are going to be. Or basically, they contain the coordinates at which these down pipes and up pipes will be displayed at. Now, pipe vel x is basically defining the pipe velocity along your x-axis, and the bird velocity, which is along the y-axis, is defined over here. So basically, your bird is going to have two different parameters. One is that it's going to move up and down, which is its velocity along the y-axis. Another is it's going to move across, which is its velocity across the x-axis. Now at the same time, the pipes also have to keep moving and they have to exit this frame. So that's what all of this is defined by. The bird acceleration is defined over here. This is the parameter that you're going to be using to define your bird acceleration along the y-axis. That is basically going to happen when you stop clicking and the bird starts falling downwards. Now the velocity while flapping, or the x-axis velocity for the bird, is defined over here. Now the bird is only going to be flapping when you're going to be pressing the key. So that's basically what you're going to be checking here. If your event takes place, which basically means that if you have key events, and that's exactly what pygame.event.get is doing. It's going to be getting all the key functions that are taking place on your keyboard simultaneously. So for event in pygame.event.get will basically help you get the keystrokes which are happening. If event type is equal to quit, or event type is equal to key down, and event.key is equal to k.escape, you're going to quit your game and you're going to close down your program. So there are two ways that you can quit your game. You can either press quit or you can press key down and escape. Now if your event type is equal to key down and your event.key is equal to space or k up. So this is basically what you're going to be using to make sure that your bird is moving. There are two main keys which are going to be coming into play over here. You can press the key down as well as the space key or the key down and the up key. So over here this is going to move your bird vertically, and it's also going to make sure that your bird flaps its wings, which is where the bird velocity, which are all these parameters, will come into play. So this will basically help your bird move forward. So basically what is happening here is that we're going to be getting the keys that the user has pressed, and if they've pressed the quit key, we're going to quit the program, and if they've pressed key down and space or key down and the up key, we're going to make sure that the bird starts moving in the y-axis as well as it starts flapping its wings and moving along in the x-axis. Now this is the function that checks for whether your bird has crashed into pipes or not. This is basically also going to define whether your game is over or not, right? Because once the bird touches a pipe, the game is basically finished. So game over here is game over, which is another function that we're defining here. So basically what's happening over here is that you're going to be checking if the game is over by checking the horizontal and vertical position of the bird and the positions of the up and down pipes. If the game is over, then you will return over here and you will basically quit the whole game. Now after this we need to keep track of the score of the player. Now how that can be done is that you get your position of your bird and the position of your pipe, and if the bird has crossed the pipe, then you basically increase your score by 1. If the current velocity of your bird is less than the maximum velocity and the bird has not flapped or you haven't pressed your key, in that case the bird is basically going to be tumbling downwards. Now another thing that you have to consider is that the user has stopped pressing the key, right? So the bird is not going to be flapping its wings. If this is the case, then the bird has to free fall towards the sea basically. So this is how we're going to be checking it. If the velocity of the bird is less than the max velocity and the bird has not flapped its wings, what we're going to be doing is we're going to be increasing the present velocity of the bird in increments with an acceleration speed that we've already defined over here. So if the bird starts flapping its wings, the velocity will steadily increase with this acceleration. Now if the bird has flapped its wings, after that we need to set the bird flap function to false again. Otherwise it will continue being true, which is not the case. So we have to keep switching it, right? The bird flap will only be true when the user has pressed the key. After that it immediately has to go back to a false variable. So that is basically what we're doing here. We're going to change the bird flap to false immediately after it has become true. Now after this, your pipes will keep moving to the left. In this game, the pipes are the ones that are moving horizontally. The bird is not moving horizontally. The bird is only moving vertically. So basically what we're going to be doing is we're going to be increasing the x coordinate of our pipe, and the pipe is not going to randomly start increasing in height, right? So we're not going to be touching the y coordinates of the pipe. Of the upper and the lower pipe, we're going to slowly increment the x coordinate by the velocity factor that we've already initialized previously. So the pipes will slowly keep moving by this velocity factor towards the left hand side of the screen. A new pipe will be added when the first is about to cross the leftmost part of the screen. So basically each pipe is covering about 5 points on the x-axis, and once it is less than 5 but still greater than 0, we're going to create a new pipe and we're going to append it to our up pipes list. And we'll also be creating another pipe and we're going to append it to our down pipes list. Now, if the pipe is out of the screen, we basically have to remove it. And this we're going to do by popping out the pipe from the up pipe list. So far, we've looked at how we can generate pipes for our window, the velocity of the bird when it is flapping its wings, and what is going to happen when it stops flapping its wings, handling the key pressing events that the user is inputting, checking whether our bird has crashed or not, updating our score, moving the pipes to the left, and creating new pipes once the previous pipe has left the screen. Now, the only thing that's left to do is build a game image window, because we've dealt with almost all the game logic that we need. So now we're basically going to start building our Pygame window. So first we're going to be putting the image all throughout the screen. We're going to be rendering the up pipe and down pipe at the respective positions on the screen. And then we're going to be putting the sea level and the bird on the screen. Another thing that you need to do is fetch the digits of the score and display them on your screen. So the digits, again, all of the images have already been included in our Flappy Bird folder, and all you have to do is display them onto the screen. To do this, all that we have to do is loop through our numbers list and display the scoreboard images on the side of our window. And this is the position at which they'll be displayed. So here we're just displaying the images on the screen. The offset is again just a variable that we've created here, and that's the variable at which we'll be displaying the images. Now, every time the score changes, you're going to have to update the game window. So that is exactly what you're doing here. You're just updating your display game window. And as we talked about, every time your display changes, you can't have two displays open at once. So the game will move on to this new display window. And again, over here, we're just setting the frames per second. And that brings us to the end of everything that we need to do. This is the basic game logic that we're going to be needing. So this whole function just defines your game logic. Let's finish running this. And your game logic has been initialized into your program now. Now the next thing that we have to do is check if our bird is above sea level or if it has hit any of the pipes. So this is what you use the isGameOver function for. So the isGameOver function will have 4 different parameters as input. So the isGameOver function has 4 parameters. You're going to be giving the horizontal and the vertical height of the bird and the height and position of the up pipes and the down pipes. Now there are basically 3 conditions which lead to a situation of the game being over. If the difference between our elevation and a certain height is less than the vertical, it means that the bird has crossed its boundaries. And that is why the game is over, which is where you return true. The another thing is that the bird hits either the up pipes or one of the down pipes. And that's what we're checking here. Either the elevation of the bird has decreased and there's no way that it can rise up again, and hence the game will be over, or the bird has hit one of the pipes on top or one of the bottom pipes. So that's basically what we're doing here. We're getting the height of the up pipe and we're checking if the vertical height of the bird is less than the pipe height plus the pipe width. So basically it can hit the pipe anywhere, right? So if this vertical height is less than this parameter, as well as if the bird doesn't hit the pipe horizontally. So that's what we're basically checking here. We're checking to see if the bird has hit the pipe horizontally or vertically. Then you will return true. And the same thing will happen for the down pipes. You will check if the bird has hit the pipe horizontally or vertically at any point. So let's run this game over function. The next thing that you have to do is the create pipe function. Now creating pipes is actually quite easy. All we have to do is fetch the height of the pipe using the getHeight function, and after that generate a random number between 0 to any number such that the height of the pipe should be adjustable to a window height. So there's only a certain amount where you can have the pipe visible, and that has to be above sea level. So we're going to be generating like a random number between 0 and this number, like 0 and the width of your screen from height to just above the sea level, and then we're going to be subtracting it by 1.2 into offset, because there's a huge chance that we get like a pipe which covers the entire screen. So to prevent that, we're going to decrease the height of the pipes a little. And then after that, all we have to do is push our pipes into a dictionary along with their x-axis and y-axis coordinates. So this is basically what your pipe list is going to look like. It's going to be a dictionary which consists of an upper pipe and a lower pipe, and along with their coordinate values. So let's run this. Now this is basically the game loop that we're going to be using. This is going to call our various functions again and again until the game basically gets over, which is defined over here. So this function is going to run, or this is your basic game start. It's going to keep running until a certain condition is met, and let's see what that condition is. So over here, the different things that we're doing initially is that we're initializing our program using pygame.init. We're basically calling all the modules of the pygame library. Then after that, we're just setting the frames per second, displaying the title of the game on top of the game window, pygame.display.setCaption. So far we only have a pygame window, right? This is basically going to initialize the background images and everything onto this window. We're gonna start loading all of our different images into our game. So we have different images for the scores, the Flappy Bird image, sea level, background and pipe image, and we're going to convert it into a form suitable to display onto our window. This is basically done using the image.load.convert alpha function. So over here you're basically going to be loading your image and converting it into a form which is suitable to be displayed onto your screen. After that, we'll basically be doing a couple of basic startup things such as printing welcome to Flappy Bird game and press space or enter to start the game. And the second you see this, you know that this has started running properly. Now this is where you have the main game starting. So over here you're basically going to be setting the position of the bird, and horizontally we're going to be setting it at 1/5 of the window width. You can basically set the bird wherever you want to. Then after that we're going to be adding the sea level, and over here we've initialized ground as 0, while true for event in pygame.event.get. Basically, while we keep getting a keystroke from the user, this whole loop is going to keep running. And what exactly is happening in this loop over here, basically we are running the program until the user stops or exits the game. Otherwise, we have basically created an infinite while loop over here. So if the event type is equal to quit, we're going to quit the game and exit the program. If the event type is key down, then we are going to be calling Flappy game. So this is basically us initializing the game start conditions. If the second after the game starts, the user clicks on quit, then we're going to quit the game and exit the program. Otherwise, if the user has pressed the key down, the space key or the key up, then we're going to be calling our Flappy game function. If the user hasn't pressed any key and nothing has happened, then we're just going to have a basic game display, and we're going to be displaying the background image, the Flappy Bird and the sea level onto our screen. This is just to keep refreshing the screen, and this is basically to set the frame rate of our screen. So let's run this. Now, if we look at our Flappy Bird game, you can see that we have all of the parameters initialized. We have a background, we have a sea level, and we have a bird over here. We've typed Flappy Bird game on top, and I'm gonna press the enter key to start. So far as you can see, our pipes have appeared here. So we already know the function behind this. We keep getting our pipes, and the second that the bird crosses a pipe, the screen gets refreshed and our score gets updated. So if you notice here clearly, if I go slow enough, and if you notice, the second I did this, the display window actually got refreshed. And the second the pipe goes out of screen, as you can see, it gets erased and a new pipe enters. So the second this one pipe goes out, a new pipe gets created. Now, as we've talked about, there are three basic conditions. One is you hit the bottom pipe and the game ends. Another is you hit the top pipe anywhere and the game ends. And the next one is your bird falls below a certain level and the game ends. So these conditions are working so far. Our scoreboard also keeps getting initialized. Another condition that you might want to check for. Oh yeah, and as you can see, another thing that you notice is the velocity, right? So the bird is technically not moving. The bird's position relative to where it started from remains exactly the same. As you can see here, the only thing that is moving is its position on the y-axis. Apart from this, the pipes are moving. And do you remember the acceleration parameter that we have? This is where you can see it come into play. So I stopped, and the way the bird free falls, all of this is because of the acceleration parameter that we set. So this is basically how you can use Pygame to, create a game. Now let us quit the game. I pressed the escape key and the entire game has quit. So over here, system exit took place, as you can see. So this is all the logic that we've used behind creating a Flappy Bird game. And as you can see, we've used the Pygame module to create.
Simple. Open your terminal and run this command. So if it's already installed in your laptop, then it will show you the requirement already satisfied. So to check the version that you're using in Seaborn, you can go with this command. So as you can see, the version is also shown. Let's understand how Seaborn thinks. The syntax is elegant. Once you get the pattern, you'll be able to use almost any function easily. Every Seaborn function follows a consistent pattern. So these are the three key parameters you'll use everywhere. That is data, X and Y columns. And hue is a parameter that is used to map the colors to categorical or numerical data. This is the template for almost every Seaborn chart. And SNS is our Seaborn. Plot is the kind of chart you want, like scatter plot, bar plot, or hist plot. Data takes you a pandas data frame, and X and Y are the column names you want on each axis. Once you understand this pattern, the rest is just remembering which plot type to call. So now let's quickly understand when to use Seaborn and Matplot library. Seaborn is when you want statistical plots fast, when you need automatic aggregation like mean with confidence intervals, or when you want the output without configuring every element manually. And use Matplot library when you need pixel level control or when you're building very custom chart types. And also when you need to fine-tune a Seaborn plot further. Seaborn ships with several classic datasets that is used for learning. So let's load 3 datasets throughout this tutorial. So now when we run it, the tips dataset captures the restaurant bills, and the Titanic has passenger survival data, and Iris contains flower measurements, and this is classic machine learning dataset. Now let's understand about different plots. Univariate means we are looking at one variable at a time. The goal is to understand its distribution and how the values are spread, and where they cluster, and whether there are any outliers. And his plot is a modern way to plot the distributions. Now let's quickly go through that. So as you can see here, the smooth kernel density evaluation parameter, and it is great for spotting the shape of your data. So it's basically used for smoother distribution visualization. So here in the output, the KD plot, that is kernel density estimation, it draws only the smooth density curve and no bars at all. So the fill equal to parameter shades the entire area under the curve. It makes it easier to see where the bulk of the data is. So the color parameter sets the fill color. So use KD plot when you want a clean, elegant view of distribution, and that is shaped without histogram bars cluttering the chart. Now let's understand about bivariate plots. So bivariate plots explore the relationship between two variables, such as if one thing changes, what happens to the other. So let's talk about this output. Here, each dot on this chart represents one restaurant visit. So its X position shows the total bill amount, and the Y position shows the tip, and the hue equal to smoker, the parameter colors dots differently for smokers and non-smokers. It lets us see if smoking correlates with the tipping behavior. And the style equal to time parameter, it changes the dot shape for lunch versus dinner. That's 4 dimensions of information visualized in a single chart. So if you take a look at the upward trend, bigger bills generally receive bigger tips. So as you can see here, the bill is 50 and here he is a smoker. As you can see, the total bill is larger here and the tips received is larger as well. Now let's quickly explore line plot. So in the output, the line plot draws a line connecting the average tip for each party size broken down by the day of the week using hue as day. Seaborn automatically calculates the mean for each group and it adds a shaded confidence interval as well around the line. It shows how certain we are about that average. So it shows us whether larger tables tip more and whether that pattern differs across different days by the week. Now let's quickly understand categorical plots. So in this output, this plots the average total bill for each day of the week and it is split by the gender using hue. So the black vertical lines here on the top of each bar are 95% confidence intervals. So they tell you how reliable the average data is. And a short confidence interval such as Friday here, it shows us the data points are confident in that average. A tall one means its variability and Seaborn calculates all of this automatically. But in Matplot library, you need to compute it manually. So now let's understand about count plot. So this is the output of count plot. So unlike the bar plot, which averages a numeric column, count plot simply counts how many rows fall into that category. So here it counts how many Titanic passengers were in each class, first, second, and third. And hue equal to survived here, it splits each bar to show survivors versus non-survivors. So in this output, we can see that third class by far had the most passengers, but the lowest survival rate. Now let's go through the box plot. So the output here, a box plot is a chart that shows you the summary of your data in one box shape. So the line in the middle of the box is the median, meaning exactly half the tips were above this value and half were below it. So the bottom and the top edges of this box shows where the middle 50% of all the tips fall. So most of the typical tips live inside this box, and the lines stretching above and below this box are called whiskers, and they extend to the highest and the lowest values in your data. Any dots, that is these that are going high and low, are the outliers. So people who tipped unusually more high or more low compared to everyone else are known as outliers. And hue equal to smoker splits each day into two boxes side by side, one for smokers and the other for non-smokers. So you can compare both groups without needing two separate charts. Now let's quickly understand about violin plot. So here a violin plot combines a box plot with a KDE curve. So the wider the violin at any point, the more data values exist in that range. The split equal to true parameter is a powerful trick. Instead of drawing two completely separate violins for each hue group, it draws one violin with each half representing one group. So this makes it extremely easy to compare the distribution shapes of the smokers and non-smokers side by side. So as you can see here on Thursday, the smokers are more compared to the non-smokers. So the violin width is larger for smokers compared to non-smokers. This is how violin plot works. So now let's understand about themes and styles. Seaborn has 5 built-in themes that control the overall background appearance. So the syntax for that is, so you're telling the Seaborn to set the style as white grid for the clean background with grid lines. Dark grid can be used with grid lines with dark background. And white is used for minimal white background. And this is used when there is no grid and dark background. Ticks is when you want a white background with tick marks only. So as you can see here, the code is executed. You can call this once at top of your notebook and it applies globally to every chart you draw. So now let's quickly understand about titles, labels, and legends. So when you assign a Seaborn plot to a variable called AX, you get access to the underlying matplot access object. From there, set_title function adds a little title with custom font size and weight. Set underscore x label function and set underscore y label function, it replaces the default row columns names like total bill with clean labels including the units. And the legend function customizes the legend title and position upper left. It keeps it from overlapping the data points clustered in the lower right area. So now let's understand about hue, size and style. These three parameters encode the additional dimensions in one chart. So this is the output. In this single chart, it has 5 variables simultaneously. X and Y gives us the two primary axes, and hue is the day that changes the dot color based on the day of the week. Such as Thursday gets one color and Friday another and so on. And size makes the dots physically larger for bigger dining. For example, 6th table gets higher dots compared to 2nd table. And style equal to smoker, it changes the marker shape, such as circles for smokers and cross mark for non-smokers. That's about the scatter plot here. So now let's quickly analyze about multivariate plots. So pair plot, one of the first things any data scientist runs on a new data set. It plots every numerical variable against every other. So as you can see here, the pair plot automatically creates a pair of scatter plots, one for every combination of numeric columns in the data set. That is, the IRIS dataset has 4 numerical features, so pair plots creates a 4 into 4 grid. That's 16 charts generated from a single function call. So the diagonal calls, it is where a variable would normally be plotted against itself. So the hue equal to species colors at every single point by flower species, making it obvious for which feature combination it best separates the 3 species. And this is called exploratory data analysis. Now let's quickly go through the heat map. So here first the tips.correlation, it calculates the Pearson correlation coefficient between every pair of numeric columns. It produces a table of values between -1. So think of it this way. Imagine asking how similar is my height to my height. So the answer is obviously perfectly identical. So it's comparing a column to itself. So it will obviously be 1. So every single row will match exactly. And this is why the diagonal of every correlation matrix is always 1. So now let's go through the total bill versus tip, that is 0.68. Here the bigger the bill, the bigger the tip is. So when total bill goes up, the tip also tends to go up, and when it goes down, it tends to goes down. Now you might think why it's not 1, because it's not a perfect rule. Some people on big bills tip poorly and some people on small tips are very generous. So the relationship is strong but not perfect. So it's 0.68 and not 1. If we see total bill versus size, it's 0.60. So more people, more orders and bigger bill. That's when 0.60 comes in. So the bigger party size tends to give a bigger bill and smaller party produces a smaller bill. So why it's lower than 0.68? Because party size does not control the bill as directly as you'd think. So 2 people can order steak and wine and spend more than a table of 4 ordering cheaply. So the link exists, but it is a bit looser. Hence it is 0.60. Now let's go through 3 projects. So here the survived column contains 1 for survived and 0 for did not survive. When we use it as a y-axis in bar plot, Seaborn automatically calculates the mean, which equals the survival rate as a proportion. So a bar at 0.75 means 75% of the group is survived. So here the first class passengers, particularly women, had dramatically higher survival rates. So this is the age distribution of survivors versus non-survivors. Here the KD curves on the same chart. That is 1 for survivors and 1 for non-survivors. The common norm equal to false is critical here. It tells Seaborn to normalize each curve independently. So both the curves have equal area, and even though the groups have different sizes. So without this, the smaller group's curve would appear as a tiny bump next to towering curve. So the result clearly shows where the age distributions differed between those who survived and those who did not. Now let's quickly go through the restaurant tip analysis. So here first we create a new column called tip underscore PCT by dividing the tip by total bill and multiplying it by 100. This converts the tip into a percentage. So this matters because a $5 tip on a $20 bill is generous, but $5 tip on a $50 bill is quite low. So the raw tip amount alone, it doesn't tell the full story. We then plot this percentage by the smoker and non-smoker groups using box plot, which shows us the typical tipping percentage and how consistent it is, and whether any usually high or low tippers exist for each group on each day. So now as we've seen the restaurant tip analysis, let's understand about the business intelligence dashboard. So as you can see in the output, now we can see histogram plot and bar plot, box plot and scatter plot. So here the plot.subplots of 2 into 2 creates a 2 row by 2 column grid of 4 empty chart areas, returning the overall figures as fig and a 2D array of axis slots. So figure size of 14,10 that we've written, it sets the total canvas size in the inches. So the key to placing each chart in the corrected slot is the axis parameter. That is ax equal to axis of 0 to 0, it goes to top left. That is to the histogram plot. And axis 0, 1, it goes to top right. Axis 1, 0, it goes to bottom left. And 1, 1 goes to bottom right. And the subtitle adds a single title across the entire figure. As you can see here in the output, there's the 0, 0 axis and 0, 1, 1, 0 and 1, 1. So the title layout function, it adjusts the spacing automatically so panels never overlap. So now we have done with the business intelligence dashboard. Let's quickly understand about Seaborn plus Pandas group by and Matplotlib integration. So this basically splits the data frame into two groups that is based on every unique combination of day and time values. So the tip.mean function, it calculates the average tip for each of these groups. And the reset_index function, it converts the result back into a flat regular data frame that is necessary because Seaborn expects standard column-based data frames, not the hierarchical index structures. So this approach is useful when you need custom aggregations, medians, standard deviations, counts, or beyond what Seaborn built-in estimator handles on its own. So now let's quickly understand about how while-in plot works with Seaborn and Matplotlib. So in this here we've written a code in such a way that while-in plot, it sets the title as tip distribution by day and the split should be equal to true and the data as tips and the x column should be named as day and y as. So we start by creating a matplot figure and axis object with plot.subplots, then pass this axis into the Seaborn while-in plot. So it tells Seaborn exactly which canvas the panel should draw on. So after the while-in shows, the ax.axLine function, it draws a horizontal reference line at the overall average tip value. This is pure Matplotlib code layered on top of Seaborn chart. So the dashed red line that you see here, it makes it immediately obvious which groups tip above and which fall below average. So this is how Seaborn and Matplotlib works together. Now let's quickly save our charts. So here the plot.saveFigure function, it must always be called before the plot.show function because show function clears the figure entirely from the memory. That is DPI equal to 300, sets the resolution to 300 dots per inch, which is the standard for print quality output. So make sure to save it before the show. So the bbox_inches is equal to tight automatically crops the saved image to fit the content snugly. It prevents axis labels and titles from being cut off from the edges. So the SVG saves as a vector file, meaning it scales to any size without pixelation. It's ideal for charts that appear in different sizes across different media. Now let me tell you some visual storytelling tips. First, lead with the insight. Tell your chart with the conclusion and not just the variables. Next, use color purposefully. Every color should communicate meaning and not just the decoration. Next, reduce the chart junk. Remove the grid lines, borders, and legends that doesn't need extra information. Choose the right chart. For distribution, use histoplot, and for comparison, use bar plot, and for relationship, always try to use scatter. And annotate the key points. Use plot.annotate to call out the most important insight directly on the chart. So let's quickly understand what are the common errors you will be facing while working with Seaborn. So this could not convert string to float. This happens when a categorical column is being used when Seaborn expects numbers. Next, when you use the old displot function, Python throws a future warning telling you that this function is outdated and it will be completely removed in a future version of Seaborn. So the fix is simple here. Just replace it with histogram plot of KD equal to true, so which does the exact same thing. It draws a histogram with a smooth curve on top. It's just the newer supported version of the same chart, so you can use this. Hue column has too many unique values. Hue works best with 2 to 6 categories, so delete them first using pd.cut function. The next is when a plot appears but shows nothing. This is when you call plot.show before adding all the customization. Always customize first, then show last. So the following are the best practices that you can follow while working with Seaborn. Always set a figure size when you show subplots. Use the assume function at the start of your notebook for consistent style. Always label the axis and add titles. Save the high DPI versions, that is dot per index, to 300 for reports and presentations. Alright, now we're going to write one connected block of code that creates a complete professional 6-panel analysis dashboard using everything we've learned. Let's walk through it. So here we start by creating a large blank canvas that is 16 to 12 inches with the master title on top. Then figure.add_subplot, it divides it into 2 or 3 column and a grid of 6 panels. So the panel 1 is a scatter plot. It plots the sepal length versus width colored by the species. It shows whether the species separate by sepal shape alone. The next one here is box plot. It compares petal length across the species. Setosa is immediately visible as having dramatically shorter petals. So here, as we can see, the length of the petal setosa is very less compared to the other species. Next we have is heat map. Here it shows a correlation between the 4 numerical measurements. The species is drops first because correlation function only works on the numbers. Next here we have KD plot. It gets a KD plot of petal width with 3 overlapping filled curves, 1 per species. It shows the full distribution shape and exactly where the species overlap. Next here we have violin plot. Violin plot gets a violin plot of sepal length across the species. It combines the summary statistics of a box plot with the full distribution shape of a KDE. It shows that the sepal length is weaker separator between species compared to petal measurements. And here in the panel 6, that is count plot, here it counts the samples per all the species. It confirms all the species have exactly 50 rows, perfectly balanced data set. So finally, we have tight.layout function. It fixes the panel spacing. The save figure, it saves the dashboard to 300 dpi before memory is cleared. And show function, it shows everything on the screen. So here in the code, we've just written the things that it should be shown here. For example, if we take the heat map, the correlation should be true and the C map should be cool warm. And we set the title as feature correlations and the subplot is 2, 3, 3. That is the rows, columns and where it should be placed. And the species, the iris.drop of species axis equal to 1. So we've used a correlation function here, so only numbers will be considered. It is same for all the plots. We've written a code in such a way that where it should appear and how it should appear as the output. So this is about a final project. Feel free to modify according to your requirements and change the figure size and the subtitles and the colors accordingly and try it with your own requirements.
You can pause the video, give it a thought and answer in the comment section. Now moving on to our topic, that is virtual environment. Most Python projects have dependencies that we install and use. For example, we use Flask for web applications and we use these libraries written and tested by many developers, so we don't have to write them again. These libraries change over time. They get new functionalities and bug fixes with some newer versions. For example, let's say you are a Python developer working on 2 different projects and each project has different package requirements. Project A requires Flask 2.0 version, while Project B requires Flask version 2.2. You cannot have both versions installed globally on your system because they will conflict with each other and you might break one or both of these projects. This is where virtual environment comes in handy. And now we'll see what is a virtual environment. Virtual environments are isolated environments that allow developers to work on multiple projects with different dependencies without conflicts. This is crucial when working on multiple projects simultaneously, especially those with different dependencies, because the virtual environment ensures that each project has its own set of dependencies that will not conflict with those of other projects. In Python, virtual environments are created using the built-in virtual environment module, which creates a directory with a specific structure that contains a copy of the Python interpreter as well as other necessary files. Every virtual environment has a Python version and a folder of third-party libraries that you will install for a particular project. Python libraries are frequently updated with new versions that include bug fixes, new features, and performance improvements. Upgrading a library to a newer version can have various effects on a virtual environment. In general, it is a good practice to keep libraries updated to the latest version, but it is also important to consider the impact on the virtual environment and the application before upgrading. It is recommended to test the upgraded library in a separate environment before making changes to the production environment. This can help to identify any potential issues and ensure a smooth upgrade process. If we update the library, maybe our code should not work as the functionalities would have been changed with the update. Now we'll see why do you need a virtual environment.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
When you install packages globally, you run the risk of breaking other projects or applications that rely on the same packages. Virtual environment provides a solution to this problem by creating an isolated environment for your project that doesn't interfere with your system environment. Now, we'll see a hands-on demonstration to create a virtual environment on our system. So for that, we'll go to our projects folder, and inside here, we'll create a folder and name it as virtual environment. So inside this folder, first we'll open the command prompt. So creating a virtual environment is a straightforward process. We'll demonstrate how to create a virtual environment using Python's built-in module, that is virtual environment. And we have opened the command prompt and navigated into our folder that we have created, that is virtual environment. We'll write a command that would be python -m, the name of the module virtual environment, and now we'll write the name of our folder we want to create. So we'll press enter, and now we'll see that we have a directory here that is with the name my environment. Once the command gets executed successfully, we will have a new directory that is my environment, but we have made. Now we have to activate our virtual environment. First we'll do that, but before that, what we can see is in the script section we have pip and the Python files here, that is the python.exe file, that is the application file, pip file. So we have Python's version installed here. So if we ask the command prompt what version is installed in our virtual environment, we'll ask him. It says 3.10.2, but it's the global Python that is command prompt is showing. So first we have to activate the virtual environment, and after that it will show us what Python version is installed into our environment. So to activate our virtual environment, we'll write a command. That is the path we'll write, and this is for the Windows. For that we'll write the name of the folder my environment / you have seen the scripts folder / and then we have activate, and now we'll press enter. You can see my environment folder in brackets. This shows that a virtual environment is active now. Now if we ask him what is the Python version that is installed inside our virtual environment, it says that is 3.10.2. So we have the globally installed Python version that is 3.10.2, and in a virtual environment it's also 3.10.2, and we have a command to deactivate our virtual environment, that is deactivate. So it has been deactivated, that is you can see that my environment from the circular brackets, it has been vanished. Now we'll check what packages are installed into our system. So now we are in the global system. For that we'll write pip phrase and press enter. So you can see these all packages are installed into a global environment system. These are many packages. So you can see these are the packages that are installed. We'll get back to our virtual environment and activate it. So to activate it, we'll get into the folder /scripts /activate and press enter. You can see that our virtual environment is active now, and now in here we'll write the command pip freeze and see what packages are installed. It says no packages are installed into our virtual environment. So here we'll install Django, pip install Django and press enter. So you could see that it has started installing it, and it is installing 4.1.7 version. Now you have seen that Django is installed into our system. Now you can work on any project without worrying about any package that conflict with other projects. Like if you name this as project A, then the Django is installed into this project, and if you want to work on project B, then you need to create another virtual environment for it using the same virtual environment command just above. And you can work on project B without worrying about any package conflicts or breaking project A. To deactivate, we have seen that we can just write deactivate and the virtual environment would be deactivated. So now, if you want to give a particular project to another person, for that you have to ask him to install all the particular version of the packages. So to find all the packages installed into an environment, we've seen the command pip freeze. It has shown us all the packages that were installed into the system environment or the global environment. Now we'll write a command to see what packages are installed in our virtual environment. So for that you could use the previous command prompt, or we could just have a new command prompt here, and here we have to activate a virtual environment again, as we are not able to see the name of the virtual environment in circular brackets. So for that we'll write the name of the directory, then scripts, and then activate. Now you can see our virtual environment is active. Now we'll write the command pip freeze, and it has shared us all the packages that are installed into our system, and these are the packages that are installed with the Django package. So now if you want to share a particular project with another person, then you have to create a file that would be requirements.txt file, and you have to write all the projects with the version names installed for your project. So for that we'll write the command pip freeze and the greater than sign, and then we'll write requirements.txt and press enter. So what this will do is it will create a file requirements.txt, and it will get filled with all the packages with the particular and respective versions. So you can share this file to a particular person, and the particular person can install all the packages just by a single command. So what command he could write is pip install -r, then the requirements.txt, sorry, it's .txt, and press enter. So you could see that the requirement is already satisfied, as in this virtual environment we have the Django installed, and with the Django these are the other packages that will be installed automatically. So the particular person has to run the command pip install -r requirements.txt and all the packages with the particular versions that are mentioned in the requirements.txt file.
Just some background on what data science is, what it is as a field, and then some of the again, some of the processes, some of the packages that we'll need, some of the tools that we'll need to work on data science. So by the end of this lesson, we want to be able to talk about data science in general, just define what it is and what we would be doing in data science. Like, what is, if you're a data scientist, what kind of things are you doing? Mainly want to focus on the process too. Like, what are the steps to solving problems systematically that we will end up following? Okay. And then we'll take a look at so I was saying that we will basically go through the steps to solve problems. I want to definitely highlight that process. Then we want to look at some of the packages that are going to help us do different things in data science, like data analysis, data manipulation, data visualization. So what are some common packages in the Python ecosystem that we will use to accomplish data science? And then lastly, there's a description of some plots. I'm going to skip those because we're going to have a whole section on visualization where we'll go through those plots in more detail. But kind of briefly, I can show what those look like, but we have a whole section dedicated to building those plots, so I'm not concerned about going through them right now. But those are at the end of this lesson. So what is data science? Okay, so what is data science? It is, we had to put a definition to it. It is a multidisciplinary field that uses scientific methods, processes, algorithms, systems to this is the big part of it, derive meaningful insights from structured and unstructured data. So that's the big part of it is obviously data is in the name, data science. So our goal with data science is to derive meaningful insights from data. And so that can involve many things. That can involve building models, which we will learn how to do later on when we get into machine learning. That can involve building out visualizations. That can involve doing hypothesis testing. That can involve many different things, but we're deriving some type of insight or finding out something interesting about our data that we have through different methods. So it's kind of, I always like to say it's the science of working with data, which is kind of a weird way of saying it because that's obviously the name data science, but it truly is the science of extracting insight from data. Is this field, and there's a lot involved in it that blends a lot of different disciplines together. It's why we say it's multidisciplinary because we kind of bring together multiple aspects of math and stats, computer science, domain expertise to be able to derive those insights. So there's things there's ideas and concepts borrowed from science, like doing hypothesis testing. There's obviously math and stats, a lot borrowed from there. There's a lot borrowed from visualization and analysis that we use in data science, but we kind of blend that with technology, right? With computer science. So being able to use Python is a big deal. That will be our language of choice for doing anything data science. That's why we kind of reviewed it in the beginning. So we'll certainly use Python. We'll certainly use different tools within Python to process data. Those are data processing tools. So we kind of blend those together to form the field of data science. So those scientific methods, along with tools working with data from technology like Python, blend those together, we kind of get data science. So where do we see data science today? There's a lot of different applications, and we'll try to describe some of them to you, which is, for example, like wearable devices. So think about like Fitbits or Apple Watches. They're always crunching data from their sensors, right? So there's some type of biometrics that are captured and sent over the internet, essentially, to basically allow us to do some type of analysis or some type of derivation of insight from that data. And then we can kind of visualize that with some graphs or some meaningful metrics so that the person wearing that device can make some sort of decision. So there's some type of insight derived, and usually some type of algorithm being applied to that. Maybe a model's being built, working with the data that's captured from the wearable device, or we're just plotting that data, or we're summarizing it in some way, but making it really useful to the end user to make a decision off of. So we're deriving insights there from all of the data collected in the wearable device. So that's kind of one application. Search engines use data science to personalize results or offer recommendations as people type in their queries. So essentially, like you have suggestions, right? Like, and these could be based on your previous browser history, all kinds of data like your cookies or your what's trending in the world or like your region. Though you probably have noticed this, right? When you're searching on search engines, you get these suggestions. Those recommendations are kind of powered by data science, right? So data is going into that to derive some insight that, hey, this is what we should suggest, and that's it gets surfaced there. One of the things that we'll look into down the road when we get into machine learning, which is the next course after this, will be recommendation systems. So how do we actually build those models that do recommendation? But in order to build those, you really need data. So that's where we got to start, is working with data to get in a position to model off of it. Finance, we see usage of data. For instance, there could be like some type of model that's built to determine a loan decision. So there could be the application, and then there could be additional data that's gathered via the details in the application. And then all that data can be brought together and kind of analyzed through the use of a model that could predict, yes, we should give this loan, or no, we should deny this loan. So again, you're deriving some type of insight from that data to make a decision, right? To make some sort of loan decision in finance. Or like we see a lot of fraud decisions made as well. Like, is this transaction fraud or not fraud? That's another big use case of data science. So based on the data of transactions, are they fraudulent or not fraudulent? Okay. A lot of other applications, those are just a few. And as we go along throughout this course, we'll really study a bunch more and get into some more use cases as we go along. This is just a preview. But what I want to go to next is kind of the process by which we attack data science problems. So we know that we should be deriving insights from data. That's what data science does. And the question is, like, how do we go about doing that? What is a good systematic way of doing it? So we're going to describe that in the process. Good question. Differences between data science versus data analytics versus data engineering. Yeah, so the difference with data engineering, let me start with data engineering. Data engineering is mostly centered around building like pipelines and building systems that can collect data. So it's more about engineering systems to like collect data and house it and store it and facilitate data transfer and data availability. So it's more about working with the data to make it available and collect it. And it's a lot more engineering heavy, as the name suggests, because you're building pipelines and building systems that will like scrape data from sources or pull data from APIs or do those kind of things that will collect data for you. That's a little bit different than data science. Data science, remember, is going to be generally like building models or doing visualization or both, derive some sort of insight, find some sort of pattern, or find something interesting about the data that's not already or hasn't is not readily known just by looking at the data. So with that being said, there's a lot of overlap of data science and data analytics, but I would say analytics is a little bit more static in the sense of a lot of analytics are just doing basic rule systems or basic visualizations. Data science usually goes a step further and builds more sophisticated models to make some sort of prediction, make some sort of decision off of. So data science generally involves more modeling than you would see in data analytics. Whereas data analytics goes a little bit deeper on doing like visualizations and doing more like experimentation, statistics gathering. Does all that make sense? Like data science is going to be more heavily on the modeling side to derive insights. That's a big deal about how to derive insights is from building a model. Yeah, that's a great question. I know there's a lot of those overlapping terms. This is a really good question. Any other questions? Okay. All right, let's talk about the process. Okay, so the process is outlined roughly here, but I'm going to take us through every single step. But if I had to break this down into basically a handful of key steps, it mostly starts at here, which is kind of initial problem formulation, which involves collecting data. So usually you have problem formulation. So you need to know like what are, do we want to build a recommendation system for movies? Do we want to figure out if transactions are fraud or not fraud? Like we're coming up with some problem that we want to solve and then going out and collecting data that might help us analyze that problem further. So we'll talk about that. Then comes the kind of data preparation phase, I would call it. So data prep, meaning that we are preparing our data for modeling with that goal in mind. Is our goal is to actually build some sort of model to tell us something, to help us make a decision or derive some insight, right? And so we will do a couple steps. I'll describe what they mean in a moment of doing some data preparation in order to get ready for modeling. Then comes the actual modeling phase. The actual modeling phase, which involves building, training, evaluating, all of that. And so then comes the modeling phase, and then comes the actual deployment of the model, meaning that we use it in the real world to bring our insights into an actual system, integrated into actual systems, so that those decisions can actually be made and used by an end user, let's say. I believe you can call a data science process even if no model is built. Step 4, 5. You can, but so I think that's fair, is to say, like, even if you're not building a model, so you're thinking just steps 1, 2, 3, 4. Yeah, that's true. Or even just 1, 2, 3. I think that's fair, but most of the time in this course or in this program, we're really going to be building models. So I want us to have this in mind, is like, even if we stop here and don't do any model building, this is what we have our eyes to, is the ability to model if we want to. Okay. But I think it's a fair point, is that it could be, it's a fair point that you could just imagine getting your data together as really like kind of a data science process. Is feature engineering the feature that will use the feature? I'm going to describe what feature engineering is in a moment. I'm going to go into that in further detail in the next couple slides. So just hang on when we say feature engineering. We'll talk about it. I was thinking for A/B testing and probably there's no model. Would you call this a data science project? That's up for debate. A/B testing, sometimes that falls under analytics. Sometimes that falls under data science. Yeah, sure. We'll talk about doing A/B testing. So even when there is no model, so I think it's fair to say it's part of data science, which would kind of just be steps 1, 2, 3, 4. So yeah, I see where you're coming from. Traditionally A/B testing is more like experimentation analytics. I agree, it's not traditional data science, but we will cover it because it's an important aspect of data science, with the idea that the part of deploying a model and seeing what the results are would be like an experiment, right? It would be, we think of it as an experiment where I build some model, see what the results are on a different group than a kind of a baseline control group that's not exposed to that model. So it's important for us to know what it is. You could argue the actual process of doing A/B testing is not really data science, but if you add in that context of usually people are interested in using it in conjunction with building a model and exposing it to users as an experiment. Does that make sense? Yep. Okay. Very good. All right. All right. Let's go into each of these steps and talk a little bit more about them. Okay. So, excuse me. Usually things start in the beginning with a problem definition, which is a goal or a question that will be addressed through collecting and analyzing and deriving insight from data. So that's the very first step, and usually this is actually something that you would work together with other colleagues usually to come up with. So usually you may come up with this with like a product manager or with another engineering group or something like that to come up with a problem like, hey, we need to build a recommendation system for our users to get better recommendations for their movies or for their shows or for the products on our website. So there usually is going to be a question or a goal, or hey, we want to come up with a sales forecast for the next 3 quarters, given the data we already have for this quarter or the previous quarters. So usually you have to start with a problem. So you have to start with a problem definition that you want to address. And honestly, that goes hand in hand with the next step, which is once you have a problem in mind, you then have to collect data around that problem. So you have to gather the relevant data sets, which could also involve working with external partners to do that. So maybe you have to work with data engineers to help you go out and collect that data or make that data accessible. You may have to work with, you may have to do it yourself and go and gather historical data that can help answer that problem. So sometimes this is up to you. You have to go and go out and collect that historical data or that data that's relevant to your problem. That is totally possible. But sometimes you're also working with external partners like a data engineer to make that possible to go and collect the data. But of course, the key word here is relevant, right? The data needs to be relevant to the problem that you're solving, and that can be a challenge. So I know these are listed as the first 2 steps, and they seem pretty straightforward, but they can be the most challenging at times, is defining the right problem and collecting the right data, getting that available. It's not always trivial. But in this course, we'll usually assume that we have these 2 things. We'll usually assume that, yes, there's a problem we know we want to address. For practice purposes, we have that. And then we also have data already available for us. We don't have to go out and fish for it and collect it and scrape it from somewhere. We'll assume that's already been done, and we're just using the data that we have available. So in this course, these 2 steps will usually be done for us, mainly just for so that we can practice all the other steps. But in the real world, that would usually be someone you're working together to formulate a problem with external stakeholders, and you're also gathering data either by yourself or with the help of maybe like a data engineer or someone like that. Okay. So again, these 2 things we'll usually have in this course. which leads us to the next phase, which is that data preparation phase. So this is where I said we need to clean the data and explore it a little bit. So usually this process can take some time. So it can be a very time-consuming process. But the typical tasks we're doing here are getting a handle on any missing data. So figuring out a strategy to handle missing data, we'll talk about that. How to identify and handle outliers, we'll talk about that. Maybe duplicate data, inconsistent data that doesn't make sense. We can identify that, we can get rid of it or have some strategy to handle it. So getting a handle on cleaning up our data is going to be an important task. And that might take some time. That might take some time to work with our data and kind of we have to learn how to do the proper code, clean it up, get it to a good state. And then once we do that, we can start to explore it a bit to gain insights. And this is where we'll usually use visualization at our disposal. So maybe we'll build some graphs to quickly visualize, get some patterns, see what the data looks like, figure out if there's any relationships in the data. That's what we'll learn about visualization that will really help us. So when we say explore, we're mostly talking about building graphs to help us kind of tell a story about what we see in that data, assuming that it's been cleaned up, right? Assuming that we have it cleaned up, we've removed all our missing values, outliers, inconsistent values. We now have a clean set of data, we can start to explore it. So usually doing visualizations, it could also be, it's not only visualization, but it could also be summaries. So maybe it's really useful to tell a story like what is the average for all these users, or what is the average sales for the last few weeks? What is the median sales? Like those kind of statistics might be really useful summaries to tell a story about the data. Okay. Okay, so we have our steps here: problem definition, data collection, cleaning, exploration, first 3 steps. Any questions about those first 3 steps? Good? Okay. All right. And again, we're gonna, like, as we go along, we will deal with these problems. We'll have actual examples that will deal with this process. So we'll see this process from end to end many times as we get into our examples later on. Bronze, silver, gold. So usually those are like data engineering terms to refer to basically how clean the data is. So like bronze is kind of like the rawest form. It's usually like data that has not been aggregated in any way. It's usually pretty raw. It hasn't been cleaned up in any way. Silver might be cleaned up, but not really aggregated. So silver might be like we've removed missing values. We've done some, we've removed outliers. So silver is a bit cleaned up, but it's still kind of raw. And then gold would usually be like our final transformations have been applied to it. Like maybe we've done some averaging, we've done some transformations. So usually those are terms that you see to refer to the different like stages of quality. Gold being like the highest quality, like the final data set. Yeah, model will run on gold. Yep. Yes, that's true. By the way, we don't really use those terms too often. I think you see those terms a lot in like data engineering. Don't really see them that much here. Just because the assumption is that we're always going to clean up, like our models aren't going to be good unless we get to a gold state, right? And unless we clean up our data, unless we do the right transformations that make sense, like our models really aren't going to be useful until we reach that state. So we're always going to be pushing to like clean up and get to a good state. Okay. So we have 1, 2, 3. Let's look at the next few steps. So once our data is clean and we've explored it a little bit, this is step 4, which is feature engineering. So this is the other kind of data preparation step that I talked about. So feature engineering, what is that? It is a creation or transformation of new features. So you might ask, what is a feature? A feature is just a variable that is an input to a model. Okay. A feature is just an input. So I want you to think of, like, in an Excel spreadsheet, a feature is something like a column. It's an independent variable, like a column that we would use to build a model off of. Like, that will be one input. We would call it a feature that's going into the model as an input. Okay. So feature engineering is the process of kind of building new features. And those can be by doing simple transformations. Like maybe we do some scaling, like dividing by 10, multiplying by 10. Those are simple scaling we can do to features. We could do more complex transformations, like doing a linear transformation to it. We could take a square root, we could take a logarithm, we could take an exponential. Many different transforms we can do to our data to create new features. And sometimes that makes sense to do that. Sometimes we don't need to do that much feature engineering, but that's something we will get a feel for as we start to do examples. Is like, when does it make sense to do feature engineering, and when do we not have to? So feature engineering will be more of an art than a science, honestly. And we're going to do plenty of examples where we do feature engineering to see what kinds of transformations we typically will do. It's part of the current data. Yeah. So everything we're talking about will be part of the current data we're working with. Is it always performed? No. We don't necessarily always do feature engineering, but it is a step. Like, we can and we should evaluate if we should. Okay. So will we always do it? No, but we have the ability to do it. And it's a step worth calling out because it can be very valuable to do. So again, we haven't learned how to do that yet, so it may not make that much sense to us, but I'm calling it out as a very important step in the process. And as we start to do examples later down the road, we're going to come back and spend some time on feature engineering because it is an important step. It is an important step often to do it. Okay. Yeah, I see how it can be a little confusing. Yeah, feature is, in data science, feature is just a variable. It's like an independent variable that's an input to the model. Yeah. It's a little bit different of a meaning than like a feature, which is kind of a new piece of software you're adding to existing software, right? A little bit of different terminology there. Okay. So this was step 4, and this was data prep. So draw a line here because this is all like the data prep, and then these couple of steps here are all modeling oriented. So once we have our data prepared, we've cleaned it up, we've done exploration to determine what we should keep. We've done some engineering to do some scaling or transform the features that we have. We can now build a model. And so this will all be something we will learn in our next, we will learn how to build models in our next course on ML, but just calling it out as, that would be the next natural step, is once we have our data cleaned up to derive an insight from it, we may want to build a model off of it. And so that will involve kind of defining a model, training it on this data that we've prepared as step number 5. And then step number 6 will be kind of an evaluation step of determining if we have a good enough model by evaluating it. This, by the way, this process isn't necessarily linear. in the sense that we may iterate here and go back and repeat these steps. So we may go back and forth and keep repeating these by building a new model, determining if it's good enough, repeating and repeating and repeating that process. And we may even go all the way back up to here and build some new features if the model isn't doing that well either. That may be possible. So by no means is this process always linear. We may repeat, especially this model training and building and evaluation steps. We definitely can repeat these back and forth until we kind of converge on a good enough model. That's something we'll discuss when we get into modeling. I don't want to go into details now, but that is, suffice to say, like, we can iterate those steps quite a bit, and we can spend a lot of time on it for sure as a data scientist. Okay. And then, oh, by the way, there's one more. So there should be a step here on deployment, which is kind of mentioned here, but I would argue it's its own step. But once we have the model done, then we can kind of deploy it. Now, deployment means a lot of different things. There's a lot of different ways to do that. We won't get into that till much later in the program. It's not really going to be a focus for us at the moment. We're mainly going to focus in on all of the data preparation steps and then all of the modeling, and then leave this part till kind of the very end of the program. Okay. But it is an important part. Like, we need to once we build a model, we do want to have it be useful in the real world. So we need a way for it to be integrated into existing systems, which can be different. There are different ways to do that. What is the percentage of the model has to see for? Oh no, that's not a silly question at all. It's really like your tolerance for if you think it's good enough. So for instance, I've worked with people where we've deployed models that have been like 70% accurate, and that's okay because we just want to get something out there to test with and to have results. So yeah, like the target percentage is different depending on the problem. That, by the way, that's something we'll talk about when we get into our next course on models and evaluation, because it turns out there's different ways to evaluate the accuracy. Like, sometimes we care more about, it's not about overall accuracy, but more about, like, are we limiting our false positives versus false negatives? Because sometimes a false positive is going to be more costly than a false negative, or vice versa. Like, a false negative may be way more costly than a false positive. So we're going to have different ways to evaluate our models, and that can lead us to different thresholds. But like, it doesn't have to be perfect. I've seen a lot of models deployed at the like 70% range, 60% range. That's okay. Mainly the reason to do that, by the way, is to get something out there so that you can iterate on it, right? You get something into production and then you can iterate on it after the fact. So you don't want to spend forever waiting for it to be perfect. Okay. All right. Any questions about that process? I know we haven't covered all the details of it, but just remember, right now it's, we formulate a problem, gather data, we do data prep, then we do modeling. And the data prep is going to be something we will focus heavily on in this course. Okay, for the moment, the data prep will be something we really key in on in our last couple of lessons. Okay, things like data cleaning, things like feature engineering. Any questions? Will we cover precision recall? Yeah, we will, just not now. We'll cover that later in machine learning when we get to model evaluation. Yeah, really no need to cover it now. So we're not building any models yet. Okay. All right, so let's go back and circle around to Python. I know, we spent some time on it already, but just to reiterate that Python will be our friend here when we're doing data science. So it's going to be the preferred programming language for anything data science, and that's true in the industry. Python is widely used, mainly because it has so many great packages to help us work with data, namely NumPy and Pandas, which are the first two we will look at. And then it has many others to help us build models like scikit-learn, which we'll get familiar with. And then it has others to do visualization that we'll study. So it basically has packages that do most of the tasks for us that we're interested in doing. So that's why we'll stick with Python. It's really great for data science. So we've talked about this before. Why people prefer to use Python is because it's open source, interpreted. It has so many great packages that are oriented for data science and can help us do data science really easily. A lot of people used to use R to do data science, but it's been a shift over towards Python because of its flexibility. Python can integrate with other systems pretty easily, whereas R is more difficult to use. R is like it's like a scientific analysis language. It's used in a lot of like statistics. A lot of statistics people like using R, but for doing data science, it's almost exclusively done in Python. So there's really you don't see R too often. I've really never seen it. I've only seen Python in the industry. So no worries about the R. Historically, R has been around. R has been around for a while, but Python is by far and away the most used data science language. For sure. Okay. So I want to briefly tell you about some of the packages that we are going to study in our course that are in Python that we will use to do data science. So I just want to briefly talk about them. And then, of course, we're going to have a couple of lessons dedicated to going into those, like NumPy and Pandas and all the visualization libraries. So the first one is NumPy. So NumPy is short for numerical Python. So that's why it's called NumPy, the numerical Python. And it is a Python package for doing computing, basically scientific computing, using these array structures that NumPy has created. And so many things are built off of NumPy arrays and the ability to operate on these NumPy arrays. So NumPy came around and created these multi-dimensional arrays, which are essentially like matrices, and also had a lot of different computing tools around the matrices and arrays that so many other packages are built off of. So we're going to learn Pandas. Pandas is built off of NumPy. So is matplotlib, which is for plotting, and so many other packages are built off of NumPy. So it's a really foundational package for working with data, because data will be stored in NumPy arrays. The NumPy array is the kind of foundational data type of NumPy, and so many things work with NumPy arrays. Okay, so we're gonna have a whole lesson dedicated to NumPy coming up next, but NumPy is going to be the first place we're going to start, just because it's so important for working with data. Its multi-dimensional arrays are so useful for storing and manipulating data. So it's pretty important. What is a Fourier transform? It is a transformation of data into like a signal, basically like a signal transformation. So you go from like basically like a time series into like a frequency series. It's used in signal processing. Yeah, analog to digital. Yeah, pretty much. Analog to digital. Yeah, it's used in signal processing. Okay, so the second package that we will study, so we'll start with NumPy. We'll start with that today. So right after this lesson, we'll dive right into NumPy and start working with examples of the NumPy arrays. But right after that is the library Pandas, which we'll spend a lot of time with. Pandas is a library built off of NumPy, so it depends on NumPy. And it basically comes around and provides a more structure to manipulating data. So if you're, like I said earlier, if you're familiar with Excel, Pandas has a lot of functionality that mimics what you would do with a spreadsheet. Basically, like structured row column data is what Pandas excels at. So Pandas is going to be a really fundamental package for us to manipulate data that's structured in kind of a row column matrix format, but it's built off of NumPy. So it uses NumPy under the hood to do all the manipulation, but Pandas provides its own data structures to kind of put data into almost like a spreadsheet format that we can manipulate. Okay. So really, Pandas is going to be really, really powerful for us to manipulate data, and we'll use it all the time. So if anything coming out of this course, you guys will be Pandas experts, if anything else. Yeah, I mean, of course, you'll learn more than that, but I think you'll come away as being really, really good users of Pandas and NumPy for that matter, but certainly Pandas. So we're going to study NumPy first, and then we'll have a lesson dedicated to Pandas right after NumPy. So we'll have a lot more to say about it, but I just wanted to kind of preview that, it's a really important package in the data science ecosystem because it helps us manipulate that structured data that's in like a row column format, like a table. Okay, then another package is the SciPy package, which is short for Scientific Python. It is another open source library that's built on top of NumPy. So it uses NumPy arrays as its underlying data structures to do the manipulations. SciPy contains a lot of scientific formulas and a lot of scientific computing tools that we'll use, especially when we get into hypothesis testing. So it contains a lot of like z-test, t-test distributions, things like that. So it's tailored for that. It also has things like the Fourier transform as well. It has different linear algebra manipulations as well. So SciPy will be really useful when we get into our hypothesis testing and A/B testing. It has those kind of those distributions that we'll need to do our tests, like a student t-test or a z-test or those kind of things. We'll use SciPy for. So really important package. We'll see later when we do hypothesis testing. Another one that is going to be useful from time to time is the stats models package. So it is one that basically has a lot of statistics oriented things. It has some basic models in there, like linear regression or logistic regression. We will generally favor a different package to do those kind of models, but just calling it out that stats models does have some useful stuff when it comes to doing statistical testing. So there are some like chi-square tests or ANOVA tests that we will borrow from stats models that SciPy doesn't have. We can borrow from stats models. So we will use it when we get into hypothesis testing as well. So these last two, so SciPy and stats models, are two packages that we'll use when we get into A/B hypothesis testing. Okay. So that brings us to scikit-learn. Now, this is going to be our primary package for doing machine learning. So this will be one that we'll build all of our models and machine learning off of when we get into our machine learning course. So we won't really use scikit-learn in this current course, but when we get into machine learning, it will be our go-to package to do all of our machine learning with. It is a fantastic library that's been developed over years to contain all the basic models that we would ever want to build. Scikit-learn is really awesome. So it can build models for so many different use cases. And it's a really easy package to use. It has a really nice interface, really easy interface. So we will see that later on when we get into our next course on machine learning. But just calling it out, that is a very popular data science library, scikit-learn. So when we get into our modeling, we will use scikit-learn. When we do our data prep manipulations, we'll be using NumPy and Pandas. Finally, for visualization, we will be using a library called matplotlib. So it is kind of the foundational Python plotting library that borrows inspiration from MATLAB. So if you guys have ever used the MATLAB plotting, it's actually very inspired by that, hence the name matplot from MATLAB. But it's going to be our main tool for using for building graphs. Okay, so it's a foundational library for building graphs. Almost every other library that does visualizations is built off of this one, built off of matplotlib. So when we get into our visualization course, we will come back and do talk a lot about matplotlib and practice with matplotlib quite a bit. Excuse me. What is that course called? Machine learning. The next course is called machine learning. Okay. And then another visualization library that we will lean on heavily is the Seaborn library. This is one that is built on top of matplotlib. So matplotlib is kind of like NumPy. It's the foundation, and then a lot of things are built on top of it. Seaborn being one of them. Excuse me. Seaborn being one of them, and it basically has just better aesthetics. It provides not only like better aesthetics than just basic matplotlib. It also has more scientific kind of plots and more interesting plots than the regular ones you get out of the box with matplotlib. So it has really interesting histograms, file implots, heat maps. It can do statistical error, like confidence interval bars. So it just builds better plots than basic matplotlib. Matplotlib is very basic. It's really easy to use. You can build a lot of plots with it, as we're going to learn. But Seaborn is really nice. It makes things aesthetically pleasing, and so we'll also use Seaborn from time to time. It's another plotting library that we'll get some practice with when we get into visualization. And another one of those is Plotly. So we have Seaborn and Plotly both built off of matplotlib in order to do plots. Now, Plotly's specialty is for building interactive graphs. So when you build a Plotly graph, you can actually, it'll pop up in your web browser, kind of like Jupyter Notebooks do. And you can click around in the graph and mark down points. You can zoom in, you can zoom out. Excuse me, I'm just getting over a cold here. So don't mind the coughs. But you can zoom in, you can zoom out, you can do a lot of interactions with Plotly. So if you want to build an interactive graph, Plotly is a good package. Again, it's built off of Matplotlib. So we'll get some practice with Plotly. So these three we're going to practice when we get into visualization. Seaborn, Matplotlib is the basic foundation. Seaborn and Plotly both build off of it. We'll get some practice with all three of those when we get into visualization. So the rest of these slides just go through some plots that we will be building later on when we get into our visualization. So just wanted to briefly go through those just to show you some of the different types of plots we'll do. So the easiest kind is basically a line plot that connects different points. So this would be like if we were plotting out something over time, like a stock price or a sales value over different quarters or weeks, temperatures over time, something like that. So basic kind of plot, we'll be able to build that, no problem. We can even mark different points on those. That'll be easy to do with Matplotlib or Seaborn or Plotly. That'll be really easy to do. So again, we'll show you how to build these with code later on when we get into visualizations, but just showing you the possibilities right now. Scatter plots, we'll do these, which have different points kind of scattered throughout on two axes here. This is usually helpful to figure out how the data is kind of maybe clustered together, or figure out if there's relationships between two variables, like if they tend to trend the same direction or in the opposite direction, or if they're kind of just distributed all over the place. So we'll be able to build scatter plots. That'll be helpful. Area plots that show like cumulative areas on top of each other, we'll be able to show that. That'll be pretty easy to graph for different, maybe tracking total sales over successive quarters, showing different contributions of categories we'll be able to do. So we'll be able to do an area plot. Basic bar plot we'll be able to do. Again, all of these examples were built using Matplotlib, so we'll be able to do that. But they have equivalent versions in Plotly and Seaborn, so again, those are built off of Matplotlib. So we can even put grids in the background to show, to kind of assist the viewing of it, to give an idea of where the different points are in the grid. So that will be easy to do. Histograms. Now, histograms are going to be extremely useful for us. We'll build histograms a lot because they will help us visualize how data is distributed, which is extremely important to know. Is it kind of distributed like this in this picture, which is kind of like a bell curve, or is it flat? Does it have kind of two peaks to it? Knowing this distribution will be extremely useful to us. So that we will often build a histogram that kind of looks like this. So histograms will be extremely useful. We can build pie graphs, which show different percentages. There may be certain situations where that makes sense. We're telling a story of our data. It makes sense to use a pie graph. That'll be easy to do. Again, these are all just examples of what's possible. We have to show you how to build these, and we will when we get into the data visualization lesson, which is what this kind of note says at the bottom. Once we get into that lesson, we will show you how to do the code to build these. Okay. So just to wrap up this first introductory lesson, we have shown you what data science is, which is kind of the extraction of insight, deriving insight from data. And we have a bunch of different packages that are going to help us do that. We also have a process which is going to help us do that, which is usually defining a problem, collecting data, doing data preparation, and then doing modeling after that. So, basic foundations at this point, what we're going to do is now go into NumPy. So we're going to start with NumPy and then go into Pandas after that. So we're going to start studying these packages. They're going to help us do some of these different tasks in data science. Any questions at this point? Okay, I'm going to open up our next lesson then, which is actually going to be, so if you guys notice, the next lesson is actually going to be, lesson 3 is broken into several different notebooks. So we're going to be transitioning into notebooks for some of these guys. Do you guys have those notebooks, the lesson 3 notebooks? I can try to download, I can try to share them with you guys if you don't. Or does anybody have the folder and want to share it for those that don't have it? It should be a collection of several notebooks. Yeah, let me download it. Okay, so give me a moment. I will upload it. I have it right here. Okay, I just uploaded it. Okay, so you guys should have it. So you want to open those notebooks. Again, you can open it wherever you want. You could do it in your own local Jupyter. You could do it in the lab environment. You could do it in Colab. I recommend Colab just because it's so easy to work with, right? So I recommend opening them up in Colab. That's what I'm going to do. I think it's just so easy to work with. So that's what I'm going to be using. All right, can everybody see the screen? I'm on the first notebook. The 3.01 notebook is the one we're going to start with, the introduction to NumPy. Okay. So if you have a moment, you want to open that one up. Again, if you're working in Colab, you can upload the notebook. So you can like once you've extracted that folder, you can upload the notebook into Colab using this like file upload notebook. That should work. Or if you have Google Drive, you can just upload that folder into your Google Drive, and then you can just launch it through your Google Drive, and it should open it in Colab. That works too. Are people able to open the notebook? Yeah. Again, it doesn't matter where you open it, just as long as you can, and you can run some of the cells, because we're going to be running them. Good, good. Good, okay. All right, so let's talk about NumPy. Now remember, NumPy is the open source library that is used for doing, math and scientific computing on basically these arrays. So we are going to take a look at the NumPy array object as the first thing that we'll look at. Now, the NumPy array object behaves very similar to a list. So we learned about lists in our previous course, and the NumPy array is very similar to a list. We can slice it like a list. We can access elements like a list. It's ordered like a list. But it's a lot faster to do mathematics with the array, and it comes with a bunch of built-in functions like mean, median, mode, all these special things on the array that we don't get with a list. For instance, Python lists do not have a notion of an average. You can't calculate the average of a list without doing a manual calculation. So, but a NumPy array has a mean function that comes built in that we can take the average. NumPy has like an average function that we can take of an array or a median or a mode. So arrays are really advantageous to work with inside of NumPy. Let's take a look at some examples of a NumPy array. So in the first cell here, I want to point your attention to two things. One is that in order to use NumPy, we import it. Do you see how we import NumPy? And we do this thing called as MP. Now what this is we do an alias. This is called an alias NumPy as NP. We basically shorthand it to NP, which is an industry standard. So anytime you're looking at code and you see NP dot something, that is short for NumPy. So in the industry, if you know, everyone is going to shorthand NumPy to NP. That's just what people do. So as is the way to alias and import, so that when we use NumPy in our code, we don't have to type out the full word NumPy. We can just do NP. So that's why you see NP here, is because and really throughout our code we use NP. You see it all over the place. It's a shorthand alias for the NumPy package that we're using. So we are importing this package, meaning that we are going to use it in our code, but we are aliasing it to NP. This is the industry standard to do. Most of these packages have a nice alias to them. Like Pandas will have an alias, Matplotlib will have an alias, just to make it shorter. Do you have to import it in VS Code? If you're using VS Code to run your notebooks, yes, you have to upload it there. You want to open in a VS Code? Yeah, you're gonna have to open the folder where it exists. But that's if you're using VS Code, like you don't have to. But yeah, if you want to, yes. Okay. All right. So the next thing I want to point our attention to is building a NumPy array. So notice that we can build this NumPy array by doing np.array. So np.array builds a NumPy array object. And what we're passing in is just a list of data. Okay, so we have a list of integers that we pass into this NP array, which will build a NumPy array out of this list. So NumPy arrays can be built out of lists, they can be built out of tuples, they can be built out of other NumPy arrays. There's many ways to build a NumPy array, but the most common is to pass in a list, to convert a list into a NumPy array. So here we are building a NumPy array from a list, which is pretty typical. By the way, you guys remember I said that I'm going to be writing a lot of comments. I'll share these notebooks in our Slack after the classes. But I encourage you guys to do the same thing, is to write comments in your notebooks. Okay, try to write comments in your notebooks to outline what the code's actually doing. How do you install NumPy? You just need to do, so inside of a cell, you can run this command like pip install NumPy. Try running that inside of a Jupyter cell. Yeah, this command is not going to work for you because this is like a generic. This is on Windows, like a generic Windows command. But if you're inside, are you inside of a notebook, Mariel? If you're inside of a notebook, just run this inside of a cell. It should install it. Yeah, that works too. You can open your terminal and do pip install. If you do that, you'll probably have to restart your kernel. No, so Colab comes with NumPy already installed. Yeah, so that's another advantage of Colab is it already has that installed. We don't need to worry about it. Yeah, so if it says requirement already satisfied, which is what this is going to say if I run this, it's because it's already installed. So this means that I already have it installed. Yeah, you already have it installed. Yep. Yep. So in Colab, it already exists. This one, new cell in this command. If you can't get it to work in your VS Code, I really encourage you to do Colab as much as you can. Just to get something that works. Because NumPy is already installed in Colab, so there's really nothing you need to do extra. Thanks, Tim. That'd be great. That'd be great. Okay. All right. So this builds, going back to this builds a NumPy array off of a list. So if we run this code, what's happening is we are building an array and storing it in this array variable, and we can print the array. Now look at what the array looks like. It kind of looks like a list when we print it, except the way we can tell this is a NumPy array is that it does not, when we print it, it does not have the commas. Notice that the data in there does not have the commas, and that's because it's being treated as a NumPy array. So it doesn't have the commas. It's not, at that point, it's now an array, it's not a list. So it looks slightly differently. And you can even see when we print out the type that this array is actually a NumPy n-dimensional array, which is the foundational data type of NumPy. So this is a NumPy ND array, which is the foundational data type of NumPy. So we have created a NumPy array, and now you can see what its type is this MP ND array. Okay. Were you guys able to run this first cell if you run it? It's not going to do anything but show this. You should see this, and then you should see it's printing out the type. You should see those two things. And do we see how this is creating a NumPy array? So np.array is that's the function we use to build a NumPy array. And we're passing in a list of data to build that array. All right. Yeah, it might take a moment to start up the kernel. All right. Any questions on this so far? What was ND array? It's short for n-dimensional array. It's the NumPy array object type. So that is the data type that we are working with now, is a NumPy n-dimensional array. It's a generic NumPy array data type. And you can see that because we do type, and we can see that we get a NumPy ND array as the type of this thing when we create a NumPy array out of it. So ND array is short for n-dimensional array. Okay. What I wanted to do is go to the next cell and talk about how we can create some matrices, essentially multi-dimensional arrays. So this array that we've created so far is actually just a one-dimensional array because it only has one dimension to it. It basically has one list of data. But of course, we would be interested in working a lot of times with multi-dimensional data because that's typically like what a spreadsheet has, right? Rows and columns. So just to give you guys an example, like NumPy actually supports 0 dimensions, which is basically a constant. So a single number, a single value is considered a 0D array. So a single value is considered as 0 dimensions, is just a single value. So if we built a NumPy array and just passed in a single integer, or it doesn't have to be integer, it could be float like 24.6, whatever it is, that would be considered a 0 dimensional array. But we've already built a 1D array, which is just a single list, basically a flat list with, so just if we use a list with a list of, I should say a single list of values is a 1D array. So we've already seen that. It is a scalar. Yeah, we would call that a scalar. Yes. Good. Yes, that's true. Scalar. Perfect. Perfect. So a single list of values is going to be a one-dimensional array here. Now, what gets interesting is now when we do a list that has list as its elements. So this is a list of lists is now a 2D array. So I want you guys to see that how we're building a NumPy array out of a list, but look at what the elements of the list are. They're actually lists themselves. So you see how within this overall list, the first element is a list that is 111. That kind of mimics basically like a row. So you think of it as like each list is like a row in a matrix. So this two-dimensional array is really like a matrix, right? So this is an interesting use case where of course we could have more than just these two. So we could have a third list here that is like 4, 5, 6, and that would be valid as well. So this would be basically a matrix that has 3 rows, and each row has basically three items in it. So we would think of it as basically having 3 columns, right? So it's like a 3 by 3 matrix, but it is 2 dimensions. It's a 2-dimensional array. It has rows and columns at this point. So it has rows and columns. A 2-dimensional array. Let me ask you guys, do we see how this has 2 dimensions to it? It's a list of lists. So it has 2 dimensions. Does all the lists need to have the same rows? What do you think? What do you think would happen if, let's try it. Let's try making this a smaller dimension. Do you think this is going to be allowed? Is this what you're asking? Like if can this be a shorter dimension? Let's see. So yeah, this gives us an error. So yeah, you're exactly right. This will give us an error that the dimensions do not match. So this is not allowed, but let's see if I add in the 6, this should now be okay. And there it is. This is now okay. No more error. Okay, no more error. So yeah, it's still going to be an error if the shapes do not match. So again, if we made this a smaller one, that's going to be an error. And it's going to tell us that we have one dimension that is inhomogeneous, meaning it doesn't match. It's not the same. We have one dimension that's not the same. Its shape doesn't match. It's not correct. So therefore, we should correct that and make sure it is matching. Okay. So that is a 2-dimensional array, list of lists. And by the way, that doesn't have to stop there. We could keep going. So now we have a 3-dimensional array, which has lists of lists of lists. So it basically has one of these matrices as each element. So see how this has basically an overall list. So this has it has a list where each element is a 2D array, right? Each element is a matrix. So here is one of those matrices, is the first element, and then here is another 2D matrix that is the next element. And this forms a 3-dimensional array. So if we print this out, we can see that we get this 3D array where this matrix is the first item, this matrix is the second item, and on and on and on. Didn't understand how 2D is different from 3D. Do you see how? Okay, so do you see how with the 2D, basically we take this whole thing and that's just one element of the 3D. This 2D matrix is one element, and then we have another 2D matrix as the next element. So we have matrices are now the elements of the 3D array. Whereas look at what's the elements of the 2D array, they're just lists. It doesn't have to be 2. That's just the example we have. It doesn't have to be 2. But by the way, one thing that gives away the dimensions is how many of these brackets we have. So you see how we have 2 brackets and see how this has 3 brackets? Yeah. Oh, you guys got it. You got it, Roberto. Perfect. Yep. You guys got it with the brackets. So what's an example of using a 3D array? Yeah. So something that uses a 3D array would be like a batch of images. So let me give you an example. So an image is like a 2D array because it has pixels, right? It's basically an image is broken down like this that has pixels with whatever resolution. And so if we have a collection of those, it's like we have a collection of these guys is a 3D array. Like if we have 100 of those, it's like a 3D array. Does that example make sense? Like a collection of images would be a 3D array because every image is a two-dimensional matrix of pixels. Yeah, a 3D array is a collection of matrices. Yep. Exactly. Does this example make sense though? Like this is a good one, I think. I'm glad you asked it because I think it's a good one for thinking about what a 3D array is. Every element is a 2D matrix. What is the maximum 2D element in a 3D array? I'm not sure what you mean by that. Maximum 2D element? Oh, how many can you fit in a three? You can have unlimited as much as the memory will allow, basically, as much as your memory will allow. You can have unlimited. You can have as many matrices in a 3D array as you want until you run out of memory, essentially. Okay, perfect. All right, perfect. So just to recap this, we have the NumPy array. So we're able to build NumPy arrays using the np.array, and we're able to take a list of data and populate it into an array. And then what we're going to do is just build off of this to learn how to manipulate that array and do different things with that array coming up next. All right, so let's go to the next notebook. Let's go to 3.02. Well, before I do that, any questions, any other questions about this building an array? Okay. Perfect. So let's go to our next notebook. Okay, do you guys have the 3.02 notebook? Do you have it up? That's the next one we're going to do. So take a moment to pull that one up. Yep, I see some thumbs up. Nice. Okay. So we're going to build off of that NumPy array by taking a look at some attributes of arrays. So assuming we have an array, no matter how many dimensions it is, what are some attributes of this array that are useful to us? Okay. So let's take a look at an example where, again, here we import NumPy and we're initially making a 2D array, right? So we make a 2D array. So then what we're going to do is print out a bunch of the attributes about this array. And we're going to explain what they do. So the first is, if we ever want to know how many dimensions an array has, there's actually an attribute for that, which is called ndim. So if we just do dot ndim, by the way, we access let me call that out here, is we access attributes of an object by using the syntax object dot attribute. So in this case, we have our array is our object. So it would be like i.e. array dot shape would be an attribute. Shape is an attribute of the array. Array is our object here. Okay, so that's our syntax to access different attributes. So the first attribute we're going to learn about is called indim, which gives us the number of dimensions. And so when we print that out, you can see what it's going to be. It's going to be 2. And that makes sense. It's a 2-dimensional array. Could the 2D array be, yeah, that's fine. That's fine. You could use that. That's still 2-dimensional. Yep. Okay. So the first is indim, which gives us the number. This gives us the number of dimensions, which equals 2 in this case. Okay, and that makes sense. We know it's a 2-dimensional array based on the fact that our elements are 1D lists. So we have a list of lists. It's going to be 2 dimensions. Now shape gives us the quantity. So it gives us basically the number of rows and columns. So in this case, what this is saying is we have 2 rows and 3 elements in each row. So shape is giving us an idea of how many elements we actually have, or what the shape of this matrix is. That's why it's called shape. So in this case, we have a 2D array that kind of looks like this, right? Where we have 1, 2, 3, and then in this example, 4, 2, 5. So we have 2 rows, and we have 3 columns. 2 rows and 3 columns. Hence, we get a shape of 2 by 3. Does that make sense? 2 by 3. Yes, Roberto, that should be true. Yes, that should be true. Yep. That should be true. Okay. So shape is going to be incredibly useful as we go forward because there's a lot of times where if we have an array, we actually just want to know how many rows and columns it has, which is the shape. So the shape is a good attribute to know. Does the bracket define it as a 2D versus 3D array? It's the fact that it's 2 brackets defines it as a 2D array. It has 2 brackets here. It's a list of lists. This is 2D. It can. So sorry, yes. A 2D array can have more than 2 rows. Yes. It's the fact that it has, so I meant to say that in this shape, we're going to see 2 entries. Sorry, in the shape, we're going to see 2 entries. Yeah. Let me correct that. So the dimensions will match how many entries we have here. So if we have two entries, because it's two-dimensional. That's what the truth. That's the thing that. So sorry, Roberto. I was wrong on what I told you. It is when we have 2 entries here, that's because it's 2 dimensions, not the fact that this is a 2. It's 2 entries in the shape. By the way, how can we get a third row? We could just add in another list here, right? So if we add in another list that has 3 elements, like 7, 8, 9, this is still a 2-dimensional array. But what I want you to notice is that it's going to turn into, this shape is going to turn different and this size is going to turn different, but it should still be 2D. So see how this shape went from 2x3 to 3x3? Yeah, the size is going to be the product. That's true. That's true. I was going to get to that next. What is the shape with 3 rows? It's just 3x3. Do you see that now? Mario, do you see it? It's 3x3. With this has a third row. It's now a 3x3. Yep, 3 rows. 3 rows with 3 elements each and a 2D array. Perfect. Yep. So now I want to talk about the size. The size is the total number of elements in the array. So in this case, we have 3x3, so we have 9 total elements. So this will always be the product of the shape, right? Lots of questions. Let me see. I'm trying to keep up. Yeah, you can have as many rows, columns as you want. Yep, no limitation. Do you have a real world example of a 3D array? Yeah, it's the one I gave earlier. It's like a batch of images would be, which we're going to work with images quite a bit when we get into deep learning, is a 3D array, because it is an array that has as its elements these matrices that are pixel matrices, right, of different resolutions. That's a 3D array, is a collection of images. Because these are each 2D. That's a real, so images, these are all images. Usually are in a 3D array. All the arrays in the same dimension needs to be of equal shape. Yeah, they do. So yeah, we saw that example earlier. Like if we try to change the shape, like even in a 2D sense, if we got rid of this would be an error, right? This gives us an error. We need this to match the size, right? We need this to match the size in order to build the array. Yep. Okay, do we see what size is? Size just gives us the total number of elements. Okay, total number of elements, which is really just a multiplication of the shape. There's 3 rows, 3 items in each row. So a 3x3 is 9 total elements. Okay. So that's the total number. The size is the total number of elements. Now the D type is telling us what every member's type is. So maybe not that interesting, but this is kind of the default. So this gives us what each element's data type. So we can grab, in this case, they're all integers, but they're in int64. So we can also grab how many bytes each one takes up, which is the item size attribute. This is each element's memory footprint, each element's memory size, which is going to be 8 bytes. And we can also get, if we want to, very rare we would actually need to access this, but we can actually get the memory reference for the array data. So array.data, we won't really ever need to worry about this, but this is actually really important for Pandas to be able to access later on, because everything in Pandas is built off of NumPy. It needs to manipulate the raw memory often in order to do different calculations with that data. So it typically will need access to that data attribute, but we generally will never need to know what that memory address is. Okay. Any questions about these attributes? I think the one that we'll use the most is probably going to be shape. We'll probably worry about the shape the most when we're working with NumPy arrays. But any other questions about them? Okay, perfect. Okay, let me show you a couple of functions. All elements in a CD array must have the same data type. No, they don't have to. Just like a list, they don't have to. When we're working with data, they typically will, but they don't have to. Yeah, you can have that. Try it out. Try it out for yourself. Yeah, you can definitely have that. All right, I want to show you a couple of functions we can do to manipulate the shape of an array. So the first one is we can actually reshape an array using the array.reshape function. So this is a function that we can pass in. So we can do array.reshape, and then we put in the a tuple with the new shape. So in this case, we're putting in 4,3, which is to say we want to take this existing array that is a one-dimensional array. So notice this is a 1D array, and we want to turn it into a two-dimensional array, right? That is 4 by 3. Okay, 4 by 3, meaning there should be 4 rows and 3 columns. And but first of all, let me ask you guys, do you think this is even possible? What do you think needs to be true in order to reshape this properly? What do you think? If I want to take a flat 1D array and put it into something that's 4 by 3, how many elements do I need to do that? Perfect. You guys are right on top of it. 12. Perfect. Yep. I need 12 elements. So what happens if I don't have 12? Do we think this is going to work? Yeah, let's try it. Error. And look at what the error tells us. I cannot reshape something of size 11 into shape 4 by 3. It even tells us directly we can't do that. So yes, that is definitely a prerequisite to using reshape, is that you need this total number of elements to match the number of elements that you start with. And then it will work. So if you're going to use reshape, you can reshape into any shape that you want to. So we could even reshape this into 3 by 4. That would be okay. We could do 3 by 4 because that totals up to 12. We could do 2 by 6. That would be okay. But could we do 2 by 7? No, we don't know how to reshape something that is 14 into a shape 12. We only have 12 items. 2 by 3 by 2? Sure, we could do that. That'd be a 3-dimensional. We could do that. And now we have a 3D array because we have each element is 3 by 2. And we have 2 of them. So each matrix is 3 by 2. And we have 2 of those. So we could do that. So that's what reshape does, is reshape can take an existing array and move it into a new shape, assuming that the shapes align properly. So reshape can do that for us. So that's actually incredibly useful. We'll use reshape from time to time. And then we can actually do the reverse of reshape. So we can always take something and flatten it out into a 1D array. Okay, we can always do that as well. So the flatten function can take something and put it into, so this will always give us a 1D array. So no matter what shape we start with, we can flatten it out into a 1-dimensional version of it, okay, by using the flatten function. So this does a particular reshape that will completely flatten the array. So you can see it takes this 3-dimensional array here and goes ahead and reshapes it, or basically flattens it right into this exactly flat 1-dimensional array. So flatten always returns a 1D array. Pretty straightforward. Is there any benefits? Yeah, sometimes we want to take something that is in one shape and move it into another because we're going to manipulate it. We're going to assume it has a particular shape to manipulate it. We'll see that later on when we get into deep learning, especially when we work with images or text. It's going to be important to reshape things from time to time. So maybe not this second, but when we get into deep learning, we'll go ahead and reshape. Okay, one more I want to show you, and then we'll take a break. Is that there is a transpose function. Now, what this does is it swaps rows and columns. So it transposes this into whatever was our rows. So this 1, 2, 3 now becomes the columns. And so this was a 2 by 3 matrix. It now transposes into a 3 by 2 matrix. So transpose swaps our rows and columns, and that's going to be useful down the road too for different algebra calculations we may need to do. We may need to transpose from time to time. Okay. Any questions on any of these functions? Hopefully they're not too bad. They're straightforward. They're just different reshaping. We have reshape, we have flatten, we have transpose. They just change the shape of the array. So we're going to start with doing some arithmetic operations. So just to show you guys that when you have data in NumPy arrays, you can do element-wise operations, meaning that we can do operations that go element by element, match them up, and do some type of mathematical operation between them. So things like addition, subtraction, multiplication, division, we can do those between elements. So for instance, we have these two arrays of the same size, the same shape, and we can go ahead and add them together, meaning that like this position is going to be added to this position is going to be added to this position is going to be added to this position. Okay, so when we do that, we get basically 40 in every slot because we get 30 plus 10 is 40, 20 plus 20 is 40, and 10 plus 30 is also 40. But look at the syntax of it. There's actually two different ways to do it. You can do the numpy dot add, and then you pass in A and B. So this is the this is one way to do it. One way to add is to use np.add, and then you pass in your array1 and array2. So you can do that. And so we add those two and store it in the result. And notice that the result is a same shape array, but just with each element added together from the original arrays. So that's one way to do it. The other is you could just do regular arithmetic. So you could just do a plus b. This is an alternative. Alternative is to just use standard arithmetic operations. It doesn't really matter which one you do. I've seen both. Both will result in the same kind of array. So we could store, we could do something like result equals a plus b, and then store that in the result, and then print the result. So it's same thing as before. We get the same array. So you can do either one. np.add a plus b. Either one will do that element-wise addition between the elements. Okay, pretty straightforward. We also have the same thing for subtract, multiply, and divide. So for instance, when we have these, now we have a 2D array. So this is now two-dimensional, but the same exact thing is going to happen. We're going to go through and subtract. This is going to do, this is the same as a minus b. So this takes a and subtracts b from it. So we have 30 minus 10 is 20, 40 minus 20 is 20, 60 minus 30, and then we do 50 minus 40. So we're subtracting those elements in the same positions to get a result. To get a result of this 2D array that is a result of subtracting every element from the original arrays. So again, you could do a minus b, you could do np.subtract. Either way should work. 2D plus 3D, could you do it? Well, you could try it out. So this is a 2D. We could try it out. So let's copy this guy. Let's do this guy, which is going to be a let's see. So let's do a 3D array. So let's do one of these guys. And then let's do another one, but let's just change up the numbers. So let's do 10, 15, 20, 25, 30, 45. Let's do np.subtract a and b. Let's see what we get. So we actually do get a result, and the reason we do is something called broadcasting, which is an interesting idea in NumPy. That what they do is they basically won't force the shapes to be aligned when you do a mathematical operation, but you might get some unintended consequences of doing that. For instance, we get some of these actually work where we get 30 minus 30, 40, 40, 60, 60. So we get these zeros here for this first guy. But notice that we basically take this and apply it to this. It basically takes this and subtracts to this guy secondarily. So we have 30 minus 10 is 20. And then 30 minus 15 is 15. Sorry, 40 minus 15 is 25. And so the shapes, the dimensions don't have to be the same. Dimensions don't have to be the same, but you can get unintended results. So be careful is the thing I would say. Be careful of doing the subtraction of NumPy will try to force the results to fit by taking this and applying it to this 2D matrix here. Right? So it can work. You're just going to get maybe some unintended results that don't really make sense, but are possible in NumPy. If you subtract a bigger value from smaller, it'll give you a negative. Yeah, it'll just give you a negative. So like try doing, in this example, what would happen if we put B first? You get negatives. So yeah, it's still possible. You just get negatives there. Okay. So we can take like 30 times 10, 20 times 20, 10 times 30, and we can get those multiplications. So if we do that, we get this array, which is going to be 300, 400, 300. So these are just element-wise multiplications. Again, the alternative is to do A times B, and that would be the same thing. So if we just did result equals A times B, that would be the same thing. But we can do np dot multiply to make it more explicit the operation we're doing, that it's A times B. And this is not to be confused with matrix multiplication. So that's something I should call out here, is that matrix multiplication is a different matrix multiplication is different and will be covered later. So traditional matrix multiplication will be covered later, and that requires the matrices to be compatible, and it's a completely different operation than doing element-wise multiplication. Okay, which is just A star B or asterisk B or np dot multiply. We can do division. So notice that this is again a scenario where the shapes are not the same. We have a 2D array and we're dividing it by a 1D array. Now what happens is we basically take this and divide it by this, and then take this and divide it by this and get this second row. So this size is going to basically match the larger of the two shapes. So this first shape is two-dimensional, 2D. So basically the shape of this is 2x3 shape. And this is only a basically a 1x3. Not even, it's just a 3-element shape. Because it's just a 1D array. So it's a 1D array. So therefore, when we do the division, it's going to do that broadcasting thing that I mentioned earlier and try to force this to be able to divide by this. And the way NumPy will do that is say, okay, which is the bigger shape? This is the bigger shape because it has more dimensions. Try to take this and divide it by these guys. What do you think is going to happen if we reduce this size? If we did this, do you think this would work? If I reduce this down to only having 2 elements, do you think this division would work? We could try it. Error. It doesn't broadcast that way. No. So you could even see it even says it tries to broadcast, but it doesn't know how to. So even with broadcasting, the shapes still need to align to some degree. So this still needs to be like it needs to be a valid shape to be able to broadcast to each one of these dimensions here. Let's try it. Yes, we can divide B by A. We're just going to take, now this again is going to try to match the shape and just do this divided by this divided by this. But remember that A divided by B is not the same as B divided by A. They're not the same result. Yeah, you can get a division by, so try making one of these zeros. So try, let's say this was all zeros and we did A divided by B. Do you think that'll work? Do you think this will work? Yeah, it basically, now it technically returns a result, but they're all infinity. Yeah, it basically says that we have a warning we cannot divide by zero. So it basically says that sure you could do it, but you're going to get infinities all over the place, and it's not you get a warning that you're dividing by zero. So it's kind of like an error there. Okay. All right. So let's go to doing exponents. So we can do element-wise exponents where every element in A is raised to a power of something in B. So for instance, we like 2 squared, we do 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th. And you can see what each one of those would be is this. So this just does every element in A, each element in A gets raised to the exponent of the corresponding element in B. So we get 2 squared, as I said, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th. That may be useful from time to time. We may have a reason to take elements from one list and exponentiate them from another list. So there's a power function here to do that. So that may be useful. Before we move on to the statistics functions, which are going to be really interesting, any questions about the arithmetic? Are they kind of straightforward? It kind of makes sense in terms of the arrays. Any questions on them? Hopefully they're very much like just regular arithmetic. They're not too bad, hopefully. Can you build arrays from set of arrays? You mean like a Python set? Oh yeah, you can. Yeah, you can build arrays from arrays. Yeah. We haven't done that yet, but I think that's coming up shortly. Yes, but you can. Yeah. Yeah, it's not too hard to do that. So In fact, I can just show you a quick example of that. So we could call a NumPy array from an existing. So we could have inside of a list, we could have np.array, and then we could have 1, 2, 3, and then we could have an np.array, and then we could have 4, 5, 6. So this should make. So if we let me display X. So this makes a 2D array. Does this make sense? Like I'm defining an array as the input elements to build an array. So yeah, you absolutely can do that. To build a new one. Yep. Okay. Good question. Any others before we go on to the statistics functions? All right. So what's great about NumPy is with the arrays, it can easily do statistics on arrays. So it can find the medians, it can find the average, it can find the standard deviation, it can find the variance. Now I know we haven't technically defined what each of those are, but that's okay. It's useful to know that given the different statistical functions that we may want to do, NumPy can easily compute them on collections of data, collections of arrays, right? Or data that's inside of an array. So for instance, if we have this 2D array here, we can compute the median of all elements in the array, which would be np.median. So there's a built-in function from NumPy, np.median. So we can do np.median finds the median of an array. Okay, so this will calculate the median. So if you're, again, we will get to what the median is later on in our statistics overview later on, but the median is kind of the 50th percentile, like the middle element, right? The middle element of we basically order it from least to greatest and find that middle element. So in this case, the middle element is 4 out of all these elements that we have. Okay, np.median. We can take the average, which is the mean. So that's very nice. We can take the average. So we can do np.mean, which will take the average of this array. So it'll average all the elements together, and we get an average of 6.3333. So that's very convenient for us that we can compute an average of an array. I want you to, now this seems really straightforward, but I want you to see how powerful this is that lists, for example, do not have this ability. There is no built-in mean function for a list. So that's why this is so useful that NumPy has this ability, and it's really optimized. It's really fast to find the mean, really fast to find the median. It's a really optimized function to do it. If we wanted to find the average, we would have to do it manually on a list. We'd have to total up all the elements and divide by the size of the list. Not that that's hard to do, but it is something manual that we would have to define. It does not automatically exist like what we see here with np.mean as a simple function that we can apply. And we can apply it to NumPy arrays very easily to compute the average. So same thing with standard deviation and variance. Those are more advanced statistical functions that figure out the spread of the data away from the average. Again, we're going to learn about these later on, but np.std does the standard deviation, and then var does the variance. So, and really the standard deviation is the square root of the variance. So if you took this variance, sorry, if you took the standard deviation and just raised it to the second power, you would get the variance. But you can compute them separately this way. Okay. So pretty convenient that NumPy provides those statistical operations. We're going to be using these quite a bit especially when we do like exploration of our data and we want to find an average, we want to find what the standard deviation is. This is going to be really useful to use the NumPy function to compute that on an array of data. Okay, really useful. All right, any questions about these guys? I mean, they're pretty straightforward, but I know we haven't defined exactly what these are. We will later. So no worries if you're wondering exactly how to calculate these. We'll talk about that later, but any question about the NumPy functions themselves? Okay. Very good, very good. Okay. Let's talk about percentile then. So NumPy also has a percentile function. So we can take an array and compute the 50th percentile, which would be the median. Again, we haven't learned what a percentile is, but if you think about ordering all the elements and figuring out like the median is at the 50th percentile, and then half the data is below that. So there's a point where like 25% of the data is below this certain value, and then 75% of the data is below this certain value, or 95% of the data is below this value. So the percentile is something that ranges between 0 to 100 we can take. So like the 99th percentile means that most, like 99% of the data is below this certain value. Okay, so like 99th percentile means that 99% of the data falls below that value if we ordered it and kind of sorted it that way. So we can compute any percentile we want by just passing in the array and then giving it a number between 0 to 100. Okay, so and this should be a whole number, 0 to 100. So for instance, we can compute the 99 percentile. Oops, I have to actually run this. Let me run that. There we go. So 99% of the values are below 22.8, which kind of makes sense because most numbers are pretty low. So there's really only one number below that number, which is the 24. So if I did the 100th percentile, that would basically be the max, right? Basically be that 24. So only 100% of the numbers are below the max. So it kind of makes sense. And then if I did the 50th percentile, that would be the median. Half the values are below that, half are above. So that matches the median that we found here, which was 4. Okay, so we can do percentile. Any questions about percentile? Okay. All right, finally, wanted to mention that NumPy, you can manipulate strings in NumPy. Now, this is less often used because typically when we're working with NumPy data, we typically don't have strings inside of there. We usually are dealing with numerical data, hence why it's called numerical Python NumPy. But it is possible to work with strings and do different string manipulations. For instance, if we have a NumPy array that has 2 strings hello world, and then another array that has welcome learners, so these are 2 1D arrays, we can actually concatenate element-wise strings by using the np.character module. And instead of doing the reason it's inside of the character module is instead of doing like a numerical addition, so typical arithmetic, it's doing a string addition, which is concatenation. So it's doing character addition here, which will concatenate these two strings, hello and welcome. So those end up merged together, concatenated together, and then world learners get concatenated together. So this is a string concatenation, element-wise string concatenation. So it's from the np.char or character module within NumPy. Okay. Very rare. It's very rare we would have to do this, but I'm just pointing this out that it does exist. Okay. If for some reason we need to manipulate strings, we will have that ability too. Okay. All right. So then we can replace substrings with new strings. So if we have this original string called hello, how are you? We can print it out and we can replace, we can use a character replacement to replace within this string, replace hello with hi. So once we do that, we can print out the new string. So then we get hi, how are you as the new string. So this does a string replacement if we can find the substring. So if hello exists, so we should test this out and see like, is there something, so we could just put in something that doesn't exist in there. You know, it's not going to be replaced. So if this is saying, okay, let's try to do a replacement of this string. Let's replace something with hi, but something doesn't exist. So it's just going to return to us. It's not going to replace anything. It's just going to return to us the original string. But this does exist. So that's going to be replaced with hi. I'm going to do a string replacement if we want to. We can also manipulate strings to do uppercase everything, lowercase everything. You can see how those, like this is all lowercase, but we do dot upper, pass in the string, it will uppercase everything. This is all uppercase, we can lowercase everything. You can see how that all works. Okay. Again, very rare we would ever need to manipulate strings, but if we did, there's this character module that can help us manipulate strings. Very rare that we would need to because most of our data is going to be numerical inside of an NumPy array. All right. Any questions there? All right, so just to recap, we have our arithmetic operations, basic arithmetic between NumPy arrays we can do, pretty straightforward. We can even use our standard, we can use NP add or we can use A plus B, NP subtract, A minus B, multiply, divide. We can all use those basic arithmetic operations. We also have a power function, which will raise things to exponents. These incredibly useful. We'll use these all the time going forward are the statistical functions like average, standard deviation, variance, median. We'll be able to compute really easily on an array. Okay. All right. So let's go to our next notebook and continue working with NumPy. So go to the 3.04 notebook. All right, now the whole point of this one is to practice accessing data within the notebook, or sorry, within the NumPy array. And truly, this is going to be great because it's going to work exactly the same as a list. We're going to be able to access elements by their position and also slice, just as we did with lists, right? So everything's going to work the same. which is going to be really nice. The one unique difference is that with NumPy arrays, we can have multiple dimensions. So that's where we need to actually be careful, is that if we want to access elements that are in different shapes, like they're in second row, third column position, how do we do that? And it's actually going to be really easy to do if we just think about it as kind of a coordinate of passing in like an index as if it was a coordinate of this is exactly what I want to access. Okay. All right. So if you take a look at this picture, this is a really great picture to break down a 2D NumPy array. So imagine we had a 2D NumPy array whose shape was 2 rows by 3 columns. So it's a 2 by 3 shape. All right. And we have elements 1, 2, 3, and 4, 5, 6 in our array. So we have 2 rows. Each row has 3 elements. Okay, so a 2 by 3 shape. Now, the element that is right here is at index 0 because it is at the first row. So it's at index 0 in terms of the row, right? So there's 2 rows. So it's either going to be index 0 or index 1 for the row coordinate. So it's at index 0 for the row. But which column is it in? It's in the first column. So it is at index 0 for the column. So this coordinate for this guy would be like if we passed in 0, 0 as the index, right? So if we passed in 0, 0 as our index, we could access that element right there, because what this is signaling is we are at row 0 and we are at column 0. Column 0. Okay. So with multi-dimensional arrays, we have to be careful about that, is that things can be accessed by their coordinate now, their index coordinate, rather than just a single index like we saw with list, right? With a list, it was just, okay, we can grab something at index 0, index 1, index 2, maybe index -1. But with a 2D array, we're actually grabbing things at their coordinate, right? So row 0, column 0 this should give me the element 1, which is this guy, right? If I were to access that element. All right. So let's try accessing. So let's take a look at this guy. This guy is now going to be at same row. So this guy is still going to be at row 0, but it's going to now be at column 1, right? So it's now here, column 1. So we should be able to access that 2 sitting at row 0, column 1 index. So this should equal 2, right? This item should be that element 2. Okay. And then lastly, from the same example, we have this 3. This 3 we should be able to get from, we're still within row 0, but we're now at column index 2. And this should equal 3. Okay, so in a 2D array, this first entry is what row we want to go to. So imagine like scanning over this grid. What row do we want to go to? Okay, row 0, that's the first row. What column do we want to go to? Okay, column 2, that's the last column. That's the third column here. Let me ask you guys, does that make sense in terms of thinking about it like a grid and a coordinate of how we access elements? Any questions on that? Are the I and J just random? No. Like in this example, it's random. It's just a 2 by 3. But they represent how many rows and columns we have, right? So I represents how many rows we have. J represents how many columns we have. Oh, sure. Yeah, yeah. They could be any letters. Yeah. No, we're just using I and J because that's the traditional indices for row and column, I and J. That's just kind of like a tradition to do that. But yeah, they could be you could use any letters there. Yeah. Yeah, no worries. Yeah, that's just the it's kind of the tradition there. Okay, so let's see how this works inside of code. So if we let's create some arrays. All right, so let's create some arrays to practice with. So we create a 1D array, we create a 2D array, and we're going to create a 3D array so we can practice accessing certain elements. So if we look at the 1D array, this behaves exactly like a list. In fact, I'm going to write that down. This behaves just like a list, the 1D array. We can access like the third element or the first element, or, in this case, we're accessing the fourth element, which is at index 3, and that returns to us the 4. So we're doing that just like a list. In fact, we can also do the very last element, which would be at the -1 index, and that is the 6. So it behaves, a 1D array behaves exactly like a list, not much different in terms of accessing the elements there. We don't need to worry about coordinates because there's no rows and columns. It's just a single, it's basically like a list, right? Very easy to access things. Okay. So, and for instance, we can add two elements from these positions together. This adds the position 1 and position 0 elements together, and so that ends up being 3. And we can see that because that is 2 plus 1, which is 3. So pretty easy to do. All right. So here is that exact. Here's another picture of everything we just drew earlier, where we're thinking of the elements at these positions as coordinates, right? So the element right here in the first row, first column is at coordinate 0, 0. And then the element right here is at coordinate 0, 1, 0, 2. And then if we go down to the next row, this element would be at row 1, column 0 index, row 1, column 1 index, row 1, column 2, on and on and on, however many rows and columns we have. So we think of accessing elements that way by their row and column index in a 2D array. All right. So for example, let's get the element that's in the first row. So this should be the first row because that is index 0. And this should be the third column. This should be the third column, right? Is the index 2. So if we go back to our 2D array, it should be the first row, which is this guy. And then the third column, it should be a 3. And it is, right? So if we print that out, we get a 3. How do we feel about that example? Do we see how we're accessing it from inside these brackets, just like we would a list, but now it's a coordinate? Do you see that one? Good? Okay. And we also have, now we can grab something from the second row and from the second row, and this, because this is now 1 and this is now the second column, So if we go back to our array, second row, second column should be this guy here, right? Second row is this guy, second column is this guy, so this should be the 5, which it is. We print that out, we get the 5. Okay, that's what that coordinate represents. Second row, second column. All right. Very good. I want to take a look at a 3D array now, which is going to be a little interesting in that we're just going to add an extra coordinate to the mix. So with the 3D array, we basically need to know which matrix are we talking about. So remember, a 3D array is going to look like this. We basically have rows and columns, row, column, row, column, row, column. We basically have an array of matrices as our 3D array. So the first coordinate is going to say, which matrix are we at? Are we at this one? Are we at this one? Are we at this one? Roberto, I'm just having a little trouble with the comments. If we already know the value we're looking for, then why do we need to use the coordinates? Yeah, so it's because we need to get familiar with how to access different elements of our data. For instance, like maybe we need to access only that last row or maybe only that last column in a collection of data, which we're going to see. We're going to practice slicing coming up in a minute. So yeah, we're going to need to be able to access entire collections of data within like within a matrix. So it's going to be important. It's going to be important to be able to grab that collection of data from a large data set. Yeah. So it seems I think I see what you're saying. Is it kind of seems like redundant to do that right now when we can clearly see exactly what value it is. But in a large data set, it wouldn't be that obvious, and we need a programmatic way to select those contents. Okay. All right. So in the 3D example, what I wanted us to see though is that notice that like the first coordinate is going to say, are we talking about this matrix or are we talking about this matrix? So we're actually going to have 3 coordinates. So this first coordinate is relating to which matrix are we talking about? And then once we know what this is, like this 0 would say, okay, we're talking about this first matrix. Then it's the same as usual with these two coordinates here are now what row and column within that matrix are we talking about? Okay, so with 3D, that first coordinate is which matrix is it? Is it the first, the second, the third, the fourth? Because remember, in a 3D array, every element is a matrix. Every element is a 2D array. So the first coordinate is saying, which matrix are we talking about? All right. And then once we know which matrix it is, we can use the next 2 coordinates to figure out what row and column of that matrix are we talking about. So let's see an example. So look at how this 3D has 3 elements. So if we break this down, this is saying that we want to access within the second matrix. That's what this first coordinate is saying. Within the second matrix, I want to access the element that's at row 0, column 0. Right? This is the second matrix. Second matrix. So in the setup, it's like we have a matrix here, we have a matrix here, we have a matrix. Actually, we only have 2 in our example. So this element means we want to look at that second matrix. And we want to grab the element that's at coordinate 0, comma 0. So let's go back to our matrix and see what that should be. So what is the second matrix? It's this guy. This is the second matrix that is within our array. And then we want to access row 0, column 0. That should be this. It should be this 7, right? So row 0, column 0 of that second matrix should be that 7. And that's exactly what we get if we print out this this coordinate. We get 7. Matrix refers to row? Kind of, yeah. It's because in a 3D array, every element is a matrix. Is a 2D matrix, right? Okay. All right. How do we feel about this three-dimensional indexing? Does that make sense? This is matrix. This is the second matrix, and then this is row 0, column 0 of that second matrix. Good. Okay. All right. Finally, I want to mention that we could do negative indexing for all of this, right? So that still applies. Like if we did -3, that would be, third from the last. So if we go back to our 1D array, we could do -1, we could do -3. So -1, -2, -3 should be the 4 here. So we can still use our negative indexing as we would with any list. So that does not change. We can still use minus indexing. We can even use it in the 2D array. So if you imagine there, this is now in terms of the column, because now this is saying in a 2D array, we want to grab the element that's in the second row, but in the last column. That's what the -1 would mean in this case. Second row, but the last column, because we have a -1 index there. So second row, last column, let's go verify that's a 6. So second row, last column would be this guy. Yep, that would be a 6, right? Because this is our second row, and this is our last column is a 6. So that's a nice thing. That's a convenient thing. We don't need to know exactly how many rows there are. If we just want to grab the last one, it's just a -1. So this is second row, last column. And then if you look at the 3D example, we have in our second matrix, the second row, last column again. So we can grab that. So that should be second matrix, but then the second row and last column. So second matrix would be this guy. Second row is here, and then last column would be the 12. Right, so there it is. There's that coordinate. Gets us to the 12. All right. Okay. Any questions on accessing elements? Any other questions about this stuff? By the way, there's some extra practice for you guys, so give this a chance. I encourage you guys as kind of homework for next time to try out this practice, extra practice here that's at the end of this notebook. So it just has you go and create some arrays and do some indexing. So go ahead and try that out on your own. Let me know what you think. Can everyone see this okay? Should be at the 4.01 notebook. Thank you guys. Thank you. All right. And then hopefully you guys have this notebook too, and are able to follow along. So as I said, we're getting into our fundamental data structures here for working with data science and eventually machine learning. And Pandas is going to be really crucial for us because it contains two really critical structures, the series and the data frame. So I wanted to take time at the beginning to review what those two data structures are, and their use cases. And then we'll spend the rest of today going through a bunch of notebooks to get some familiarity with those things like series and data frame. So we'll be doing a bunch of examples of different manipulations and different ways to work with data inside of series, inside of data frame. So we'll be covering the ins and outs of that, as well as some other features of Pandas that we'll use along the way from every now and again. So that'll be all of the beginning of today will be Pandas. If we have enough time, we'll get into lesson 5, which will be around visualization. So we'll start going into, doing things like plotting and using libraries like Matplotlib and Seaborn and those. But mainly want to focus today around Pandas as a really fundamental Python library for us doing anything with data. All right. So where we had left off last week was that I told you guys Pandas was going to be really important for us, and had mentioned that it had these two primary data structures that we will use all the time, which are the series and the data frame. So just to review that, the series is essentially a fancy NumPy array. It has a NumPy array that underlies the series that contains the actual data. So you think of it as kind of a one-dimensional array. What's special about a series, though, is that it also has an index to it that can be customized. So it doesn't have to be just a standard like positional index like what we've seen with arrays. They have natural order to them. They have a 0, 1, 2, 3, 4th, 5th element. We can actually have a custom index that could be a string, it could be a date, could be really any object we want it to be. So that's what makes a series kind of special, is it has the array of data, but with a custom index, which is useful in different situations to customize that, as we will see. Now, a data frame just takes that into a second dimension. So if you think about a series as being kind of I would think the best example of a series is kind of like a column in a table or a column in like an Excel spreadsheet. Okay, that's probably the best example of a series. It's got a single column has just a bunch of data. It has a bunch of data, and it can have like a row label like you see in Excel, right? So every entry can be labeled coming from row A, row B, row C, row D, etc. That's a series, but a data frame is really the whole table. So a data frame is basically a collection of series that a data frame has rows and columns to it. So it's got a bunch of different series. We think of it as kind of a two-dimensional array. Data frame is going to be incredibly useful for us because nearly all the data we work with that has structure to it, especially in machine learning, will be in the form of a data frame. We'll put it into a data frame, we'll manipulate it as a data frame because it will have rows and columns to it. Those columns will represent different attributes of the data. So think of an Excel spreadsheet as that example, right? You have different columns that represent different things. Maybe if you're thinking about a bunch of data that represents different houses, every row is an example of a house, and every column is a different feature of that house, like the number of bedrooms, number of bathrooms, the price, those kind of things. So if I had to draw a picture of these two guys, again, the series is kind of a single array. I think of it like a column, and those entries are inside of the series, and it does support different data types, including different objects. So I see your question, Tim. Yeah, a series can hold different objects. Can it hold a function? In theory, it could. I haven't really seen that, but I don't see why it couldn't use a function inside of there. But yeah, like generally it can hold objects, like any object, which everything in Python is an object. So yeah, haven't really seen a use case for it, but I'm sure that it could. But anyways, the series is going to be this one-dimensional array, and then it's going to have an index like A, B, C, D, etc. That's fully customizable. So it doesn't have to be the standard kind of positional index. Could be fully customizable. Now, that's the one-dimensional, that's the series. And then if you extend that into 2 dimensions, you have a data frame, which is going to be kind of an entire table. So it's going to be many series kind of stacked like this, and you have rows and columns. So, and then you may have, just like in Excel, you can have an index here like A, B, C, D, etc. as the index. Okay, so series is one-dimensional, data frame, 2-dimensional rows and columns. Okay. All right. So that being said, let's start with the series and then we'll work our way up to extending that into 2 dimensions. So we're going to start by looking at the series. So in general, as I said, a series is going to have, it's going to have data, which is going to be that one-dimensional array of data, and it's going to have an index. So, and again, that index can be fully customizable. It can be by default just the standard positional index. So just like we would see in a list or in a NumPy array, it would be 0, 1, 2, 3, just like you see in this little picture right here. This would be kind of the standard like positional index of the series. And then this is your data here. That is the underlying data of the series. What's really nice about Pandas is it actually builds on top of NumPy. So this underlying data is actually stored by Pandas as a NumPy array. And so because of that, series kind of inherit all the nice properties of NumPy arrays in the sense that they can do all the same arithmetic. They can be manipulated in a lot of the same ways. They have a lot of the same attributes, like a shape and a reshape function and a transpose and all these things. So that's really nice about really series and data frames. The underlying data is all built on top of NumPy, which is nice. So you can create a series out of a list. You can create it out of a NumPy array. You can make a series out of a tuple. You can make a series out of a lot of different data. It's just that one-dimensional array that has that special kind of index to it that we could customize. So we're going to see different examples of building a series and manipulating a series. The other thing I should mention is that there's no restriction to the kind of data that the series can hold. So it can hold objects, it can hold strings, it can hold integers, floats, really all of those. And it can even be mixed. So just like in a list, we would see, we can have strings, we can have floats, we can have those kind of things. All right, so let me show you an example. And the first place we'll start is by importing Pandas. And this is just like we did with NumPy. Remember, all of our NumPy examples had import NumPy as MP. All of our examples here with Pandas are going to be import Pandas as PD. This is something we're going to get super used to as we go along, is the fact that we see PD, that instantly should tell us we're using Pandas. That's the industry standard. So industry standard alias for Pandas is PD. So if you're reading some code and you come across a PD, that is just short for Pandas, and that's the standard in the industry. So everyone would understand you if you were using PD there. So we import Pandas as PD. Look how easy it is to make a series. We just start with a list. So we just have a regular list of 1, 2, 3, 4, 5, just those 5 numbers. and we create a series by doing pd.series, and we pass in that data as an argument to the pd.series function. This constructs a series, and we store this as a series object. So what's interesting about this is when you first create the series, if you don't specify an index, so if you don't specify the index, Pandas uses the default positional index. So it just assumes that the data is going to be indexed by position. So that's just, this 1 would be at the 0 index, this 2 would be at the 1 index, this 3 would be at the 2 index, and on and on. So it's just the standard, just like we learned how to slice, so we learn how to access elements by their index. That's all we would need to do to access these items of the series. So that's if you don't specify an index. But I want you to see this example here where we use the same data, but now we actually customize the index to be, special labels for every item. So for instance, 1 would be indexed with A, 2 would be indexed with B, 3 would be indexed with C, and so on. So the way we do that is when we create the series, we actually explicitly pass in an index array, which signals that these elements are going to, all of this data is going to be indexed by this specific index. And then why that's relevant is because when you print out this series, you can access things. Look at how down here we actually access things according to this B index. Or obviously we could pass in a C or a D or an E, and that's how we would access things. Okay. But in the series that does not have that just has the default index, notice that we can access things by this numerical just positional index. So we could access the first thing, we could access the second thing, and then this would access the third thing, which is at index 2. Okay. So, and by the way, you can combine these. So you might be wondering, well, we have some data and we have an index. Why don't we just map those two together? And we can. So if we use a dictionary, we can actually combine those two together and say, okay, A should map to 1, B should map to 2, C should map to 3, D should map to 4, and E should map to 5. And we can create a series from this dictionary. You can actually build a series from a dictionary, and what this will do is it will treat all the keys as the index values, and it will treat all the things that they map to, the values, right, will be the data. That'll just be the data, right? All of these 1, 2, 3, 4, 5 will be the data, and this E, D, C, B, A will be the index. Okay, so when you do this, when you use a dictionary, keys become the index, and values become the data. Does that make sense when we're creating a series? Any questions on that? We can use a dictionary. We can just use a regular list. You can also use a NumPy array. It doesn't have to be a list. You can use a regular NumPy array to create a series. So all the code here is just creating a series. Nothing that interesting going on so far, just creating a series. And I want you to see, if we were to print out, I'm going to add this in here, just one little cell below this. I'm going to print out the series so you can see it. Let's print the series. You can see that it's going to have, notice how the series prints out with kind of 2 columns. This is indicating that this is the index, 0, 1, 2, 3, 4, right? It's the positional index of this regular series. And then here's the data, the 1, 2, 3, 4, 5. Okay. So you see both of those. Let's print out this series with index. And let's print that guy out. And you can see now that the index is A, B, C, D, E. That should make sense. This is kind of like an Excel column, isn't it? Because Excel, if you're familiar with those spreadsheets or even in Google Sheets, right? Every row has this index A, B, C. Like you're dealing with cells that are in row A, B, C, D, and on, right? Let's take a look at a series with dictionary. This should be series from dictionary. And we get the same thing, the A, B, C, D, E, 1, 2, 3, 4, 5. What is the difference between dictionary and series? Well, a series is a different object. A series is a pandas object, and therefore it has certain functions available to it, like finding an average, plotting, finding a mean, or sorry, finding a median. Like it has a lot of built-in functionality as a series that you don't get as a plain dictionary. Does that make sense? Like you get a lot of, we're going to see this in pandas, you get a lot of functionality if you're a series. You get a bunch of statistical functions that can be easily ran. You get you can do a bunch of summarization on that data. You can do plotting against that data relatively quickly as a series versus as a plain dictionary. It would be object. Try it out. So try it out. If we did, so let's say we did a string inside of here. So let's make that 3 a string. So we have integers and strings. Let's now print this out. They basically, do you see how they're all objects, which means that Pandas would actually convert everything to a string. Once it sees one string, it's going to treat all of these as a string. So if you see a data type as object, that likely means everything is a string, because string is technically an object. Yeah. So we can convert that back to an integer, rerun that, it goes back to an integer. Okay. Okay. All right, let's see what we get. So I think it's a valid question. What's the difference between a dictionary and a series? Because it's getting at like what do we get by having a series that we wouldn't have if we just had the dictionary? And it turns out that we get a lot of different functionality out of the series that we wouldn't otherwise have. So we're going to see some of those functions. The first couple of functions I want you to take a look at are right here, which are the head and tail functions. So what these do is they give you a view, or essentially a copy of the first n rows. So whatever value you put in here, you'll get those first few entries. Head goes from the top, so it goes from the beginning of the series and does the first however many rows. So if you don't put a value in there and you just have this, the default is 5. The default is the first 5 entries. Okay, if you don't put anything in there, you could put a value in there like 10 and you'll see the first 10, right? Or you want to see the first 3, you put in a 3. So head gives you that copy of the first 3 elements, and tail gives you, on the reverse end, it gives you kind of that slice. Think of it as like a shorthand for a slice. It gives you a slice of those last 5 guys. So this is almost like this is similar to doing series, and then we were to slice out the like last 5 entries. Think of it like doing something like that. And then this is similar to series, and then we do the first 5 like that. Okay, so head and tail very interesting functions that actually we will use quite a bit with data frames, particularly to just get a quick view of the first 5 rows and last 5 rows with the tail. So if we were to run this, we could print out that. So we could print out the first n rows, and we get the first 5 entries, right? We could actually do the first 2, and that would just give us the top 2, right? From the top. Now we could print out the last 2, let's say. So print last n rows, and this does the last 2, right? All right, so head and tail, pretty straightforward. They give you the first, either from the beginning, first 2, or from the end, the last 2. Series have a shape to them, which makes sense because the underlying data is a NumPy array, which also has a shape. Now let me show you what the shape is. Let's print the dimensions. Print that, and let me comment that out. So as you can see, this series only has 5 elements, and it's basically one-dimensional. So even though it has an index, it is one-dimensional. It doesn't have rows and columns. It basically only has rows, as 5 rows of data. It's just a single column, essentially, right? It doesn't have multiple columns, so we just say it has a shape of 5. It's just one-dimensional data, right? So a series is always 1D, one-dimensional. Okay, it's always one-dimensional. All right. Now let me show you a really awesome function called describe. Now this is a cool function to give you a bunch of the statistics, basically give you a summary, a descriptive summary of your data. So when you have, this is the advantage to having your data in a series, is you can easily run a describe function and see how it's series.describe. What this is going to do is give us a quick descriptive statistical summary of our data. So it's going to print out the mean, max, min, median, and then like various percentiles of the data. So it's going to give us that quick view of all those statistics, which is really nice. So let's see that. So if we print out the stats, we can see everything that gets produced. So you can see here we get this summary. This is our descriptive summary. We get a count of how many values are in the series. We know that there's only 5 because we created it with only 5. That makes sense. The average is 3. That also makes sense. Just the numbers 1 through 5. So the average is 3. The standard deviation is 1.58. The minimum is 1. 25th percentile is a 2. The median, which is the 50th percentile, is 3. That makes sense. The 75th percentile is 4. Also makes sense. And the maximum is 5. That makes sense, right? It's just 1, 2, 3, 4, 5 is our data. But that's extremely useful, right? To get that quick, you just run one function, you get all this summary of the various stats of that data. Is pretty useful. And it's actually going to be incredibly useful to do when we have data frames. The describe is going to be something we'll use quite a bit on an entire collection of series in the data frame. Any questions on the describe? Does that make sense what it's doing? It's taking our series data and just doing a bunch of statistics on it. So we get things like the max, the min, the average, the median, all of those get produced on that series of data. Pretty convenient. Can we get the median alone? Yeah, we can do, remember how we had the np.median function? We can do that. So if you just wanted the median, you could do, there's 2 ways to do it. You could do series.median, like that, or you can do np.median and pass in the series. You could do it either way. If you just want the median, you want to compute the median. Right? So we can't forget that. The underlying data is a NumPy array, so this function is compatible with the series. All right. Okay. So if we want to get all of the unique values of the series, we can run this unique function, which will give us all the unique values that exist within the series. So if we print this out, this should be the values 1 through 5 because we don't have any duplicates. They're all unique, right? So this should just give us all of those values. Clear that out, and it does, right? So 1, 2, 3, 4, 5. This basically gives us a list or an array essentially of all of the unique values. If we run the unique function on the series, that's another advantage, right? If your data is in a series, you can quickly get all the unique values. If it's in a dictionary, that might be harder to do. Might be harder to kind of sort through it and try to deduplicate it. So unique. We can also get the number of unique. So if we just stick an N right in front of that unique, N unique gives us a count. So this should be 5. This should tell us how many unique values there are. We should be able to print this out and see that there are 5 total unique values, right? Just the numbers 1, 2, 3, 4, 5. Pretty straightforward. Any questions on those functions? We're going to use these more and more. I would say head and tail we're going to use quite a bit, especially with data frames. And what's nice is these functions on a series actually carry over to data frames one-to-one. So the head function, the tail function, the shape, describe, unique, and unique, these will all carry over to data frames pretty easily. So data frames are going to be those multi-dimensional, two-dimensional data structure that we will extend our knowledge into after we cover series. Any questions on these functions? Good. Okay. Fantastic. So we can keep going then. So just like with NumPy arrays, we can do arithmetic with series. So we can add series, we can subtract series. The catch being that it can be tricky to do arithmetic with series when they do not have the same index. Let's see how that plays out. So these series have different indices. Remember, this series was built with the default index with 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4 as the indices. And this one was built with the indices that have the character indices, right? A, B, C, D, E. So it might be a question of like, what actually happens if we add those series together? Like the data, if we were just looking at the data arrays, those make sense to add together because they're just arrays that are the same shape. So it makes sense to add their elements together, and that should be a very natural thing. The question is, what happens with their indices? So let's see what we get. Let's print that out. So it turns out that Pandas doesn't know what to do with that because they don't have the same indices. So this is just a warning that you can add together series that have the same indices, no problem, and the resulting data is just going to have that same index as the first two. But when you add together, these have different indices. So just to give a warning here, we have a warning. These series have different indices. We can't add them together. Okay, we can't really add them. Now we don't get an error, but we basically get an undefined result, right? We don't know how to add things together because, and look at what the new index is. It thinks it's adding them two together. We get 0, 1, 2, 3, 4, and then A, B, C, D, E. It's just a mess, right? It's just a mess. It doesn't really make sense to do. So if you're adding series together, or doing arithmetic in general, multiplying, subtracting, all those NumPy arithmetic operations we learned last week, you can do them as long as they share the same index. Yes, the order matters. Yeah, for sure. The index order matters because that dictates the position of elements. Right? The relative position of elements is determined by the index. Okay. Now I want to show you something really cool as well, which is the ability to basically apply a function to every element of the series. So if we have a series, we can manipulate every element of it at once by using a special function called apply. So apply does exactly what it sounds like. It applies a function to every single element. So the input to apply is going to be a function. So this is where the input, or I should say the argument to the apply function is a function. And we have a special function here that we have not seen before called a lambda function. So we haven't seen this before. What this is, this notation here actually is declaring a function. Lambda declares a function without having to use def. So it's a shorthand in Python to define a function on one line of code. And what it means is this is defining a function very similar to def, and it's saying we have a function that has one argument, and we take that argument and square it. So that's a function. It's saying take whatever argument is input to this function and square it. So what that means is on this series, we're going to take every element, because those are the arguments to this apply, and we're going to square them. So that's what this means. So this has the effect of squaring each element, because it's star 2, remember, is the second power. So this will square each element. That's what apply means, is apply some function to every single element. And this is we're defining a function here to say, take every argument and square it. That's what that function is. Now, do we have to do it that way? No. The alternative to doing this is if we quickly came up here and said, let's define a function called square, where we take any x and we return x star 2. That's a function really easily, right? That's a function that squares the arguments. And so instead of doing this, we could alternatively do the same exact thing, but instead of passing in this lambda, we could pass in our square function there. Okay, which says we should be taking the elements of x and the elements of the array, the series, and we should be squaring them. This is the same thing. This is the same as above. It's the same thing as doing this. Lambda is just a shorthand for just doing def and returning this argument. This is your argument to the def, and this is what you're doing to that argument. You're squaring it. Does that make sense on the lambda? That this is equivalent to, this is exactly equivalent to this lambda. Exactly equivalent to that lambda is just a shorthand for this function. Yes, Roberto. Yeah, it's shorthand. So lambda notation is you declare lambda as a keyword, and then you write down your argument. And you can actually have more than one argument. So you could do x, comma, y, comma, z if you have 3 arguments, let's say. In the series, we only have one argument, which is every element. That's the intention, is to apply this function to every element. So there's only ever going to be one argument. So we have one argument, and then we have a colon, and then we have our math to say, what are we going to do with the argument to return? So the colon is like shorthand for returned. Lambda is like shorthand for def. So yeah, it's always def returned. Okay. And we always, so the other thing I don't want to, the other thing I don't want to get away from either is this notion of apply. This is a really powerful idea. This is a nice shorthand to say, I want to take every single element of this series, and there could be millions of them. There could be millions of these elements. I want to take every single element and apply some function to every single element. And this is the way to do it. So apply is really powerful. We're actually going to use apply quite a bit as we move along and work with data frames. Apply will be really useful to apply a function to every column or specific columns that we want to transform. We will use apply. Any questions about apply or the input to apply? Remember, the input to apply is a function. Whether you define the function like this, traditionally like a function, or you use a shorthand lambda, either way, those are functions. Okay. Let's make sure this works. Let's print out, so let's print out the squared series. Let's do both. Let's do the lambda version first. Let's uncomment that. Do the. I don't see the version in your contacts. Who do you want? Let's do this. Oh, I forgot to put this. Okay. So see how this, let me comment this out so we don't try to print that out again. Rerun that. Okay, so see how it ended up squaring everything? So there we took the apply and gave it the lambda function and ended up squaring every element all at once. So everything gets squared. And again, like we could do it this way. Alternatively, we could run it this way, and it should work the same. There it goes. So the same result, whether we use the traditional def function definition or we use a lambda, either way, get the same thing. Okay. Cool. So no questions on apply. We will use apply quite a bit whenever we want to make sure to transform all elements of a series. Remember, in the apply, every element of the series is going to be applied to this function. Or I should say this function is going to be applied to every element of the series. So apply will transform everything in that series according to this function. Now, the kind of the more targeted way to replace values is the series.map. So this is a little less, this is basically more targeted than apply. More targeted than apply. It's a replacement of values within the series. So essentially what we're doing here is we're going to take our series and replace this data with this data here. Replace this 2 that's in our series with this data here, and replace this with this data here. And so you can choose which data values you're replacing in the map. You don't get to choose that with apply. Apply is going to apply that transformation to everything in the series. All of it's going to be mapped with this function. Whereas map is going to do a specific replacement. So map can be useful like if you only want to transform certain data values. So if you want to find out where there's a 0 or a 1 or a 2 and replace those with certain values, you can do this. This kind of does like a find and replace. You think about it like that, find and replace. So let's see what the result of this is if we print the mapped series. So you can see that 1, 2, and 3 get replaced, but we actually don't have any replacement for 3 and 4. So those get mapped to NaN because we don't have a specific replacement for them, and their original data was integers. So we now have strings, and we had those integers. We don't know how to replace those, so those get overwritten with NaN. So the thing you have to be careful with a map is you want to make sure you basically cover all the cases that you have within your series. So if you have, 1, 2, 3, we know that the other data members are 4 and a 5. We should probably pick some candidates to replace those with. So if we have 4, we want to map that to 4 probably. And we had a 5, we want to map that to 5. So again, this is a more specific find and replace. So now all of that data has been replaced, and we actually have those replacements that we can now make. Okay, so map will map these data members to this value, and that will happen for every copy of this. So if we had a bunch of 1s, they all would be replaced with 1. Every instance of 1 would be replaced with 1. Not just like the first one, but every instance. All right. Questions about map? Do we see how it's different than apply? Apply is going to take a function and apply it to everything all at once. We're not picking and choosing what to replace something by, which is what we're doing with map. All right, very good. A couple more examples. So beyond applying transformations or replacing certain values with something, we can also do things like sorting. So this should make sense to us that we can sort. So by the way, the default sorting is least to greatest. So it's an ascending sort. If we want to turn that off and do a greatest to least, we have to go into here and turn that, we have to do ascending to false. Okay, so if we do ascending to false, let me jot that down. Ascending equals false, we'll do greatest to least. So this will sort our data. So we have 1, 2, 3, 4, 5 currently from the beginning to the end of our series. If we do this sort, it's already sorted, but if we do a greatest to least, it should put it now as 5, 4, 3, 2, 1, right? It should now be sorted like that. So let's go ahead and print that out to be sure that it got sorted properly. So print sorted series. And you can see now we have 5, 4, 3, 2, 1. And you can also see the indices now change to where this is now 4, 3, 2, 1, 0 because the data retains its index. So we're sorting the whole series. The index also gets sorted along the way. So that's something to be aware of is when you're sorting the series, you're sorting both the data and the label. That label comes along with it. Or I should say the index, not the label, the index. So if we were to keep this as true, which is the default behavior, it would just be how we had it. It was already sorted, right? 1, 2, 3, 4, 5. So in order to do a greatest to least, we have to put this to false, ascending as false, and that will be the greatest to least sort. Does that make sense? Any questions on the sorting? That's valuable, right? That should be a natural thing we can do is we can sort the series. You can do that in any spreadsheet, right? You can sort a column. So we better be able to do that, right? That should make sense as a basic operation we should have is the ability to sort a series. Okay. Very good. Let me move on to a couple of really important things that deal with missing data. So we have a simple function here to check and see if there's any missing values, which is series.isNull. So this will check and see if there's anything missing, meaning that we have a blank value or an NaN value in our data. So we're missing something for that index for some reason. Maybe we loaded in this data from a spreadsheet and we're missing a value. We want to be able to see if we actually are missing anything. Let's see what this returns. So you can see what this does. This goes through and checks every entry and sees if any of them are true or false. If it's true, so this will return true for missing entries. So if there was a true here, that means that slot in the series has a missing value. It has an NaN. It was blank, essentially. It has an NaN. It doesn't have a valid value there. So it's null. This will give us a check for every entry. And more importantly than that is maybe we want to know the total of them. So let me show you an additional example is we can see the number of missing values, which is if we just tack on a sum. If we just tack on a sum there at the end. So if we take this and total that up as an aggregation, we can get how many missing values there are. So this should be 0. There is no missing data in our sample series, right? It's just 1, 2, 3, 4, 5. There's no missing numbers here. So, but we could confirm that this should be 0. So you see here we get 0 as the number of missing values. There is no, so both of these are valuable. This is valuable to see which slots are missing. And we could have a place to see how many are missing. Can you insert null? Yeah, you can overwrite. So we could overwrite a value to be null by doing something like series 0 equals none, that would overwrite the first entry to be a null value, none. Does that make sense? This would overwrite the first entry to be null. Yeah, none. The Python equivalent is none. Yeah. By the way, if we do that, look how many are missing now. After we do that, look how many we get missing now. We get one, right? So we overwrote that first item. Now when we do this, we actually get one. That should make some sense to us, right? Yeah, it's because is usually counting the number of a specific data value, like count how many zeros there are, count how many ones there are, count how many twos there are. In this case, we're getting a total. That's what sum really represents, is how many total nulls do we have? So we're thinking of count a little differently in this context. Like it's the count of how many of a certain data type we have. In this case, we're checking is null, which gives us like a Boolean 0 or a 1, and we're totaling that up. So if we have all zeros, the total, if we add a bunch of zeros, we get 0. All those falses are like zeros. So we total all those zeros, we get 0. In this case, when we fill in a null value here, we get 1 missing value as the total, because now there's a true. There's actually a true sitting here, which we could see if we printed that out again. If we printed series.isNull, there's now a true sitting here, which is a 1, basically. Python treats as 1. So we total that up, we get 1. All right. So you may be asking, well, what do we do if we have a null value? Well, luckily there is a nice function to replace null values with a default value, and that is the function fill in a. So if we're missing something, we can go ahead and just fill it with a specified value. So in this situation, we have a null here. Let's fill it with a 1. Let's go ahead and fill it back in with a 1, because that's what it used to be before I took it out and said it was none. Let's go ahead and fill that NA with a 1, and then let's print the filled series. So now this should have that null value filled in with the 1. And there we go. So we have 1 there, and all the values we have no more null values. So fill NA will fill back in, it will fill in any missing values with a default. Okay, so pretty convenient. If we identify anything missing, we can fill it in, right? We can fill it in with a default, with this fill NA. Any questions on this? All right. So what I wanted to show you next is the ability to essentially filter a series. So we can put in conditions to basically filter out different rows or different entries in the series. And I want to show you how to do that very easily, which are just going to use our comparison operators to basically generate some filters for us. So I want you to see the syntax of that. So we have this sample series that we built from this fake data. We have index A, B, C, D, E, and we have that data mapped. We have those values mapped to this data 10, 20, 30, 40, 50. Okay, so some fake data there, and we build our series. So we have a new series sitting here. I want you to see the syntax of how we can generate a filter. So generally, we can build filters by using the comparison operators and the brackets for value selection. So remember, we typically will use brackets to put an index in there. That's typically what we're used to doing, right? We put in a 0, or we put in an A, or we do a slice. We can grab elements that way. So think of doing that, but with a comparison filter now. So this would, like, for instance, this says we want to pick only elements of the series that are going to be bigger than 30. Excuse me. So we have, we pretend like we were going to pass in an index here. So we have series bracket, because what would typically go here would be something like this, right? That would typically select something from the series. It would select the first item, or we could slice it to be something like that, right? We could slice. So that's how we select things. But in this case, we're actually going to do a filter, which is a condition to say, I only want to keep items that meet this criteria. That's the filter. Okay. So inside the brackets is our filter condition. So it's basically, we only keep elements that meet the filter. So let me show you what this should be. If we're filtering out to say, only give me items from the series that are bigger than 30, we should only get this part of the series remaining, right? Everything else should be filtered out, because 10, 20, and 30 are not bigger than 30. They're all less than or equal to. So these guys should be left out, and we should only be seeing this as the result of that filter, right? We should only see those guys as the result of the filter. So let's make sure we do. Let's print out this selected greater than 30. So here it is, right? We only, oh, it already did it for us. So it already showed us this. The selected greater than 30 results in only those two parts of the series remaining. So that was an effective filter, right? To only give us the items that are bigger than 30. So that's how we filter. And so all we have to do is, if we want to do other kinds of filters, we just have to do other kinds of comparison operators. So for instance, let's pick all the items of our series that are exactly equal to 20. How many of those do we have? We really only have one. Only this guy exactly equals 20. Right? So when we do this filter, this should ignore everything else and only give us this item out of the series. So our series is going to be filtered down quite a bit to only this element. And we can see that. So when we come down here, the part that gets printed out there is going to be only that part of the series, the index B and the 20, the data 20. Right, so that is that filter. Not equal to 40. Which items of our series are not equal to 40? That's what this filter really is asking. So we go to our data and look at it. We have a 40 here. Which parts of the series are not equal to 40? Well, it's basically everything else, right? This is not equal to 40. This certainly is, this is, and this is as well. It should be everything but that 40 should be filtered out and returned back to us. So if we take a look at that, what is not equal to 40? We get everything else in the series, 10, 20, 30, 50. So that was an effective filter, exactly what we were hoping for. Okay, so greater than 30, equal to 20, not equal to 40, those are all valid filters. And I want you to see that syntax where this is inside of the bracket. It's basically replacing an index. They say, I want to pick something based on a condition, not based on an index. Okay, based on a condition. Any questions on that? Okay. So I'm going to show you some other examples of conditions. For instance, we can actually combine conditions using logical shorthands. So this is multiple conditions we're combining. It is greater than 20 but less than 50. So this is greater than 20, and this symbol here we haven't seen yet is the shorthand for and. It's the Boolean and symbol. So this ampersand symbol is shorthand for and. So this means that we're looking to filter out data that is bigger than 20 and less than 50. So multiple conditions combined. Now we could do or. There's a shorthand for or that we could use in here. And that is the pipe. Basically the pipe symbol is shorthand for the logical or. So we could have a pipe symbol here. Oops, I don't know what happened. Yeah, we could have a pipe symbol here, which would signal that we would be looking at this condition or this condition. So things that are less than 50 or bigger than 20, which would really be everything. So it's kind of a useless condition, but we can have that one. So does that make sense? Those are just shorthands for and or. And so because we can filter on conditions, there's nothing stopping us from filtering on multiple conditions that are logically combined. So greater than 20 and less than 50, well, what should that be? Should really just be these guys here. Those are the only things that are greater than 20 and less than 50. We should just get those two out of it. So if we went down and looked at it, we would get these two guys as the filter, which makes sense. So we can do that. That's a valid way of filtering. You can also, what's really cool is you can also filter based on a specific list. So you could say, I only want to keep values that are inside of a specific list. So this is where we use the is_in function. So this is a function that gives a Boolean true or false if the members of this data are inside of this exact list. So what this means is we should really only be keeping values that are going to be 20, 40, or 60. Only those three numbers should be kept. So if we go back to our data, we only are going to keep only these two. There's no 60. So 60 wouldn't match to anything. So we're really only going to keep the 20 and the 40. Okay. So is_in is a special kind of filter that only retains values that are actually in this collection. So if we did this by list, we only get those two, only the 20 and the 40 remain. You can do string filters. So for instance, if we had our data was all strings, we could filter based on the string starting with a B. So that's actually a very specific condition, right? So we want to filter all strings that only begin with B. So in this case, that would just be the banana should be the only one that is returned, the only entry that's returned. Everything else starts with A, C, D, or E. So that's possible. Okay. Let me pause there. Any questions about these guys? On this one, this starts with? Yeah, so what this means is we have a series that has strings. If we were to filter it, what we're doing is saying, okay, here's our overall bracket. So that does not change, right? We have our string series and we have our bracket to say we want to select something. The bracket's always meaning let's select something. So first of all, that's why we have a bracket. Then this accesses the strings. So whenever you want to access string functions, you do your series.str, which is the string module of the series. So that gives us access to string functions, and one of those functions is finding out if a string starts with a certain character. So that's what the syntax means is give me only the things that start with a B as a character. Which strings start with a B? In this case, this is the only one that starts with a B, and you can see that based on the starts with, the only thing that gets returned is the banana. Right, it's the only thing that gets returned. Yes, it is case sensitive. It is. So if we did capital B, this would be different. This would be nothing. Nothing starts with a capital. So yeah, lowercase b is not the same as uppercase B. So we'll continue. We were practicing, selecting items from the series, and one of the crucial ways of doing that, that's also going to be very crucial for data frames as well, is the loc and iloc, which operate on different indices. So what's really important to know is that loc allows us to pass in basically the labeled index. So our index that we have, which is either the default one or the one we provided when we created it. In this case, we created a series that had a index with A, B, C, D, and E. So loc will allow us to select multiple of those indices, almost like a slice. So loc allows us to use our index. So we use our series index to select data. So we're selecting A, we're selecting C, and we're selecting E. So we pass those into a list inside of the loc function. And we can pass in as many as we want. We can pass in just a single value. It doesn't need to be inside of a list. But loc is pretty typical for selecting multiple elements using the index. So that's the key thing to remember about loc. It uses the index of the series to select items, and you pass in typically a list of those indices that you want to pick. So we're picking the elements at A, element at C, and the element at E. So go back to our data. That should be 10, 30, and 50. So if we go back and look, that should be at those three guys, right? A, C, and E, 10, 30, and 50. Okay, so loc uses our indices. And now, how is that different than iloc? So iloc always uses position. So this always uses position regardless of index. So even if you have a really nice index that you've provided, like a date or in this case, A, B, C, D, E, we can ignore those and just use their position within the series, which is what iloc does. It just uses the numerical position of the elements. So, for instance, if we want to pick the very first item, we know is at index A, but in terms of its position is really just position 0 within the series, right? Position 0 is the very first item, even though it has an index A. In this case, we're picking the positions 1 all the way up to 4. We're doing a slice. We can do that. We can slice based on position. So that's okay with iloc. So remember, iloc is different than loc. Loc uses the index, whatever index we have defined, which is, it can be special, right? It can be dates, it can be strings, it can be objects. That index can be whatever we define it to be. iloc will always use numerical positions, always. So you would never put in, like, this would be invalid to do this. This would give us an error. We can only use this with loc because that is the index of the series. But the positions are just the data positions within the series array. So we have just a natural ordering that always exists of our data within the series, and we can use that with iloc. Okay, so they're very similar. They're both used for selecting data, but they use different indices. Loc uses the defined index of the series, and iloc uses the numerical position of the elements. Okay. Any questions on those? So we see, by the way, this is 1 all the way up to 4. So what is at position 1 would be this guy, even though it's at index B. Even though it's at index B. And what is position 4? Well, this is 0, 1, 2, 3, 4th, the 4th element of our data. So that would be all the way up to 50, but not actually including 50. That's the slice. So it should be 10, 20, 30. What is 4? It's a position. It's just this would represent the 4th element in the data. The 4th element in the data, which is, this is the 0th element, this is the 1st element, this is the 2nd, 3rd, and this is the 4th. Right? Numerical position. That's what iloc uses. Based on this data, what do you think is at the first position? At position 1, what data do you think is at position 1? If you were looking at this, so 10 is not at position 1. 10 is at position 0. 10 is at position 0. What's at position 1? Right, it's at 20. Yep, it's 20. So yeah, let me explain it one more time. Yeah, so let me explain it one more time. So series have an index we can define, right? So in this case, we have 5 elements. We have 5 elements, and so we have 10, 20, 30, 40, 50. And do we agree that the original index we set up for this is A, B, C, D, E? Does this make sense for our series? This is what our series looks like. Do we agree on that? So without worrying about the positions or the loc or the iloc for a moment, does this make sense for our index? This is based on this data. That's our index, A, B, C, D, E. Okay, so we do agree on that. Okay. Now, what data if you were to ignore this index for a minute, this is the index, and just think about this data's positioning from left to right, what index would we say, or what position would we say is the 10 at? What position is the 10 in the array? If we were to just think of it as a list, let's say, what position is that? Right, it's position 0. And what position is 20? It's at position 1, right? And so 30 should be at, what should be 30? 2, perfect. 40 should be 3, and 50 should be 4. So what I was saying with those examples is iLoc uses these positions, while loc uses the index. Does that make sense now? When you think of it this way? iLoc uses those positions of the data, the relative positions of them, to select things. So when we say 1 to 4, that's this slice, right? That's this slice of the data. Not including, I should say, not including the 4. So it's really this slice. Yeah. iLoc, default indexing, loc, user indexing. Yes, I think that's a good way of thinking about it. Yep. For sure. Go to the syntax? Yeah, let me go over to there. Does it make more sense when you see it with the picture? So you see the code, loc using A, C, and E. It's picking those 3 items using the defined index. 1 to 4 is a slice. It's 1 to 4 will be this slice that I've circled here. 1 to 4 is this slice. Right, it's a slice. And remember, the 4 really means it goes up to 4, but not including 4. So it's the slice 1, 2, 3. Yeah, no worries. Any other questions on this? All right. Very good. Very good. Okay. So what I wanted to show you guys is that was the end of this notebook, but there is some extra practice. I encourage you guys to try this out on your own. So this is your own practice here at the end. Try this out on your own. So this 4.01 notebook, try this out when you get a chance to do some extra practice accessing and manipulating this data. Okay. So you have some example arrays here. You'll build some series and go through and do some selecting of some data using the different methodologies we just showed with loc and iLoc, and picking different indices and things like that. So this will be some extra practice for you. What I want to do now is go over to talk about the data frame. So we've talked about series so far. We have some different functions on a series. Most of these are going to carry over exactly into the data frame in the 2-dimensional aspect. So everything we've been doing, mostly been dealing with 1-dimensional data, but we are going to deal with two-dimensional data. Let's go over to 4.02 now and talk about the data frame. Okay. So if you have a moment, pull up the 4.02 notebook. We're going to go over to that and talk about the data frame now, which is going to extend everything we just learned over into the two-dimensional data with rows and columns now, which is going to be the data frame. You guys have this notebook? And go over to the 4.02. Yeah, just go over to that one. We're going to do that one next. Okay. So let's remind ourselves what a data frame is. So a data frame is now going to be our two-dimensional extension of the series, where we are going to have a tabular data structure, meaning it's going to look more like a table. We're going to have rows and columns to deal with now. And what's going to be really interesting is we'll actually have multiple indices to worry about because we have multiple dimensions. So imagine if we had these two series of apples and oranges. So we had a series called apples. It has this data 3201, and it has just a natural positional index of 0, 1, 2, 3. So nothing that interesting. We have another series over here called oranges that has data that looks like 0, 3, 7, 2. It also has the same index of 0, 1, 2, 3. That's fine. That's just the default index. Now, what we can do is concatenate these into a single data structure called a data frame, where now these two series actually form columns in this table structure. So now we have more of a table, which is a data frame that contains one row index. So this is called the row index here. So it has a row index, which is row 0, row 1, row 2, row 3. So we can think about the data at a row level. So we can say, okay, this is one row. This is one row. It's very much like a spreadsheet, right? This is one row. This is one row. We have that. And then we have data at the column level. So we have these, what are known as the column index that we have here. So the column index just allows us to select columns based on those names. So we can always go into this table and grab the apples column, we can grab the oranges column, we could grab the apples and oranges columns together and pull back multiple columns. We have that flexibility with a data frame, just like you would in a spreadsheet. You can pick data at a column level as well. So you always have that flexibility in a data frame to select rows, to select columns, to select rows and columns. So that's something we're going to learn how to do, is select data based on where it is, what row it's in, what column it's in, select sections of a data frame, or rows and columns. What will be the merge title? So that's up to us as a variable. The title of the data frame is not that important. It's more when we add these two columns together, we get a single data frame with two columns, and we have a row index and a column index. Oops, this is the row index. But the name is whatever we want to call it. We can label it whatever we want as a variable. Like we could say this is our fruits data frame. We just call it that. Fruits data frame, which has apples and oranges as columns. And it has 4 rows, right? It has 4 rows of data and it has 2 columns. Basically, the shape of this is a 4-row, 2-column matrix, right? think about this as a NumPy array, that's what that is, right? 4 rows and 2 columns. Okay. So one thing to point out about this so I told you guys it has a row index and a column index. So those will be really useful for when we want to select data from the data frame. But the other thing is there's no restriction on the data types in the data frame. So the data types of one column can be completely different than the data types of the next column. So like this column could be all strings. This column could be all floats. That's totally fine. There's no restriction there of what the columns can be. They can be mixed data types. That's totally fine. There's no restrictions on the data types. Oh, that's just random data. It's just random. It doesn't represent anything meaningful. It's just random. We just wanted some values to be in there. Yeah, they can be different for each row. Yeah, they can certainly be like they generally could be if let's say I had like this data type was a string. So this column was a string, this column was a float. Then I'm gonna have like within this row, this is gonna be a float, but this is gonna be a string. So yeah, the rows can be different. If you have mixed data types, the rows are going to be different. Yeah, we're going to have lots of examples. Yeah, they're coming up. They're coming up. This is just to get us introduced to the data frame. Yeah, we're definitely going to have meaningful ones coming up. We're going to load. So the most meaningful example I can give you is most spreadsheets can be loaded into a data frame structure. So if you take any like CSV or Excel sheet, they can be loaded into a data frame, and then we can do all of our analysis on that data frame. That's typically what we're going to do with the data that is inside of a comma separated value file, a CSV file. We'll load that into a data frame. We're going to practice doing that quite a bit. Okay. All right, so before we get to those examples, let's talk about how we can create some example data frames using our code. So here we are going to import pandas as PD. And one of the most common ways of creating a data frame is from a dictionary. That's one of the most common ways of creating a data frame is from a dictionary. Now, why from a dictionary? It's because these keys in the dictionary are actually going to be our column names. These are going to be our columns. The keys are going to be our columns, and then the data within those columns are going to be inside of this list. Okay, inside of each of these lists. So I'll show us that data frame in a moment, but this is pretty common. So the keys become the column indices, and the data within the columns are the values, which are the lists. So those lists become the data within the columns. So the name has these 3 strings, the age has these 3 ages, and the salaries have these 3 integers. So let's go ahead and see that dictionary. So it actually looks like this. Name, age, and salary. It looks like this. This is our data. It has 3 rows. That's not surprising because it has every column has 3 entries. So it ends up being 3 rows. And here's the name column has Alice, Bob, and Charlie. The age column has those ages that were in that list. And the salary column has those those three there. So using a dictionary is one way of building a data frame. It's a very common way. So we can do that. The other way is to use mixed type list. So basically where you define every row. So creating a data frame from list is possible, where we have a list for each row. So we have the first row, we have the second row, we have the third row, and we actually manually supply what the column names should be. So this is all the row level data, and this is the column name. So we can actually build a data frame off of that using pd.dataframe. We pass in our row data, and we say, here's what our column should be labeled. Here's the column indices. So these are the column indices. We say, here's what our column should be. Here's our row data, and that builds the same data frame. Builds the same exact data frame as we had before, just doing it not in a dictionary, but in a list of lists, essentially, right? All of our rows are utilized here as like this. I agree. Yeah, the dictionary is probably the cleanest way to build a data frame. I would agree. Probably the cleanest way. But this does build the same exact data frame. All right, same thing. We can use NumPy arrays. Now this is a NumPy array. This is the 2D array of our rows, right? So here's the first row, here's the second row, here's the third row, and we can give it our column indices as well. So again, the NumPy array data is our rows of the data frame. So this data formulates our rows, and we're passing that in to build our data frame. So this should be the same exact data frame that we have from before, just using NumPy arrays to build it. Okay. All right, let me give you a more practical example that will be realistic to a lot of the use cases we will see over the course of the program when we're loading in data. And this is one that's used all over the industry. People use it all the time. I use this one nearly every day, is reading data from a file. So if you want to read a CSV file, you use the pd.readCSV function. So read CSV, and all you have to do is pass in the file path. So now this path looks a little wonky because I am inside of Colab and I had to mount this file within my drive. So this data is in my Google Drive on Colab, but generally like if you're in VS Code, this would be a path to the data that is somewhere on your computer. So this is just a file path to this CSV file. Okay. And by the way, you guys should have this data. If you go into your, let me show you where it is. So if you go into your LMS, let me log in. Do you guys have access to the data sets? It should be from your reference materials. It should be in this data sets here. Okay, this data sets. So go to this data sets and the reference materials, and that's where I'm getting this house price CSV from. So if you download that and extract it onto your machine, that's where you can get that. That's where you can get that file from. So house prices. By the way, if you have it in your Google Drive, you have to run this code. You have to run this code first to be able to access files that are stored on your drive in Google. So you want to run that first, and that makes your data accessible within your so this is if you're running in Colab. If you're running in Colab, you want to run that in a cell, so this makes your data accessible. Let me write that down. This makes your Google Drive data in Colab. Okay, so you have to run that, and then once you run that, then you can access data that's within your drive. So if you go to this like folder icon, you can see you can browse your drive within this folder icon. This is likely going to fail for me because I didn't mount the drive yet. Let's see. Yep, so it can't find my drive files, but I just run this, permit. There is, but only for the folder you have open. It's just the like file explorer on the left. Roberto, it's just the file explorer on the left, but only if you have it only in the folder you have open. So what I would recommend if you're working in VS Code is to I would recommend to put that data set in the same folder as where your notebook is, so it can discover that file pretty easily. Does that make sense? Like put that data set file. So there's two files in this notebook that you're going to want access to, which is the house prices and the iris Excel. So put those in the same location as this notebook, and it should work. So let me actually put a comment here. So you should be doing pd.read CSV, and then it should be file path to CSV, wherever that is. So I think the easiest thing to do is put it at the same location as where the notebook is saved, because if it's in the same place, then that should just be pd.read CSV, and then it should be house price .csv. Should just be that. Loads the whole file. Yeah, loads all the data in memory. Yep. That's right, Tim. I don't have import drive command on the, yeah, this is for Google. This is for Colab. This is only for Colab. You need this to access data on your Google Drive. The two files are the house prices CSV and the iris Excel XLSX. Do you have those two? House prices CSV and iris XLSX Excel sheet. So you can build a data frame from here. Now, when you load all this data and you print it out, it's actually quite a big file. It has about 5,000 rows. So it's not going to show you all of that data, but we're going to have some functions we can do that can easily get us some summaries of this data, which will be nice. Okay, so we'll have that coming up shortly. But there are 5,000 rows. So, or sorry, about 4,600 rows. So it's a decent amount of data there, 4,600 rows. And the iris data also has 460 rows and 18 columns. 4,600 rows, I should say. Sorry. All right, were you guys able to run this? Were you able to read the CSV using Pandas? Were you able to run this? Not able to. Make sure that the path that you have the. Oh, that's fine. The output's getting truncated. That's fine. That's expected. It's not going to show you all 4,600 rows. That's expected. Yes. Are you running in Colab, Mario? You are? Okay. You have to give permissions. So there should be like a pop-up when you run this code. When you run this, there should be a pop-up to give permissions from your Google account for this notebook to access your files. So make sure that that pop-up actually shows up and you click and you validate it. You should see a pop-up when you run this. Okay. Yep. Worst case, by the way, what you could do if your drive isn't mounting, a backup is to go. Do you see this file? Do you see this files on the left? And this is for everyone running Colab. If you're unable to get the drive to mount, what you could do is you could just upload the file into the workspace. So if you go to this files, you can upload. You can hit this upload button to upload data. So you can see this upload here. From if you click on this and then you click on this, you can upload the file manually into this workspace, into the notebook workspace. So you could do that too. If you have the file on your computer, just upload it. That works too, without having to mount your whole drive. So just click on this upload, and then you can upload the file. So I just uploaded the house price CSV. So now I have it available in the session. And then I could just like that. What should it look like? It should look like this. You don't have to do Google Drive. You can do it this way too. Do you see the way I just showed? Where you can upload it into the session, into the notebook session. You can do that. You can keep the file on your local and then just upload it to your notebook using this files upload. Roberto, do you see this? Like all of this data displaying? That's how you know it worked. If you rerun the cell, that means it worked. It should display the same thing. if you scroll back up, people posted it, but it's in your LMS. It's in the data sets here. See this data sets link? It's this one. Download the data sets. And we're doing the house price and the Excel and the Iris XLX. Yep. Okay. So were people able to run this and get you should see this output that has a bunch of so this is printing out the contents of the CSV. That's right, Roberto. Yep. Yep. That's right. Okay. So you guys should be able to see this. Now, this is loading. Let me just take a step back and say, this is loading the data into a data frame. So now this is the contents of the CSV are now in a data frame. So we can do data frame operations to that data, which is going to be really useful. We can manipulate it. We can do summaries. We can do group bys. We can do filtering. We can do all kinds of stuff to this data frame now that we've loaded all that data into the data frame. So read CSV, we are going to use a lot during the program. We're going to use a lot to load in data from a file, to load in data from like a spreadsheet style file into a data frame and then manipulate that data frame. Okay. And there's a read Excel. Pandas actually supports a lot of different read functions. So it has read JSON, read Parquet, read all read arrow. It has all kinds of different file types that it supports. Okay, so not just CSV and Excel, even though those are very common, we can read all kinds of different files in Pandas to load them into a data frame, as long as they're supported. Okay. All right, so we practice loading in the data, but now what we want to do is practice accessing data from that data frame. Now that we've seen we can load data in, how do we actually access data and then start to manipulate it, summarize it, do all those things we were doing with series, we want to extend into the data frame. So let's get some practice there. Let's scroll down and build an example data frame with some fake columns here. So we have column underscore name, column 1, column 2, another column. We're going to practice accessing data from this. And then eventually we're going to come back to this data frame with all of that data we just loaded from the house prices or the Iris and practice working with that. But for the moment, let's work with this fake data frame built from this. So we do pd.dataframe, that builds it out of this dictionary. And here's our column data that we have mapped to these different column names. So if we want to access a column, it's super easy to do. We just pass in that column name here inside of the brackets. So we do df, which is the name of our data frame, and we just have column name here. That's going to access all of the data within a column. By the way, what do you guys think is the data type of an entire column? We just studied it. What do you think an entire column is inside of a data frame? It's a particular type of object. You're right, it's an object, but what type of object? It's a pandas object. Not a string. We just learned about it. We just were manipulating it. Series, very good. So a column is a series. Okay, a column is an entire series. Yep, a column is a series. So when we access this column, it's as if we're accessing an entire series. Okay, so if we print out that column, we get this. This looks like a series, doesn't it? It looks the same because that's what it is. It's a series. We're grabbing that entire column, which is 5, 15, and 8. So to access a single column, we just use the braces and we pass in that column index name and we pull back all the data from that column, which is really a series. So remember, a single column is a series, is a pandas series. So we're actually accessing that series when we do column name. By the way, if we were to try and access an invalid name, we will get an error. So let's say we did some column. Now this doesn't exist, so this will give me an error. So if I try to do this and that doesn't exist, this will give me an error. And you can see what kind of error I get. A key error that this does not exist. Basically, I don't know how to access that column because it doesn't exist. Right, so this is, we would not want to do this. We would want to use the proper column name, and that should work just fine. Okay. All right, now how about this guy when we pull back multiple columns? So we can use a list and select multiple columns at once. Now, what is a collection of series? We are studying it right now. What is a pandas collection of series? Perfect, DF. Perfect, you guys got it right. Data frame, perfect. So when we pull back multiple columns, this should be multiple series, which is a data frame. So you guys are absolutely right. When we access multiple columns, gives us a data frame. So this is actually going to be kind of a miniature data frame. It's only going to be these two columns because we're accessing these two guys, which are these two columns worth of data. That's kind of like a mini data frame that's part of the whole data frame, right? Selected columns there. So let's look at that. When we access multiple columns, we get these two guys, which is a data frame. Okay, we get column 1, column 2, and we see the data when we have 3 different rows from the data frame. So we definitely can access as many columns as we want by passing in a list into that data frame bracket, and it will allow us to access multiple columns. Now, we can't forget about loc and iloc. So, for instance, iloc will allow us to select particular rows based on the index. So, iloc of 0 is based on the position. So, this is saying, let's grab the data that is at row 0. So, again, this is using the positional index 0. Regardless of what the actual index is, the user-defined index, and data frames can have user-defined index. The rows can actually be a custom index as well, because we know a series can have a custom index. So iloc doesn't really care about our custom index. It's going to use the positional index to grab that entire row. It's grabbing the first row. So df.iloc is grabbing this entire row, which has values of 5, 10, and 100, and 25. If you look at it, that makes sense. That should be this row here. That's the row, that first row. We can do filters, just like we did with series. We did filters. We can do so we can do conditional filters here. Where now, how do we do that? It's exactly how we would have done with the series, right? So we do a bracket to signal that I want to access something, and here we give a filter. So what this filter does is this will filter rows of the data frame that meet the condition. Okay, so any row where this condition is occurring, in other words, this column name, it has a value greater than 10, we will keep. So we go to that, column name bigger than 10, which ones are bigger than 10? It looks like only this guy is bigger than 10. So we really should only be keeping this row here. Should be the only row that gets kept, because that is the one that corresponds to where this column has a value greater than 10. Okay, do we see how that filter works? We're really checking, so we go back to the syntax. We're checking where a particular column is greater than 10. Only those rows do we keep where this condition is met. So what we should do is go and double check this. So the filtered rows, we only are keeping that one row. So we just filter that one row because that's the only place where this guy is bigger than 10. So that's very powerful. We do this very big kind of filter operation on the data frame. So you have to think of the filter operation we did on the series, we're extending it into 2 dimensions. We only keep the rows where this condition is met. Okay, only keep the rows where that condition is valid. Any questions on that? Only keeping the rows where that condition is valid. Good. I know that the filters on the data frame can be a little confusing. This is printing a label, and then this is printing out the actual filtered data frame. This is just printing a regular string. So it just says this, and it puts a new line right here. So the \n is this new line right here. Yep. Okay. Yeah, so why do we need df twice? It's because overall we access data by using df and then the bracket. Right? So that should be generally accessing data. We saw that with the series too, right? It's a series and we have bracket. We saw that with lists. Usually it's a list and then a bracket and we pass in an index. So we generally have the first df with the bracket to signal we're accessing something. Okay, just generally we're accessing something. Now the reason we have df twice is because inside of here is a filter condition, and the condition says I want to look at this column. So the reason we have the data frame twice is you see that we're accessing that column, which is df bracket the column. This accesses this column and says, I want to check where this column is bigger than 10. All the rows where this column is bigger than 10. That's why we see df twice. We see it once on the outside to signal that I want to access something from this data frame. What do I want to access? Only the rows where this condition is being met. Only the rows where that condition is true. That makes sense, Roberto? Yes, we're going to study that coming up. We're going to study that exact thing, how to get a summary. We're going to look at that. Yep. It's coming up soon. That's correct. Yeah. So if we had multiple conditions we were checking, we would be using df multiple times. Yes, that's true. Show once again how we can load data from local folder. Yeah, sure. So do you guys see this folder over here? Do you see this folder icon on the left? Click that. Click that folder. And it should show something like this. And then click this upload button right here. That's how you load data into your notebook session. Yeah, so you can get the path. By the way, you can always get the. Do you see the file in there now? Do you see the file in there when you upload it? You can get the path of it by clicking to the right of it, these three dots. You see how there's three dots? If you click that, you can copy the path. Click on copy path, and then you can. It's the same code. It's the read CSV. Read CSV, and then you put in your path inside the string. Like this. Which I think is probably the same, probably this for you. It's not from your computer. No, if you're in Colab, no, it's not going to be from your computer. It's going to be from the uploaded file. Are you working in Colab? Yeah, so if you're in Colab, it's going to be from this path. It's this path of the uploaded file. Or your drive path, wherever it is in your drive. Yeah, we're just somewhere in the cloud where you've either uploaded it here, and you can always copy that path. Oops. Oh. Okay. Where was I? Oh, we were doing the filtering. Okay. Let me ask you guys, does the filtering make sense to us? It does? Okay, perfect. All right, I have one more thing I want to talk to you about on the filtering, and then we'll take another little bit of a longer break, so we've been going for a couple hours now. So once we filter like this, we're basically picking all the rows that we want out of the original data frame, right? Because that's what this does. It selects rows based on meeting this condition. But there's nothing stopping us from accessing a particular column after we do that filter. So that's what this, I'm going to scroll down to the bottom of this cell and go to this example, and I'll come back and talk about IAD, and loc in a minute. Once we come back from our break, I'll cover those. But do you guys see how we are accessing? This is the filter again, same exact filter. This is bringing back. So let me copy this and make a comment here that this part of it gives us the DF rows that meet the condition. And then we access a particular column of these rows. So that's what this does. Do we agree on that? So this is saying I've already filtered my data frame to be filtered to this set of rows, but it's still all columns. So if I were to draw this, right, if I were to draw this, we've basically filtered it out to this selection of rows. Just imagine that, right? We've filtered it down to this selection of rows. But what this thing does is says, let's zoom in on this column. Right? Let's zoom in on that column. That's what that does. So we are allowed to do that in the syntax. Once we filter, we can select a column from the filtered result. We can basically chain those together, which is what that's doing. That code is doing. Yeah, I'll summarize it in a moment. Okay. All right. So let me just summarize the things that we've done in this cell. Let me move that. So all we did was we created a data frame with some example data. We didn't even use that data yet. We'll come back to it. But we're just using this example data from this dictionary, and we were just practicing some different things, like accessing a single column. All you have to do is put the brackets and then the column string, which corresponds to whatever column you're selecting. That is going to retrieve the series of data, in this case, like the column, right? 5, 15, 8. So it's doing that. You can select multiple columns if you pass those names inside of a list. So column 1 and column 2. This is actually going to give us a data frame result, right? Because now we have multiple series being pulled back. Multiple series equals a data frame. Okay, multiple series equals a data frame. So we have a data frame result that is giving us only these 2 columns out of the 4 columns that exist. We can use iloc to grab a row based on the position, the positional index of that row. Like this is the first row. We can do the second row. We could do the third row, the fourth row, etc. So that's just the first row. We did a filter. So this is just a basic filter. We were just talking about this where this is the condition. And so this is saying, let's grab all of the rows out of this data frame where this condition is being met. Okay, all of the rows where that condition is being met. All right. Then, yeah, different from a slice. This is a filter, different than a slice. This is because this is conditional, right? A slice is more positional based. It's not conditional. This only selects data that meets this condition. This is conditional. And then what we said is based on this condition, we can actually select another column right after that, which kind of chains it together. Yes, Roberto, it's like a bidirectional. Yep. So while you try that, let's continue talking about on this set of examples here. We had the at. We had just gotten to the at. Now, the at is like the equivalent of loc for accessing a single entry in the data frame. So this is the equivalent of df.loc for a single value. So at will use the index. So at uses the index, uses the row index and the column index for accessing. So the row index in this data frame is just the default. It's just the positional, just happens to be that way. Does it have to? No, it could be dates, it could be strings, it could be anything. In this case, we didn't specify any special row index. We do have column indices, right, which are these names. So we can use those, but there's no special row index with this dictionary when we create this. So it just has the default row index. So when we use at, we can say, I want the value at the first row, which is row 0, the second row, which is row 1, the third row, fourth row, fifth row, and those are all going to be this positional index because that is the true index of this data frame, the row index. However, we also have the column index, so we can access things based on that. So column name, we're grabbing the element in the column name column, but the first row here. So this should fetch us this 5 because we want to be within this column, but the first row. So this at should return to us the a 5. So if we go down to single cell by label, this should give us 5, which is what it does. So sometimes you can use at. Again, this you only ever use it if you want to access a single item, which is kind of rare. You're not usually going to be grabbing just a single item in the data frame. Usually you're going to be grabbing multiple rows, multiple columns. But there is the at function for passing in a row index and a column index to access a single item. Yes, but that's true, Ramiro. But I would call it the row index and column index. In this data frame, the row index is 0 because it has the default index, right? It has the default index for the data frame, which is 0, 1, 2, 3. It's this. This is the row index, right? This is the row index. And then this is the column index. Column index. All right, so with at, we have the equivalent of loc, but for accessing a single item. We also have I@, which is this is the equivalent of iloc. So this is the equivalent of iloc for accessing a single element. And so this one we use. So this one uses the positional index for row and column. So we do not use the name for the column. We only use its positional index as far as which column are we in, going from left to right. Are we in the first column? Are we in the second column? Are we in the third? This would signal that we are in the second column because that is the column that is at index 1. So if you use the positions with I@, or iloc, for example, we would be like, this is column position 0. This is column position 1, column position 2, 3, regardless of the actual column index, right? It has a position within the data frame going left to right. Every column has a position. So I@ uses this column position. It also uses the row position regardless of what this is. It just happens to be the same because the data frame uses the default row index. But so 0, 1, if we did I@ and then we did 0, 1, would be the first row, second column, right? First row, second column. So that should be this guy. So we look into our data that we have, which is this data frame right here. It should be first row, second column. It should be 15. So we want to make sure that we get 15. So if we run that single cell by position, don't know why it's saying. Finally, we have df loc. So if you guys remember, loc uses the we've kind of already talked about this, but loc uses the indices, right? So it uses the row index and the column index. In this case, we're selecting the first row, but all of this column named column name. So here we are selecting the first row, but all of column name column. We're picking all of those values. So we should be getting first row, but the whatever is in the column name entry. And so that would be if we go back to, we should be in the first row, but only getting this 5 essentially, which is the value in that column name. So loc will use the indices just like at would. So at uses the indices. Loc also uses the indices. Basically, loc we would use though when we want to select. So we use loc just like we did when series, right? We use loc to select multiple values. You can even slice the rows. So for instance, we can grab the first 2 rows and slice it that way. And that would pull back multiple values for this data selected with loc. So it's actually going to grab all of those rows 0 and 1 and the data belonging to column column name. So you can even put it, so you can use loc to grab multiple entries. So you can have a slice in there, which is pretty interesting. So here's a slice. 0 and 1 rows. All right, any questions about these? We're going to get to some really important summarization functions coming up, but any questions about these, like accessing patterns? I think the most common way we will access data will likely be from picking columns like this, or honestly doing filters like this. Those will probably be the 2 most popular ways we select data. JD, they do for the rows. Yes, because most people use the default row indices, but the columns usually have a label, right? They usually have a name. Like this example up here. The columns usually always have a header. They usually have a name, right? If you think about an Excel spreadsheet, columns usually have a header to them. But rows, yes, usually will have a default index like 0, 1, 2, which kind of lines up with their position. Okay. Very good. All right, let me get to some exciting summary functions that we will cover next. So I want to go through some basic data frame functions now that we've seen how to access data. Let's look at some other convenient functions, and some of them are going to be really familiar from basically from series. They're going to be the exact same, like head and tail and sort and is null. Those are all going to be the same that we have, except now it's going to be in multiple dimensions. So let's take a look at some of those examples, but some of them are going to be pretty unique. But some of them are going to be basic multi-dimensional extensions of the functions we've already seen for series. So let me walk you through some of the functions that we are going to do some examples with. The first couple we've already seen, which are head and tail. So just like in series, we have a head and tail function which shows us the first few rows of the data frame. Remember, if you don't put anything in the head and tail argument, like if you leave this blank, it will just do by default the first 5 or the last 5 rows for head and tail. Now, why is that helpful? It's actually really helpful often when we load in a data frame. The first thing we typically do is run a head or a tail so we can sanity check what we just loaded without having to print out the entire data frame. Printing out the entire data frame is usually inefficient, and we don't it's going to get truncated anyway. So a very standard thing to do is to just print out the head or just print out the tail so we can get that view of the first 5 or last 5 rows to sanity check what we just loaded in. So that's a very common thing to do. We're going to see examples of that, and we're going to use head and tail quite a bit as we move along. And as we load in data, that'll be usually the first thing we do is head or tail, just to take a look at the data we just loaded in. Yes, it's going to include the header. Let me show you an example. So if we go back to the data we loaded earlier, so the house prices, let's print out the head. So df.head. It shows you the header, but it just shows you the first 5 rows. See how it's just the first 5 rows? But we can see all of the contents of the data pretty nicely and succinctly. So it's a very useful thing to do, right? When you load in this data, this is very useful to do to sanity check, what did we just load? What does it look like? df.head, we can get a sanity check of what the data looks like after we load it in. And we could do tail, so that will give us the last 5 in the data set. Right, that'll give us the last 5. So you can see there's 4,600 rows. This gives us the last 5 of them. Sanity check that too. Usually we look at the first 5. Okay. So head and tail. Now, you were asking Roberto about a summary earlier. Here is a couple of really nice summary functions, which are going to be 2 that we'll use quite a bit. One is called the info, which gives us an information summary of the data frame, including all of the columns that exist, all of the data types, and if there's any data missing from those. So the df.info function, which you see used right here, is an incredibly useful function to give us a summary of what is there. Okay, it gives us a summary of what exists. So let me show you what that looks like on the example I just did. So on that house price data set, we looked at df.head. Let's do df.info and print out the information summary. So if you take a look at this summary, what it looks like is we have a total number of columns. We have a total number of rows. So 4,600 entries, that's 4,600 rows. We have a listing of all of those columns and how many non-null values they have. So you can quickly eyeball and see which columns are missing data, because we're expecting to have 4,600 entries in every column. Those are the rows. And this tells us how many were not null. So 4,600, that's a good number. That means we have full amount of data not missing. Right, that's pretty good. Not only that, but we get the data type. So what this would tell me is anytime I see object, I'm thinking of that as a string. thinking of that as a string. So the date is just a string of the date. The price is a float, bedrooms is a float, bathrooms is a float, square footage in the living room is an integer, square footage of the lot is an integer, floors is a float, waterfront is an integer, view, all of these things. You could see exactly what year that it was built was an integer, year that it was renovated. So you could see what all of these columns are about these houses. It's all different attributes of the houses. These are all strings, so they're related to like street, city, zip, country. They're all address related things. Are all, strings. That's not surprising. So you can see that we have a bunch of float columns, a bunch of integer columns, about 5 string columns, and this is how much memory our data frame takes up. That's a pretty good summary, I would say. Is this the summary you were looking for earlier? Okay, that's a pretty good summary of all the columns and their data types and not null. This is a great summary. Yeah, so this is df.info. df.info gives us that information summary about this data frame. What is non-null? Non-null means not missing, like not null values, not missing. Right? Meaning it's like not empty. Okay. So we have info, incredibly useful. Now, do you guys remember this? We had this for the series, was the describe. Now, this gives us a summary of the statistics. And now if we take that describe, remember, it was operating on every series, but what is every column of our data frame? Let me ask you guys, what is every column of our data frame? What kind of data type is it? There we go. Yes, it's a series. So should we be able to do describe to every column? Because remember, describe was a function on a series, right? We've already seen that. Describe gave us a summary, a statistical summary of our series. So it should be natural to extend describe to the whole data frame. That should be pretty natural. And we will. So basically what describe will do, we'll take that same exact describe that we did on a series and we'll do it across every column. Every column that is, the catch is, it's only going to do it to columns that are numerical data types. So it's not going to do this to strings, okay? Because it doesn't make sense to compute like an average or a median or a percentile. Right? It doesn't make sense to do that to object columns. So it's only going to do this to numerical types. So it's going to do that summary for every numerical column. So numerical meaning it's some type of integer or float. It's going to compute the min, max, average, median, percentiles, standard deviation. All of those are going to get computed. So that's a great summary. That's a really great summary to get a sense of what our min and max, like our range is, what our average is. That's a great summary as well. So let's run that on the housing prices. So we go back up. We just did info. Let me do df.describe. So this should be computing those averages. So this is going to be computing those values across all of those numerical columns here. So for the bedrooms, the minimum is 0, kind of wacky, 0 bedroom. And the max is 9. So there's a 9 bedroom house in there. The minimum bathrooms is 0. I'm gonna guess that's likely because it was missing, so it just filled in a 0 in the spreadsheet. but the maximum bathrooms is 8, and the average bathrooms is about 2, little over 2. The average bedrooms is about 3. I think that makes sense. It's pretty reasonable. Just sanity checking. Just sanity checking that. And then we see that the average price is sitting here about 55,000, or sorry, 551,000, I think is what that is. Because Roberto, I mean, it's not missing, but it was filled in with a 0 ahead of time. So there technically is a value there. It's just meaningless, basically. But there is a value there. It's just kind of like defaulted. Yeah. So you're right. Like 0 bathrooms would make no sense. So that data is probably not good. Probably not very great data, but it's not missing. There is a value there. It just happens to be 0. It was probably like whoever was recording that data didn't have a number of bedrooms and bathrooms, so they just put 0. Does that make sense? Like if you were filling it out from a survey or something, they probably just put 0 as a default. You didn't know what it was. Just put 0. How can you remove scientific notation? You can display it, I think, as a normal value. So I think if you grab, let's try this. Okay, so if you set that at the pandas level, which will default that for everything, yeah, that works too. I like the round though, because we can be a little more selective on when we do it instead of just doing it by default to everything. But thanks for, yeah, I agree that should work, setting it at the pandas level. Thanks for supplying that. Yeah. Yeah, Roberto, this is just rounding the describe results. It's not rounding the real data. No, it's just rounding the describe results. That's true. Okay. What do we think about describe? Does it seem useful to you guys? Does it seem useful to have a nice summary view of the statistics? Like you get a mean, you get a min, you get a max, you get remember the 50th percentile is the median, right? You get the median, standard deviation. So about the average house price in this data set is about 551,000. Now there's a max that's way out there. Looks to be like 26 million. I mean, that seems like an outlier. I'm gonna guess it's this 9-bedroom, 8-bathroom one that has 13,000 square feet. But seems like seems like an outlier potentially. But maybe we'll study that later on when we get into identifying outliers and such, which we will. But that seems like yeah. And the square footage of the lot. I mean, this seems like a lot of land. So that's, we'll have to see if that's an outlier or not. Okay. All right. So let's go back to our function. So we had describe. Now, the shape we know we can get. So that's just an attribute. This isn't even a function. This is just if we ever want to see how many rows and columns we have, we can do dot shape. So we go back to our data. We can do, so we had the statistical summary. We can do df dot shape to see how many rows and columns we have. So we have 4,600 rows and 18 columns. That we know that's what we had. So not surprising there. We can always do dot shape to see what we have. Now, what's interesting is we can also do dot columns to get a list of all of the columns that we have. So that's another useful one if you want to quickly see, if you want an exact list of all of your columns. So df dot columns. This gives us a list of all of our columns. So we can quickly see which ones we have. And we have a list of those guys. So df.columns gives you the kind of listing of all the columns that are in your data frame. All right, loc and iloc, we've already talked about. Those gives us the ability to access data. So we have, those are the same from series. We just did some examples with those, so I won't spend too much time on them. I want to get to a couple of interesting ones. Any idea why I'm not getting my house price head or tail? Data load is complete. Are you running it like what did you load it into? What did you name the file when you did read CSV? What did you name it? Okay, so you should be doing df csv.head. Does that work? You could try, you can either run it in the cell or you can try printing it. Either one should work. If it's not working for you, you could try restarting your session. You could, if you're in Colab, you could try restarting your session and rerun it. Maybe that'll work. Okay, it works. All right, great. Yeah, that should work. Just df.head. That's what I did here. You don't need to do it with print. You can just do it in a cell and run it. Should work. Yep. Should work. Okay, so we can sort, we're going to do some examples with sorting down below. But what we can do now, what's interesting about a data frame is when we sort it, now we have columns at stake. So sorting is a little more complicated. We have to decide, how do we want to sort this data frame? Which column do we want to sort the rows according to? So that's where sorting the data frame has the ability to sort by one or more columns. So here you pick which columns you want to sort by. You can. We're going to do some examples with this, but you can basically sort by. You can sort by one or more. So you can say, hey, I want to use the square footage and sort everything from greatest to least square footage, which will shift all the rows around according to that square footage column. You could sort by the number of bedrooms, number of bathrooms, right? We can pick which columns we want to sort by. So that's the only thing is, like, when we're sorting a series, we just sort the data. It's only one dimensional, right? So we just sort it. But when we have a data frame, we have to be more selective and pick which column we want to sort by. So that's the only thing that we have to be careful about. So we'll do some examples with that. Now we have some another interesting function here that we're not going to get to today, but we'll cover this in our later lesson 8 or 9, or sorry, 9 or 10, when we get into working with our data. But data frames support group by operations, which is basically, like, if you're familiar with SQL, doing a grouping of the data according to a certain column, and then we can do aggregations based on that group. So we will learn about this later, but data frames support grouping according to certain columns, which is really useful. So suppose we want to group by number of bedrooms. So we want to take all of the houses that have a certain number of bedrooms. So all the 2-bedroom houses, all the 3-bedroom houses, all the 4-bedroom houses. want to group by those and figure out what their average price is. We could do that. We could group according to the bedrooms and then do like a mean on the price. Those kind of slicing and dicing we will be able to do later. We're not going to get into it today because it's a little more advanced, but we're going to have a whole lesson dedicated to doing this in the future. So we'll come back to group by later on. But that's a really, really useful, as you can imagine, right? Grouping by column is really useful. So we'll get into that later. Now, one function we've already seen, and it will show up here again, is the apply. So we have that basically the same to where we will be applying a function usually to a column to transform that column. So usually we will apply to a column or maybe multiple columns in order to transform them. So maybe we want to take a column and multiply everything by 10, or take a column and square everything or divide it by 5, or whatever the case is. We can use df.apply to apply a function to a particular column, just like we were talking about with series, because what is a column? It is a series. So it should make sense that we can apply a function to that series. And so we will be able to do that. We're going to see some examples here of using apply to transform an entire column of a data frame according to a function. Right. So remember, the argument to the apply is a function. So we're passing in, hey, what function do I want to transform this entire column according to? Do I want to square everything? Do I want to cube everything, take the square root of everything, take the logarithm of everything? And really, when you're looking at the column level, that would be every row, right? Every entry within that column we're going to transform. So we will do that in some examples coming up. So we're going to see apply. Now, something we're going to see later on that that will be also in the same basic lessons that we're going to learn about group by is going to be the merge or concat. Now, this will be able to take multiple data frames and merge them together. That's incredibly useful. You can imagine like loading in data frames from multiple files, and those will create multiple data frames, and we want to bring them together in some way. So merge them, like join them together like you would kind of like a database table join. We'll be able to do that, or just actually concatenate them. Just maybe they represent the same column, so we just stack all the rows on top of each other in a concatenation. So the ability to merge or concatenate data frames, we'll learn about that later. I don't think we'll do any examples today of those, but we'll, again, whole lesson dedicated to grouping, a whole lesson dedicated to merging, concatenating. So we'll certainly cover that later on. Okay. By the way, any questions about any of these functions so far that we've kind of touched on? We're going to do some examples. We're going to do apply. We will do sorting. I'll show us that in a minute. But any questions about some of these functions so far? Good? Okay. Nice. Okay. All right, so a couple more. What's really nice, and we're going to learn in the next lesson on how to do this alternatively with Matplotlib and Seaborn and some of the plotting libraries, is data frames have built-in plotting that uses Matplotlib as kind of the backend to do it. But you can actually directly from a data frame plot columns, which are really useful if you want to quickly visualize something about that data frame. So if you want to actually see what is a bar graph of or a histogram of all the housing prices, we could do that really quickly just with the data frame. We don't need to use any additional plotting libraries. So that's usually for quick plotting. We're going to see some examples of this coming up of how we could do this within this notebook. We'll see some examples of doing this, but we'll also, in our next lesson, in lesson 5, we'll talk more about plotting. Lesson 5 will be all dedicated to doing plotting with the more sophisticated libraries that are dedicated to plotting. But just for doing something quick, the data frame actually supports plotting directly out of the box. We can do something like df.plot and directly plot attributes of it, rows and columns of it, which can be pretty useful. All right, finally, data frames have the ability to drop rows or columns. So if for some reason we need to delete rows or columns, we can definitely do that. A pretty typical use case for that is maybe we load in a data frame from a CSV, like a file, and there's some columns we just don't need. Maybe there's a user ID, or there's some type of useless like extra column that's snuck in there that we don't actually need. We can go ahead and drop it. So you can drop multiple columns, you can drop multiple rows. We will see some examples of this as we go along, but pretty typical use case is dropping columns. And usually what you do is you just pass in the column argument here of which column do you want to drop. So it's like, okay, I have a user ID column. I don't really care about it. I'm gonna drop that, but doing df.drop and then go ahead and pass in that column index to go ahead and drop it. Okay. So we'll see an example of that coming up shortly. Okay. Any questions on some of these functions? We're going to jump into some examples next of some of these guys that we've been talking about, but before we do that, any questions on any of them? Okay. Very good. All right. So let's go ahead and take a look at some examples. So we're going to have some fake data here in our data frame. So we're going to build out the data frame we kind of had earlier, very similar one. We put that in the data frame, pd.dataframe, build the data frame here. Oh, you had a question on the merge. Left and right, no, those are the two data frames. So this would be merged together. So this would be df1 and this would be df2. We have two separate data frames and we're merging them together. The on is usually a label of a column that they share. Like if they share a primary key column, then that would be like a join. Yeah, Roberta, that's like a SQL join. Yeah, this would be an inner join between these two tables, and we have a join key here. That would be a column. This would be a column that we want to join on. We'll learn about that later. Yeah, we're gonna have a lesson dedicated to doing that. Okay. All right, so if we were to go back to this example, now head and tail, no surprises there. We can print out the head and the tail. This gets us the first two rows. This is the last row. So first two rows should be these guys, and then the last row would be this guy. So we can take a look at that. First two rows, again, here's those. Last row, this is this. I don't think there's that much surprise with head or tail. I think we're pretty comfortable with that. Info we've already seen before. So the info about this one is that it has these 4 columns here. It's not missing any values. It only has 3 rows. It's not missing any data there. It's a pretty small data frame, only 220 bytes. Makes sense because we don't have that much data stored in there, just some integers. It's not that big of a data frame. Only has 3 rows. And the shape of it, so we can print out the shape. It is a 3x4 data frame. It has 3 rows and 4 columns. We know that. It makes sense, right? Not that surprising there. But some of these things we will see, like, now let's sort it. We could actually sort some of this. Let's sort this data frame. Let's do some additional code here and sort it. So let's go ahead and do print, and then let's do df.sort values. Let's go ahead and sort according to, this is where we pass in the column that we want to sort by. So let's go ahead and sort according to this. Oops, I'm in the wrong section. Let me sort. I want to sort this one. Let's sort according to column. Which column should we sort according to? Maybe this one, which is unsorted. Let's sort it from least to greatest, so column name. Let's use column name as the column we want to sort according to. Let's see what this does. Oops, this might need to be, sorry, this might need to be a list. Oh, I didn't run this yet. That's why. Okay, there we go. So it ends up sorted. So see how that now shifts around this guy to be sorted. Now all of the rows are sorted according to this column. So we went ahead and sorted that, which will you see how originally it started as 5, 15, and 8. Now it's been sorted from least to greatest, which is the default. But of course we could change that to be ascending equals to false, and it should now do greatest to least. So 15, 8, 5. So that's the primary sorting that's done. And so that's an example of sorting. We could also, so this is an example of sorting. And then we'll do an example of dropping. So let's go ahead and do df.drop. Let's go ahead and drop the column. Let's drop column 1. Let's say we deemed that guy to be pretty useless. We're going to go ahead and drop that one. So we can go ahead and drop that column. Now, one argument here I forgot to mention is that if we don't, the default is to not do this permanently. In other words, if I run this, it's not permanently going to be dropped. We're just going to get a copy of the data frame as if it was dropped. So we're not going to get, so I could save this result as df with, and save that as this. And what that will do is it will pretend that we had dropped this column from this data frame and store that result in this new data frame, which is a copy of the original. If we don't want to do that and we actually want to permanently drop, then we can set this argument called in place, and we set that to true. Now, what that will do is it will permanently drop that so that this data frame no longer will have this column 1. So we can do that, and it will no longer have column one. Oops, I may need to have this inside of a list. Oh, I think I need to do columns equals. There we go. So now if I go ahead and do df, it no longer has that column, right? It no longer has that column in there. So this is saying I want to drop this column, and I want to do it permanently. So therefore I go back and print out the df. It no longer has that column in there. It's been deleted. I've like permanently removed that. But if I don't do in place, let me show you. If I don't do in place, let's rerun this. I want you to see the difference. If I set this to false, which is what the default is, then I do that, and then I print out. If I go back and look at the df, it still has column one in it. So it's not permanently deleted. I just get this copy when I do this. And I can certainly store that df with drop. And then I can display this, so df with drop. And now this guy does not have column one, but if I go back and look at df, it still has that column. So you have to make that choice when you do these drop operations. Do you permanently want to alter that original, or do you just want a copy with that dropped column? It's really up to you, but either so if you want to permanently alter the data frame, you set in place equals to true. It will permanently drop it. Does that make sense to us? In place equals true will permanently drop it. Any questions on that? We stopped using it earlier. So I stopped using it because when you're working with data frames, you don't need to print out everything. You can just run it in the cell and it will render the data frame directly in the cell. That's a specialty of notebooks. They render data frames for you very nicely. So you don't need to directly print everything. You can just execute the data frame and it will display it in this nice kind of like table format. So yeah, I should have called out sooner. We can do both. Like if I print this, it's just gonna display it in a lower cell. It's just gonna display it like this. It's not gonna be as nice. If I just, it's still the same data, but if I just do df, it's gonna render it as kind of a table, which is nice. That's just a feature of the notebook. All right, so this is the 4.03 notebook. So you have a moment, you want to pull this one up. This is the one we had finished last time. We had just gotten to the beginning of it. This is where we left off on. And we had skipped down to this portion of it where I had mentioned that we have the ability to convert dates that come from our data as a form of a string. We have that ability to convert those dates over to a datetime object, which is really advantageous in Pandas to do because we can extract a lot of information from that object and manipulate that object a lot better as a datetime object rather than if it was just a regular string. It's not that useful. So this was an example of doing that. I just wanted to recap that. Here we have a single column, which is the date column. And so if we were to do df.info at this stage, which is what I put there in the code to kind of do like a before and after. If we currently look at that info, it tells us that the date is an object type, which is Pandas's way of saying that's really a string. And we know it's a string because we are hard coding the data as a string, right? So it's being read in as a date string. But one simple line of code we have here to overwrite that date column and set it equal to a conversion, which is to take your existing string date column and pass it into this toDatetime function. What that's going to do is Pandas is going to convert those strings over to what are called datetime objects. And you can tell it's a datetime object because when you look at the info after doing that, you can see that now we go from a generic string over to datetime 64 object, which 64 just represents the precision. It's down to like, it can go down to the nanosecond of time. Yeah, Tim, it guesses. So there is an argument here in the toDatetime. There is an argument here to supply like a format string to say like, here's the expected format of these. Here's the expected format of. So see how there's an argument called format, which would be something like this. We can do format equals, and we can pass in a string to say like, okay, we should have years, months, days, something like that. So if we know ahead of time what it is, we can pass that in, but Pandas will take its best guess based on what the string looks like. So in this case, it is like this, right? It's years are first, then months, then days. So it is like this, but Pandas will guess at that and take its best guess based on the underlying string. But yes, you can change the format here that is expected when you're converting the strings into the datetime objects using this format argument of the toDatetime. Does that make sense? So you can override it, but Pandas does a pretty decent job of guessing what it is. Which is the default behavior. If you don't specify kind of a specific format, it will try to guess what it is based on the string. Okay, so why bother doing that? Well, it's because once we have it as a datetime object, which it now is, we can extract various pieces of information about that date. So, for example, we in order to access attributes about the date, we use the DT property, which is short for the datetime property. So we're accessing the datetime attribute, and we're accessing the day of the week. So, or sorry, the day of the month. So this would give us like the numerical day. In this case, we know from the string it should be 1, and it should be 2, and it should be 3. But we're actually going to generate that into a new column. This is going to take every date and extract its day of the month. So this extracts the day of the month from the date object, from the datetime object. Okay, that's what this .day does, is it extracts the day of the month. So, and we should end up with a column that has 1, 2, and 3 as oh, I'm sorry, not those. Should be 1, 15, and 20. Those are the days of the week. So let's get the format right. Similarly, we can extract the month of the year. So this is going to be the first month of the year. This is going to be the second month of the year. It's going to be the third month of the year. And that's going to be the integer month. So this will extract the integer month of the year. So first, second, third, fourth, all the way to 12. And then this will extract the integer year. So we know these are all 2023. So every one of these should be 2023. But of course, if we had data that had different years, we can extract that year directly from this date object. And so in a way, you can think of this toDatetime function as kind of like parsing the date. It kind of parses the date for us. so that we can extract pieces of information out of that date that we may need to know. We may need to know specifically what is the day of the month, what is the month, or what is the year. You may care about only those pieces of the data. So if we take a look at it, you can see that these turn into integers because these new columns have the extracted information from these dates. What's great though is even when we have datetime objects and we go ahead and print or we display the datetime object, it still displays like a normal, formatted date, which is nice. Like it doesn't display as a generic object. It actually displays as same thing kind of as a string, but we know it's a datetime object, and that's what allows us to extract these bits of information out of those dates. Okay, so that's pretty useful. Now, these are not the only pieces of information we can extract. We're actually going to do some more examples with it, but those are pretty useful just to be able to extract the day, month, and year from the string. Any questions on that? Good. Okay. All right. So let us continue then. We also can extract other things from the datetime objects. So we have an example right below where we actually, instead of converting strings over to datetime objects, we are going to basically build a date range. So Pandas supports building a custom range of dates if you want to build. So this will create a custom range of datetime objects. So what this means is we want to build a range that starts on this and has 5 days essentially. So the default is how many days do you want to separate from the start? So think of this almost like a slice of dates. We want to start on the first and have 5 days worth of data. So when we first look at our data frame, it starts on the first and goes all the way up to the 5th because that is 5 total days. So if we change this to 10, that would be 10 days starting from the first. We could do 100 days starting from the first. So think of this as number of days that we want starting from this exact date. This builds a range of datetime objects using this syntax. Okay. So what's nice is we don't need to convert anything here to strings. Because we're building a custom date range, it already is going to be a datetime object. And because of that, we can extract something like the day of the week. So this is an integer. So we extract the integer day of the week. And something I should say about that is Monday is 0. Sunday is 6. Okay, so it starts on a Monday as a 0 and then goes Monday, and then Tuesday is 1, Wednesday is 2, Thursday is 3, Friday is 4, Saturday is 5, and Sunday is 6. So this just gives us the integer day of the week. Why might we care about that? Because that might be useful data to know is what day of the week is a particular date. We can always extract that if we know the datetime object. We can extract the day of the week, which is not immediately known. If you take a look at this date, like January 1st, we don't know what day of the week that is necessarily, but Pandas can compute what day of the week that should be by just extracting that from the datetime object. It can extract that. Okay. Now here's an example where we can use that day of the week to create a new column. So we're going to create a new column called is weekend, and we're checking here if we can, if we divide by 5, if we get a remainder of, if it goes into, if the weekday if we divide by 5, if we get 1, that means that it must be a 5 or a 6, right? That's what this means. But the alternative is to do something like df date, and then we could just do .dt.weekday is greater than or equal to 5. That would probably be the that'll be the same thing, because the only 2 days that are going to be a weekend is a 5 and a 6. So if it's 5, it's a Saturday. If it's 6, it's a Sunday. So I think that would be, we could just do that. I think that would make more sense, is to just check this condition if this is a true or false. That would be the same. That should give us the same result as this. So this is a way of doing it, is checking the integer division by 5. If we get a quotient of 1, that means 5 will divide at least once into that day, which means it must be a Saturday or a Sunday, right? If 5 goes into that day fully at least once. That's right, JD. Yeah, it's a quotient. Oh, I'm sorry, I missed your question, Roberto. Are periods always days, or they can be weeks? No, they can be different. In the date range, you can change the frequency to be like a string. So the frequency can be like a day, it can be a week, it can be a month, it can be a year. Does that make sense? It's a character. The default is day, which is D. So this means 5 days starting from this day. That's what this would, if that's what you read with this. But we could change it to be months. So it'd be 5 months starting on this date. Does that make sense? That's a great question. Great question. Yeah. So it's this frequency parameter, which changes, like you can change it to weeks. So 5 weeks starting on this day. I think you can even do quarters. So like 5 quarters starting on that day. You can do Q frequency. But the default is day, 5 days. You can do time. You can also do hours. So you can do like hours, which is H, or minutes, which is M. So you can do those kind of frequencies as well. Actually, I think it's lowercase m for minutes. Uppercase M is months. Yeah, we can. I mean, yeah, we can run this. So you see how we did every month. It goes to the end of the month. So see how it goes to the end of the month for those 5 months. So monthly starting on this date. So 1 month from that then is 1 month from then is this, 1 month from then is this, 1 month from then is this, 1 month from there is this. And then just as another example, we could change it over to weeks, which should be changing this frequency to W and running that. So you can see you get weekly values starting on the 1st. And notice that the weekday is always the same, because that makes sense. It's just 1 week from that day. It's always going to be on the same weekday. For doing hours and minutes, yeah, that's true. So our date doesn't start that way. So it should be like, it should start like something like this. That's true. Our date should be something like this in order to use hours and minutes. But we're just working at like a daily level as a simple example. Biweekly, I think you could do, you could customize it. I think there may be a parameter here to do, starting, ending, frequency. I think there is, like, maybe a B is biweekly. I think it might. Yeah, I think it might have. I think it might have biweekly. Have to look that up though. All right. Let me ask you guys though, does it make sense how we're creating this is weekend column? Does that make sense how we're creating this is weekend column, which is coming from the day of the week? And initially, like you can either do it this way, or you can do the integer division by 5 and check and see if that's 1. The quotient is 1. Okay. Oh, it's biweekly. Yeah, it is 2W. Makes sense. Every other week. Yeah, biweekly. Let me stick with the daily for now. All right. Okay. So what I want to show you next is the ability to add and subtract periods of time from an existing date. So one of the advantages to having things in a datetime object. So here's an example where we convert the existing dates over to a datetime object. And remember, if they're already a datetime object, it's not really going to matter if we do the conversion. It's not going to produce an error, but it's not really going to do anything. It's already a datetime object. But supposing we were to convert those over, this is now guaranteed to be a datetime object. One of the things we could do is subtract or add, which does some type of shift of periods of time. And the way you do that is you use a pandas time delta object. So we use time delta objects to do date arithmetic. So basically shifting of dates. So for example, this is going to take our current dates and subtract 1 day. So time delta gives you an object representation of a period of time. So this is shifting our dates back by 1 day. And how do I know it's 1 day? It's because the argument in the time delta corresponds to those frequencies. Basically, like how much time am I talking about? Is it 1 day? Is it 1 week? Is it 1 month? Is it 1 quarter? Is it bi-weekly? So is it 2 weeks? How much time am I shifting off of these dates? So what this does is this is going to take every single date and subtract 1 day. That's all that means. The time delta is kind of a representation of 1 day being subtracted from the date. Now, do we have to subtract? No, we can also add to shift forward. So this is going to be, the first one is a shifting backwards. This is now a shifting forwards of our dates by 1 day. So this adds a period of 1 day to every date. Now, why is that useful? Sometimes when we're manipulating our data, we may want to shift the dates around to do some type of manipulation to the data. So we may need to shift our dates forward by a week. We may need to shift backwards by a week, or by a day, or by an hour, or by a minute. So if we ever need to do any of that plus or minus of a time period, we're going to use a time delta object to do that shifting forward or backward. So you can see what the result of doing this is. We have our existing dates from our date column, and the previous date goes back 1 day. So you can see what the new dates are for that column. They're automatically computed for you. That's the really nice thing about datetime objects. It's taking our existing dates, subtracting 1 day. So we get a new date object, which represents that shift back by 1 day. So we have 12/31. Here we're taking this, we're shifting it back by 1 day, which lands us on the 1st. Here we're on the 3rd, shifting back 1 day. It's going to give us a 2nd, and so on and so on and so on. So that time delta really represents like how much time do we want to shift by. Same with going forward. You can see what the next date is. If we take the existing date and we shift forward by 1 day, we get the 2nd. If we're on the second and we shift forward by a day, we get the third, and on and on and on. And so, when we're at the end of the month and we shift forward by a day, Pandas will handle going to the next month and shifting forward into, like, if we're on January 31st and we shift forward one day, it will go to February 1st of the next month. Right. And you can even see this, like when we shifted back one day, it actually went to the previous year. So it did a good job of recognizing, okay, we're on January 1st, we're on New Year's, want to shift back one day. So we need to go back to 12/31 of the previous year. So it's doing that math for you as long as you shift by a time delta. It will do the math for you of what the new date should be. Okay. Any questions on these time deltas? Do those kind of make sense? Time delta represents a period of time, and you can manipulate existing dates by adding or subtracting time deltas to existing datetime objects. That's the thing to be wary of, is if you add or subtract time deltas, it's only going to work with existing datetime objects. It's not going to work on strings. Okay. All right. So here's an example where we have a couple more time delta examples. This creates a frequency. This creates a date range that starts at January 1st, but has 10 hours of time. So it's going to generate 10 hourly intervals starting on the 1st, which assumes that it's at 000 of the 1st, goes forward 1 hour 10 times. That's the date range. And we can shift forward that time by 3 days, or however, we can shift forward by hours. Like if we replace this with hours equals 3, we can shift everything forward by 3 hours. So time deltas you can just pass in different arguments here to represent different periods of time, like weeks, months, hours, years, quarters, those kind of things. So here's an example where we take all of those existing dates and we actually shift them forward by kind of an arbitrary amount here, which is shifting forward by 2 weeks, 3 days, and 12 hours. So you can see the starting date is the first. The starting date is the first, and then we shift forward by 2 weeks and 3 days and 12 hours. So we go 2 weeks is 14 plus another 3 plus another 12 hours. So that brings you into the 18th at 12. And this was the first hour. This shifts forward to the 18th at 1300, on and on and on. Okay. Any questions on this example? Good. Okay. So hopefully we're comfortable with time delta. How many iterations it takes? We only have to do, so we are adding to the entire column all at once. So it doesn't do any iteration. It just does it in one execution. So really just one execution to add all the time delta to all of those dates. Because we had 5 rows, right? We had 5 initial dates. So we started out with 5 dates. This is taking the entire date column, which has 5 entries, and adding this amount of time to it. Does that make sense? Like we had a column that had 5 entries, 5 dates. We produced that up here. We produced that. Actually, I realized I didn't run this. So if I rerun this, this should be the proper, yeah, there we go. It should print these does that make so sorry, now it has the proper number because we had 10 periods. This data is based off of running this cell first. That should be proper now. What is range 1020? So range, do you remember what range means? Range is a list. So a list of values that start at 10, go to 20, but doesn't include 20. And it increments by 1. So this is just a list of numbers 10 to 20. And this is a list of numbers 0 to 9. Does that make sense? That's the range function in Python, which creates a range of numbers with a starting, you just give it a starting and a stopping point. If you only have one thing, this is the same as having a starting point of 0. It's not being used in this yet. It's just here as additional data columns. These are just additional data columns that are in the data frame. It's not really being used with the dates. It's not really being used with the dates yet in this example. It's just mimicking if we had extra columns of data. But yeah, no, it's good questions. Good questions. Yeah, well, because there's 10 rows, but yeah, if that's what you mean, yes, there's 10 rows, so it'll do 10 shifting of dates by this amount. Yeah. Okay. Any other questions about the time delta? This is an example of time delta. We're using a time delta to shift forward. It's the shift forward time. So if you have a data frame, or you're working with dates, it can be helpful to generate a new column that is like a 1 week ahead of the dates, so that like maybe you can do filtering on a different collection of dates that is shifted forward in time. Okay, so it's useful for generating new dates that are shifted from your original dates. That's the purpose, is to generate new dates from the existing dates, which comes up in data analysis. It comes up in plotting. It comes up in a lot of scenarios. Yeah, it can go back. You can subtract. If you subtract, it goes backwards, right? Yeah, you can go backwards. You just have to subtract, right? Because subtract will take the existing date and go back by 2 weeks, 3 days, 12 hours. If you subtract. If you add, it goes forward, right? By that amount of time in the time delta. So I think we had an example earlier of going backwards, like here. This goes back 1 day. This goes forward 1 day. Yeah, so to go back, you just have to subtract a time delta. Okay. Now, I want to show you something really important with time series data that's actually going to show up quite a bit when we get into doing more analysis and doing some plotting of time data that is indexed by time. And thing we're going to take a look at is something called resampling time series data. So what this means is that the dates can be at whatever interval that they are. So I can have dates that are at the day level, month level, year level. I could have hourly dates. I could have time that's at the seconds, and I can have a bunch of different rows that represent data at the second level, day level, whatever it is, right? So resampling is the process of aggregating those times to be at different intervals than what I start with. So let's say I have data that is at the hourly level. So I have a record of like a temperature. Let's say I have a record of a temperature that is, and then I have the date, I have it recorded at every hour. So I have it on 01, 01, 01 on that day, but I have it at 0, 0, 0, 0, 0, 1, or sorry, 0, 0, 0, 0. So I have it at the very beginning of the day, and I have the temperature as let's say 40 degrees Fahrenheit. So I have 40 degrees, let's say. Okay, and then I have another recording at the next hour. So I have a data point that is at the same day, so 0, 1, 0, 1, 0, 1, but then I have it at the next hour, which would be 0, 1, 0, 0, 0, 0. So let's say I had a record here, and it's now 41 degrees, let's say. Okay, so and on and on and on. So I have a bunch of data that's at the hourly level. What we can do is we can actually resample this to get an aggregation at a different level. So let's say like I don't really care about what the temperature is every hour. I care what the temperature is across this entire day. So I only care about it across what is it on average across this whole day. So I could boil down all of these dates into a single record for that day. So I could just have an entry for 0101, 2001, let's say, and I have now an aggregated temperature here of it's like 53.7, let's say. So now, and then I go and so then I have a bunch of data that's at the hourly level for the second, but I can aggregate that down to an average for that day, which is maybe 54.2. So something like that. So this process is called resample or resampling, which changes the frequency, basically aggregates the data at a different frequency than what it is recorded at. So let me give you an example of that. Let's say I had a bunch of values that are recorded for each day, and I wanted to get an aggregation. Let's say I wanted to get an aggregation in our data frame. So you see how I have a bunch of different values that are at an hourly level currently for this data frame. What I'm going to do is pick all of my numerical columns. That's I forgot to mention this. Let me come back to this in a moment. This picks all of our numerical columns. So basically exclude any strings, exclude any objects. Let's just pick all of our integers or float columns that we have. And what we're going to do is we're going to resample those at a daily frequency. So I'm basically going to roll all that data up into an aggregate, and which aggregation am I going to choose? You can put that at the end. So you can take a maximum, you can take an average, you can take a median, you can take a sum. Any of those pandas functions that we've seen that do a statistical operation, we can do a count, we could do a total, which is what we're doing here, the sum. We can do a mean, we can do a max, we can do a min. But this is what this is doing is aggregating that data at the day level. So notice that we take all of this data, which has 10 different entries for these columns. Let's print out our data frame so far. So our data frame has existing dates, it has these existing values, and it has these time delta shifted dates. But what we're going to do is basically aggregate all of this data to be resampled at the day level. So it's going to produce a single data point for this day. Does that make sense what it's doing? We're producing a single data point for the day. And we have to say, how are we doing that? How are we aggregating? Well, we're really taking a total. We're taking a sum. So we're actually going to sum all of these guys that correspond to that day. We're going to sum all of these guys that correspond to that day and get a total for that day. But, you know, we don't have to use a sum. We could do a min or a max or an average. So we can, of course, replace this with mean. We could replace it with the maximum across that day. We could replace it with the minimum across that day. But here we're using the total across that day. And how do I know it's resampled at the day level? It is because this is the frequency of our sampling. So we are producing a data point at the day level, knowing that we already have values at an hourly level. We're aggregating them to the day level, and we're aggregating them via this function, the sum. So see how our other two columns produce totals of 45 and 145. Yeah, you can. So yes, what you would do is you have to do it in two steps. You basically would generate the resample data frame, which is just this, and then you can do an apply. So actually that might be worth taking a look at, is then you kind of do like an apply, and then you can do a lambda or an apply your function here. Does that make sense? Like you can do an apply to basically apply your function to the resampled rows that you get, to like the aggregated rows. Yeah, you can apply a function to it. But the pretty typical thing is to do some type of aggregation to it, like a statistical function. In this case, we're doing sum to get the total for each day. Something I should mention is that doing resample assumes that the dates are actually the index of the data frame. So that's a big assumption. So you can only resample if the dates are the index of the data frame. So one of the things that we do first is we actually set the index to be the date column. Now that's important because if you take a look at the DF at that stage, once you resample it, if we were to print the DF before we do the resampling, oh, because I already ran this one, so I have to redo it. Let me redo it. Sorry. Rerun this. Rerun this. Rerun this. Okay, so if you take a look at our dates, or our data frame, so what we did is we set the index to be the date. So remember, if we don't do that, the default index is, see how when I printed it out before, the default index is the positional index of the rows. That's the default behavior when you create a data frame, right? It just gives us the index as 0, 1, 2, 3. That's the default. But we can overwrite that by doing this set index function, and we purposely want to permanently, that's what the in place equals true does, right? Permanently reset the index to be the date column. So now when we print out this data frame, you can see that the index is actually the date now. That is the index. There's no positional index anymore. The date is actually our index. And once the date is the index, then we can do resample. So resample assumes your data has the index as some type of date time object. So it's not going to work if you just have if you have the default positional index. Resample won't work. Yeah, Roberto, let me explain that. I'll explain that in a second. Do we see what I'm saying by resetting the index? Where this is a way to set the index on a data frame to something that we like, an existing column. So saying, okay, set the index to the date column. That's what I want the new index to be, and I want to do that permanently, which is why I have the in place equals true here. So we let me write that down as a comment. We permanently in place equals true. Set the index to be the date column. Permanently do that so that resample will work. If in place equals false, then remember it doesn't do it permanently. It gives you a temporary copy of the result. So you would have to do something like df temp is this, and then we would resample df temp, because this will, like, if this is false, then it doesn't permanently affect the underlying data frame. It only gives us like a view of the result. So that's why usually, yeah, we don't need to do this. If we just put in place as true, that will permanently alter it. And then we could just operate directly on the regular data frame. Yeah, you could set the index back. So once you're done doing that, you can reset the index. Let me show you how to do that. So you can reset the index to the default by using this, which is you can do df.reset index, and then you want to do in place equals true. Okay. So you want to do in place equals true. Does that make sense? This will reset the index to be the default. It'll just reset it back to the default. That's how you set it back to the number. Okay, let me go back and explain, because it's a good question. What does this mean? So the select D types is a way in Pandas. Select D types is a way to select data. So one way to select data is to use the brackets, right? And we can put in filters in the brackets. We can have many different conditions in there that will pick out the rows that we want to return when we're selecting data. But select D types will select rows, or it will select data from the data frame according to what we include or exclude. So include, if we have an include argument, that means I want to return all data that is numerical in type. That's what select D types does. So this will return all data that is a numerical data type. So what does numerical mean? Think of int or float, right? Some type of numerical data type. So the reason we do that is because resample is not going to be able to aggregate things that are strings or other types of objects, right? Does that make sense? Like it's not going to make sense to aggregate a bunch of data at the hourly level down to a day when we have something that's like a zip code or something like an address. It's like, how do I take the average of an address? Can't really do that. So what this does is it filters the data to only include numerical values, right? Only include numerical values when we do this operation. So this is like a select D types is like a filter. It's like a shorthand. It's like a shorthand Filters to only columns with numerical data types. Does that make sense? Any questions on that? This returns a portion of our data frame that has only the columns that are numerical data types. So if I were to read this out loud, and this might be helpful, it's like if I read this out loud, what this is doing is saying, okay, take our data frame, filter our data to only the numerical columns, aggregate it at the daily level, and aggregate with a sum. That's how you read that, right? That's how you read that from left to right. Take our data frame, filter out only the numerical columns, aggregate it at the daily level with a sum. The date isn't a string. We've changed it to a date time object. We've changed it. It's a date time object. It's not a string. Yeah, that's what it's doing. Aggregate all columns which have numeric data. No, so that's the thing is the date time object has been put as the index. It's not a column anymore. So that's why this code is so crucial to set the date, which was originally just another column, as the index. So it's not going to get aggregated because it's the index. We set it as the index on purpose to facilitate the resampling. And let me make a comment here that the D is for daily aggregation. Obviously, we could do yearly, we could do weekly, we could do quarterly, we could do monthly. We can do different types of frequencies there. Basically the same frequencies that we could do earlier in the date range, we could do here in the resample. So see how the main takeaway to this is we go from data that looks like this at an hourly level to a single value for the day. We go down to a single value for the day for those numerical results. Now that is extremely powerful. Like that resampling operation is extremely powerful to be able to aggregate time-based data at different frequencies. Really useful, right? For summarizing, for generating reports like quarterly reports or like yearly summaries. Like it's extremely useful function. Categorical data is, data that belongs to usually a distinct number of categories or discrete number of possible values that it can be. So for example, we may have data that is usually this would be like in the form of a string, and there's only a certain number of possible strings that data can be. So like, for instance, what if we had a column that had values that were like this, where the entries in that column were only things like low, medium, high, and those are the only three values we saw. That is definitely a good example of a categorical column or categorical data. Because in that setup we only have three discrete possibilities, the data points are only going to be these three possible categories, which are low, medium, and high. Pandas does support allowing you to convert objects into categorical data into a categorical data type. And the reason you may want to do that is to have a sense of ordering or be able to sort based on those categories. So for instance, we can take the values that are like low, medium, high, and we can generate a categorical data from that, which is going to be basically a series which has a categorical data type. So this goes from a string, and the data is now going to be categorical, and we can tell it what categories exist. So in this case, only low, medium, and high exist. And we can say that there is a natural ordering, and the ordering follows the order that's inside of the categories list. So low is first, then medium, and then high. And it goes from least to greatest. So low is the least value, medium is the next, high is the highest categorical value. So all of our data now can be converted into a categorical series, which can be useful for sorting it, because now instead of sorting it alphabetically, which we may not want, because if we were to sort this, it would just be treated alphabetically as strings. Now, if we were to sort this, it's going to be sorted according to these rankings of the category, low, medium, high. So putting things in a categorical type often has a benefit of allowing us to then have some natural order amongst the categories, which can help us whenever we are doing analysis or sorting that data, or grouping that data and slicing and dicing it. Okay, so let me run this. So the what I want you to see is now the categorical variable is now it now is data that looks like this, and has 3 categories ordered from low, medium to high. So it goes from regular, the data starts out as just a list of strings, and it turns into basically a series that then has categorical data. So pretty useful. What we can do with categories as well is we can count how many unique values there are from each category. Now, we saw this, I think on Monday I showed us this, but showing you guys this again is you can take categorical data like we have here, or you can take data that's just regular strings. It actually doesn't matter if it's in categorical format or not. We can take data that's just regular strings, and we can compute the value counts on that column, which generates the number of occurrences of each unique discrete category. So in this case, we have data that only belongs to A, B, and C, but we can see C only shows up once, which is what this count is. B shows up twice, which is here and here. So you can see what that count is. And then A shows up the most, which is 3 times. You can see that's what that count is. Remember, you can pass in a normalize equals true argument here to create percentages. So half the data, this is signaling that half the data is category A, which makes sense. There's 6 entries and 3 of them are A. And then 1/3 of them are B, because 2 out of the 6 are B, and then 1 out of the 6 is C. So you can produce percentages. The default behavior is just to give you the total count of how many are each category. Now, this is extremely useful. Like when we get into modeling, this is going to be extremely useful, because often we're going to care about our data from the perspective of like, how many examples do I have of things that are like pictures that are cancer or not cancer. And maybe it's we run this value counts function on it, on the cancer column, and we see that most of the data is actually not cancer, which would be a pretty typical scenario. And then some of it, like some percentage of it is, but we can see that the majority of it is not. So this is a good way to kind of figure out what those relative amounts are between the members of the categories. So this looks like, there's mostly it's A, but there's a few examples of B and 1 example of C in this data. So value count is an extremely useful function on a column. Usually you run this on 1 column to kind of see what the categories are. So not only does it give you the counts, but it also will give you the unique categories within that column. Here we have an A, B, and C. We know that because we can see it. But if you imagine you loaded in this huge spreadsheet, you may not know all the discrete values that are in a column. You may not know that right away, but if you run value counts, you can actually get those. And not only that, you can get a frequency of how often those show up in that column. So pretty useful. Okay, any questions about value counts? Okay. Yeah, so normalize equals false is the default behavior. That's just going to give you the raw count of each category. So this tells us that there's 3 A's, there's 2 B's, and there's 1 C. So normalize is false. Normalize equals false is the default. So you don't even really need to put it in there. It's the default. And this means that we get raw counts of each category. So if we set it to true, we get percentages. So if we set it to true, we get percentages. So see how it changes to where A is now 50% of the data. So this means that of this column, 50% of the entries are A. 33% of them are B, which makes sense because 2 out of the 6 are B. And then 0.1677, that's the ratio of C. So there we have 1 out of the 6 examples are C. No, Tim, value counts is really a function on a series. So you should only be doing it on a single column because remember, what is a column? It is a series. So really should only be doing it on a single column at a time. Certainly you can do it on more than one column, but you're only accessing a column at a time and then doing it. Yeah. It's because it's a function on a series of categorical data. And that's the use case anyway, is typically the use case is to zoom in on one particular column or maybe a couple and do the value counts on those, the columns of interest. All right, cool. So value counts we'll see again. We're going to use this quite a bit here and there as we progress. This will be a really useful one when we get into modeling. Okay, really useful function for us as we will see later down the road. Let's talk about another really useful thing for modeling, which is to convert data from categorical into numerical. Now, this is an extremely, I really want us to understand this because this is something that is going to be extremely useful as we get into modeling, is machine learning models are going to not really be able to make use of these categories as they are, because it's not going to know how to work with strings out of the box, right? So because they're mathematical models, they're going to struggle to make sense of, well, what is an A string? What is a B? What is a C? What is a D? It's not really going to know what those are. So what we want to do is convert those into a numerical collection of data. And the way that we do that is we actually generate new columns which indicate the presence of that category or the absence of that category. Let me give you an example. So if we have this original data here, so let's just say we had a column called data and it took on these values like we see here. We have an A, we have a B, we have an A, we have a C, we have a B, we have an A. Okay, let's say we had that. Now, what we are going to do to convert this to numerical is generate some new columns that indicate the presence of each one of those discrete categories. So, for instance, we're going to create a new column that is basically going to be do we have data underscore A? Do we have that value? Do we have data underscore B? Do we have B? Data underscore C. Do we have C? Now, in this first row, do we have A? Do we have the presence of A? And we take a look at it and we see that, yes, this entry is A. So I should have a 1 here and a 0 here and a 0 here because I don't have a B, I don't have a C, but I do have A. So this is going to indicate the presence of A. And this is going to indicate the presence of B, as you can imagine. And likewise, this is going to indicate the presence of C. So in this first entry, I have A in our data. That's the first entry in our data. So I have presence of A. So I marked down a 1 for that column and a 0 for presence of B and a 0 for presence of C. Let me ask you guys, what do you think presence of A column is going to be for this next entry? So if I look at this entry, what's going to be the presence of A? It's going to be 0. Yes, perfect. You guys are right on top of that. This is going to be 0. Now, what is going to be presence of B? And how about presence of C? Perfect. So presence of C would be 0. Perfect. So does this process make sense how we are converting? So look at what we're doing. We're converting our categorical data into numerical data because now this is all integers, which is great from a model perspective. That's fantastic. I actually have numerical data I can work with. So that's fantastic. Now, what was the cost of doing that? I have 3 new columns. It's not for free. There's a cost to doing that. And you are going to always have that scenario where when you are converting your data over from categorical to numerical, you are going to get as many columns as you have discrete categories for your data. So this data here only has 3 possibilities. So I need to make 3 new columns that represent the presence of those 3 categories. Does that make sense? The presence of those 3 categories. So I have 3 new columns. Yeah, Roberto, I'm gonna give you a real world use case in a moment. I'll give you one in a moment. Let me explain again, because this is incredibly important to understand because we are going to do this procedure all the time. By the way, this procedure has a very special name in machine learning, which is called, it's this name called one hot encoding. So one hot encoding is the name of this process of turning categorical data into numerical data. That's called encoding, one hot encoding. Why is it called one hot encoding? Because you're using 1s and 0s to indicate the presence or absence of categorical data. Okay, one hot encoding is this process. turning categorical data into numerical data. That's what we're doing. And that's just the terminology. one hot is like hot is like that. It indicates presence. Like it's there. You can feel it. It's hot. It's presence. That's all it means. Yeah, it's live. It's active. That's the category that's active. You can think of it like that. Yeah. It's hot versus cold. It's like cold is kind of the absence of temperature. Okay, so let me walk through that again because it's really important that we walk through this and understand it. So this data example has a column called category. Okay, it has a column called category, which only has 3 discrete values. It can only be A, B, or C. And you can see the data here. The first entry is A, second entry is B, third entry is A, fourth entry is C, fifth entry is B, and last entry is A. That's what I have here with this data, right? I have that data there listed in a column. So for any time we have categorical data listed in a column and we're going to do modeling with it, we want to do one-hot encoding. We have to do one-hot encoding. The model will not be able to make use of the string. We have to do one-hot encoding. So we have to turn this into numerical data. So the trick to doing that is to generate 3 new columns. These columns represent the presence of those unique categories. So we have a column for presence of A, we have a column for presence of B, and we have a column for presence of C. Let me pause there. Does that make sense so far of the setup? So in order to convert our data to numerical, I'm saying let's create 3 new columns which indicate whether or not we have one of those categories, A, B, or C. The presence of A, presence of B, presence of C. That's all I'm saying is we're going to set up 3 new columns to represent this one column of data. We're going to generate 3 new columns called presence of A, presence of B, presence of C. And the way we're going to fill out those columns is we're going to look at our data. We're going to look at our data and we're going to say, what is the value of that data? It's an A. So therefore, presence of A should have a 1 because that means, yes, we have presence of A in that first entry, in that first row. Presence of B, no. We actually have absence of B. So we should have a 0 there. There is no presence of B. There's 0 presence of B. And there's no presence of C. So that also should be 0. So we have converted A into a 3 different columns, presence of A, presence of B, presence of C, where there's a 1 in the presence of A spot and a 0 in the other 2 spots. Okay. And we go down to our next entry. We look at B and we say, okay, how about B? It does not have presence of A, so that should be 0. It does have presence of B, so that should have a 1. And it does not have presence of C, so that should be a 0. So we have this, we have 0, then we have 1, and then we have 0 for that second row. If you have, so you're thinking correctly that if we have 10 discrete categories, we have to generate 10 new columns. It's going to be 10 new columns that we have to create to indicate presence of those 10 categories. Yes, they have to be 10 new. And we're going to have a pandas function that's going to do that for us. So if you're asking, is there a shortcut? Pandas will do it for us. Yeah, Pandas will do this for us. I'll show us the function. Luckily, Pandas does this for us. We don't have to do it manually. I'm just trying to show you the procedure of one-hot encoding and what it does so we understand it. Okay. Should it be a categorical variable or any data? So technically you can one-hot encode any data. Now, do you think it makes sense to one-hot encode numerical data? Do you think it makes sense to do that? Like, would we want to do presence of 2.3, presence of 3.5, presence of 4.7? Like, would we want to do that if we have a lot of, because what's the issue with floating point numbers? What can they be? What can floating point numbers be in general? Like, what's their range? Or even integers for that matter, like what's their range? Yeah, so the issue is that, yes, floating point values can take on any number. There's an infinite possibility of what those values could be. So we don't want to end up doing presence of 2.3 because we can have presence of 3.67521, right? We end up having to do an unlimited number of new columns to represent each one of those floating point values. It doesn't scale. So you really should only be doing one-hot encoding for categorical data. You should only be doing one-hot encoding for categorical data, like strings that have discrete number of possibilities. Does that make sense? Like that's when we want to use this, is for discrete number of options, which is what categorical data has. Okay. Yeah, I saw a question. 1 or 0 are constant with these numbers, no matter how many yeah. And does it make sense that only one of them is going to be a 1, and because you're only going to have presence of one of them in every row, and then every other one has to be 0. So you're only ever going to have a 1 once, and then every other entry has to be 0. That's what it has to be, because you're only going to have presence in one place. You're only going to have presence of one of these categories, and then every other entry is going to be 0. Is there a limit? And basically until you run out of memory, that's the only limit. So technically Pandas doesn't enforce a limit. Basically you can, if your data frame grows too big, like if you have too many unique values and your data frame grows too big, you are injecting too many new columns, that's when you would hit the limit, like the memory limit of the data frame of your machine. But like technically there's no limit. Okay. So let me do two things. Let me give you a real world example. Okay. Let me give you a real world example, and then let me show you the pandas function that will do this for us, the one-hot encoding, okay? So I'm going to give you a real world example first. So in the real world, there are a lot of categorical features that are, or I should say variables, that are going to be useful for predicting something. So for example, there's a lot of things that are discrete when it comes to recommendations. So think about something like Netflix. The genre of a movie is a discrete categorical variable, isn't it? So a movie is going to be something like horror, comedy, adventure, action, thriller, right? It's going to be one of those strings. So if we were to build a model off of that to do a recommendation, which is what they do, they generate recommendation models to recommend movies to you. the models are not going to understand those strings, but they are going to understand the numbers, which we can do the presence features like in the one-hot encoding. So a realistic example is to take like a movie genre that could be a unique category like comedy, action, romance, whatever it is, and convert that over to a one-hot encoded column so that a model can use that for recommendation. So movie genre, and then we could have genre. We could have a new column that's genre comedy, genre action, and then genre romance. And then we have, but these are like our presence. These are like our presence features, right? Or I keep saying the word feature, which I haven't taught you guys what feature means yet. But let's say column. These are presence columns. So genre comedy, there's going to be a 1 here, 0 here, 0 here. Action, there's going to be a 0 here, 1 here, 0 here. And romance, 0 here, 0 here, 1 here. So now a model is going to be able to work with these numbers. So a model is going to like a recommendation system is going to like that data a lot more than it likes this. It's not going to like strings. And we're going to see that when we get into machine learning. When we actually build our own recommendation systems, we'll see why. The numbers are so much more useful to the model than strings. So that's a real world example. And that's not just for recommendations, it's for a lot of different predictive models. A lot of predictive models care more about the numerical data rather than strings. So it's in our best interest to convert any categorical data into numerical data prior to building a model. It's really important to do that. So we haven't learned that yet. We haven't learned how to model or do anything like that yet, but we will. Give us some time, we will. Can Pandas use drive space as memory like R? What do you mean by like hard disk space? It can cache things, yes. Yes, it can cache things to the disk. Yes. So you will add those features to each. Yes, we will add those to. We will replace the strings with that and basically get rid of the strings. We will just have this and completely drop this because it represents the same data. We could put the values in an array, run a loop, and then use that to update the counter of each genre, like genre comedy. Yeah, like we could get a count, but a count doesn't tell us presence of that data in a row. Does that make sense? Like it's important to know that this row is comedy. This row is action. This row is romance, which is why we use a 0 or a 1. Right? It's because we're using it as a variable like presence of comedy, presence of action, presence of romance. We use a 0 or 1 for that. So you're thinking more about like counting the total number that we have, which may be useful for analysis. But I'm thinking more about it from identification, right? Yes, exactly. Very good, very good. Okay. Before I show you the Pandas example of converting things into the one-hot encoding, any other questions about the mechanics of it? Does one-hot encoding make sense to us? Like what it's doing? Any questions on it? I'm going to show us the Pandas example of how we can do it in the code in a moment. Okay, very good. Okay, so the way that we can do this in Pandas automatically to do the one-hot encoding is a function called getDummies. So in Pandas, there's a function called pd.getDummies, and all we have to do, all we have to do is pass in this column of your numerical data. And actually, what getDummies can do, getDummies is a very flexible function. You can pass in more than one column at a time. So you can pass in multiple categorical columns, and it will convert all of them into their one-hot encodings, which is pretty useful. But in this case, we only have one column, so we're just going to pass in this category column. And now you can optionally, you don't have to do this, but you can specify a prefix, which is the prefix is for the new generated column name. So that the prefix is the new generated column name during the encoding. So when we do the encoding, we could name this whatever we want. We can name it presence. We can name it. Typically, the default behavior is just to name it the column. So the prefix is just the column name. In this case, it is category. So, for example, this means that our new columns are going to be category prefix and then whatever the category value is. So category A, category B, etc. So whatever the discrete options are for that column, we can have the prefix. Now, one other important part of this is by default, the getDummies is going to use Booleans. It's going to use true or false to indicate the presence or absence. But we want to use numbers like 1 or 0. So the way that you do that is you change the D type to be an integer. So we want it to be integer result, which will change the true or false into 1 or 0. So we want to purposely end up with numerical data, right? We want to take our categories and end up with numerical data. So when we run this, you can see what we get. We get the, now this should make some sense to us, this result, because what we're getting here is the first entry is an A. So we get presence of A, 0 presence of B, 0 presence of C. That makes sense for the first entry. If you go to the next entry, it's a B. So we should have a 1 here in the category B column, which indicates presence of B. And so then the next entry is A. We get presence of A. That makes sense. The next one is a C. So we get presence of C there. The next one is a B. We get presence of B. The next one is an A. We get presence of A. So getDummies does the one-hot encoding for us. And the only thing we generally want to remember is to put in this data type of integer in here, which will ensure that the results end up as 1s and 0s, which is what we want. We want to convert those. Strings into numerical values. How it is used. I was kind of describing how it's used. I mean, so let me ask you this, like from a mathematical perspective, if we're building a model, how does a model that does mathematical equations, excuse me, how does a mathematical equation know what to do with a string? This is the fundamental issue of why we have to do this, is it's not going to know what inherently to do with a string. It doesn't know what to do with B. It doesn't know what to do with A. It doesn't know what to do with C. It doesn't know what to do with B. right? There's no way to really incorporate that as a number into a model. It's not really a way currently. Now, do we think that we can incorporate ones and zeros? Yes, we should be able to incorporate ones and zeros. So it's to our benefit to turn this data into this data. This is the same data. It's the same data. It's just represented differently, but it's the same data, right? It really represents the same data, just in a different format. One is one hot encoded and one is the original categories. Models are not going to be able to use this format. Models are not going to be able to work with that. Models can't work with these strings. But it's not like now they can't work with the strings, but it's not like we should ignore it. It's still useful information to know that, okay, this data is category A, this next row is category B, this next row is category A. Let me give you an example. In the house prices data set, do you remember how we had data that was number of bedrooms, number of bathrooms, and square footage? Those were all numerical. There were pretty useful categorical columns as well. So there were things like the neighborhood or things like the zip code, things like the address that are important categorical features as well that give some meaning to the house, like what state it's in. The state is a discrete categorical feature that may be really useful to tell what the average, like the price is going to change based on the state. So that is a useful variable to know, but we can't use the state as a string, but we can use presence or absence as ones and zeros. So that's where it's going to be used, is in our modeling. We haven't learned modeling yet, but this is where this is going to be an incredibly useful pandas function. Get dummies, right? Get dummies is going to be an incredibly useful pandas function to do one hot encoding. Okay. Any questions on the get dummies function? By the way, the get dummies returns a data frame. You can see that here, that we generate our new columns, category A, category B, category C. Those all get generated based on this input categorical data. So it spits out those. And of course, we're going to get as many columns as we have discrete values for this data. So if we had 10 different values in here, we're going to get 10 different columns that get produced. Any questions on that? Okay. All right. So as an alternative, something that we can also do that is going to be useful when we are doing modeling, and we want to, instead of doing presence or absence, maybe we want to assign each unique category with a numerical label that increments. So for instance, we could have a mapping here that says, well, A should be assigned to 0, B should be assigned to a label of 1, and C should be assigned a label of C. Oh, poll came up. Okay, thank you. C should be assigned a label of 2, let's say. So we can encode this way, which will also change over those strings into numbers by assigning a label to every unique category. So what we're going to do is assign A to 0, assign B to 1, assign C to 2, and on and on and on. Like if we had a D, we would assign that to 3, If we had an E, we could assign that to 4, and on and on and on. So we can do this, and then it instantly maps our data to a new column that would be like 0, 1, 0. It's exactly this data here that you see, right? All of those values get mapped into their labels. And so this is called label encoding versus one-hot encoding. This is just a slightly different way of doing it. When we do modeling, we'll always do one-hot encoding. Label encoding is useful when we want to assign a label to a category for the thing that we are trying to predict, but not for the input variables. The input variables, we usually will always do one-hot encoding. But for the independent variable that we are trying to predict, if it happens to be a category, I'll give you an example. So for let's say we were trying to predict fraud, and we had we had fraud. We had a column called label, and it was either a string that was fraud, not fraud, fraud, not fraud, and on and on and on. So there's only 2 possibilities. We could label encode this to have a new label that would be like fraud is a 1 and not fraud is a 0. Fraud is a 1, not fraud is a 0, and on and on and on. So label encoding is useful for the thing that we're trying to predict. We can assign a label to it that is numerical, because again, a model is going to struggle to predict a string. A model is not going to be able to predict a string, but it can predict a number. It can generate a number. So it makes a lot more sense to convert the thing we are trying to predict over to a number versus keeping it as a string, like fraud or not fraud, or cancer, not cancer, cat versus dog. We could assign a label of 0 or a 1, or maybe if there were 10 categories of animals, like cat, dog, leopard, panther, cheetah, wolf, we could assign like 0, 1, 2, 3, 4, 5. Like we could assign a bunch of numbers to those for the thing we're trying to predict. Okay, so one-hot encoding will be used for modeling, or our basically our variables that go into the model, and label encoding will be used to convert what we are trying to predict, right? The actual outcome label over to something numerical, so the model can have an example of how to predict that, like what number should it result in. Does that make sense? Any questions on that idea? I'll show us how to do it in the code. It's not hard to do. Which part? Which part, Roberto? It is, but if it's mathematical, how can it generate a string? That's the issue. It's like if I give you an equation and I put numbers in, how am I going to get a string out? Do you see the issue there? If I'm putting numbers in, how am I going to get a string out of it? Yes, exactly, JD. So one-hot encoding is used for inputs. Label encoding is used for outputs, because we need to convert those strings into numbers. Yes. Yeah, it is. It is, Roberto. So label encoding is also generating numbers, the same as one-hot encoding, but it's for a different purpose. One-hot encoding is specifically to say do I have presence of this variable or do I not? Right? But the label encoding is just assigning a label to something to directly convert it over as a mapping. So think of the fraud, not fraud example. I'm going to relabel that to a 1 and a 0. It's not about presence or absence. It's about relabeling it into a number so that when I'm predicting something, I have a number to go off of as an output. Yes, they go off. So the default behavior is to assign them to their index. Yes. Yeah, exactly. But high-priced house from a mathematical model perspective is likely going to be mapped to a 2, and medium would be a 1, and low would be a 0. Yes, in label encoding, you can have multiple values. So look at this example here. It has A is mapped to 0, B is mapped to 1, and C is mapped to 2. So yeah, you can have more than 0 and 1. With label encoding, you can have as many as you have possibilities. So if you're predicting 10 different animals, you're going to have 0 through 9. Like 0 could be dog, 1 could be cat, 2 could be fox, 3 could be giraffe. Do you see what I'm saying? So yeah, you can absolutely have more than 0 and 1 in label encoding. You're never going to have that in one hot encoding. Never going to have that in one. In one hot encoding, you're only going to have 0 and 1, which indicates presence or absence, which is important from an input perspective. This label encoding is only useful for describing the outputs of a model, because we generally want those to be a number, and we don't want it to be like presence or absence. We want it to be a single value, right? We want it to be a single value. So fraud would be mapped to 1, not fraud could be mapped to 0. Or like in the case of animals, cat could be mapped to 0, dog mapped to 1, fox mapped to 2, turtle mapped to 3, on and on and on. Okay. Let me show you how you can get the labels. It's actually not that hard to do. There's actually multiple ways to do it. We're going to see a different way to do it down the road that involves the scikit-learn package. But for right now, we're going to just use pandas. So the way we can get the label encoding is we can first convert our data to a categorical type. We've actually already seen this using the pd.categorical is an alternative to convert to categorical. But once we convert to categorical, we access the categorical attributes by using, so we access .cat to get the categorical attributes, such as the label encoding, which is from the codes. Codes gives us the mapping encoding values. So .codes gives us the unique label encodings that we have for those different categories. So for instance, as I was telling you earlier, A gets mapped to 0, which we extract from these codes. A gets mapped to 0, B gets mapped to 1, A we already know is 0, C gets mapped to 2, B gets mapped to 1, and A gets mapped to 0. So in essence, we have converted our categorical data again into something numerical. It's just this is a different strategy than doing one-hot encoding. It's doing what we call label encoding, which is going to be done for a different purpose. Usually it's done for model outputs. One-hot encoding is done usually for model inputs as data going into a model. And label encoding is usually done for data that would be the output of a model. Again, we haven't learned about modeling, but hopefully that is reasonable why those would be different, why we need a different strategy to convert from string to numerical, depending on if we're dealing with inputs or outputs. Any questions on this? That's a great question. It's because some of the functions come from pandas. So the functions that come from pandas are going to come first. Like this is you know that because it's from the PD package, right? So get dummies is a function from pandas. The things that come after are functions on an object, like a data frame or a series. Like a series has a value counts function, or like a data frame has a sort values function. So those come after the data frame because they are methods or functions of that object. Whereas this is a function coming from the pandas library directly. So pd.getDummies comes from pandas and we pass data into it as an argument. Versus like if we already have a data frame, we can operate on that data frame by sorting it, by doing value counts, whatever the case is. Does that make sense? Yeah. So that's now as you practice more of this, you start to remember which things come from pandas and which things are inherently done on a data frame once I have the data frame. Like there's a bunch of functions we've already seen that operate on a data frame, like head, tail, info, describe, right? Those are functions on a data frame once we have the df. So usually you see it as df.describe, df.info, df.head, all those things. But this is a function that is generically from pandas, and we pass in a column or maybe a collection of columns to do the one-hot encoding. But it's a great question. All right. So there is some extra practice here that, again, I will leave to you guys. Feel free to do this between now and next Monday. This is just extra practice for you to work through doing some converting of existing columns in the this is, by the way, this is for the housing price data set. So you're going to be doing some practice with the house price data set to analyze the year built and year remodeled ad, to convert those to datetime format, and extract things like the year, month, or day, because these are dates. Calculate the difference between when the house was built and when it was remodeled. So you can subtract those dates, calculate the difference, which will give you a time delta object. Count the number of categories in the categorical features. So some of that data, if you remember, is going to be categorical. So those are going to be things like the zip code, the state, the address. So sometimes we want to know how many of those houses are from Massachusetts, how many are from New York, how many are from California. We should be able to do value counts to determine those numbers. And then we also I would encourage using something like the states to do the pd.get dummies to get some practice with building one-hot encodings of the data. So I'd recommend picking one of the categorical features or categorical variables and doing the get dummies with it. Yeah, the house price is CSV. That's what this wants you to practice with. This is with the house price CSV. Housing data set, which is the house price CSV. Yeah.
So this is going to be our last notebook in Pandas, so inside of lesson 4. But as I said earlier, by no means will it be like the last time that we work on Pandas. We will be working on it quite a bit as we continue, because most of the time, anything we do is really going to be working with Pandas in general. So this definitely won't be the last time we work with it. But I wanted to wrap up with some additional topics in Pandas. One is going to be working with text data. There may be sometimes a need to work with strings, like some of our columns could be strings and we need to manipulate those strings. So I wanted to basically describe how we might do that and see some examples. I also wanted to show us like different methodologies for iteration over all of the rows inside of a data frame, and kind of caution us to those methodologies and what the proper way to basically apply a function is to every single entry in a column. As you can imagine, that's going to use our apply function, but there are other ways to kind of iterate through every single row if for some reason we needed to do that. It would be very rare. I'll point that out, the kind of the syntax that we would need. I wanted to briefly describe sorting. We've kind of already done that, so I won't spend too much time on it, but we can definitely sort a data frame according to different columns. We can use those as kind of our sorting columns. And then just briefly talk about how you can plot things with pandas, knowing that, we have additional plotting libraries that we're going to learn about in lesson 5 coming up that will take care of plotting for us. But Pandas actually does have built-in plotting support to quickly do plotting without having to go to those other libraries and explicitly build out plots. Like if you just want a really quick one, like if you want to plot a column and figure out what the trend of that column is, you can easily do that within Pandas without having to use another plotting library. So it does support built-in plotting. I'll show us that. But let's start with text data. So if we have strings, kind of just like with series, we can access string attributes by using the .str attribute of that column. So this data is all string data. So we can access the str, which gives us access, kind of like how dates are the .dt. They give us access to things like day of the week, and month, day, year, those kind of things. If we do str, we can do different operations on the string and access different attributes of the strings. So for instance, we can uppercase everything, we can lowercase everything, we can get how many characters there are in that string. So for instance, like the hello string has 5 characters, so its length is 5. World has 5 characters, its length is 5, and on and on and on. You can do different operations. So this finds the length. And notice that we are getting that from the str attribute and then doing different operations on it. So if you're ever working with strings, you're likely going to find yourself using the str attribute and then doing functions on that to kind of operate on that whole column. As I said, you can lowercase everything. So here we're creating a new column called lowercase, which takes the existing column of data we have and lowercases it. So it removes all those uppercases and lowercases everything. You can see there. We could uppercase everything back, which would do upper. So you can see how that like that uppercases every single character. But we can also lowercase every single character, which is what we had before. So pretty straightforward. Like working with strings isn't something we'll do that often. Most of the times when we're doing data science and modeling and we have strings, we normally won't work with it too much. We'll actually just convert it over to one-hot encoding to use it with models. So it'd be very rare that we have to do operations like this, but just pointing them out to you that we can operate on strings if we need to. Okay. Um, So another one is like we can check and see if strings contain any other substring. So this can be like checking if this data is within this existing string. So the only one that would return true on, this is something that's going to return a true or a false, is going to be that last one. So data science definitely contains data as a substring of that full string. So it returns true. So you can check and see if certain strings contain certain elements, which would be like certain characters. Like we could see if it contains an O, if it contains an L, if it contains a P. So we could do things like that. So we could check and see if things contain the P. Um, of course, Python is the only one that does, so it returns true in that example. Okay. Pretty straightforward, I think. Any questions on these kind of things working with strings? There's more functions. I'm not showing you all of them, mainly because again, it's going to be very rare that we would ever really need to work with strings. Usually we're just going to convert them over to one-hot encoding because the strings are usually going to represent some type of categorical variable for us when it's in our data. Identify space? I think so. Well, we can check that out. So I have a single white space here, and data science contains a space. So yeah, the substring of just a single space character. Space is a valid character, like white space. It is a character, so it is. This is the one that has space, right? Okay, cool. Any other questions about working with strings? An old term, yeah. Yep. All right. So what I wanted to get to next was something more important, which is going to be how we operate on collections of rows at a time from the data frame. And data frames actually support a couple of objects that allow us to iterate through the entire data frame if we need to. However, we should be really cautious if we find ourselves looping over the all of the rows using something like a for loop. It's generally discouraged because it's very slow as an operation. So it's very rare that we should ever find ourselves having to do a for loop where we work our way through every individual row. For one thing, most of the data that we work with will have lots of rows, so that will be incredibly inefficient, looping through every single row, and we generally don't need to do that when we have something like apply, or we can do direct operations on columns that will do a calculation to every single row all at once. There's not really a need to loop over every single row. If you find yourself doing that, you're likely doing something wrong, and you should rethink what you're doing, just because it's going to be incredibly slow to do that. But Python does support um, a couple of functions on the data frame that give you an access to every single row in the data frame, and you can see what they are here: iter rows and iter tuples. I'm going to show you an example of those. But it'd be very rare that we would ever need to use these. So let me show you an example of what I mean by this. So notice that we have a data frame built out here with two different columns and only three rows. So we have column one and column two. So really we have data that looks like column one, which is column one, which has data that looks like one, two, three. And then we have column two, which has data that looks like A, B, C. So a very simple data frame. Now, what this code here is going to do, this df.iterRows, it's going to give us the ability to access the index and the row as a tuple. So essentially what it's going to do is loop over the entire data frame, all rows, one row at a time, and give us access to the entire row. Not only that, but the index, which is index 0, this is index 1, this is index 2, and it gives us that in a tuple. So the first time through the data frame, you can see what the index is. It's 0. We actually print that out, print out the index, and we also print out the value at column 1 of the row and the value at column 2 of the row, of the current row in the iteration, right? So on the first loop, on the first pass through the data frame, we are on the first row, so we have index 0 and we have a 1 and an A as the two values from column 1 and column 2. That makes sense. That's what this is. Then we go to the next iteration, which goes to the next row, and that gives us index. We are now on index row index 1, and we have column 1's value is now 2, and column 2's value is now B. So we can have access to those elements of the row by doing something like this. Okay. And then on that final iteration through, we are on row index 2, and the data that's in column 1 is a 3. The data that's in column 2 is C. So you can see that here. Okay, so iterRows gives us the ability to access the entire row at once, and then we can access particular items of that row based on the column name, just as we would like in a data frame where we put the bracket and put the column name. So we can access that elements of the row in that way. I should caution you that this is very slow. So unless there's a very specific reason why we need to loop through every single row, we generally shouldn't be doing this. You could argue like one of the reasons we might want to do this is to manipulate this row element, or this row element or whatever. Like maybe we want to add them together or multiply or do some operation. And there's going to be different ways to do that that are much faster and do not involve an explicit loop over the data frame. I'm going to show us those. So it's generally going to be discouraged to do a loop like this. If you find yourself doing it, try to not do it. Try to think of a different way to do your operations. You really shouldn't be looping over every single row. It's generally discouraged. Okay, but there's the code to do it. Any questions on that code? Does that make sense what we're doing? We're iterating through every row in a for loop, and we have access to the index and the entire row as we loop through that. As we loop through that. But we really should think twice about doing that because it's going to be a pretty slow operation to loop through every single row. There's much faster ways to do manipulations that we may want to do. Any questions there? Okay. All right, so let me give you an alternative. So like if for some reason we wanted to go through every single row and multiply everything by 2, well, we have a way to do that that does not involve looping through every row. That's going to be much faster, which is using the apply function. So we've already seen this with a series. Remember, what is a column? A column is just a series. So of course we can do apply to any column in the data frame, and that will allow us to manipulate that column and multiply every element by 2, square it, take the logarithm, whatever we want. This is a lambda function that we are applying to every entry in this column that will take the entry, which is what this argument is, x, and multiply it by 2. That's what this lambda is doing, is saying take your value and multiply it by 2. So when we apply that to this existing column, we are going to get a new column that has every element multiplied by 2. So we have a 20, we have a 40, and we have a 60. So pretty straightforward, but if you ever want to generate a new column with a mathematical function of an old column, generally you're going to want to use apply. Now, could you do this with the for loop? You could. You could iterate through each row and take the value that's at the existing column and multiply it by 2. That's going to be slow. That's going to be slower than if we just did apply and did an apply function to this entire column, which Pandas has an optimization to do apply. It does it so much faster than manual kind of iteration through every row. So again, like if you want to do an operation to every element in a column, use apply. You pass in that function to apply, and that will apply that function to every row of that column. Okay. So we've seen this before. So nothing that new. But just showing you again, and applying a function is going to be faster than if we looped through here. So like what we could do, let me show you the alternative. So the slower alternative is to do something like for index row and df.iter rows, if we did row and we generated a new column equals row, and we access the existing column, and we took that and multiplied it by 2. Now that will do the same thing. It will take whatever is in the existing column, multiply it by 2, and set that as the new column element. But this is going to be, there's no reason to really do it this way. It's going to be slower. It's less readable than if we just did apply and took this existing column and applied this function to it. This will be faster. Pandas has optimizations for doing apply. This will be slower. Don't generally want to do this. All right. And then let me show you another alternative notation. So if you're doing something really simple, and you don't need a complex function here, like multiplying by 2, I would argue is really simple. You don't need anything that fancy. Like something simple could be like adding 2 columns together, or multiplying 2 columns together, or dividing 2 columns, or subtracting 2 columns, those basic arithmetics between columns, or even with a column and a constant, like multiplying everything by 2. You can do what is called a vectorized operation, where you actually take that whole column and you do arithmetic with it to another column. And Pandas will optimize this. Pandas optimizes this operation to be really fast. Now, why does it optimize it? It's because it uses NumPy under the hood, and it turns out to be an incredibly fast operation that would be so much faster than looping through every row and adding this row element with this row element. Like we could do that and get the same result, but it would be so much slower than if we did it this way. So taking the entire column of A, adding it to the entire column of B, We don't need to loop to do that. We can just directly do it. We can just directly do that arithmetic between the columns, and that will give us the new result, which adds those together. So that is called doing a vectorized operation because we think of the whole column as a vector, think of the whole other column as a vector, and we're adding two vectors, which is a really simple, it's like adding two NumPy arrays. It's a really simple operation. Okay, so you can do a lot of vectorized operations. You can do, another example would be instead of apply, we can actually do um, new result, or let me actually call this double result, would be df, take an existing column, so let's call it column A, and multiply that by 2. Okay, or multiply it by 3, whatever your favorite constant is. And that will generate a new column that takes the column A and multiplies it by 3. Okay, so 3, 6, and 9. So this is an example. We could use apply for this, which would be like df column A dot apply, and then lambda x times 3. Like we could do that, but the doing it this way is actually going to be faster. And so when you have something really simple, we can just directly operate on the column most of the time and avoid doing apply, avoid doing for loop for sure. We never want to do that. It's going to be incredibly slow. How would you average a set of columns? So that would be using the built-in mean function. So you pick a set of, like, you pass in a list of column A, column B, and then you do like np dot mean. You could do it that way. Does that make sense? Like you pass that into the average, like a NumPy average, or you can you could do it that way, or the alternative would be to do dot mean like that. You could do it like that. So we can't forget our statistical functions, right, that we have on our data frames. Could we do this by looping through every row? Sure, but it's going to be so much slower and inefficient. I would never recommend doing that. Okay. All right. So just like with now we mentioned this example here to say you can also iterate over a series, just in the same way. So as an alternative, um, as an alternative to iter rows, you can loop over an individual column. You can loop over an individual column because remember, every column is a series. So you can grab the what are called the items, which gives you the index of that series. It's basically the index of that row and the corresponding data point in that column. So you can iterate over an individual column instead of all rows, which is a little bit better, but still there's very rarely a need to do that. Very rarely a need to ever do that. Yeah, so that's a good question. Is there any specific condition where only looping is useful, even if it makes the program bulky? So I would say only where you're doing something that is so complicated that cannot be put in an apply. that you need access to only specific, like you're doing a transformation that involves elements of the row, like maybe you're concatenating strings, doing some transformation, then doing like math with it. You're doing something so complex that you actually have to loop through every row, and it can't be encapsulated in a simple lambda. That'd be the only scenario I could see. Just something really complex. Yeah, just something so complex that you can't get away with doing it in a lambda and you really have to do it. Or sorry, you can't get away with doing it in an apply. And you have to iterate through every row in order to apply that operation because you're doing something really custom. That's the only scenario. But again, like that's going to be something so complex, which would be very rare that you would do something that complex that you couldn't do in just an apply. Okay. All right. Any questions so far about iteration or doing operations kind of on the at the column level? Hopefully, so your options. So just to recap this actually, your options when you're working with columns is your first choice. If it's something simple like doing arithmetic or multiplication by a constant or applying a simple function like an exponential or a logarithm, you can actually just do that directly to the column like this. So if you can do that, that's actually going to be the fastest and most efficient way is to just directly operate on the column. If you can do that and your operations are really simple, you can get away with doing that. That should be your first choice is directly operate on the column. If you need to apply a more specific function, you can use dot apply. That should probably be your second choice, is to think about if I have a custom function, can I apply it to every entry in this column? That is going to be maybe you need to do that because you have a custom function you want to apply, and it's not so simple to just operate that on the entire column like a basic arithmetic here. So that would be your next choice is apply. Last resort, last resort, something so complex that you can't use apply and you can't use direct arithmetic would be looping through every row. That would be last resort. Iterating through every row, and then utilizing those row elements to do some custom operations with. Okay, that should probably be the last resort. Okay. Any questions on that though? Okay, very good. Let's go on to sorting. So let's talk about sorting the data frames. We've kind of already practiced this a little bit, so I won't spend too much time on it. But we do have the ability to sort data frames, which of course will rearrange it according to a column or maybe a collection of columns, and it can be, either greatest to least or least to greatest kind of sort. So you can see in this picture, like in this example, we are sorting based on the height column, which will rearrange it from least to greatest and kind of shuffle those rows according to the sorting. And so let's take a look at that with this example. In this case, we are going to take this data and sort it according to the age column. So one of the things we need if we're going to sort is to specify what column do you want to use to do your sorting, and that you can pass that in the by argument. So we are sorting by the age in ascending order. So ascending order because the ascending argument is going to be false by default, which indicates that we are sorting according to the age from uh, uh, sorry, ascending is true generally, which means it will be a least to greatest sort um, by default. So ascending equals true is the default behavior. So if we don't pass anything in there, that will be what we get. We get a least to greatest. So you can see this gets rearranged where the age is now least to greatest. This is like in a spreadsheet, right? You take a spreadsheet and you go into a column and you sort your spreadsheet according to that column. It's kind of the same thing. Taking our data frame, sorting it according to this column. If we want to do descending, so if we want to do descending, we could do df sorted equals df dot sort values, and then we can do the same exact syntax where we pass in our column, except now we do ascending equals false. So this will now do the greatest to least sort. So it reverses that. Okay, so ascending false. Does a greatest to least sort. Okay. Pretty straightforward, I think. Nothing, terribly interesting going on there. Oh, the other thing I forgot to mention is if you do sort values, it will not do it permanently to that data frame unless you do the in place argument. So if you want to permanently sort the original DF, you need to use in place equals true arg. So what that means is you would do something like df dot sort values. You could use the by age column, but in this case we would do in place equals to true. And this will permanently sort this data frame so that going forward, its values will be permanently sorted. Notice that we didn't do that. We just did sort values, which return, it's just like all those other things that return a copy of the data frame that has been sorted, and we store that into this df sorted variable that we can work with going forward. So when we do this, this original data frame is not permanently altered underneath, right? It's not permanently sorted until we do in place. So if we do in place equals true, then going forward, this DF will be permanently sorted. Okay, so just like a lot of it's true of so many data frame operations. They're not going to be permanently altered until we do in place equals true. It's just how it is. Okay. All right, so the other thing is you can sort according to multiple columns. So all you have to do is in the by argument, just pass in a list, and it's going to go in order of the list. So what that means is it's first going to arrange the data frame according to this first column, which is the age, and then it's going to secondarily sort according to this, if it can, right? So. The age is the primary sorting because it is first, and then the salary would be kind of like the secondary sorting for any like tiebreakers. For instance, like if the age was tied, then we would sort according to the salary from least to greatest. However, you can change the greatest to least or least to greatest as your primary or secondary sorting. You can actually change that in the ascending argument. You can pass in a list. So what that means is the age here should go from least to greatest because that is ascending true, but the salary would be kind of reverse sorted. So the salary should go from greatest to least if there was any tiebreaker of the age, right? So if any ages were tied, we would then sort according to salary, but that would be actually a greatest to least sort. So whatever is greatest would be first. Does that make sense? Like multiple columns could be used for sorting. Think of this as just here's your primary sorting, here's your secondary. You can have as many as you want. You can actually have as many as the number of columns that you have. You can sort according to those. Any questions on that? Okay, pretty straightforward then. Um, let's see. You can also sort according to the index. So this is useful when your index is something interesting other than the default index. So this will kind of reverse the data frame because the index is of course 0, 1, 2 by default. And if we do an ascending sort false, this will kind of like uh, reverse it in effect, right? Because now the it's now a greatest to least index sort. So the index 2 would be first, index 1, then index 0 is last. So you can also sort according to the index. This is useful when you have things like time. Like if your index is a date, you could sort according to like earliest to latest in terms of the dates. That may be useful. So when your index is something interesting, you can sort according to your index, which is pretty useful. So notice the syntax is a bit different. It is sort index rather than sort values. So sort values is used for any column you want to use to sort with. Um, Whereas sort index is, of course, just going to use the index. So when your index is something interesting, that can be helpful. Like if your index is a collection of dates, you can sort that, which will go like earliest to latest. Okay. And we've already seen an example of sorting a series, so I won't really spend any time on this. We know we can sort a series. We've already seen that. The reason we're calling that out again here is because, again, what is every column? Every column is a series, so we can go into an individual column and sort it if we need to. And that may be useful to extract the values out of a particular column and sort it so that we can manipulate it if we need to. So we can always take a column and sort values just as we can an entire data frame. So no surprises there. All right. Any questions with the sorting at all? Feel pretty good about that? I think it sounds like we feel pretty good about sorting. I think it's pretty straightforward. Again, it's just like if you had a spreadsheet and you were to sort your data according to specific columns. It's the same exact concept in Pandas. Okay, very good. For large data sets, do you know if our data set or Pandas is faster overall? It depends on what you're doing to it. What did you have in mind? Like, if you're doing basic arithmetic, like if you're doing operations like this, like multiplication or addition of columns, I actually think Pandas is going to be faster because Pandas is backed by NumPy, which is pretty fast for doing those kind of things. I think Pandas is going to be faster for doing like basic vectorized operations, but anything beyond that, it could be slower. Yeah, I think for doing basic vectorized operations, I think it's going to be faster. I think you get in trouble with Pandas when you get outside of that. At that scale, yeah, it's going to be. I mean, there's other, by the way, there's other things that can work with data that's that big, right? There's other frameworks that can work with large data. Something like a Spark or something would probably be more ideal. Not that we'll cover that in this program, but yeah, generally for dealing with data at that scale, we probably would move outside of Pandas altogether anyway, and be working with some other big data framework. Okay. Um, all right, so let me finish up Pandas by telling you guys a little bit about some plotting. So if you have a data frame, you can actually quickly plot the column data by just doing df.plot. So a very simple function which will generate the plot. Now we haven't learned about matplotlib. That's going to be in our lesson 5, which we're going to get to next. But suffice to say that df.plot uses matplotlib in the background. Pandas will use that, but we don't have to explicitly go into matplotlib and build an entire plot to quickly generate one off of a data frame. So df.plot will build a simple line graph of each column. So it's plotting A and B, where we have the x-axis is just the basically the row index. So I should mention that here, the x-axis is the row index. So that goes from 0 to 4. And then the y-axis is the data. Y-axis are the column values. Right, so it's plotting. If you take a look at it, it's plotting 1, 2, 3, 4, 5, and then 5, 4, 3, 2, 1, which are these two lines here. And you can see they even get labeled A and B. Something we're gonna learn about how to make plots. So I'm not too concerned right now about like how do we get this legend here? How do we make these different colors? We're gonna learn about that in a few minutes. But again, Pandas has the ability where we don't really need to do anything that fancy. We can just quickly plot a data frame if we need to do that. If we need to quickly plot it and we don't want to spend time setting up an entire plot, we can just do df.plot. One thing that I'm going to talk about in a little bit is this plt.show. So this code is the equivalent of print. This is basically the equivalent to print when working with graphs. So it's yeah, why not write that? It's because this is matplotlib's way of doing the print function to say, okay, I'm ready to display the graph. It's like it basically is like a display function that comes from matplotlib. So I'm gonna show us why in lesson 5. So hold on to that thought. I'm gonna show us why this is important in lesson 5 when we actually talk about matplotlib. We haven't covered it yet, so I don't want to go too down that road. But it's in the next lesson. It's gonna be in lesson 5. Yeah, this PLT part is matplotlib, but this is not. This is just the data frame.plot, which is what I want us to focus on. This part is from matplotlib, which is basically the print statement of matplotlib to like display the graph. So it's nothing that interesting other than saying, okay, I'm ready to show the graph. So it's like print. It's like print your graph that you have available from df.plot. df.plot generates the plot. So this code generates the plot in the background. And then we don't actually display it until we do plt.show, which will print it out. So this like renders the plot data and gets it all ready to be printed. And then plt.show is kind of like our print function that will actually then display it. So this code kind of generates the plot. This actually prints it out. So we're going to see if that doesn't make sense now, that's okay. We're going to see plenty of examples of plt.show coming up of why we want this to be here. Right. So Pandas isn't responsible for displaying the graph. No, it's responsible for building the graph with this basic data frame.plot function will generate the plot. But it's not responsible for displaying anything. That doesn't happen until we run this code. And Roberto, I would encourage you to try this. Like in your VS Code, try running this, try creating this and leaving out this and see if it actually prints it out. Okay. So this won't do anything until we do plt.show to actually render and display the graph. Okay. So I wanted to show you a couple other types. Again, not going to focus too heavily on this because we're going to get into building our own plots in Matplotlib coming up in lesson 5, which is going to be next. But we can do a bar graph as well. So we do df.plot and we pass in a bar parameter. This will create a bar graph that looks like this. So it takes our indices 0, 1, 2, 3, 4, and it generates it generates a bar graph of the values in our data. So we have A in the data, which column A has values 1, 2, 3, 4, 5. Column B has values 5, 4, 3, 2, 1. So we display kind of a bar graph of that data here. And the only thing we really had to do is do df.plot and then change this over to bar. The default is just a line graph. So if we don't put any type in there, so like what we just did with bar, it's just gonna build a line plot by default. Okay, it's just gonna build a line graph by default. Okay, and it turns out that there's other types. I'm not going to get into them really because we're going to explore those in Matplotlib in 5.01. But there are other types that pandas can do out of the box. I will say that it's rare that we would actually use this as our plotting methodology. Generally, we will build the plots directly in Matplotlib code, which is what we're going to learn how to do next. Okay. That's what we're going to learn. But it's just to show you that Pandas does support doing like really quick plots on data frames if we need to. Like if we want to get a quick view without having to go into Matplotlib and write some Matplotlib code, we can actually quickly plot some characteristics of the data frame if we want to. Okay. All right. Any questions on this notebook? PLT is the industry shorthand for Matplotlib. Again, we haven't covered that yet. We'll cover that next. We'll cover that next. Yeah, Roberto, I was afraid of that. I think it's because the notebook the notebook plugin in VS Code automatically renders graphs. But if we were to run this in a script as well and we didn't include this, nothing would display. Like if we remember when we talked about running code as a .py file, if we have like plotting code in there, it's not going to render until we do plt.show. It's the print statement of displaying graphs. So if you're running in a notebook, the notebook may have built-in support to automatically render the graph. It's kind of like when we can do, you know how we can display a data frame without actually doing print? It's because the notebook kind of can render that for us, right? So the notebook can render this for us without, notice how we didn't do print? It's the same concept. Normally we should be doing plt.show to kind of print the graph. Yeah, so like it kind of like this where we don't like I could put a print here and it would display the information as well. PLT.show is how we would ensure that we display the information if we were running that code in like a PY file or in a notebook backend that didn't automatically render the graph.
Now guys, before moving ahead, let us try to understand about REST API. So REST stands for Representation State Transfer Protocol. It is a kind of a web service that basically allows clients like web apps and mobile apps to interact with the server using HTTP methods. Now, you would be dealing with methods like get, post, put, delete. Now, if I talk about get method, guys, so get is all about retrieving a data, okay? And if you want to use post HTTP method, it means like we'll be creating any new data. Similarly, if you talk about put, then this given method updates the existing data. Suppose, for example, you have this data along with you, which you just recently entered using the form, and in which you entered your name, ID, and your given designation. Now, suppose I want to send a HTTP request where I want to change this data, the current designation, to something else. So, for the same purpose, you'll be using put as a given request. So, in this way, you could also do it, and definitely you will have one more option to delete it. So, delete is also one of the HTTP verbs, okay, basically HTTP method, which is going to delete the data from the given database. So guys, basically REST APIs are commonly used in web development, backend systems, and microservices. Now, we will outline our project. We'll be using a layered structure to create our given projects for this API tutorial. And we'll be using Python's backend framework, Flask, to do the same. So as you can see all over here, I have created this folder Python REST, under which you could see that I have these subfolders: controllers, models, repository, services, init.py, and app.py. Now, let's try to understand the role of each of the given folders. So, as you can see all over here, that in this given folder, we have app.py, which is basically the main entry point. So, this will be the entry point of our application. So, this given file is going to initialize our Flask app. It is going to register the controllers, okay, whenever our server starts. Then we have the controller file, okay. So basically in this file, we are going to define our API endpoints with the help of those methods that we discussed, like get, post, put, and delete. And this given layer will be responsible for handling all the user requests, and it is going to send the appropriate response based on that. Then this given controller layer is going to call our business logic layer, okay, which is basically the service layer to process that given data. Think of this as a front desk of your API. It receives requests and directs them to the right department. If I talk about service file, then in this we are going to implement the core logic of our application, which is going to call the repository layer, okay, to interact with the databases. And it is also going to validate and process data before sending it to the controller. This is where the actual decision making happens. It ensures that data flows correctly between controller and repository. Now, I hope you have got a brief idea about these files. So we have one left file, init.py. Now, this is a given file which is going to make each directory like controller, services, repositories, model act as like a Python package. So it is basically required for importing modules properly. Now, you could see this is a given folder structure, and I would recommend you to use this folder structure for basically, creating organized code, easier maintenance, scalability. And each component has a specific role. You can maintain it will be very kind of easier maintenance. You can modify one part without breaking, everything. And the scalability is also there. Easily you could add new features without cluttering the code. Now let us try to understand what is there in our models folder. So here we have file name item.py. This file is going to define how our items are structured in our application. So you can see all over here we have created a class item. This defines a class item that represents an item. And then you could see we have written def in itself, item ID, name, description, and we have binded all these variables all over here. Just like that we do create a constructor in Java, and similarly we use this dot given field name to bind it, so that the particular thing could be what kind of behavior could be occupied in that object. So similarly, we could see that init is a constructor in Python, which basically initializes the item within it. So here we have item ID, which is a unique identifier. Then you have a name. For example, you could put name as laptop. Then you have description, where there is the description of the item. And finally, you have def to dict self. And then you are returning the ID, name, self.name, description, and self-description. So basically, this converts the object into dictionary or a JSON format, so it can be returned as an API response. So you would have got a brief idea of what we are exactly doing in our model class. Okay, so we are defining all the parameters that our given API will be returning, or what given data that will be adding to the post request. Now, after you have created your model, it's always a good activity to go to your services class. Okay. Now, before moving to the services, let us go all over here and try to understand. So you could see that we are using an instance of repository all over here. Now, what happens, guys? So basically, after creating your model, it's always a good practice that you should go to your repository, write a code in the repository. So let us try to understand our repository first, okay? And then after that, you create your business logic. So basically, all over here, you could see we are importing our models.item, importing the item all over here. Then we are creating a class called item repository. Okay. Then you could see we are doing self.items, which is basically storing items in a memory like a dictionary. So dictionary is acting as a database. Then we have put self.counter equals to 1, which is basically going to generate unique items IDs. Okay. And then you could see we have created def create self name description, and then we are using item string self.counter name description. So basically, this given piece of code creates a new item object with auto incremented ID, and it adds to the dictionary with self.items. Okay. Now there's another method called def get all self, which basically returns all the items as a list of dictionaries. Okay. So that's one thing you should remember. Then what we have all over here in this piece of code, def get by ID, self item ID, item equals to self.items.get the given ID, and then you are returning in the form of dictionary. If item is there, then return, otherwise do nothing. So basically it retrieves an item by its ID and it returns none if the item doesn't exist. So you have got a brief idea regarding the get by ID. Okay. Now similarly, for updating the given data, there is a def update function. Okay. So you could see it's written that def update self item ID name description. If item ID is present in the items, then what you have to do, you have to assign the given item with the proper ID. Okay. You have to access this item, then you have to access it name and description and return in the form of dictionary. If present, then do it, otherwise return none. Similarly, there's a delete function that we have created, and it returns self item.pop item ID none if it's not none. So basically it is popping up, or it is deleting the item ID present. Okay. If that item ID matches the given item ID present in the item, then it will be popped out. Now we have successfully created our item repository, and this given layer will be responsible for interacting with the database and do a bit of manipulation. Now let's move to our service layer, which will basically be using the instance of repository for all the business logic that needs to be implemented in our REST API will be done by services. So you could see we have this file name item services.py. Just right click on this. So guys, as you can see all over here, that when the request is coming from controller, it is directed to the services layer. Okay. Then the services layer is using the item repository instance to interact with the database and do all the manipulation. So all your business logic, imagine like services file is acting as a middle layer between the controller and the repository. It is somewhere here in the hierarchy of communication. Now, if you could see our code, we are importing the repository from item repository. Then what we are doing is we are creating an instance of item repository so we can call all the database functions. Now, you could see in this line that we are doing the same thing. Now, in the next, we are creating a method def get all items, and we are using the instance of the repository and calling the method get all. okay, which we have created in the repository. Similarly, by get by ID method, the same thing that we have done. For updating the item ID, we have done the same thing, and for deleting the item ID, we have also done the same thing. Now, the logic for these methods are built in the repository section. So whenever the controller, for example, let's go to our request ID. Suppose if the request goes to get the given item by ID, okay, as you can see in the controller layer, so slash item ID, okay. So now it is going to go all over here, and the service method that's all over here, so it is present that get item by given ID. So it will be calling the service instance. Now if you go in the service class, guys, so in the service class you have this method def get item by ID. Now this method is going to call this given method which is present in our repository section. So def get by ID, and here is your logic written, which is basically interacting with the DB. If you connect it to MySQL or MongoDB or anyone else, so all manipulation you could do is. So there are a lot of things you could do with the REST API. Now let us try to understand our controller layer once. Okay, so you could see all over here that in this given file we will be creating all the important HTTP request methods that are get, post, put, and delete. So basically this given layer will be handling all the given request which is coming to the endpoint. So our base endpoint is slash item. Okay, so this is a given URL that is mentioned. So when your application is running on a given port, so you can use HTTP localhost slash items slash item slash item ID. If you want to get that particular ID, you could post it or update it using the put request, and also you could delete the given item. Now let us try to understand the code present all over there in this file. So you could see initially what we are doing is we are importing our Flask module. Okay, so as you can see, so in Flask we are importing blueprint, request, and JSON file. Now blueprint allows for modular routing. You could use it for that purposes. Request basically reads the incoming data from the request. Now you have JSON file, which basically converts Python objects into JSON responses. So you can see all over here we are importing item service to access the business logic. Now you can see item controller, blueprint, item controller, name, service equals to item service. Now what it is doing, guys, it basically creates a Flask blueprint, which is basically item controller, to handle all the requests which is coming to slash item route. Okay, this creates an instance of item service to interact with the stored data. Now you could see all over here we have the post request first, like creating the item. Okay, so you could see we have used this annotation item controller dot route. So route here we have to give the given route which is going, and you could mention the method, what kind of HTTP method you are using. So suppose here we are using the post method. Now basically you are creating the item, so you are requesting a data from the request.json. So we are using this given package from the Flask library. Then what you are doing is that this data, it is going to read the JSON file. Okay, then you could see it calls service.create item to create an item. Okay, and then it returns a new item with the status code 201. Okay, now similarly if you go and see all over here in get slash items, okay, so in the get all items request, what we are basically doing is we are trying to use the method get request. Okay, so which is going to return the resource. Suppose you added any data, like suppose let's say for example you added a product with name, ID. Okay, so when you are going to go at this URL get slash items, so that given data will be returned. So basically it is going to call service.getAllItems to fetch all the items that you have added in your database. It is going to return the list of all the given items. Now every item added will have the particular item ID. Now if you want to access the individual items, then this given method will be called. So basically you are using the instance of service to call this method get item by ID. Then you are returning the JSON file item, okay, in that format, the JSON format. Now you could see all over here we have the update method all over here. So you could see we have the method mentioned name as put, and the given way to actually update the data is you have to access the given data by that ID. So in this case we are basically accessing the user's data by the given user ID. So that's why we have used item slash item ID. Similarly for the controller we have the same thing mentioned for deleted the given item with its item ID. Now similarly you could see we have put the method as delete, okay, and then it deletes the item if it exists. So you could see it is stored in the variable success, and this is calling the method from the service class, okay, which is present delete item by given id. And finally, it is going to return a JSON data with message name as item deleted. If the given item is present, means if the operation is success, you return it. Otherwise, else return a error response. So basically with the message as, item not found. Basically 404 status code. So this is how our controller is designed in this project. You would have got a brief idea what packages we are using from the Flask library, okay, and how our given layers are actually working and interacting with each other. So there is a lot of dependency management going on in this REST API, okay. So that's it, guys. So we have created all those things. So guys, you can leave init.py is empty right now because we are not doing the package level imports in this. So this code looks pretty much fine. This project structure looks good. Now, if you go to the app.py, our server will run on this given port, and this is our local host. Okay. So go to your terminal after this, guys. So click on terminal. So you could see we are in our required directory. Now type the name of your given file, okay, and try to run it up. So type Python, okay, and then type app.py, and let's see what is happening. So you could see our server is running on this port. Now I'll be using terminal, guys, to check how our, whether our get request or post request is working or not. So what you could do, guys, you can open PowerShell, okay. Now, guys, as you can see all over here, we have put a post request in our terminal, and we're using PowerShell for the same. So you could see I have put the header as content type, and the file is application.json. And this is a body which I'm sending right now, name, laptop, description, MacBook Pro, okay. Now, you could also see I also telling it to convert it into JSON with depth of 10, and then I'm invoking this URI to the REST API. So guys, now let us do the post request. Now guys, as you can see all over here, let's say we are giving the body something like this. Hash headers @ the content type is application.json, and here you could see the body is mentioned with the name, description, okay. So this is a Dell Pro laptop, and finally I'm invoking it to the given URI, which is the method is post, and I'm attaching the headers and the body section that I've sent all over here to this given URL. Now just click onto it, and you could see our item with the ID 3 Dell Pro 16 laptop is created. So it means that our server is running great and everything is all good. Now guys, let us try to use a get request and see whether our given items are added or not. So as you can see all over here, we have updated it to MacBook Pro 14 with M3 chip. And this is how you could do it. Now let me also show you how could you do the delete request. Suppose we want to delete this given ID. Now the same command that you have to invoke REST method with the given URI, you have to add the URI with the given item ID set with the ID 1, and I'm using the method delete. Now click on it, and you could see message item deleted. Now let us try to use a get method, okay, and we could see we don't have any items with the ID 1. So guys, this was a short tutorial on REST API using Flask and Python, where we were using the layered architecture of controller, model, repository, and a service.
This is going to be a really interesting and fun session where I'll be asking you a few generic quiz questions related to coronavirus. Please make sure to answer them in the comment section of the video. We'll be happy to hear from you. COVID or coronavirus is an ongoing global pandemic of coronavirus disease that emerged in 2019 and was first identified in Wuhan, China. It is defined as an illness caused by a novel coronavirus called Severe Acute Respiratory Syndrome Coronavirus 2, commonly known as SARS-CoV-2. On March 11, 2020, the WHO declared COVID-19 a global health emergency. The virus has so far infected over 22 crore people and killed more than 4.5 million innocents. In India, there have been over 3.3 crore confirmed cases and nearly 4,41,000 deaths have been reported so far. This data is according to official figures released by the Union Ministry of Health and Family Welfare. As the world tries to cope up with this deadly virus, We request all our viewers and their family members to follow all the necessary precautions to avoid getting infected. Quiz time. Now let's see our first quiz in this project. What does corona in coronavirus mean? Here are the options. Is it A, beer, B, respiratory, is it C, crown, or is it D, sun? This is a very generic question. I'm sure a lot of you may already know, some of you may not. Please let us know your answers in the comment section of the video. We'll be glad to hear from you. Now in this video, we will use 3 different COVID-19 datasets and perform data analysis using Python and Tableau. The project will give you hands-on experience working on real-world datasets and how you can use the different Python libraries to analyze and visualize data and draw conclusions. You will learn how to create different plots in Tableau and then make a dashboard from the visuals. The project will give you an idea about the impact of coronavirus globally in terms of confirmed cases, deaths reported, the number of recoveries, as well as active cases. We will also see how India has been affected since the pandemic started and dive into the different states and union territories to learn more about the COVID-19 influence and the vaccination status. First, let me show you the 2 datasets that we'll be using. So for our first project using Python, we'll be using the first 2 datasets, COVID-19 India and COVID vaccine state-wise. Let me open the 2 datasets. Okay, so this is the first dataset. You can see here we have the date, we have the time, then we have the different state names. If I scroll down, you can see we have Kerala, Tamil Nadu, Delhi, Haryana, Rajasthan, Ladakh, Punjab, Telangana and other states. Then we have something called as confirmed Indian national. So actually this 2 datasets, confirmed Indian national and confirmed foreign national, we won't be using. So in the demo itself we'll be dropping these 2 columns. What we are concerned about are the last 3 columns, the cured cases or the recoveries, the number of deaths reported, and then we have the total number of confirmed cases. Let me just sort the B column, that is the date column, so that you have an idea about the recent data we have. I'll continue with the current selection and sort it. You can see here this is till 11th of August 2021. So this data was collected from Kaggle. It has some discrepancies that we will see in the demo. The data is available for free. We will provide the link to the datasets in the description of the video, so please go ahead and download them. The visualizations and results that you will see in the demo are based on the datasets that we'll be using. We haven't pre-processed the data to remove outliers or any missing values. Now before I jump into the demo, let me show you the second dataset that we are going to use. Okay, so COVID vaccine state-wise is my second dataset. Let me open it. There you go. So this is the second dataset that we'll be using in the Python project. You can see we have a column called updated on, then we have the state. Again, you can see here there are a few discrepancies here. It has taken the country name and not the state name. Below you can see there are the different state names, and you can also see we have information about the total doses administered. We have the sessions, sites, first dose administered, then we have the second dose, then we have information about male and female doses. You can see here the different vaccines administered, Covaxin and Covishield. You have Sputnik V, and here are the different age groups as well. And finally, if you see, we have male individuals vaccinated, the total number of female individuals vaccinated for a particular day. We have information about transgender individuals vaccinated, and finally we have the total individuals vaccinated each day. Alright, before we jump into the hands-on part, let's have a look at the second quiz in this project. So here is the second quiz question. Which is the first country to start COVID vaccination for toddlers? Is it A, Japan, B, Israel, C, Portugal, or is it D, Cuba? This is a very recent development that took place. If you watch daily news updates on coronavirus, you'll be definitely able to answer the question. Please give it a try and put your answers in the comment section of the video. It is really important for our viewers to know the right answer. Alright, so now let's begin with our demo. So I am on my Jupyter notebook. So the first project we are going to use Python Jupyter notebook. I'll just rename this notebook as COVID Data Analysis Project. I'll click on rename. Alright, so first and foremost, we need to import all the necessary libraries that we are going to use. So first I'm importing pandas as PD. This is for data manipulation. Then we have NumPy as NP. NumPy is used for numerical computation. Then we are importing matplotlib, seaborn and plotly. These three libraries will be used for plotting our data and creating interesting visualizations. Finally, I'm also importing my datetime function. Alright, so I'll hit Shift Enter to run the first cell. Now it's time to load our first data set, which is related to the COVID-19 cases in India for the different states and union territories. So I'll create a variable called COVID_df. df is for data frame. I'll use my pandas library and then give the read_csv function, since our data sets are CSV files, and inside double quotes I'll pass in the location where my data sets are present. So I'll just copy this location, I'll paste it here. We'll change the backslash to /, and after that I'm going to give my file name followed by the extension of the file. I'll say COVID-19 India.csv. Let's go ahead and run it. Alright, now to see the first few rows of the data frame, I'm going to use the head function. I'll say head, and within brackets, let's say I'll pass in 10, which means I want to see the first 10 rows of data. If I run it, there you go. Here you can see from 0 till 9. So we have 10 rows of information, and these are the different column names. You have S number, date, time, state or union territory. Then you have confirmed Indian national, confirmed foreign national, cured cases, deaths reported, and the confirmed cases. Alright, now moving ahead, let's use the info function to get some idea about a data set. If I run it, you can see here it gives us the total number of columns. We have 9 columns. The total number of entries or the rows, we have 18,110 rows of information starting from 0 till 18,109. You see here the different types of variables or column names that we have. Then it has information about the memory usage as well. And this side you can see the data types. Cool. Now we'll use another very important function, which is to get some idea about statistical analysis, the basic statistics about your data set. For that I'll be using the describe function. Okay, so if you can see here, the describe function is for numerical columns only, and you have the measures such as count, the mean, standard deviation, maximum, minimum, the 25th percentile, 50th percentile, and the 75th percentile value. Okay, now let's move ahead and import the second data set, which is related to vaccination. So I'll create a variable called vaccine_df. I'll write pd.read_csv function, which is present in pandas library. I'll move to the top and I'll copy the file location, and we'll change the name of the file. Copy this and let me paste it here. and instead of COVID underscore 19 underscore India, I'm going to say COVID underscore vaccine underscore statewise. Okay, so this is the dataset that we saw, COVID underscore vaccine underscore statewise. Alright, let me run it. Cool. And let's display the first 7 rows of information from this data frame. I'll be using the head function, and inside the function I'll pass in 7. There you go. So here you can see we have from 0 till 6. There are total 24 columns. A lot of them have null values, you can see here. Alright. Now, from the first data set, which is the COVID underscore DF data frame, we'll be dropping a few unnecessary columns such as the time column, confirmed Indian national and confirmed foreign national, as well as the S number. We don't need these columns, so it's better to learn how to drop the columns for our analysis. So I'll say COVID underscore DF dot, I'll use the drop function, and within square brackets I'll pass in the column names. The first is S number. I'll give a comma. Within double quotes I'll say the next column is time. My third column that I want to drop is confirmed Indian national. Give another comma. Within double quotes I'll say confirmed foreign national. Outside the square brackets I'll give another comma and pass in my next argument, that is in place equal to, I'll say true. I'll give another comma and say axis equal to 1. Let's run it. Okay, it has thrown an error. Let's debug the error. Says confirmed Indian. Okay, it should be Indian national and not Indian nation. I'll just mention it as national. We'll run it again. Okay, now we have removed these 4 columns. Let me show you the dataset now. There you go. So we have only the date column, state or union territory, cured, deaths and confirmed. Now let's see how you can change the format of the date column. For that you have the function called toDateTime. I'll say COVID underscore DF. I'll pass in my column name, that is date. I'll say equal to PD dot. I'll use the pandas function, that is to underscore date time. I'll say COVID underscore DF, which is my data frame name. Pass in my variable, which is date. Give a comma, and I'll use my argument, that is format equal to, I'll say percentage %y, give a dash, say percentage %m, give another dash and say percentage %d. Let's run it, and I'll print the head of the data frame. Cool. Now moving ahead, now we will see how to find the total number of active cases. So active cases nothing but the total number of confirmed cases minus the sum of cured cases plus deaths reported. So let's find the active cases. I'll give a comment. Okay, I'll first write my data frame name, that is COVID underscore DF. Within square brackets I'll give my new column, which is active underscore cases. I'll say equal to COVID underscore df, and my first column would be the confirmed cases column minus, I'll say COVID underscore df, then I'll pass in my cured column plus, I'll again say COVID underscore df and add my deaths column. This time let's print the last 5 rows from the new data frame that we have created. Okay, let's run it. Okay, it has thrown an error. Let's debug it. Says data frame object has no attribute tails. This should be tail. There you go. You can see here we have added a new column called active cases, which is the confirmed cases minus the sum of cured and deaths reported column. Now we will learn how to create a pivot table using the pandas library. So in this table we'll be summing all the confirmed deaths and cured cases for each of the states and union territories. So we'll be using the pivot underscore table function for this. I'll create a variable called statewise and say pd dot. I'll use the pivot underscore table function. I'll pass in my data frame, that is COVID underscore df, and then I'll give my values parameter. Inside the square brackets I'll pass in my columns confirmed deaths, and then we'll have the cured column. I'll give a comma, and next argument would be index, which is going to be my state slash the union territory column. Let me bring this to the next line so it is more readable. I'll say union territory. I will give a comma now and pass in my last argument, which is agg function, that means aggregate function, and this function would be max. Alright, let's run it. Okay, now I'm going to find out the recovery rate. So recovery rate is basically the total number of cured cases divided by the total number of confirmed cases into 100. So I'll say statewise, and within square brackets I'll pass in my variable that I want to create, which is recovery rate. This will be equal to the cured cases multiplied by 100 by the total number of confirmed cases. Within square brackets I'll give my column as confirmed. Let's run this. Okay, I'll just copy this column, paste it here. So this time we are going to find out the mortality rate. So mortality rate is nothing but the total number of deaths divided by the total number of confirmed cases into 100. So I'm just going to replace the names. Here I'll say mortality. Alright, and then instead of cured I'll say my deaths column into 100 divided by the confirmed cases. Let's run it. Okay, now we are going to sort the values based on the confirmed cases column, and we'll sort it in descending order. So let me show you how to do it. I'll say statewise equal to, I'll use the function sort underscore values. So I'll pass in my variable statewise dot and use the sort underscore values function. I'll say by, I want to sort it by my confirmed cases column. Give a comma and I'll say ascending equal to false. Let's run it. Now we are going to plot our pivot table using a nice visual. So for that I'm going to use my background underscore gradient function, and inside that function we'll pass in our CMap parameter. I'll show you how to do it. I'll say style dot background underscore gradient, and inside this we'll pass in a parameter called CMap. So CMap stands for color maps. This is present inside the matplotlib library. So here you can see there's a nice documentation on choosing color maps in matplotlib. This is provided by matplotlib.org. If I scroll down, you can see there are a number of CMaps that you can use. Purples, blues, you have something called reds. There are other things like magma, you have summer, autumn, spring, winter, cool, all these. You can use whichever color map that you want, and here you can see the different shades or the gradients. Okay. So I am going to use my color map as cube helix. Let me run it and show you the pivot table. There you go. Here you can see we have our pivot table ready. Now, as I said in the beginning, there are a few discrepancies in the data set. So here you can see there's one called Maharashtra, and there's also Maharashtra triple star. This you can ignore. Even if I scroll down, you have Madhya Pradesh followed by 3 asterisks. You can ignore this value as well. Even for Bihar we have. So these have been duplicated. And here you can see the different state names and union territories. Then on the top you have the confirmed cases, cured cases, the deaths reported, and the new columns that we created. These are calculated columns, recovery rate and mortality rate. And we have ordered it in descending order of confirmed cases. So far our data says that Maharashtra has the highest number of cases, followed by Kerala, Karnataka, Tamil Nadu, Andhra Pradesh and Uttar Pradesh. So these are the top 5 states which have the highest number of confirmed cases. Even if you see, the mortality rate is also high for Maharashtra. And if I scroll down, the mortality rate is also high for Uttarakhand, if you see here. If I scroll further, you have Punjab, the mortality rate is also high. Alright. So this was our first visual that we created in the COVID data analysis project. Now moving ahead, we'll see the top 10 states based on the number of active cases. So we'll start. I'll give a comment, top 10 active cases states. Okay. So we are going to explore another very important pandas function in this, which is known as group by. So I'll first pass in my data frame, which is COVID underscore df dot followed by the group by function. I'm going to group my data based on state slash union territory column. Then I'll say dot max, which is to find the maximum value from the states that have the highest active cases. So I have passed in my active cases column, and we're also going to group it based on the date column. After that, we are going to sort the values. So I'll use my function that is sort underscore values. I'll say sort by my column that is active cases. Let me bring this to the next line. Underscore cases. I'll give a comma and say ascending equal to false, say dot, and then reset my index. For that I'll use reset underscore index function. Okay, let's check if everything is fine. I have missed a square bracket here. Let me give another square bracket here. Okay, and all this we are going to store in our variable called top underscore 10 underscore active underscore cases. Okay, now let me go ahead and run this cell. Okay, there is a syntax error here. Now let's run it. Okay, now I'll create another variable called fig. Here we'll pass in the plt, which is for matplotlib library, and we'll give the figure size using the fig size argument. It's equal to, and within a tuple and passing the size, let's say 16,9. We'll run it. Okay, and let's give a title to our plot. So here we are going to create a bar plot. So using plt.title, we'll pass in the title, let's say top 10 states with most active cases in India. I'll give a comma and pass in the size of my title, let's say 25. Okay, you can see we are slowly being able to create our graph. The most important thing is to pass in the x-axis and the y-axis. I'll say ax, which is for axis. To pass in the axis, I'm going to use the bar plot function that is present inside the Seaborn library. I'll say sns.barplot. I'll say data equal to my variable, which is top underscore 10 underscore states. This is actually active states. Alright, and now I'm going to use the iloc function and take the first 10 states. So I'm using a colon and then giving 10 as my value. ILOC is for index location. I'll give a comma and say my y-axis to be active cases. Give another comma and say my x-axis to be state slash union territory. Give another comma. We are going to pass in the line width to 2. I'll say line width equal to 2, and we'll give an edge color. Let's say the edge color is red. Okay, so I have my access defined now. Let's run it. There's an error here. It says top 10 active states not found. Let's go to the stop and see the exact. Okay, so this is top 10 active cases. Let me change it to cases here. Now run it. Okay, the x-axis also has a mistake. This should be state/union territory. Now let me run it. There you go. We have our plot created, but as you can see here, the labels of the different states and union territories are overlapping. So for that, let me first pass in the x labels. I'll say plt.x label, and my x label would be states. Then I'll say plt.y label. My y label will have the total active cases. And finally, I'll write plt.show. Before I run it, let's collate all the lines of code that we have written for our top 10 states for most active cases in India into one cell. So what I'll do is I'll just copy this and we'll keep adding in this cell itself. Okay, I'll go to the top. Next, we'll copy my figure size and we'll paste it here. Next, let's take the title and put it here. Give a space, and we are going to copy this cell and I'll paste it here. Alright, now it's time to run it. There you go. You see it here. We have a nice bar plot ready. On the top you can see the title, top 10 states with most active cases, and you see the edges are in red color for all the bars. On the x-axis you have the different state names: Maharashtra, Karnataka, Kerala. You also have Andhra Pradesh, Gujarat, West Bengal and Chhattisgarh. So as you can see, Maharashtra has the highest number of active cases based on our data, followed by Karnataka, Kerala and Tamil Nadu at second, third and fourth place respectively, and in the 9th place we have West Bengal, in the 10th place we have Chhattisgarh. On the y-axis you can see the total active cases, which are in lakhs. Okay, now moving ahead, now we'll see the top 10 states based on the total number of deaths reported. So I'll give a comment: top states with highest deaths. Okay, so I'll first create my variable saying top 10 underscore deaths. This will be very similar to what we did here, just that we need to change a few column names. So instead of active cases we'll be using deaths. Okay, so I'll start with my data frame, that is COVID underscore df, followed by using the group by function, and I want to group my data based on the state slash union territory column. Then I'll choose the max function, and within double square brackets I'll pass in my column names deaths and date. Let's make it consistent. I'll be using single quotes. Okay, I'll say dot, I'm gonna sort my result, therefore I'm using the sort underscore values function. I want to sort it by deaths column. I'll give another comma and say ascending equal to false, which means I want to order my result in descending order, then I'll say dot reset underscore index. Okay. After that, I'll give my figure size. I'll say plt dot figure, and within brackets I'll pass in my argument, which is fig size equal to, using a tuple, I'll say 18 comma let's say 5. Now let's give a title. For that I'll use the title function which is present in the matplotlib library. I'll say top 10 states with most deaths, and let's give a size to the title 25. Now it's time for us to give the access labels. I'll just scroll down. Okay, so I'll say ax equal to, again this will be a bar plot, so I'm using my Seaborn library followed by the bar plot function. My data will be top underscore 10 underscore deaths, which is this variable. I'll give my index location ILOC. I'm going to choose 12 states. The reason being, there are some discrepancies in the data. I'll show you once I plot this result. So in the y-axis we'll have deaths column. In the x-axis we'll take state slash union territory. Okay, I'll give another comma and say line width equal to 2, and we'll give an edge color to our bars like we did here. So I'll say edge color equal to, let's say, black. Okay, now finally we'll give the x label, the y label. So I'll say plt dot x label. X label would be states. My y label will be total death cases. Then I'll write plt dot show. Now let's run it. There you go. You can see here we have a nice bar plot. On the top we have the title top 10 states with most deaths. Now what I specifically wanted you to see was these discrepancies in the data. You can see here Maharashtra is repeated twice. Even in our data that we collected from Kaggle, Karnataka spelling has an error. You can see here we have a few rows of information where Karnataka is spelled as K-A-R-A-N instead of K-A-R-N-A. Alright, so to remove these two results, or to ignore these two results, I had given my index location till 12. So we have Maharashtra, Karnataka, Tamil Nadu, Delhi, then Uttar Pradesh, West Bengal, Kerala, Punjab, Andhra Pradesh and Chhattisgarh, with the states that have the most number of deaths reported. Okay, now we'll create a line plot to see the growth or the trend of active cases for top 5 states with most number of confirmed cases. So the states are Maharashtra, Karnataka, Kerala, Tamil Nadu and Uttar Pradesh. I can show you. So these are the states with highest number of active cases. Okay, I'll just give a comment saying growth trend. Alright, so for that we'll start with our figure size as plt.figure. I'll use my parameter fig size equal to 12,6. I'll say my axis as sns dot This time we are going to create a line plot. My data would be my original data frame, that is COVID_df, and within square brackets I'll say COVID_df, and we are going to pass in the state or the union territory column. I'll give a dot and use the isIn function. So the states should include Maharashtra, I'll give a comma, the next state should be Karnataka, next we have Kerala, give another comma, my fourth state is Tamil Nadu, give a comma, and my fifth state would be Uttar Pradesh. Alright, so I'll give a comma here and then say x equal to the date column, y will be active cases column, and I'm going to use another parameter called hue, which is to give different colors to the different states, the 5 states that we are looking for. So hue will be my state/union territory column. Okay, after this I'll say ax dot set title. My title will be top 5 affected states in India. We'll give a size, let's say 16. Alright, okay, this should be size equal to 16, and to make sure everything is fine, let me just move it to the above line. Okay, now we'll run it. Okay, there is some error again. It says invalid syntax. Let's see where we went wrong. Let me bring this to the above line. Okay, this should be COVID_df. Okay, make sure you keep these small errors in check. Let's try and run it again. Alright, if I scroll down, there you go. Here you can see we have the top 5 affected states in India. You see the different states here and the colors. So this violet or the purple color is for Maharashtra. You can see how the active cases surged around April and May, and then you can see even for Karnataka the active cases surged very rapidly around May and June. Then it has decreased, luckily. Similarly, you can see the plots for even Uttar Pradesh as well as for Tamil Nadu. So all the 5 states, you can see one common trend, that after March, so around April, the cases started to emerge very rapidly, and later after July they started dipping. Okay, now we are going to use our second data set, which is related to vaccination. Alright, so first and foremost, let me go ahead and print the data frame for you so that you know the data that we are going to use. So this is the data we are going to use for our next set of analysis. Even this data has a few errors, and you can see there are a lot of missing values. It makes sense because not all the days you would have vaccination for people, and very crucial error that we are going to deal with is this state column. Here you can see in the state column we have India in a few rows, so we are going to ignore these rows. Alright, first let's rename our updated on column to just vaccine date. So you can use the rename function present in the pandas library to do it. So I'll say vaccine underscore df dot rename. I'll say columns equal to, within curly braces I'll write updated on, which is my original column name, give a colon. I want to change this to vaccine underscore date. I'll give a comma and say in place equal to true. So it will change my column name from updated on to vaccine underscore date in the original data frame. Let's run it. Now let me go ahead and print the first 10 rows in the dataset. You can see here we have successfully changed the column name to vaccine underscore date. The rest of the columns remain the same. Alright, now you can check the total number of columns, rows, the data types and the memory usage using the info function. Here you can see it. We have total 24 columns, 7,845 entries, and these are the columns that are present. And if I scroll further, you see here says the memory usage, and here on the right you can see the data type. Cool. Now as you saw, the data has a lot of missing values. Let's find the sum of all the missing values for each column. So I'll say vaccine underscore df dot is null, and then I'm going to use the sum function over it. If I run it, there you go. So almost all the columns have missing values, but columns such as male individuals vaccinated, female individuals vaccinated, even for columns like the age groups, there are a lot of missing values. Now in the next step we are going to drop a few missing value columns. So I'll say a new variable called vaccination. I'll give the data frame name vaccine underscore df and use the drop function, and inside the drop function we are going to write columns equal to, I'll pass in the column names that I want to drop. I'll say doses administered. So this is the column that I want to delete, Sputnik V doses administered. I'll give a comma. The second column is AEFI. The next column is 18 to 44 years. Within bracket it has doses administered. Give a comma. I'll say 45 to 60 years, doses administered. Give another comma. The final column that we are going to drop is 60 plus, which is this one, 60 plus years. Doses administered. Okay. So these are the columns that we want to drop, and finally I'll give my parameter access equal to 1. Okay, let me just recheck these column names. First one is Sputnik V doses administered, then we have EFI followed by 18 to 44 years doses administered, then we have 45 to 60 years doses administered, finally we have 60 plus years. I have added a S here which was missing, and there should be a space as well because there's a space here in the column. Now let's run it. Alright, so we have successfully dropped the columns that we wanted to drop. Now I'll say vaccination.head. You can see here we have dropped those columns and we are left with these columns now. Okay, now we are going to create a plot, that is a pie plot, to see the vaccination for male and female individuals. So I'll give a comment as male versus female vaccination. To create this pie plot, I'm going to use the Plotly library that we had imported, which is this one, Plotly. Okay, so first of all we need to filter out the male individuals from our data frame. I'll say male equal to vaccination male. I'll passing in the column individuals vaccinated. Need to recheck the variable name whether it is correct or not. You see here male individuals vaccinated. Then I'll say dot sum. Similarly, we'll filter out the female individuals. I'll say female equal to vaccination, which is my new data frame. Within square brackets, I'll pass in the column name female individual vaccinated. I'll say dot sum. Okay, these should be individuals as per the column name present in the data frame. Cool. Now I'm going to say px dot py function, which is present in the Plotly library. I am going to give the names of the pies. So first one is male and the second one is female. Give a comma and say values equal to male comma female. Then I'll give a comma and pass in my title, which is male and female vaccination. Okay, this should be names. Alright, now let's go ahead and run this cell. So it'll take some time to create the pie chart. Here we go. See here I have my title male and female vaccination. So these are the two pies or the areas. You have the label female and the value. Here you have the label male and the value. So from our data you can see 53% male individuals have been vaccinated compared to 47% for females. Okay, now we are going to drop all those rows where our state was mentioned as India in the original dataset. I had shown this to you in the beginning, so we are going to remove rows where state is India. Okay. So to do that, I'll say vaccine. I'm creating another variable called vaccine, and we'll use our original data frame that we had imported, which is vaccine underscore df. I'll say vaccine underscore df dot state not equal to India. Now let's print vaccine. Okay, you can see here we have our data frame printed, and from this data frame we are taking only those values or the rows where state is not equal to India. Cool. Now what we are going to do is we'll rename the last column, which is total individuals vaccinated, to just total. So I'll say vaccine dot rename. We'll use the parameter columns equal to, within curly braces I'll say total individuals vaccinated, give a colon, and we'll change this to just total, give a comma, and say in place equal to true. And finally I'll print my head of the new data frame. This should be columns equal to. Okay. Now you can see here, if I scroll to the right and if I check, we have successfully renamed our column. Alright. Now moving on to the last two visualizations that we'll see in this first project using Python, that is to find the states with most number of vaccinated individuals and the state with the least number of vaccinated individuals. Okay, just give a comment, most vaccinated state. Okay, for this I'll first create a variable called vax underscore VAC, which is for maximum vaccination. I'm going to use my data frame vaccine followed by the group by function. I want to group it by state column, and we'll find the total sum of vaccinated individuals for each state. I'll convert this to frame. There should be a dot to underscore frame, and I'll pass in my column name, which is total. After that I'll say max underscore VAC equal to max underscore VAC dot sort underscore values. I'm going to sort it by my total column and say ascending equal to false, which means I want to sort it in descending order so that we have the states with the highest number of individuals vaccinated. I want the top 5 states. Now let's go ahead and print it. So this will create a nice table for us. There you go. Here you can see we have Maharashtra, Uttar Pradesh, Rajasthan, Gujarat and West Bengal as the top 5 states with most number of vaccinated individuals. Now we are going to use this table and convert it into a chart. Now I had already written my code for the bar plot. I'm just going to paste it. So here I have defined my figure size as 10,5. Then I'm giving a title as top 5 vaccinated states in India and the size is 20. After that I've created a variable called x, which is going to store my bar plot. This bar plot we have created using the Seaborn library, and you see here I have my y-axis defined, then I have the line width and the edge color as well. I have given my x label as states, y label as vaccination, and I'm finally going to display my plot. So let's go ahead and run it. Okay, you can see it here. We have converted this table into a bar plot now. So first we have Maharashtra with the highest number of vaccination. Then we have Uttar Pradesh, Rajasthan, Gujarat and West Bengal. Now I want the viewers watching this video to find the states with least number of vaccinated individuals and convert that table into a bar plot that will show the bottom 5 vaccinated states in India, which means the states which have least number of individuals vaccinated. So please go ahead and put your codes in the comment section of the video. It will be very similar to these two cells, just that now we want to know the least 5 vaccinated states in India. So please put the code snippets in the comment section of this video. We'll be more than happy to know from you. In case you are not able to do it, we'll definitely give the answers in the comments itself. Alright, so this brings us to the end of the first project on COVID data analysis using Python. So in this project we used two datasets. One was on the COVID-19 India dataset for different states and union territories, and the second dataset that we used was for analyzing the status of vaccination in the different states in India. Now we'll move on to our second project. Okay, so before moving on to our Tableau project, let's see the final quiz. Which of the following is not a common coronavirus symptom? So this question is to make you aware of the correct COVID symptoms. Here are the options. Is it A, fever, B, vision loss, C, loss of taste and smell, or is it D, cough? Please put your answers in the comment section of the video and let us know what you think. Now we'll move on to our second COVID data analysis project. For this project we'll be using the Tableau software and a global coronavirus dataset. First we'll look at the dataset and the fields we have. Okay, so I am in my dataset folder. We have already seen the first two datasets in our Python project. This time we are going to use the global COVID data. Let me open it. Alright, so here you can see we have the different country names. There are 192 countries in our dataset. Let me go to the top. So we have country or region. We also have the code for each of the countries. Then we have a column called last updated. So here you can see our data is still 12th of March 2021, and there are two columns which don't have any information, that is people hospitalized and people tested. Then we have a column called active cases. Then we have a column for confirmed cases in the different countries. We have the number of deaths, and then we have the incident rate, the latitude and the longitude for the countries. Then we have the mortality rate. This is in fractions. Then we have the number of recovered cases, and finally we have a column called UID. So we'll be mostly using the country column, active, confirmed, deaths, and the recovered cases column. And we'll be using the Tableau software to create interesting visualizations, and we'll convert those visuals and put it in the form of a dashboard towards the end of the project. Okay, so let me close this file, or let it be open. I'll search for Tableau public. You can see here I have Tableau public installed. You can use the desktop version of Tableau or the public version of Tableau. So for this project we are going to use the Tableau public edition. So here you can see I have created a few visuals already. If you want, you can clear them out. Okay. Now the first thing we need to do is to connect our CSV dataset to Tableau. For that, under Connect, we have to a file. I'm going to use text file, and under Chrome downloads, I'll search for my folder COVID-India, and here I have my global COVID data file. Let me open it. This will take some time to load. There you can see. So on the Tableau you can see the view here. It shows the country or the region. You have the last update. You have columns like active, confirmed, deaths, mortality rate, and recovered. And here you can see the symbols for the different columns. So this is a globe, which means this field is a region or a geographic field. ABC means it's a text field. Then we have the calendar, which is for a date field. ABC are text field, and this hash represents numeric fields. Alright, so now that we have loaded our data, let me just click on sheet 1. So this is the canvas where we are going to create our different reports. Alright, so on the left you can see there are two panes, the data pane and the analytics pane. In the data pane you can see the name of the dataset, global COVID data, and here you can see the different columns that we have in the dataset. So on the top, the ones marked in blue are called as dimensions, and at the bottom, whatever you see are marked in green and are called as measures. So dimensions are always represented with blue icons and measures are in green icons. So Tableau has automatically detected the different data types for each of the columns. Alright, so first of all we are going to create a simple table to see the total number of confirmed cases for each of the countries. So for that I'm going to drag my country or the region column onto rows. Here you have rows. I'll just drag it and drop it here. There you go. It has populated all my country names starting from Afghanistan till Zimbabwe. So it has ordered in ascending order of alphabets. Now to see the total confirmed cases for each country, I'm going to drag my confirmed column onto text. So here under marks card you have the text option. I'll just drag it and drop it here. There you go. So Tableau how easily has shown me a table where you can see the different country names, and on the right you have the total number of cases that have emerged from these countries. Now this is not the most recent data. As I told you, this data was till March 2021. Cool. Now you can go ahead and sort the table based on the total confirmed cases. Here on the top you can see here there are two options to sort in ascending order or in descending order. Let's first sort in ascending order by sum of confirmed cases within country and region. There you go. So here you can see these are the countries which have very few cases, and if I scroll down you have France, UK, Russia, Brazil, India and US with the highest number of COVID-19 cases. If you want, you can also sort it in descending order so that the countries with the highest number of confirmed cases appear at the top. You can see it here, and these are the countries that have very few COVID cases. Now you can convert this simple table into different charts and graphs. To do that, here on the right top corner you have an option called show me. Now I can just click on this horizontal bar graph, so that will automatically convert my table into a bar graph. Again, you can go ahead and sort the data. There you go. So here you have US, India, Brazil, Russia, UK, France, Spain and Italy. This is a horizontal bar graph sorted in descending order of confirmed cases. Now suppose you want to display only the top few countries with the highest number of confirmed cases. For that you can select these bars. So I'll select till, let's say, Germany, or let's say till Argentina. Okay, and I'll click on keep only. You can see it here, it says 12 items selected, that is the sum of confirmed cases. I'll just click on keep only. There you go. So this horizontal bar graph has information only for these few countries that have the highest number of confirmed cases. Now you can go ahead and play with the color formatting. So here under colors, let me choose a green color. Okay, now you can mark here, since we selected only the top 12 countries with the highest number of confirmed cases, so what we did was we just filtered it to the top 12 countries. So Tableau has automatically added country region in the filters card. Now if you want, you can go ahead and edit this filter as well. Suppose you want to remove Argentina, you can just uncheck this, click on apply and OK. You see here Argentina has been removed. I click on undo, so Ctrl Z to get it back. Cool. Now you can convert this horizontal bar plot into a vertical bar plot. Let me show you how to do it. I'll just remove these fields from my chart. Now what I'm going to do is I'll drag country or region onto columns, and I'll have a confirmed column under rows. There you go. Here you can see we have a vertical bar plot now, and again you can use the axis now to sort your data. This is in descending order. Similarly, you can sort it in ascending order. Here you have the option to sort your data. Okay, cool. And below you can see the different country names. Alright, now you can go ahead and give a name to this sheet. Let's say top 10 confirmed countries. Just apply and click on OK. You have the title to this plot. Similarly, you can change it here as well. Top 10 confirmed countries. Okay, now let's move on to our second visualization, where we will create a global map. So this global map will show the different countries present in the map and the cases that they have. So to create the map, first I'll drag my longitude generated field onto columns, and then I'll drag latitude onto rows. You see here we have the map ready, and now I'll drag country region onto detail. So this will give you the different country names. You can see here we have Canada, the United States, Mexico. Here you have India, Sri Lanka, there's Australia, this is Brazil, and similarly we have Spain, France, Belgium, there's Italy here, we have also Greece. Similarly we have the African countries like Central African, Angola, and on the top you have Russia, and this is Iceland, so on and so forth. Now I'm going to drag the active cases column onto detail again. Now if I hover the cursor, you can see the active numbers for Brazil, you can see for India, you have countries like China, then here you have Thailand, Algeria, Now I'm going to drag the confirmed cases column onto label so that you have the labels here. You can see here the confirmed labels. Cool. Now if you only want to focus on a few countries present in a particular region, you can highlight that region. For example, suppose for Europe you want to focus on this region. If you select it, it will highlight only those countries, and if you hover your mouse over these points, it will show you the active cases and the total number of confirmed cases. Alright, now if you want, you can go ahead and change the color of the circles. Let's say I'll keep it as red. Okay, so this is how you can create a map to represent the different active and confirmed cases. I'll rename the title to global cases. I'll just click on apply and OK. Similarly, I'll change the sheet name as well to global cases. Okay, now from this map you can see the countries such as USA, Brazil, you have Russia and India with the highest number of COVID-19 cases. Even in countries such as Spain, the numbers are really high, and a lot of the African countries were also impacted. And these small countries like Solomon Islands, you have Fiji Islands with few number of cases, even for New Zealand as well. Alright, now moving to our next visual. Now we are going to see the top 10 countries where highest deaths have been reported so far due to the pandemic. For this, we will create a tree map now. So first of all, I'll choose my country column and put it under columns, and then I'll select the deaths column and put it under rows. I have the bar plot ready. Next, I'll go to show me, and here I have the option to select a tree map. You see here, for a tree map you need one or more dimensions and one or two measures. So I'll just click on this tree map. Okay, here you can see I have my tree map ready. So Tableau has automatically adjusted my fields. So it has removed my fields from rows and columns and put it under size, color and label. Next, I will drag my country column and put it under filters, and from here I'm going to choose top. I'll filter by field. I'm going to select the top 10 countries based on the total number of deaths. Just click on apply and click on OK. So these are the countries: US, Brazil, Mexico, India, United Kingdom, Italy, Russia, Spain, France, Germany, which have the highest number of deaths reported. Now you can also give the label. I'll put the deaths column under label so that you have the labels here. Alright, so this was a tree map that we created to show the top 10 countries with the highest number of deaths. I'll just change the title, top 10 deaths cases. Now you can also edit the title in terms of the font, color and everything. Let's say I'll keep it Tableau bold and I'll choose this as 14. Click on apply and OK. There you go. Similarly, let's rename the sheet to death cases. Cool. Now moving to the next visualization, where we'll see about the recoveries. So before we move on to create a visualization for the top 10, or let's say the bottom 10 countries in terms of recoveries, let me show you how to change the color of this tree map. So here by default Tableau selects the automatic palette. If you want, you can change it to different palettes. Let's say I'll go with gold, purple, diverging. Click on apply and I'll click on OK. If this is not looking that great, you can select another one, let's say red, green, white diverging. Cool. Now let's go to our fourth visualization, which is about top 10 recoveries. I'll click on apply and OK. First, I'll drag my country or the region column under columns, and then I'll take the recovered column under rows. This time, instead of sum, we are going to choose average. Okay. And here I'll select my packed bubble chart. After that, I'm going to drag my country or region onto colors, and then I'll also put country under filters. So I'll go to the top menu and I'll filter it by field. I want to show the top 10 countries based on the average number of recoveries. If I click on apply and OK, you can see here these are the countries that have the highest number of average recoveries. You have India, Brazil, Turkey, Italy, Argentina, Germany, Colombia, Russia, Poland and Mexico. I'll just rename this sheet to recovery cases. Cool. Now let's move on to our next visual. Okay, so here we are going to create a scatter plot to analyze the total confirmed cases versus the total number of deaths. So whenever you have two numeric fields, it is better to create a scatter plot to visualize the cases. So for that, I am going to drag my confirmed cases to columns, and then I'll drag my deaths column onto rows. Okay. So by default, the shape is a circle, and to see all the countries, I'm going to drag country under color. I'll say add all members. There you go. Here you can see the legend for the different countries, and the top you have US with the highest number of confirmed cases and the highest number of deaths as per our data set. Then you also have Brazil here, which has the second highest number of deaths. Then you have Mexico followed by India. So this data is not a very recent data. This data was last updated on March. Now from this, we are going to filter out the top 10 countries with the highest number of confirmed cases and the deaths. So for that, I'll drag my country column onto filters, and I'll go to top, I'll filter by field, I'll say top 10, and I'll click on apply and OK. So here you can see we have Siberia, Sweden, Belgium, Netherlands, Spain, Italy, France, Russia, UK, and you have Brazil. So these are the countries which have the highest number of active cases. So instead of active, let's select deaths, click on apply and OK. Okay, now if you see, we have US here, Brazil, India, then Mexico, UK, Russia, France, Italy, Germany and Spain, which have the highest number of deaths reported so far. Now if you want, you can change the size of the circles based on the highest number of active cases. So I can just drag my active column under size. So you can see here Spain, France, UK have the highest number of active cases. Now let's say instead of active, I'll just have my confirmed cases under size. Okay, and then you can also change the shape from circle to any other shape, let's say square or this asterisk. Okay, let's go with the triangle. Cool. I'll rename this sheet to confirmed versus deaths. Click on apply and OK. I'll rename this to confirmed versus deaths. Alright. Now moving on to our next visualization, where we will see the mortality for each of the countries and figure out which countries have the highest mortality rate. Okay. So first I'll drag mortality rate onto column, and then I'll have my country column under rows. So there you go. Now let me go ahead and sort it in descending order. So you can see here you have Yemen, there is Mexico, Syria, Sudan, Egypt, Ecuador, China and other countries which have the highest mortality rate. And you can also select the country region under colors. Let's go ahead and edit the color. Instead of automatic, let's select summer, or you can go for some other palette. Let's say Tableau Classic Medium. I'll assign this palette. Yes, I'll apply and OK. Alright. Finally, we'll move ahead to our last visualization, where we'll create a dual axis chart. So the dual axis chart in Tableau will have one column and two different visualizations on the rows. So here you have one column, and on the right also you'll have one column with their own axis values. So this dual axis chart will be for recovered cases and the death cases. Let me show you how to do it. So I'll drag my country field onto columns, and then I'll choose recovered column onto rows. So here I have got my line chart, and the second column I'm going to choose is the deaths column. I'll hold my cursor and I'll place it when I get this green color rectangle. I'll place it here. There you go. So now we have created two measure names, deaths and recovered, and here you have the axis values. You can synchronize the axis values if you want. The recovered cases are in millions and the deaths are in thousands. Now let's go ahead and change the recovered line to bars, and we're going to short it. Okay, now let's change the color. We'll select, let's say, blue. I'll assign the palette, click on apply and OK. And if you want, you can also change the color for deaths from blue to, let's say, winter. I'll assign the palette, click on apply and OK. You can have whichever color you want, and to make the axis same, you can just right click on this axis and click on synchronize axis. So here you can see the values. Let's keep it in thousands only. Cool. I'll rename this sheet to dual axis. Okay. Now before we move ahead and create our final dashboard, I want to show you one more feature in Tableau, that is to format the labels. So you can see here, instead of writing 5,30,821, we can change this in terms of millions or thousands and write it as, let's say, 530K. To do that, what I'll do is I'll go to Format, and here we have the option to select Font, and in Font I'll go to Fields and click on Sum of Deaths, and here in this pane I'll choose Number Custom, decimal places will be 0, and display units I'll select thousands. You can see here the values have been changed to 531K, 193K, 158K, so on and so forth. Cool. Now let's go ahead and create our final dashboard. Here is the option to create a new dashboard. So I'll just click on New Dashboard, and we are going to increase the size here so that it fits our view. So we have selected the default view, and the size I'm going to choose here is automatic. So now we can drop our sheets one by one. First, let's drag the global cases sheet here. Okay, you can see we have our map. Now I'm going to choose the top 10 confirmed cases. Alright, and after that we'll choose the death cases sheet. So Tableau will prompt you to place the sheet at the right location. Okay, and now I'll choose my fifth visual, which is confirmed versus deaths, and if you want you can choose any one of these. Let's say I'll take the dual axis chart. Now you can just minimize the sheets and adjust the sizes to make it look better. Okay, so you can see here we have our dashboard ready. Now you can still go ahead and customize the dashboards in terms of adding different filters to it. We are not going to show that. Now you are getting some messages here: 2 unknown, 4 nulls. You can remove them as well, and here on the top you have the option to click on the presentation mode. There you go. So this is our final dashboard that we have created. Alright, so this brings us to the end of the second coronavirus data analysis project using Tableau. Now you can just click on escape to go back. Alright, now you can save this, and this will be published in the Tableau public platform under your profile. So that brings us to the end of this video tutorial on COVID data analysis project using Python and Tableau. Welcome to this exciting video on Olympics dataset analysis using Python by Simplilearn. This is going to be a very interesting and interactive session where I'll give you a brief about the history of Olympics and throw some light into the recently held Tokyo Olympics. But we'll focus more on using Olympics dataset that is available on Kaggle and perform some exploratory data analysis. You will understand how to use different functions in Python to analyze and extract meaningful information. During the course of our discussion, I'll be asking you a few general questions related to the Olympics. Try to answer them in the comment section of the video. So let's begin. The Olympics is one of the biggest sporting events on the planet. It is held every 4 years. The first modern Olympics took place in Athens, Greece in 1896. As per National Geographic, the original Olympics took place in 776 BC, so they began as part of an ancient Greek festival which celebrated Zeus, the Greek god of sky and weather. The rings in the Olympics logo represent the 5 continents: Europe, Africa, Asia, the Americas and Oceania. From 1924 to 1992, the Winter and the Summer Olympics took place in the same year, but now they alternate every 2 years. Before I move on, here is an interesting question for you. Only 2 people have ever won gold medals at both the Summer and the Winter Olympics. Who are those 2 people? Please share your answers in the comment section of the video. We would like to know from you. The Summer Olympics in Tokyo began on the 23rd of July and recently concluded on the 8th of August. We got to witness some thriller matches that went down to the wire, some amazing victories, and sadly, there were a lot of heartbreaks as well. Winning and losing are part and parcel of any game. Fans across the world were really happy to see this global event happen this year following last year's postponement due to the coronavirus pandemic. With our Olympic fever high, let's take this opportunity to work around a project to perform exploratory data analysis using Python to analyze and visualize past Olympics data and answer specific questions. In this video, we will be using specific Python libraries such as NumPy, Pandas, Matplotlib, and Seaborn to make sense of our data and extract meaningful information. We are going to visualize our results with different charts and graphs. Before I show you the dataset that we are going to use for our analysis, I have another general question for you. Which is the first Olympics where all the participating countries sent female athletes? I repeat, which is the first Olympics where all the participating countries sent female athletes? Put the year and the city name where the Olympics was held in the comment section of the video. We'll be more than happy to hear from you. Now, let me go ahead and show you the datasets that we'll be using in this video. So here you can see I have my Olympics dataset folder that has 2 datasets. These are CSV files. One is called the athlete_events and the other one is called NOC_regions. So we'll be using these 2 datasets. These datasets can be downloaded from Kaggle. We will post the dataset links in the description of the video. Please go ahead and download them. These datasets have been directly taken from the internet. Now I'll show you the datasets. So this is my first dataset. You can see on the top athlete_events. So I have around 15 columns. You can see the count here, and there are nearly 2,71,116 rows of information. So this is a huge dataset that we are going to use. The other dataset we are going to use in this demo is called NOC_regions. Now here one thing to note is NOC stands for National Olympic Committee. This is a 3-letter code that is given by the Olympic Committee. You have the region names. So AFG is for Afghanistan. You have ALB for Albania, ALG for Algeria. We have also a column called notes. You find some notes about the region. For example, here Antigua is actually Antigua and Barbuda. Alright. Let's move to the first dataset that I showed you. This is our primary dataset for our demo. So these datasets have been directly taken from the internet and were not validated. So the results that you will see in the demo is purely based on the data that we have collected. So the file athlete_events.csv contains nearly 2,71,116 rows of information, and there are 15 columns. So each row corresponds to an individual athlete competing in an individual Olympic event. So here ID is actually a unique number for each athlete. Then we have the name, which is basically the athlete's name. We have the sex or the gender, which is male or F for female. Then we have the age of the athlete, which is in terms of integers. We have the height in centimeters of the athletes. Then we have the weight in kilograms. We have the team name. These are the country names. You have China, Denmark, Netherlands. There are around 200 country names. Then we have the NOC. As I said, NOC is a 3-letter code that stands for National Olympic Committee. We have the games. This games contains the year and the season. You can see here 1992 summer. You also have the Winter Olympic information. Alright. Then we have a specific year column to tell you in which year this event had occurred. Now the year column is also an integer column. We have the season, so whether it was Summer Olympics or Winter Olympics. Then we have the city name. This is the host city. Then we have the sport name. You can see here we have basketball, judo, football, tug of war, speed skating. There are so many. Then we have another column called event, which is the complete event name. As you can see, the sport name is basketball, but the event name is basketball, men's basketball, to be very specific. Again, for speed skating, you have different categories like women's 1000 meters, 500 meters. All right. Now the final column is the medal column. So it has the information about the athlete, whether the athlete had won a medal, be it gold, silver, bronze, and NA means the athlete did not win any medals. So we'll use these two data sets. Now let's get started with the demo. We'll be using Jupyter Notebook for our analysis. So I'll take you to my Jupyter Notebook right away. I have opened it on Chrome. So this is my Jupyter Notebook that we are going to use. You can see here Olympics dataset analysis. I have already have a few cells that have been filled with some piece of code, and you can see there are some comments written as well. We are going to use this dataset. So let's get started. First and foremost, we'll import the datasets. So we are going to use NumPy, Pandas, Matplotlib, and Seaborn. Let me hit Shift Enter to import all the libraries. All right. Now the next thing is to load the datasets using Pandas read_CSV function. So I'll create a variable called athletes. I'll say equal to pd dot. I'll use the read_CSV function, and inside this function we'll give the location of the files. So I'll copy this location and here I'll paste. Make sure this is within quotations, and these are all /. I'll give another /, and after that I'll give the file name, that is athlete underscore events dot csv. I'll close the quotation. Let's run it. Okay. Similarly, we will load the second data set. I'll create another variable called regions. So it will have my data frame. I'll use the same function pd dot read_CSV. I'll just copy this file path till here. We'll paste it, and I'll give my second file name, which is noc_regions.csv. You can verify here. The first one is athlete_events. The second one is noc_regions. Okay, I'll close the quotation and we'll run it again. Okay, there seems to be some error. I think this is the regions. Cool. Now moving ahead, let's see the first few rows of both the datasets. I'll use the head function for that. I'll say athletes.head. So this will print the first 5 rows from my dataset athletes. You can see here from 0 to 4 you have 5 rows of information: the ID, name, sex or the gender, age, height, weight. If I go to the right, you have games, year, season, sport, event and medal. Now let's see the second dataset that we imported or loaded. I'll say regions.head. It says regions is not defined. Let me cross check it. Okay, I have taken it as region. Let's make it regions. Cool. Now let's run it. There you go. So these are the first 5 rows from our second data set. You have NOC, region and some notes. Alright. Now the next step is to combine both the data sets. So we'll join the data frames using the pandas merge function. Let me show you how to do it. So this is going to be a horizontal join. I'll create a variable called athletes_data df. Then I'll use my first variable, which is athletes. I'll say dot merge, which is my function name. I'm going to merge the regions data frame. I'll use the how parameter. In how, I'll give my value as I want to do a left join, and my common column in both the data sets is actually NOC. So I'm going to use the NOC column as my common column to merge both the data sets. Now let's go ahead and print the merged data frame. I'll say athletes underscore df dot head. Let's run it. There you go. So if you see clearly, if I move to the right, you can see here we have added two more columns that were present in the second data set, which was regions. So we have regions and nodes added to my first data set, that is athletes underscore events. Cool. Now one thing to note here is, see, the column names are not consistent. If you see here, the rest of the columns start with a capital letter, but if you see the last two columns that we just added now start with a lowercase letter. So we'll use the rename function to make the column names consistent. But before that, let's see the shape of the data frame. So I'll print the shape of the data frame to know the total number of rows and columns. I'll say athletes. If I hit tab, you will see it will give me the prompt. I'll select athletes underscore df. I'll use the shape attribute. Let's run it and see the result. You can see here it gives me the total number of rows, so 2,71,116 rows, and earlier we had 15 columns in the first data set, and now that we have added two more columns, so the total number of columns becomes 17 now. Cool. So now it's time to make the column names consistent. So I'll show you how to do it. I'll say athletes underscore df dot, I'll use the rename function, and then I'll say columns equal to, I'll use curly braces, my first column, that is region. I want to change it to region, but the R should be capital now or uppercase. I'll give a comma and then say my second column, this should be region actually. My second column, that is nodes, I want to change the first letter to uppercase, so I'll say capital N. The rest all remains same. I'll give a comma here and say in place equal to true. So it will change the column names and will reflect in this athletes underscore df data frame. Let's run it. Now to verify, you can again use the head function. I'll run this again. Let me scroll down and move to the right. You can see the difference. There you go. So we have successfully renamed the last two columns, region and nodes. All right. Now moving ahead. Now I'll show you how you can use the info method to print information about a data frame, including the index data type, the column data types, non-null values, and memory usage. So for that, you just need to use the info function. So I'll write athletes underscore df dot info. Let's run it. There you go. So here we have the data columns. You can see total 17 columns. You have 2,71,116 rows or entries. Then you have the different column names, and it says non-null and the data type of the column. Below you can see some information about the memory usage. All right. Next, The describe method is used for calculating statistical information such as mean, standard deviation, the percentiles of the numerical values of the data frame, and much more. It analyzes both numeric and object series and also the data frame column sets of mixed data types. So let me show you how using the describe function you can display some statistical summary. I'll just write describe and give parenthesis. Let's run it. Okay, if I scroll down, you can see here by default the describe function will only give information about numerical columns. So here you can see we have the total count, the mean of each of these columns, you have the standard deviation, the minimum and maximum value, and then we have the 25th percentile, the 50th percentile, and the 75th percentile value of the columns ID, age, height, weight, and year. Alright, now one thing to notice here is if you see the year column, the minimum year is 1896. So this is when Olympics started, and until recently the Rio Olympics that was held in 2016. Alright, now moving ahead, now let's check if there are any null values present in the columns of the dataset. So first I am going to create a variable called NaN values, give equal to, I'll say athletes underscore df, and the function to check is I'll say is NA. I'll create another variable called NaN underscore columns, and here I'll use the any function. I'll say NaN underscore this variable which is underscore values dot I'll say any, and I'll print my NaN columns variable. So this will display the result in terms of Boolean values. So if there are any null or NaN or missing values in any of the columns, it will say true, otherwise it will say false. Let's display the result. There you go. So if you mark here clearly, so there are nearly 6 columns where we have missing values. You have age, height, weight, medal, region, and notes columns that have missing values, so hence it has given us true. The rest of the columns do not have any NaN or missing values, hence they are false. Alright, let me scroll down. Now let's see the total number of null values for the above 6 columns. So I'll say athletes underscore df dot, I'll use the function is null, and again I'll use the sum function. Okay, this should be is null. If I run it, you can see it here. So our age column has 9474 rows where we have null values. Then we have some null values for the height column as well, for the weight column. So these are the total number of rows where we don't have any information regarding age, height, weight, or region. Notes, this medal is self-explanatory because a lot of the athletes who participate in Olympics don't win any medals, so for them the value is NA. Now before I move ahead, I have a question for you people. So the question is, I want you to print the column names containing null values or missing values in the form of a list. So please answer this question and put it in the comment section of the video. We would be happy to know your approach. So the question, I'll repeat it again. I want you people to print the column names containing null values or missing values in the form of a list. So basically on the top we saw there were 6 columns that had null values. I want you to print these 6 columns in the form of a list. Alright, now moving ahead. Now let's see the data for specific countries. let's say you want to see the athletes who have participated in the Olympic Games from the beginning for India. For that, you can filter your result using a function called query. So let me show you how to do it. I'll say athletes underscore df dot, will use the query function, and then I'll say team, which is my column name, should be equal to, and the value I'll give is India. Now let's display the first 5 rows of information or the details for the athletes who are from India. If I run this, okay, there is some error here. Okay, so we need to make sure this entire expression or the condition should be within single quote. I'll just delete this single quote from here and we'll add it in the end. Now let's run it. There you go. So here you can see we have the top 5 rows of the athletes who are from India. You can see here the region is India, you can see the NOC is India, the team is India, and let me go to the left. You can see the name of the athlete, the sex, age. So for age you have some missing values, you have the weight, team, year, and everything. Alright. Similarly, you can also check for Japan. Let me just copy the above code. I'll paste it here, and instead of India I'll say Japan. I'll run it. There you go. So if you see here, you can see all the details are for the athletes who are from Japan. Alright. Now moving ahead. Now I want to know the top 10 countries who have participated since the inception of Olympics in 1896. So for that I'll create a variable called top underscore 10 underscore countries. I'll say equal to, I'll use my data frame, that is athletes underscore df. I'll say dot team, then I'll use the function value underscore counts. I'm going to sort my count in ascending order. Just mark the way in which I'm writing the functions. Any error in terms of syntax or the flow will throw you an error. I want to display the top 10 countries. Now let's go ahead and print it. I'll say top underscore 10 underscore countries. Alright, let me run it. Okay, it has given us an error. Let's debug it. Okay, so this should be value counts and not count. Let's run it again. Another error. Okay, so this should be short underscore values and not value. Let's run it again. There you go. So here you can see the top 10 countries participating in Olympics since 1896. You have United States, then we have France. So these are the number of participants who have taken part since 1896. So the most number of participants have come from US, then we have France, Great Britain, Italy, Germany, Canada, Japan, Sweden. We also have Australia and Hungary. I'll scroll down. Now we are going to convert this table that we got, or the output that we got, in the form of a graph. So I'm trying to create a bar plot to plot the top 10 countries who have participated in Olympics. So here I'm using the figure function to give the figure size. So these are the dimensions 12,6. Now I'll tell you what this pltxtix means. Just wait for a while. I have given a title to my plot saying overall participation by country, and then using the Seaborn library and the bar plot function, I am plotting the x and the y axis So my x-axis has top. I should make this top 10 countries because above we used top underscore 10 underscore countries. Similarly for y-axis, I'll make it top underscore 10 underscore countries, and then I'm using a color palette called set2. Let's run it. There you go. So if I scroll down, you can see here we have a nice bar plot. This is a vertical bar plot, and here you can see the bars which represent the different country names. First we have United States, which has the highest participation since the beginning of the Olympics. Then we have France, Great Britain, Italy, Germany, Canada, and we have the rest of the countries. Cool. Now moving ahead, the next visualization we are going to see is the age distribution of the athletes. So for this, we are going to create a histogram. I'll be using the matplotlib library specifically for this visualization. So I'll say plt.figure. We'll give the figure size using the argument fig size equal to, and this will be a tuple actually. My size is going to be 12,6. I'll say plt dot title. Now you can give any title that you want. I'll say age distribution of the athletes. Then we'll also give the x labels. I'll say plt dot x label. This will have age. Then we'll say plt dot y label, and this will have the label as number of participants. Next, I'm going to use the hist function, so I'll say plt.hist, and I'll pass in my data frame, that is athletes underscore df dot age, which is my column name, comma, I'm going to pass in the bins. For that I'm going to use the np.arange function, so np is for numpy, and inside this I'll say 10, 80, 2. So my bins will start from the value 10 and go until 80 with a size of 2, comma, I'll give another parameter that is going to specify the color of the bins. I want my color to be orange, and then I'll use the edge color to separate the bins. I'll say edge color, this is the parameter or the argument name, and the color I want is white. Let's give a semicolon here, and this should be edge color. There's a spelling mistake here. Now let's run it and we'll see the output. So there you go. So this is a nice histogram that shows the distribution of the age of the athletes. You can see the title age distribution of the athletes. On the y-axis you have the number of participants. On the x-axis we have the age values ranging from 10 to 80 with a size of 2. And if you see this, we have most number of athletes who have an age between 20 to 30. You can see here. So early 20s we have maximum number of athletes participating in the Olympics. We also have a few athletes who are beyond 40 years of age. You can see here we have a few athletes even closer to 60 also, and similarly we have a few athletes who are under 18 years of age. Alright, now you can see here the bins we had taken orange color, so all the bars are represented in orange color, and the edge you can see here we have the white color. Alright, now moving ahead. Now in the initial slides of the video we discussed the summer and winter Olympic games. Let's look at the different sporting events that are part of the Summer and Winter Olympic Games. Just to give you a heads up, the Winter Olympic Games are held once every 4 years for sports practiced on snow and ice. So here I have my variable name winter underscore sports. So I'm extracting for season equal to winter, and I am going to display only the unique values. Now let me run this cell. Okay, so you can see here these are the different winter sports that are held during the Winter Olympics. Now similarly, let's see for Summer Olympics. So what I'm going to do here is I'll just copy this cell of code and we'll edit the variables. I'll say summer underscore sports, athletes underscore df remains the same. Here season, we'll change it to summer. Dot sport dot unique remains the same, and here I'll say summer underscore sports. This should be small. Now let's run it. There you go. So here you can see we have more number of Olympic sports that are held during the Summer Olympics compared to Winter Olympics. So these are the sports that are played on snow and ice, and these are the sports that are played during summer. Moving ahead, now it's time to analyze the total number of male and female participants who have taken part in different games since 1896 till 2016 Rio Olympics. Alright, so I'll say gender underscore counts, which is my variable name. I'll use my data frame, that is athletes underscore df dot my variable name, that is sex, dot value underscore counts, and then we are going to print gender underscore counts. Let's run this. There you go. So since the inception of Olympics, we have more number of male participants than female participants. Now here in this current cell, you can see we are trying to plot a pie chart for male and female athletes. So I have given my figure size, then I have my title as gender distribution. I'm using the matplotlib library and the pie function. I'm using the variable gender counts that we used here. Then I'm giving my labels as gender underscore counts dot index. Now I'm using this auto PCT. The auto PCT parameter enables you to display the percent value using Python string formatting. So this is my string formatting that I have used, and I'm initialized my start angle for the pie chart as 150 degrees, and I'm also giving shadow to my pie chart. So I have written shadow equal to true. Let's run it. Alright, so you can see here this is my pie chart that shows you the distribution of the male and female participation. So for male it is 72.5%, for female so far it is 27.5% as per the dataset that we have. We can change this start angle to, let's say, 180 degree, and it will change the pie chart to this direction. Cool. Now moving ahead, this time we are going to find the total number of medals that the athletes have won. So I'll use my data frame athletes underscore df dot, and then my column, that is medal, I'll say dot value underscore counts. Let's run it. There you go. So you can see the gold medals, the bronze medals, and the silver medals are very much similar to each other. The numbers are pretty much the same. Alright, now it's time to focus on the total female athletes who have taken part in each Olympics. So I'll create a variable called female underscore participants. I'll say equal to, and then use my data frame name, that is athletes underscore df. Using square brackets, I'll say athletes underscore df dot, the gender should be equal to female, and I'll use ampersand. I'll say, just copy this, paste it here. I'll say dot season equal to, we'll check for Summer Olympics, and I want to extract only the gender column, so here it is sex, comma, my year column, which is year. Okay, and then I'll say female underscore participants equal to, I'll just copy this, paste it here, and then I'll use the group by function, say group by, which is part of the pandas library. I'll say year, and then I want to find the count. I'll reset the index, say reset underscore index is a function, and finally we are going to print female underscore participants, and let's say the head. Alright, so what we are trying to do is, I'm trying to filter my data only for the female athletes for Summer Olympics, and here I am printing the participation based on each year, so I'm finding out the count. So here we need to add one more square bracket. Alright, now we'll run it and see the result. There you go. So you can see here from 1900, 1904, all these years you can see the female participation. Let me change it to tail so that we have the recent data of the Olympics. You can see it here for the Beijing Olympics, 5,816 women athletes participated. In 2012 London Olympics we had 5,815 Olympics. Similarly for the 2016 Rio Olympics we had more participation than the London Olympics, so 6,223 women athletes had participated. Alright, now here this is another way in which you can filter your data for female athletes. So I'm using two parameters. My gender should be equal to female and season is Summer Olympics. Let me just run it. I have stored it in a variable called Women Olympics. Now here I am trying to find a count plot, or I am trying to create a count plot using my Seaborn SNS library. I have set my style to dark grid, then my figure size I have given as 20,10. My count plot will have the x-axis as year, the data is Women Olympics, and palette I'm using as spectral, and then I've given a title Women Participation. Let's run and see the output. There you go. If I scroll down, you can see on the top I have the title for my count plot which says Women Participation, and on the y-axis I have the count, and at the bottom you can see the different year values from 1900 till 2016, and 2016 had the highest number of female participation. Cool. Let me scroll down. So in this cell of code we are trying to plot a line graph. Let me run it and show you the output. So this line graph shows the trend which says plot for female athletes over time. So here you can see the line graph. So gradually the women participation has increased in Olympics since its inception. There was a slight decrease here. This is around 1950s, and again you can see here there's a decrease with the women participation in 1980, but since then, since 1980, there has been continuous increase in the participation of female athlete numbers. Cool. Now coming to the next section of our analysis, Now we are going to filter the data to see the details of the athletes who have won gold medals. So I'll create a variable called gold medals. It's equal to, I'll use my data frame as athletes underscore df, and within parenthesis I'll use my data frame name, which is athletes underscore df dot, I'll use the condition medal equal to, and my value would be gold. Next, I'm going to say gold medals dot head. Let's run it. There you go. So here we have the top 5 rows of the athletes who have won a gold medal. You can see all the records have medal as gold. Now we are going to use this subset of the data and perform some more analysis. So here I want to take only the values that are different from NaN. So I'm going to use is finite function, and inside that I have set gold medals age. Let me just run it. Cool. Now I want to see the athletes who have secured a gold medal beyond the age of 60 years, which is very rare. So we'll see the total number of athletes with more than 60 years of age having won a gold medal. So here I'm going to say gold medals. I'll use my column as ID, and then I'll use my variable gold medals, and then I'll say age should be greater than 60, and then I'll close my square bracket and say count. Okay, let me just verify if everything's fine. Yeah, I'll run it and we'll see the result. So there are total 6 athletes who have won a gold medal having age more than 60 years. Cool. Now let me check for which sport these 6 gold medals have come. So I'll say sporting underscore event. This is going to be my variable name, equal to, I'll use the same variable name gold medals. I'll going to choose my sport column, and then I'll give my condition age greater than 60. Now let's go ahead and we'll print the variable sporting event. If I run this, you can see it here. So for art competitions, even for archery and shooting, and this one called rook, we have had gold medals from athletes who had an age more than 60 years. Now we are going to plot this result or the table that we achieved on the top. So I'll say plt dot figure. I'll give my figure size equal to, let's say 10,5. Then I'll say plt dot, we'll use the tight layout, say tight underscore layout. Then I'm going to use the Seaborn library and create a count plot for my variable sporting underscore event. Then I'll say plt dot title. I'll give the title as gold medals for athletes over 60 years of age. Let's run it. And if I scroll down, you can see here we have a nice count plot. I have my title gold medals for athletes over 60 years. And since for archery we had 3 players who secured a gold medal having an age more than 60 years. You can see here archery is 3, art competition 1, rook is 1, and shooting we had 1 medal. Alright. Now we'll see the total gold medals from each country. So for that I'll say gold medals dot, we'll use the region column, and followed by that I'll use the value underscore counts function, and I'll reset the index with name equal to, I'll provide the medal column. Then we are going to print the head for the top 5 countries. Let me run it. You can see it here. So USA has secured the most number of gold medals. Then we have Russia, Germany, UK, and then we have Italy. Cool. Now in this cell I am going to create a plot to visualize the table that I got above. So I've used my labels, my titles. I'm using the cat plot function that is present in the Seaborn library. I have my x-axis, my y-axis, the data which is total gold medals. Let me just verify. Okay, and we'll run it. If I scroll down, you can see this is a different palette that I had used, which is a rocket, and you can see USA has got the most number of gold medals. Then we have Russia, Germany, UK, Italy, and France. Now we also have included France here, which was not present in this table. The reason being I have used head as 6, so it will give me the top 6 countries. Alright, now we will analyze and look at the data for the most recent Olympic event that is present in our dataset. I'm talking about the 2016 Rio Summer Olympics. So first of all, I'll create a variable called max year, which will be equal to my data frame name athletes underscore df, my column name year, and I'll use the max function. Then let's go ahead and print my max year. I'll just show you the output. You can see here my max year present in the dataset is 2016, the Rio Olympics. Next, we will create another variable called team underscore names that will be equal to my data frame name athletes underscore df. Within square brackets I'll give parenthesis and then say athletes underscore df dot year should be equal to my output, that is max year, which is actually 2016, and then I'll say ampersand. I'll just copy this, we'll paste it here. This time I'll use the medal column and say equal to gold. I'll say dot team, then I'll say team underscore names dot value underscore counts dot head, and will display the top 10 countries. Let me run this. There you go. So in Rio Olympics, United States secured the most number of gold medals. Now the reason this is 137 is we have also counted the team events, for example basketball. Similarly, Great Britain had 64 gold medals in total, Russia 50, we have Brazil 34, Argentina 21, France 20 and Japan 17. Alright. Now using the above result, we are going to create a bar plot. I'll just change this team underscore list to team underscore names. Similarly here also I'll make the corrections as team underscore names. Cool. Now we'll run it, and you can see here we have a nice horizontal bar plot. So we have United States at the top, Great Britain, Russia, Germany, China, Brazil. So here I am displaying the top 20 nations since I have used head as 20. So these are the top 20 nations who secured the most number of gold medals in the Rio Olympics. Alright. Now in the final section of this video, we will create a scatter plot to visualize the height and weight of male and female athletes who have won a medal. Now it can be a gold medal, a silver medal or a bronze medal. But before that, we need to filter the data only for athletes who have won a medal. Now if you had noticed here, our medals column also had a few null values, so we are not going to consider those null values here. We are only going to consider for the athletes who have won a medal. So for that, I'll create a variable called not underscore null underscore medals equal to, I'll say athletes underscore df, then I'll give my, let's make it df, I'll give my condition. Let me just copy this, I'll paste it here, and then I'll give my condition height and use the not null function, and then I'll say ampersand, create another parenthesis, I'll say athletes underscore df. This time we'll consider the weight column. Again I'll use the function as not null, and I'll close the parenthesis. Okay, I had missed one s here. Cool. Let me just run it now. Alright. Now we are going to create our final plot. I'll say plt.figure. I'll give my figure size equal to, I'll say 12,10. I'll say axis equal to SNS dot. We'll be creating a scatter plot to plot the height and weight of the athletes who have won a medal. I'll say scatter plot. In my x-axis I'll have height, comma. In my y-axis I'll have weight, comma. My data should be not underscore null underscore medals. So this is what we created here, not underscore null underscore medals, comma. I'll use hue equal to my sex column. Cool. Finally I'll say plt dot, I'll give a title to my plot, saying height versus weight of Olympic medalists. Cool. Now let's see our scatter plot. This might take some time to give the result because there are so many athletes present in a dataset who have won a medal, and also we are filtering in terms of hue, which is for male and female. There you go. So if I scroll down, you can see here we have a nice scatter plot. On the top we have the title of the plot saying height versus weight of Olympic medalists. You can see our age as the hue. So blue points are for the male athletes and orange points are for the female athletes. And on the y-axis we have the weight in terms of kilograms, and you have the height in terms of centimeters. Cool. So that brings us to the end of this demo session on Olympics dataset analysis. So we used two datasets to carry out this exploratory data analysis, and we created some visualizations to analyze and visualize the data. Alright. So that brings us to the end of this video tutorial on Olympics dataset analysis. Indian Premier League, that is IPL, is one of the most popular and exciting events in world cricket. IPL 2022 will begin on 26th of March, so it's the best time for us and our viewers to learn about how to perform exploratory data analysis using the recently held IPL auction dataset. So in this video, all the results and insights that you will see are totally based on the data we have collected from Kaggle. We will leave a link to the dataset in the description of the video. You can go ahead and download it. For this demo, we'll be using Python and Jupyter Notebook to answer specific questions. So let's get started. We'll move over to our Jupyter Notebook. Okay, so I'm on my Jupyter Notebook and this is the file that we are going to use. So here you can see I have some of the cells already filled in. So this will save us some time and we can explore this data set in depth. So this is the file that I'll be using, or the IPython notebook. Cool. So first let's go ahead and import all the crucial libraries that will be needed for our analysis. So here you can see I am importing the Pandas library, the NumPy library. These are for data manipulation and numerical computation. Then we have Seaborn and Matplotlib for data visualization. Then I have imported this warnings module so that we do not get any warnings while running the code. Cool. So let me just hit Shift Enter to run the first cell. So here we will import all the libraries. Okay, it's done. Now the next step is I'm going to create a data frame in the name of IPL, and here I'm importing the dataset using the read_csv function, which is part of the Pandas library. So PD here has been imported as Pandas. I'm giving the dataset location followed by the name of the dataset. So here the name is IPL_2022_dataset.csv is the extension of the file. So let me go ahead and run this as well. Alright, so now we have successfully imported or loaded our dataset. Now the next step, let's go ahead and explore our dataset. So I'll use the head function for this, IPL.head. Okay, so here you can see the different columns. We have an unnamed column which is actually unnecessary for our analysis, so we'll see how to drop this column. Apart from that, we have the name of the players, the base price at which the player was sold, or whether the player was a draft pick. So here Rashid Khan from Afghanistan, Hardik Pandya, then we have Subman Gill. These are all draft pick, and then we have the price at which the players were listed in the IPL auction. Then we have the type of player, whether the player is a bowler, an all-rounder, a batsman, or a wicketkeeper. Then we have the cost in rupees. This is in crores. So basically this column tells us the price at which the player was sold in the auction. Then we have the price or the cost in dollars. After that, we have 2021 squad. Basically, this means in last year's IPL, where was the player? So here you can see Rashid Khan was playing for SRH, the Sunrisers Hyderabad, in 2021. But this year in 2022, he'll be playing for Gujarat Titans. Similarly, Hardik Pandya was playing for Mumbai Indians for past few seasons, including 2021. But this season is going to play for Gujarat Titans. So on and so forth. Now, let's see the total number of players that are present in the dataset and the total columns that are there. For this, I'm going to use the shape attribute. So I'll write IPL.shape. You can see here there are total 633 players that were part of the auction, and this includes the players who were draft pick also. And there are total 8 columns in my data frame IPL. Next, let's use the info function to check the columns, their data types, and the total non-null objects. So I'll say IPL.info, which is a function, so I have to use brackets. There you go. So here you can see it says total 633 entries from 0 to 632 data columns. We have total 8 columns, and then these are the different column names, and here you can see the total non-null objects present in the column, and here you can see the data types, and at the bottom you can see the memory usage as well. Cool. Now the dot columns attribute will return the name of the columns in the data set. So if I say IPL.columns and run it, it will give me all the different column names that are present in the data frame. Now, as I said, the first column, which is unnamed :0, is actually unnecessary. So we are going to drop it. For that, we are going to use the dot drop function, and then I have passed in my column name followed by the axis, on which axis is it there, and then I say in place equal to true, which means it will replace and permanently remove the unnamed column from the data frame. So let's run it, and now we'll again check the head of the data frame. You can see before we had the unnamed column, which was the first column in the data frame, and now we have successfully removed it. So player becomes the first column in the data frame. All right, now moving ahead, let's see the total number of null values that are present in each column of the dataset. So I'll say IPL dot, I'm going to use the isNull function followed by the sum function. If I run this, you can see here the player column doesn't have any null values. Similarly, base price and type column also don't have any null values, but you can see cost in rupees and cost in dollars have nearly 396 missing or null values. The reason being those players were not picked in the IPL auction, and hence there was no price associated. And then you can see there were a few players who were not part of the IPL squad in 2021, so those are being reflected as null as well. Now we'll check the rows that have cost in dollar as null or NaN. So here I have used IPL, and after that I'm passing in the column name, which is cost in dollars, and then I've used the isNull function. If I run this, you can notice the cost in dollars column, all these values are NaN or null, and even the same rows have NaN for cost in rupees as well. Cool. Now the next task is to fill these null values or NaN values with zeros. So for that, I'm going to use the fill NA function, and here I have passed in 0. So all the null values in the dataset will be replaced with 0 for cost in rupees column and cost in dollars column. Let me just run it. All right. Okay. Now we will see the players who were unsold in the 2021 auction, which means we will check the rows that have null values for the 2021 squad column. So what I'll do is I'll say IPL within square brackets, I'll say IPL, and then I'll pass in my column name, which is 2021 squad, and then after this I'll say dot is null. So this cell will give us the unsold players in the 2021 auction. If I run this, you see here, you mark the 2021 squad column, all these players were unsold or did not participate, so hence it has NaN values. Alright. Now what we are going to do is, we will replace all the null values that are present in the 2021 squad column with not participated. Like how we did in the previous example, we replaced all the null values with 0. Here we'll replace with a text value called not participated. So I'll say IPL, I'll pass in my column name, which is 2021 squad, equal to, I'll say IPL 2021 squad dot fill NA, which is the function, and here I'll pass in a text or a string saying not participated. Alright, let's run it. Before that, let me just scroll it down. Now I'll run it. Cool. Now that we have treated the null values successfully, let's verify it again. So I'll just say IPL dot is null, and then I'm going to use the sum function. If I run this, okay, this is also a function. Cool. Now if you see, we have successfully removed all the null values and replaced with either zeros or not participated, and hence now you can see none of the columns in the IPL data frame have null values, so it shows 0. Great. Now moving ahead, now we are going to add another column called status, which will hold two values, sold and unsold. But before that, we are going to slice our data frame. So here I am looking for all the rows where cost in rupees is greater than 0, and those should be unique, and I'm storing the value in a variable called teams. So here you can see we have the different teams where the cost in rupees is greater than 0. Now I'm going to create another column called status. So I have written IPL within square brackets. I'm passing in the column name, which is status, and that will be equal to the team replaced by sold value. Let me just run it and show you the result. There you go. So here you can see we have added a new column called status, and it has values sold and unsold. If I just say IPL, at the bottom you can see the unsold values as well. Cool. Now in the next cell, we are going to check for duplicated players. So there are duplicate rows in the data frame, but here the names of the players are same, but in reality the players are different. So it is quite understood that different players can have the same name. So to get those names, I am using the duplicated function, and I'll say keep equal to false, which means I don't want to keep those players. Now let's run it. There you go. So here you can see Lalit Yadav, we have two entries. So Lalit Yadav here is an all-rounder whose base price was 20 lakh for 2022 IPL, and last year he was playing for the Delhi Capitals, and this year also he is sold to Delhi Capitals. Next we have Lalit Yadav, who happens to be a bowler. So this is again different Lalit Yadav. So last year he was unsold, and even this year he remains unsold. Similarly, we have Amit Mishra, who earlier used to play with the Delhi Capitals, but this time he remains unsold, so on and so forth. So you can see 2 entries for Subham Singh as well and Shivam Mishra. Alright. Now let's answer a very basic question. We're going to find out how many players have participated in the 2022 IPL auction. For that, we have already seen the total number of rows that were present, but again I'm going to use the shape function, and within square brackets I'm going to say 0, which means it will give me the total number of rows. And you can see 633 players were part of the auction. This is as per our data that we have collected from Kaggle. Up next, we are going to find how many types of players have participated. So I'm going to say types equal to, say, IPL. I'll use the column name, which is type, and I'm going to find the count of each type of players that are present in the data frame. I'm going to use the values underscore counts function, and then I'll say types dot reset underscore index. If I run it, okay, there is an error here. Let me debug the error. Okay, so this should be value underscore counts, and the variable name is types and not type. So let's run it. You can see here we have the different types of players. So all-rounders, there are total 242 all-rounders who are part of the auction. Then we have 215 bowlers, 112 batsmen and 64 wicket keepers. Now using the above table that we just created, I'm going to plot my first pie chart. So for that I'm going to use the matplotlib pie function. So plt.pie, I'm using types.values since I want only the values from this table, and then I'm saying labels equal to types.index. I've used a label distance of 1.2 to maintain some space, and then this is my format in which I want to print or show or display the percentage of distribution. I'm going to use shadow, so it says shadow equal to true, which is another parameter or an argument, and then I'm going to start my angle at 60 degrees, and here I have used a title called roll of players participated that will have a font size of 15, and finally I'm saying plt.plot. So let me just run it. There you go. So here we have a nice pie chart or a pie plot. So you can see the different pies here. We have all-rounder, wicketkeeper, batter and bowler. So majorly there are all-rounders in the auction, followed by bowlers. Then we have 17.69% batters and 10.11% wicketkeepers, which is the lowest. Cool. Now we are going to create another bar plot or a bar graph that will tell us how many players were sold and unsold. So for this I'm going to use a count plot. So we'll create two bars, one for sold and the other one for unsold, and each of the bars will have different colors. One will have orange, the other one will have pink, and I'm using labels. So to label the x-axis and y-axis, I have sold or unsold. Y label will have number of players. The title of my bar graph would be sold versus unsold. I've given a font size of 15 and I'm saying plt.plot. Now the function that you see here at the bottom will display the data labels for each of the bars. Let me just run it and show you the result. There you go. So I have used a figure size of 10,5. Alright, now you can see we have a really good bar plot which says there were total 237 players sold and 396 players were unsold as per the data we have. Cool. Now you can also print the total sold and unsold values. Let me show you how to do it. I'll say IPL dot, we can use the group by function, and I want to group it by status column, and the value that I want to measure is the players count. So I'll say players, rather player, and then I'm going to use the count function. If I run this, you can see here I've successfully grouped the unsold and sold players. The values are matching with the bar plot that we just created. So sold were 237 players and unsold are 396. Cool. Now we are going to see the total number of players bought by each team. Again, this is going to be a count plot, so basically a bar plot. So here the condition I'm passing is, in the teams column the value shouldn't be unsold. So players bought means the value should be sold. So here I'm using this condition, and the rest of the things remains the same. One improvement I have done here is I'm using x-ticks rotation equal to 70 degrees. This basically means the x labels would be tilted by 70 degrees. Now let's see the bar plot. There you go. So here you can see I have the title players bought by each team. On the y-axis we have the number of players, and on the x-axis you can see the values have been tilted by 70 degrees. Let me just zoom in so that you can see it better. And this is the bar plot. So the maximum a team can purchase is 25 players. Some of the teams have also purchased 24, 22 and 23 players. Let me just show you. So Gujarat Titans have totally purchased 22 players. Then Delhi Capitals have total 24 players in their squad. Again, Lucknow Super Giants have 22 players. If I scroll and see again, Bangalore Royal Challengers, or RCB, the Royal Challengers Bangalore, have 22 players in the team, and Rajasthan Royals and Sunrisers Hyderabad have 24 and 23 players respectively in their teams. Alright, now we will create 3 more columns called retention, base price and base price unit. For that, first of all, I am creating a new column called retention, which is equal to IPL base price. Let me just run it, and then I'm going to replace these values that are present in the list, 2 crore, 40 lakh, 20 lakh, 1 crore, 30 lakh, 1.5 crore, with from auction, and I'm saying in place equal to true. Let me just run it. Then we are going to treat the base price. So here in the base price column, I'm going to replace draft pick value as 0. So let's run that as well. And now I'm going to split the base price value into 2 separate values called base price unit and base price. So basically I'm splitting on the space that I have. Let me show you how it is going to split. So this is, let's say, our base price column. What I did was I replaced the draft pick values to 0, and then the rest of the values will be split into 2 columns called base price unit. So basically it will have the unit of the base price, let's say crores or lakhs, and the base underscore price column will have the value, which is 2, here 40, 20, 20, so on and so forth. Let me just scroll down and run that particular cell. Now to create these 2 columns, the base price unit column and the base underscore price column, I have used the lambda function, and I'm splitting based on the space. Let's just run it. Now I have replaced retained with 0, and let me show you the final data frame that I have. So here you can see we have replaced the draft pick values in the base price column to 0, and on the right side you can see the 3 different columns that I wanted to create. So one is called retention. So zeros refer to draft pick. Any other value will say the player was picked from the auction. Then you have the base price unit. So here you can see crores, lakhs, and the value base prices 2, 40, so on and so forth. Cool.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's check how many players were retained and bought from the auction by each of the teams. So I'll say IPL, let me just scroll down, dot, I'm going to use the group by function. Then I'll say team, comma, retention. Then I'm going to use the value as retention because I want to find the count of retained players. Then I'll say colon -1. Let me run it. You can see here the different team names because I have grouped by team and then retention. So I have Chennai Super Kings. From the auction they had picked 21 players and they had retained 4 players. Coming to Delhi Capitals. Delhi Capitals in the 2022 IPL auction they picked total 20 players and they have retained 4. Similarly, if I scroll down, let me talk about, let's say, Punjab Kings. They have picked 23 players from the auction and retained 2 players from the team last year. Talking about RCB or Royal Challengers Bangalore, they have picked 19 players from the auction and they have retained 3 players. Alright. Now in the next cell of code, we are going to display the players in each team based on the different types of players. So let me just run it and show you the result. So here I am using the same condition. The value shouldn't be equal to unsold, and I'm going to use another parameter called hue for the different colors. So here I have used hue as type because I want to show the players in each team based on the different types. Again, I have given my title to the bar plot, and then I have the X label, the Y label, and my rotation is 50 degrees now. If I scroll down, you can see the different types of players. Here is the legend. So blue is for bowler, orange or yellow is for all-rounder, green is for batter, and red, which also looks like maroon, is for wicket keepers. And on the x-axis you can see the different team names. Alright, now let's answer another couple of questions. So here I have, what is the highest amount spent on a single player by each team? So to solve this question, I'll say my data frame name, that is IPL. Then I'm going to say retention equal to, this should be from auction because we want to see the highest amount spent and not from the retained players. Then I'm going to group by, I'll say team, and then I'll say cost in, let me just copy it from here, cost in rupees, that is in crores, and I'll say max colon -1 dot sort underscore values, I'll say ascending equal to false, which means I want the sorted result in descending order. Okay, let me just bring this to the left side and we'll run it. There seems to be some error. Let me check the error. It says there's a spelling mistake. This should be team. Let me run it again. There you go. So you can see Mumbai Indians have spent 15.25 crores for one of the players, and this player happens to be Ishan Kishan. Then Chennai Super Kings have spent the highest amount for a player who happens to be a bowler. The name is Deepak Chahar. They have bought him for 14 crores. Kolkata Knight Riders bought Shreyas Iyer for 12.25 crores, and so on and so forth. So these are the highest amounts spent on a single player by each of the teams. Let me scroll down. Now we are going to see the player retained at maximum value or maximum price. Now if you follow IPL, the maximum price at which a player was retained happens to be Ravindra Jadeja. So let's see at what price was he retained. I'll say retention equal to I'll say retained, then I'll say sort underscore values by equal to, I'll use the same column, cost in rupees, that's in crores. I'll say ascending equal to false dot head, and I want to find the top player. Again there's some error. Let's see where is the error. Says ascending equal to false dot head. Okay, this should be sort underscore values. Within bracket I should say by. I think this should be fine now. Let's run it. There you go. So you can see here our result is player name Ravindra Jadeja, who was retained for 16 crores by Chennai Super Kings. Cool. Now the next cell of code will display or print the top 5 bowlers who have been picked in this year's IPL based on their cost in INR. Let me just run it and show you the result. You can see here Deepak Chahar went for 14 crores. Then we have Shardul Thakur, who was bought by Delhi Capitals. Earlier he was part of CSK for 10.75 crores. Then we have Prasidha Krishna, who has been bought by Rajasthan Royals this time. Last year he was with KKR and he has been bought for 10 crores. Similarly, Lockie Ferguson has been bought by Gujarat Titans and he played for KKR last season. He has been bought for 10 crores while his base price was 2 crores. Then we have Avesh Khan. You can see Avesh Khan's base price was just 20 lakhs and he has been bought for 10 crores by Lucknow Super Giants again, and last year he was part of the Delhi Capitals. Now you can replace this value. Suppose let's say you want to find the top 5 batsmen picked or batters picked with the highest amount. You can just say batter instead of bowler, and if I run this, you can see here Shreyas Iyer was bought by Kolkata Knight Riders for 12.25 crores. Last year he was part of Delhi Capitals. Then you have Shimran Hetmeyer, who's from West Indies. He has been picked by the Rajasthan Royals for 8.5 crores. Then we have Rahul Tripathi, Sikha Dhawan and Devdutt Padikkal. Now if you wanted to check for, let's say, all-rounders, you can replace batter with all-rounder. If I run this, you can see Liam Livingstone has been bought by Punjab Kings this season for 11.5 crores. His base price was just 1 crore, and last year he was part of the Rajasthan Royals. Then we have a player from Sri Lanka, Hasaranga. Then we have Harshal Patel, Shah Rukh Khan and Rahul Tewatia, who have been the top 5 all-rounders picked at highest amount. Cool. Now finally, we want to see the players who were part of the IPL last season but were not picked for this year's IPL. So for that, what I'm doing is, first I'm renaming my 2021 squad column. This column I want to rename it as previous team. Let's run it. Then I'm going to find out the unsold players. So here I'm saying previous team not equal to not participated, and then I'm using another condition. The team should be equal to unsold, and I'm going to find out only the player and the previous team. So let's run it and see the result. So here you can see these players were part of the IPL last season, but they haven't been picked this season. And last season they had played for, let's say Suresh Raina played for CSK, Steve Smith was part of the Delhi Capitals, Saqib Al Hasan was part of KKR. If I scroll down, you have David Malan, who played for Punjab Kings in 2021. Owen Morgan, who played for KKR. He also captained KKR, but unfortunately he was not picked this season. Chris Lynn from Australia also remained unsold this season. Andrew Tye, we have Ben Cutting, Aditya Tare. There are other players as well. We have Kane Richardson, Dhaval Kulkarni. Cool. So these were the players who were part of the IPL season 2021, but unfortunately were not picked and remained unsold for 2022 season. Cool. And that brings us to our end of this demo session on IPL Data Analysis 2022. So we learned how to use the different functions and attributes that are part of the Python libraries, and we manipulated the data, we visualized the data and answered some specific questions. In this video, we'll be using 4 publicly available datasets about Formula 1 that has information from 1950 to the 2019 F1 season. We'll see how using the Python libraries you can perform exploratory data analysis and draw valuable insights. So let's begin by understanding what Formula 1 is. Formula 1, also known as F1, is a motorsport defined by open-wheeled single-seat race cars. It features the best drivers in the most powerful and technically advanced cars. The sport is governed by the FIA, that is International Automobile Federation. Here 10 teams comprising of 2 drivers each compete in a series of races over a period of 1 year to find out the ultimate driver and a constructor champion. In our demonstration, we'll be using 4 datasets. Let me show them one by one. These are all CSV files. Now this is the first dataset that we'll be using in our demo. So if you notice, the dataset does not have column names. In fact, none of the datasets have column names. So while importing the dataset, we'll assign the column names using the names parameter. I'll show that in a while. Now this is the results dataset. The results dataset has information about the result ID. Then we have the race ID, driver ID. We have the constructor ID, grid, position. Then we also have information about the fastest lap. Then we also have information about rank, the fastest lap speed, and the status ID. Now moving on to the second dataset, which is about races. Now this is the second dataset, which is about races. So it has information about the race ID, the year in which the race was held. Then we have the round number, circuit ID, then the name of the Grand Prix. So you can see here Australian, Malaysian, Chinese, Spanish, Monaco, Turkish, British, German, and others. Then we have the date on which the GP was held or the Grand Prix was held. We have the time and a URL which basically leads to the Wikipedia page of that particular Grand Prix for that year. Now moving on to our third data set. So this is our third data set, which is about drivers. Now it has the driver ID, the name of the driver. You can see here Hamilton, Rosberg, Alonso, Raikkonen. Then we have Sato, Massa, Button, Weber and all. After that we have the number code. Then we have the forename of the driver, the surname of the driver, and then we have the date of birth of that particular driver. We have the nationality as well. And we have the Wikipedia page for the driver. Now moving on to the last data set, which is about constructors. So this is the fourth and the final data set that we'll be using in our data analysis project. So here we have the constructor ID, then the constructor reference in Formula 1, and this is the actual name of the constructor. So we have McLaren, we have BMW Sauber, Williams, then we have Ferrari, Toyota, Red Bull, Force India. We also have Jordan, Jaguar and all. Next we have the nationality and the URL, that is the Wikipedia page of that particular constructor. Now let's head over to our Jupyter notebook and we'll start with our analysis. Here is my Jupyter notebook that I'll be using for this demo. You can see some of the cells are already filled. This is just to make sure we save some time. So using these datasets that we just saw and our libraries such as NumPy, Pandas, Matplotlib and Seaborn, we'll answer specific questions such as the drivers and constructors who have been the most successful throughout the history of F1 sport. Then we'll explore the impact of starting and finishing positions and if the speed of the cars has changed over the years. So let's begin with our analysis. First and foremost, we are going to import all the necessary libraries. So here I'm importing NumPy, Pandas, Matplotlib and Seaborn. And after that I'm writing percentage matplotlib inline. That is to ensure that all the plots are embedded inline. I'll hit Shift Enter to run it. It'll take some time. There you go. So we have successfully imported all the libraries. Now the next step is to load the data and assign column names. So I'll load my first data, which is results. I'll say pd dot read underscore csv. I'll give my file name, which is results dot csv. And then using the names parameter, I'll pass in the column names. So actually I have written the column names in a notepad. Let me open that. So I have this F1 notepad created which has the column names. I'll just start copying the column names. Within the names parameter, I'll paste it. If I scroll to the right, you can see the different column names that have been assigned. And for that, I'm going to say comma, and I'll write header equal to none. I'll close the bracket. Cool. Similarly, let's import the second data set, which is about races. I'll say pd dot read underscore csv. I'll give my file name, which is races dot csv, and then I'll give the names parameter. This is actually names and not name. Okay. I'm going to copy the second line and I'll paste it here. And again, I'll say header equal to none. we'll import our third data set, which is about drivers. So I'll say pd dot read underscore csv. I'll say drivers dot csv. Then again use the names parameter, and I'll copy the third line now, which has the column names for the drivers dataset. Here I need to give another parameter, which is header equal to none. Finally, we are going to import our constructors dataset. We'll say constructors equal to pd dot read underscore csv, which is the function present in the pandas library. I'll say constructors dot csv, which is my file name, and then again I'll use the names parameter. I'll go to my notepad, and this time I'll copy the fourth line, which has the column names for the constructors dataset. I'll paste it, and here I'll give my final parameter, that is header equal to none. Alright, now let me hit shift enter to run it. Okay, we see some error here. Let's debug the error. It says no such file or directory, drivers.csv. Let's see where was the issue. Okay, this should be driver.csv. Cool. Now we have successfully loaded the data and assigned the columns to the various data sets. Now the next analysis is to merge all the data set. So here I'll create a data frame called df, and I'll use pd dot merge function. First I'll use the results data frame that we just imported above, this one, and I'm going to merge it with races data frame, and from the races data frame I'm going to take specific columns like the race ID, then I need the year, after that I need name. Next I'm going to take the round column as well, and I'm going to use on parameter. So on parameter is actually the column that is common to both the data frames, that is results and races. So here my common column is going to be the race ID because it is present in both the data sets, and I would like to merge. So for that I'm going to use how. So I'm going to use a left join. So if you know SQL, you will be aware of left join. It takes all the rows from the left table and only the matching rows from the right table. I'm again going to use the merge function. So I'll write df equal to pd dot merge. I'll say df comma, and now I'm going to merge the drivers dataset, and I'm going to select specific columns. So I'll say driver ID. Make sure there are no spelling mistakes in the column names. Then I'll say driver ref, which is the name of the driver or reference, comma, and then I want the nationality of the driver. Alright, I'll give a comma. I'll say on which column I want to merge. So here the common column is going to be the driver ID, Again, how is going to be a left join. Going to the final merge part, I'll say again df equal to pd dot merge. I'll pass in my data frame and my final data set which I have is about constructors. From constructors, we are going to choose specific columns. So I'll take the constructor ID, then I'll take the name column, and again the nationality column of the manufacturer. Here I'll say on equal to the common column I'll use is constructor ID. Give a comma and say how equal to left again. Cool. Make sure you're merging it with the right column names. So let's run this cell to merge all the 4 data sets. I'll hit shift enter. Oops, there is some error. Let's see. It says constructor ID index. Okay, there's a spelling mistake. This should be constructor ID. Cool. Let's run it. There you go. Now the next thing we want to do is to drop the unnecessary columns. So I'll say df dot drop. Within the drop function, we are going to pass in the column names. I'll say number. Then we also don't want the position column. Next we have position underscore text. After that we have laps. Next we are going to drop fastest lap. Then we'll also drop the status ID, comma. We'll drop the result underscore ID column. Then going to drop the race underscore ID column. We'll also drop driver underscore ID column. And finally we are going to drop the constructor underscore ID column, and I'll say access equal to 1, and in place I'll say equal to true because I want to remove it from my original data frame, that is df. There you go. Now the next thing I want to do is I want to rename some of the columns. So I'll say df dot rename. I'll say columns equal to, now we are going to pass in a dictionary. I'm going to change the rank to test underscore lap underscore rank. Let me give a comma. Now I'll say name underscore x equal to, I'll say the Grand Prix name. So I'll say GP underscore name. Next column I'm going to focus is the nationality column. So I'll say nationality underscore x. I'll give a colon. The value I'm going to pass in is driver nationality. Alright. Up next, we have one column called underscore y, and that I'm going to change it to constructor name. Another comma, I'm going to say nationality underscore y colon, change it to constructor nationality underscore nationality. Finally, we have driver underscore ref column, and that I'm going to replace with just driver. Finally, I'll say in place equal to true. Cool. Just verify if all the column names are correct. Let's run it. Alright, so now we have successfully renamed the columns. After that, in the next cell, I'm going to rearrange the columns. So here I'm using the same data frame and we have just renamed the columns. So starting with year, Grand Prix name, round, driver, nationality, and others. Let's run this. Up next, we're going to drop the 2019 season data because it is incomplete. So I'll say df equal to df, then I'll say year not equal to 2019. Let's see how to sort the values. So I'll say df equal to df dot sort underscore values, which is the function name. I'm going to sort it by year followed by round followed by the position underscore order, comma, I'll say ascending equal to first, let's say is false, next I have true, and then I'll have true. Alright, moving ahead, now we are going to see how to replace the /n values in the time column with something called NaN, because the time column was not registered when a driver did not finish a race or was lagged by another driver. So to do this, I'm going to say df dot time dot, I'm going to use the replace function, and here I'll say / or /n, and I'm going to replace with numpy's NaN. I'll say in place equal to true. Let me just copy this because we are going to use the same meters. Next, I'm going to replace the milliseconds value, the milliseconds dot replace. I'll paste it here. Then I'll say df dot fastest underscore lap underscore rank dot replace, paste it. Next I have df dot fastest dot lap dot time, say replace. To that I have the next column, which is speed. So I'll say fastest underscore lap underscore speed dot replace. I'll paste it. So here I'm going to replace this particular value, the backward slash n with nan. Let me run it. Cool. Step, I'm going to change the data types for fastest underscore lap underscore speed to float, then fastest underscore lap underscore rank to float again. Now, problem here is we cannot convert it into an integer because there are missing values, so we are going to change it to float. Again, for milliseconds also we are changing it to float values. Let me run it. Now I'll reset the index. Let me show you how to reset the index. I'll say df dot reset underscore index. I'll say drop equal to true. I'll give a comma and say in place equal to true. All right. That we have done our initial processing step of the data set. Now we'll check the shape of the data set. Then we see all the data sets, the total number of non-null values, the memory usage, and we'll check the head of the data set. Now to see the total number of rows and columns, I'll say print df dot shape. You can see here there are total 24,197 rows in my dataset and there are total of 15 columns. Now let's use df dot info function. So it gives me the year, the Grand Prix name, the round number, driver, constructor name, grid, position order, total number of points, time, then time in milliseconds, the fastest lap rank, the fastest lap speed, the nationality of the driver, the nationality of the constructor. Then here we have the total number of non-null objects. And then you also have the memory usage at the bottom. Finally, let's see the head of the data frame. So I'll say df dot head. Let's say I want to check the first 10 rows. There you go. If I scroll down, you can see here we have the top 10 rows printed, and you have the year, the Grand Prix name, round, driver, constructor name, and other columns. Now let me just brief you about what these column names stand for. So the year column that you see here is the season that the Grand Prix took place, and then we have the name of the Grand Prix. Now the round column is the number of the race in each season. For example, 1 means it was the first race of the season, and then 2 means it was the second race of the season, so on and so forth. Then we have the name of the driver. For that we have the name of the car constructor, so you can see Ferrari, Mercedes, Red Bull, Renault. Then we have the grid, that is the starting position before the race. Actually this depends on the qualifications which occur 1 day before the race. Then we have the position underscore order column. This means the final position at the end of the race. Then we have the points column, that is the total number of points scored in the race. Next we have the time, that is the amount of time that took to finish the race. Only the winner's time is displayed, and drivers behind the winner are shown how far behind the winner they are. Then we have the milliseconds column, that is the amount of time that took to finish the race in milliseconds. If I just scroll down, I'll just move to the right, go to the top. Then we have the fastest underscore lap underscore rank, that is the order of the fastest lap during a race. Next we have fastest lap time, that is the shortest amount of time that took to complete a lap in the race. Then we have the lap speed, that is the average speed of the fastest lap. Then we have the country to which the driver belongs to, and then we have the constructor nationality, that is the country where the car constructor is based out of. Okay. Now here I'm going to set my figure size to 10,6. This is going to be for all the plots that we are going to create afterwards. Cool. We'll create a data frame that will have all the Grand Prix winners. So here I'm going to say driver underscore winner equal to, use my data frame df dot, I'll say loc, then I'll say df, I want the position underscore order, and that should be equal to 1, so which means the driver won the race. And then I'm going to use the group by function. I'm going to group it by driver, and for values I'll say position underscore order, use the count function followed by sort underscore values. I'll say ascending equal to false. Change it to 2 underscore frame dot reset underscore index. So what essentially I'm doing here is I am finding out all the drivers that have participated and won a Grand Prix. Next, I'm going to create a bar plot. So this is going to be the first visualization of our analysis. So I'll say SB, which we have taken in our analysis. Ideally it should be SNS, but SB also will work. So I'll say SB dot bar plot. I'm going to say data equal to driver underscore winner. In the y-axis, I'll have driver. In the x-axis, I'll have position underscore order. Then I have color equal to green. That I'll set my alpha value to 0.5, or let's say 0.8. Then we are going to give a title to our plot. So I'll say plt dot title. Let's say most Grand Prix winners in F1. Then we are going to label our axis. So for Y label, I'll have driver name. We have the X label that will have number of Grand Prix wins, and I'll say plt dot y ticks. Cool. Let's run it, and you can see we have our first bar plot here. Now the bar plot shows that there are a large distribution of Grand Prix wins. Only a few drivers in history of F1 have won over 20 Grand Prix in their careers, and there are some drivers who completely dominated the F1 racing and have won over 50 Grand Prix in their careers. So we are going to focus on those top 5 or top 10 drivers in the next section. So what I'm doing here is, from the above result that we just got, I'm going to filter out only the top 10. So I'm going to use the head function, and inside that I passed in 10. If I print it, you can see here As per the data that we have Michael Schumacher, who is the position order leader with 91 GP wins. Then we have Hamilton, Vettel, Prost, Senna, Alonso. Then we have Stewart, Clark, and Lauda. The data that we have is not the most recent one. So if you check the actual stats, Hamilton has actually overtaken Michael Schumacher and has won over 103, close to 103 races as of now. And next we have Michael Schumacher. So this is not the most recent data. Cool. Now using this data, we'll create another bar plot for the top 10 drivers. So I'll say sb dot bar plot. I'll say data equal to the name that we have used, that is top 10 drivers. So I'll say top 10 drivers. In the y-axis we'll have the driver name. In the x-axis we'll have position underscore order. For the bars, I'm going to use a color equal to, let's say, blue this time. I'll set my alpha value to be 0.8 and I'll say, let's say, line width equal to 0.8, and I'll also give an edge color of, let's say, black. Cool. Follow the same drill. I'm going to give a title to my plot. So I'll say plt dot title most GP winners in F1. We'll give a Y label that says driver name, and then I'll have X label which will have number of Grand Prix wins. Cool. Let me see if everything is fine and then we'll run this. There you go. You can see we have a very nice horizontal bar plot that shows the top drivers in F1. So as per our data that we have Michael Schumacher, who has won over 91 or close to 91 races. Then we have Hamilton, Vettel, Alonso, Clark, and others. All right. In the same way, we are going to create bar plot for the top constructors that have participated in F1. So here I'm finding out all the constructor winners. So here I'm using my position underscore order equal to 1, and then I'm using the group by based on the constructor name, and then I'm finding the count of position order and sorting the values in descending order, and I'm changing it to frame or to a data frame. And to create my bar plot, I'm using the bar plot function, the data which is constructor underscore winner. In the y-axis I'll have the constructor name, on the x-axis I'll have the position order. So you can see here I've used color as pink and I've given a title, X label, Y label, and Y ticks. Let's run it. There you go. So here you can see again the data is widely spread. So we have a lot of constructor names. Now our next task is to check the top 10 GPA constructor winners. So here I'm using the head function and finding out the top 10. If I run it, you can see here the manufacturing companies or the constructors who have won the most number of races are Ferrari, McLaren, Williams, then we have Mercedes, Red Bull, Team Lotus, Renault, and others. Okay, now we'll convert this data into a horizontal bar graph or a bar chart. So that will show the bar plot for the top 10 constructors. Now let me show you how to do it. So I'll say SB, which is for Cbond dot bar plot, going to say data equal to top 10. Let me just confirm the name. We have top 10 constructors. Scroll down, I'll say constructors. The y-axis, I'll have constructor on the x-axis, I'll have position underscore order. Then I'll say color equal to, let's say we'll use the red color for the bars. Then I'll set my alpha to 0.8. I'll say line width equal to 0.8, and my edge color, I'll say black. That I'll say plt dot title, say top 10 most GP wins. Plt dot y label would be constructor name, and I'll have plt dot x label as number of GP wins. Cool. Let's run it. There you go. So here you can see we have Ferrari at the top, then we have McLaren, Williams, Mercedes. I'm pretty certain by the end of 2021 season, Mercedes would have gained a lot of wins, since Hamilton has been on the top for Mercedes for quite some time now. All right. Now, finally, we are going to create a regression plot that will show how two variables, that is the starting position and finishing position, vary. So to do that, I'm going to exclude the data points with grid 0 because it skews the data. So 0 means that the driver started from the pit lane. So I'm using this function called reg plot to plot my regression line. Let me run it and show you the result. There you go. So if you see here, we can easily see there's a linear relationship between the starting and finishing position. So on the x-axis we have the starting position, on the y-axis we have the finishing or the finished place, so which is what is actually expected, right? Now we can also see that most races had up to 25 drivers. You can see the density of the points here, but some of the races also had over 30 drivers. You can see the light color blue dots. Next, we are going to check whether the speed of the cars changed over the years. Now, since this data is only available from 2004 onwards, so we have taken years that start from 2004 onwards. Now let me show you the result of this data. So essentially we are plotting the average speed amongst all teams during the fastest lap at individual Grand Prix, and here on the y-axis you have the average fastest speed in kilometer per hour, and then you have the different GPs, and you can see here the year values. Now In general, what we see is there's a decrease in the average fastest lap from 2004 till around 2015 for almost all the circuits. And again, from 2015 onward, the speed started to increase. You can see here there's an increase after 2015, there's an increase here as well. You can also notice that the speed is very different on each track. For instance, if you check the Italian Grand Prix, which is here, Italian GP has the fastest race in the calendar with average speed exceeding over 240 kilometers per hour. On the other hand, if you talk about the Monaco Grand Prix, let me show you. If you see here, the Monaco GP is the slowest race with average speed below 160 km per hour. Now this is actually expected because the Monaco Grand Prix has very narrow streets and hence the drivers cannot drive fast in this circuit.
Data analysis using Python and taking the top 1000 Instagram influencer dataset. Before we start, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. I'm repeating again, I hope the screen is clearly visible and the audio is fine. If yes, please type in yes. If there are any issues, do let us know in the chat section so that we can resolve them. In today's session, we will go through the data analysis using Python. We already have a dataset with us where we have data of top 1000 Instagram influencer. We will analyze this dataset using Python. Before we move on to the programming part, let's discuss data analysis and the steps and the importance of the same. Data analysis is a process for acquiring, arranging and changing data so that prediction about the future and the data-driven decision can be made. Finding potential answer to business problem is also helpful. Let's move forward and see steps to perform data analysis. So first one is define the question. What commercial issue are you attempting to resolve? By raising it as a query, you can concentrate on coming up with a precise response. And the second one is collecting data. To answer specified research question, test a hypothesis and evaluate outcomes, data collection is the act of acquiring and measuring information on variables of interest in a systematic and defined manner. And the third one is cleaning data. Your data should be explored, cleaned up, and deducted and organized as a necessary. Do whatever needs to be done, but wait a moment, give it some time. And the fourth one is analyzing data. Perform a variety of analysis to gain insights. Concentrate on a descriptive, diagnostic, predictive, and prescriptive types of data analysis. And the fifth one is visualization and sharing your findings. How can you most effectively impart your knowledge and suggestions? The trick is using communication and visualization technologies together. After seeing the steps to perform data analysis, let's move forward and see some importance of data analysis. So, Python is a high-level open-source interpreted language that offers a fantastic approach to object-oriented programming. It is the one of the greatest language for a variety of projects and applications. According to data scientists, working with mathematical, statistical, and scientific function is a breeze with Python. It provides top-notch libraries for working with data science application. Python is the one of the most widely used programming language in the field of science and research due to its simplicity and use. This means that even those without engineering skills might quickly learn how to utilize it. Furthermore, it works better for rapid prototyping. There are some most common libraries used for data analysis. The first one is NumPy, Pandas, Matplotlib, SciPy, Seaborn, and many more. So what do you guys think about data analysis? Do share your thoughts with us in the chat section. Now let's move to our programming part to perform data analysis using Python. So first we will open command prompt to write command to open Jupyter Notebook. So we will write Jupyter Notebook. Press enter. So this is the landing page of Jupyter Notebook, and select open new Python file. So this is how the UI looks like. So at first we will import some major libraries of Python which will help us in mathematical functioning. So the first one is NumPy. NumPy is a Python library used for working with arrays. It also has a functions for working in the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So we will write import NumPy as NP. So here NP is denoting NumPy. So we will import the next library is Pandas. Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structures and operations for manipulating numerical tables and time series. So we will write import Pandas as PD. Here PD is for denoting pandas. So we will shift close back. So after importing the libraries, we will move ahead and import dataset. So for importing dataset, we have to write data equals to pd dot read underscore csv, and here we have to write our dataset name, dataset insta dot csv. Press shift plus enter. Yeah. Here pd is for pandas library, read is used for reading the dataset from the machine, and csv is used for the type of file which you want to read. So then we can write data to see our data. So see, this is how our dataset look like. So let's first rename this column name followers. This one, followers in million, by writing followers only because it is so lengthy, and this followers column we are going to use most of time. So it will save our time. So we will write here data dot rename column equals to that curly braces. Here we will write the name of column which you want to rename followers in millions. Colon to followers. So here we will write in place equals to true. Okay, then here we will write data okay, it is not changed yet. Okay, because it is followers. To give one space here. Yeah, done. So rename function is a function which is used to rename the column name. So there are many keywords arguments like index, column, axis, copy, in place, level, errors, which you can use as a parameter. So column name is changed to followers. Let's move on. So here you can see the three dots, this one. And we are unable to see our full data, like only we can see the 10 rows. So like we have 1000 rows, right? So for that we can write here, we can write pd dot set underscore options display dot max underscore columns, and here we can write none. After that, this is for columns, and we can write for the same for the rows, sort underscore options. It is option, not options. Okay, we can write here display dot max underscore for rows. Perfectly done. Okay, we can write here none. Yep. So pandas features and options, this one, system that allows you to modify various aspects of their behavior. Users are most likely to change display related options. So the maximum number of rows by default is 10. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the maximum number of rows by default is 10. All rows of data frame are considered if the value is set to none. Set the display value by setting as max rows to none and passing it to the set option. All rows from the data frame will be shown. So let's move on and see our full data by writing data frame name here. So okay, let me debug the error. Okay, here column name LUMNS. Okay, sorry. So here we can write data. So see, this is how our data look like. The 1000 rows. With full 1000 rows, like from 999 to 0. Yeah. So moving ahead, here you can see the NaN values like this. NaN and below NaN, NaN. So NaN means not a number, and it is one of the typical methods for representing the dataset missing values. It is a unique floating point value and can only be changed to the float type. So let's change it to 0 for the better result and the better prediction. So we will write here data dot fill NA 0. So by writing this, we will shift plus enter. So all NA values are now changed to 0 with the help of this fill NA function. This fill NA method replaces the null values with a specified value. So after this, let's move on to the another function, which is shape. So we will write data dot shape, then shift plus enter. Yeah. So this shape function will return you a number of rows and columns your dataset have. So here we have 1000 rows, you can see, and 7 columns. Yeah. So let's move on to the another amazing function, which is info. So here we will write data dot info. Perfect. So data frames information is printed by the info method. The data includes the total number of columns, their labels, data kinds, memory use, range index, and another number of cells in column. Note that the information method does indeed print the information. So here you can see all information has been printed, like all the columns name, all the non-null values count, and data types for the particular column. So let's move forward and see our next function, which is data.columns. So which is data.columns. Okay, again I wrote wrong. LUMNS. Okay, perfect. So as per the name, you can easily tell me in the chat section what is going to print for us. So this function is going to print all the columns name. So here we have names like name, rank, category, followers, audience country, authentic engagement, engagement average, data type is object. Why data type is object? Data type is object because this is taking as the one category, that is why it is taking as an object. So let's move forward for the next function, which is describe. So data frame comprises of numerical data, and each column's description includes the following details like count is the total amount of non-empty values, mean, the standard deviation, and many others. So here we will write data dot describe open brackets. So C. So here you can see all the columns which have numerical data is displayed by the full description. So this is our mean, count, STD, minimum, 25% of the particular date column, 50% and 70%, and the maximum value present in the column. So moving forward, let's solve some questions like how to show audience country, like from which country we have the most number of followers. So let me write this question as a comment. So for comment we have to use hashtag. So here you can write how to show audience from which country we have most number of followers. Okay, perfect. Yeah. So let's solve this with a small line of code. We can write here data, here column name as audience country dot value underscore counts normalize was to true, then we will round it to 2. Okay, here we have to write the capital T. Perfect. Yeah. So returns an object with counts of distinct value. The resulting object will be arranged in descending order, with the first element being the one of the that appears most frequently. By default, exclude any values. Index value count, normalize equals to false, sort equals to true, ascending equals to false, or bins equals to none. Is a syntax of counting values. The normalize function in Python processing package is used to normalize the data. It accepts an array as input and converts its content to a range between 0 and 1. After that, it will give back an output array with the same size of input array. If we remove round function, it will show the output like it is still showing the values, but we round this value for how many decimal places we have to see the value. That is why I has written 2 here for 2 decimal places. So we will write here. Yeah, the data looks like good. So from this question, we can say maximum audience is from United States with like 28%, followed by India like 16% and Brazil 15% and so on. So let's move to our next question, which is how to show audience country, like who is having more followers from India or a particular country. So let me write it as a comment. So how to audience. Okay, this is 3 hashtag show audience country, like who is having more followers the question is that like who which influencer is having more followers from India. So don't worry, we will like do for the more and more countries. So here I have to write data underscore ind for India. So equals to data and again data. This is our data frame name. So audience tree. Here we can write double equals to yeah. Here we can write data. So here we are giving data ind name of, you can say, a variable name, and data is our data frame name, and audience country is column name, and India is a country name from which we want to collect influencer. So let me do this. Let me debug the error. Audience country. Okay, C is capital here. Yeah, perfect. So these all influencers are who has audience from India. So like Cristiano, Virat Kohli, that Khabi, Justin Bieber, Instagram, Zayn, The Rock, and so on. So let's take another country this time. We will take United States. So we will write here data underscore USA. Okay, data again, and audience. C is capital now. Country. Perfect. Equals to. It is USA or United States. In the United States. Perfect. So United States. So data dot USA. This time I'm using score and dot head. So we have to write same code like we did for India. Here I have used the head function. You can see the head function to show only 5 first rows. You can also write only data USA, so to see the full data. So I will write like this. I can do like this. So here I can see the full data. The influencer who belongs to United States, that audience country who belongs to United States. So I will control Z for head function. Yeah. So okay, let's do for one more country, Brazil. So let's write data underscore Brazil equals to data again data at audience is capital country equals to Brazil, how it is written. Brazil. Okay, Brazil, B capital. So here we will write Brazil. B is capital, forgot. Brazil. So here we will write data underscore Brazil. So we have to write same code like we did for India and USA. So here let me use a function called tail. So here I have used the tail function to show only last 5 rows. Head will show you the first 5 rows and the tail will show you the last 5 rows. So you can also write only Brazil to see full data. So let's move forward and see our next question, which is like how to show audience for a particular category. So let me write this question as a comment for your better understanding and readability. So here we will write how to show audience for a particular category. Okay. So this time I will use fashion category. So let's write code for this one. So fashion equals to data underscore USA, data underscore USA. Right here category, okay, dot str dot contains, right here fashion comma na equals to false. Okay, fashion. That's, yeah, here I'm using the data USA set for retrieving the fashion category. We can do this for all the data using our data frame name. We can also write data only here. So I have given the column names as a category, and str contains means string which contains fashion. This is what we have to print, and na should not be false. Okay, so let's see why it is showing this data underscore USA. Okay, here F is capital. Is capital. So yeah, perfect. See, these all influencers which have audience from United States like Kendall Jenner, Zendaya, and Beyonce. So these all influencers which have audience from United States and belong to some kind of fashion industry. So moving ahead, let's take one more category. This time we will take sports category because sports is something like which most of people like. So we will write here sports equals to data. This time we will take India dataset. IND. I guess we have wrote the same. Yeah. So here we will write data underscore ID and category same str dot contains. Perfect. We will write here. We check one thing. So sports S is capital. Sport comma NA equals to false. Then sports again. Okay, this time we will use sports dot hat. So use India data and all the things are same, just replace fashion with the sports. So see, these are all the influencer Cristiano, Virat Kohli, Khabi, Rohit Sharma, Hardik Pandya, which have audience from India and belong to some kind of a sports industry. So as I'm talking before, like we can use data frame name for all data instead of using like India data or like this one. So we can also write like this data only. Okay, let me create one more for the for only data. So we can write like here sports. So data. Here we can here we are like taking our data like full data frame name. So we can write category name. So dot str dot contains contains sports, comma na equals to false. Okay, here we will write sport a. So as I'm talking before, like we can use data frame name. So instead of like writing only data India or data USA Brazil. So these influencer like from sports category belong to any one country. So this is our full influencer category. So let's move forward and do this again for the music category, like because music is also one of the favorite category of you folks. So we have to write music. Okay, music equals to, we will do is for the whole data. So data category, yeah, dot contains I guess M is capital in music. Yup, it's capital. So music N equals to, so this data will contain all the category influencer name which belongs to music category, whether they are from India, USA, Brazil, or any other country. Doesn't matter. See, you can see Indonesia, South Korean. So moving forward, let's change our some column data types to integer type. So we can write here data equals to data dot as type, round bracket, then curly braces. So here we can write followers, if followers, and then it should be changed to integer, and take it from here, authentic engagement. Overcome the spelling mistakes, so I can take from here integer, and let's do for one more engagement average. So integer. Right. So here we can write data dot head. Yeah, perfect. All the columns change to integer type now. So this is how we can change like data type in column. Here, like data is our data frame name, this one, and the as type, this one, as type is the method like which gives a back a new data frame with the requested data type for the data. To select a data type for each column, you can either cast the entire data frame so that the type, or I use Python dictionary like in the following example, like calories, pulse, or whatever, respectively. I repeat, calories, pulse, duration are all like integers value respectively. So let's move to our next question, which is like top 20 category by follower. Before making graph for this one, let me create like top variable followers. So here I can write like top 20 followers to data dot n largest and largest. Like we need 20. So we can write here. I am writing followers spelling like this because we have to like this. Followers. Follwers. So perfect. Yeah. So top 20 followers we have taken as a variable name to store followers and to obtain the first n rows arranged by the columns in descending order. Use of the n largest function, which is this one, n largest function. Specified columns are also returned. I repeat, but they are not used to determine ranking. So data frame dot n largest, you can write the syntax like this: self comma like n comma column names, or keep, you can also write keep equals to first. So top 20 followers are generated. Let me create graph. So first we will import library, like one of the main library for visualization, which is matplotlib. So for importing this we have to write import. Okay, so we can also write like, instead of writing import, we can also write from matplotlib import pyplot as plt. So for the Python programming language and its NumPy numerical mathematics, matplotlib is a graphing library with the help of general purposes like GUI toolkits like Tinker, Python, Qt, and GTK. It offers an object-oriented API for embedding plots into applications. So after this, let's create the figure. So we have to write plt dot figure, like again figure size equals to, we can take 12 and 8. Perfect. So we will create figure 2 here equals to plt dot bar top 20. We have take followers dot category comma category top 20 followers. Okay, followers dot followers comma, like label should be followers it should be, like I'm taking 0.8 here, and my favorite color is maroon, so I will take maroon color. So plt dot xsticks font size should be like 12 and rotation should be 90. Perfect. So let's create y and x labels. So plt dot y label followers followers comma font size should be, let me take 16 here, and plt dot x label category And the font size should be 16. So let's set the title for this now. For plt.ti title is top 20 categories towards comma. Font size should be, let's take it as 20, and plt dot underscore layout listen, and we can write plt dot tick label underscore format is equals to y. Style should be plain. Okay. So this is how the visualization look like. Here I have used the bar graph for this visualization, and top 20 followers dot category, and this one top 20 followers dot followers are the x and y values, and color is something like which color you want to show with, and you can choose as your preference. And x and y labels are used to print in x and y coordinate, like this followers in millions and category. So this tight layout, this tight layout in I repeat, this tight layout function, this tight layout function, this tight layout function in PyPlot module of Matplotlib library is used to automatically adjust subplot parameters to give a specified padding. So plt.tick label format is used for in which axis or in which style you want to print. Plt.tick label is not necessary to write or to showing paragraph. So like when we can remove this, so our visualization should look like this. So it is not necessary. Okay. Tool Z. So let's move to our next question. Like using bar graphs, let's see how our category look like. So first we will create, I'm writing here, showing categories using pie chart. Okay. So using pie chart, let's see how our category look like. First we will create categories. So we have to write here like types equals to data dot category dot value underscore counts, and this one, yeah, types, okay, types dot reset underscore index. Yeah, here we have used types as a variable and value counts, like we already discussed before. So these all are the categories from our data. So let's create the pie chart now. So for plotting a pie chart, we have to write plt dot pie like types dot values comma label should be types dot index, this one, Label should be type.index. This music, cinema, lifestyle, modeling, and so on. So index, comma, label distance equals to 1.2, and then auto PCT should be like percentage 1.2 F percentage. So like shadow should be true. Perfect. And let me add one more thing. Start angle. Angle should be 60. Okay. So plt dot title is like, you can say, different categories comma font size should be 20, and let's plt dot plot. So let me check everything is correct. Values, labels. Okay, here we can write labels. Type dot values, labels equals to type dot index, and label distance equals to 1.2. So here auto PCT is equals to like, okay, shadow equals to true, perfect, and starting is equals to 20, 60. So plt dot title, different categories. Okay, fine, everything's great. So it's not coming. Okay, perfect. So this is how our pie chart look like. This is looking like a mess because we have more than 100 categories. That is why like 100% is splitting into 152 categories. Like you can see here, we have 152 categories. Okay, so this is how, sorry, this is how our like pie charts look like for our different categories. Let me write D capital. Yeah, perfect.
Creating a Telegram bot using Python. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update. In this session, we will create a Simplilearn bot that will help its users to choose from various courses offered by Simplilearn. Now, let's understand the uses of bots. The first use of bot is to get customized notifications and news. A bot can act as a smart newspaper, sending relevant content to its subscribers as soon as it's published. The next use is accept payments. A bot can offer paid services or work as a virtual storefront. Another use is create custom tools. A bot may provide you with alerts, weather forecasts, translations, formatting, or other services. And another use is build social services. A bot could connect people looking for conversation partners based on common interests or proximity. With the understanding of uses of bots, now let's create our own bot. You will have to follow the steps to create a Telegram bot. And the first requirement to create a bot is you should have a Telegram account. Now let's move to Telegram. And using the Telegram, we will interact with the Telegram bot further, which is going to provide us with the bot and the token, which will act as a password for that bot. And then we will create a Python program to do all these interactions. So you need to get the Telegram app whether on the desktop or in your mobile phone. I'm going to use desktop versions. You can download the desktop app from desktop.telegram.org. I will show you how to download it. desktop.telegram.org. Here you can see that Windows bit64 version is available, and you can see all the platforms and you can choose according to your needs. I have installed the Windows 64-bit version and the Telegram app. Now we'll search for the board father. And be careful and click on the verified one with the blue tick. This is the one. Just click on it and you can click on the start to start the conversation with the board father. You can see the various commands here. And board father is again a bot which Telegram has created in order to do automation of all the bot creations. And now to create a new bot, we'll start with the command /new bot. Here you can see this is the command. You can click on that or just write here /new bot. Now the father bot has replied, alright, a new bot. How are we going to call it? Please choose a name for your bot. So here you have to choose a name for your bot. I will go with the name Upskill by Simplilearn for my bot. Now the father bot has replied good. Now let's choose a username for your bot. It must end in bot like this, for example Tetris bot or Tetris_bot. You need to make sure that the username is unique and it ends with _bot, or it should have bot at the end of the username. Bot father will inform you if your username is already taken. So I would be going with the username upskill_1122 Simplilearn_bot. And the bot father replied, done. Congratulations on your new bot. You will find it at, this is the link. Hey, if you click it, you will just get to your bot. And we have received the token for our bot. Here you can see, use this token to access the HTTP API. This is your token. And the bot father said, keep your token secure and store it safely. It can be used by anyone to control your bot. As soon as you receive the token, you have to write another command, that is /setPrivacy, and press enter. It will change the privacy settings for your bot, so no one can misuse your bot token. And now you have to choose the bot you want to change the privacy settings. So we are currently working on the upskill_1122_Simplilearn_bot. So we'll choose this, and here you can see that the security is enabled. You have to write disable or choose disable from here. Now success, the new status is disabled. So your bot is now secure and your token can't be misused by anyone else. This is how we created a bot, and now we will use this in Python program. First, we will see the external packages we need to install for this project. For that, we will move to command prompt and install the packages. The first package is pip install python-telegram-bot. As you can see, the package is already installed on my system. So you have to install the package and then open your IDE. For that, I will create a folder. And I will name it as Telegram bot. And inside I will open my IDE. For that, I will write the command cmd and open my Visual Studio Code. Now I will create a new file and name it as telegram.py. And now first thing I will do is import telegram.ext. Now we are going to load the token provided by the board father. So we'll move to Telegram and copy the token provided by the board father. So this is our token. We'll copy it and move back to our IDLE and create a new variable that would be token. A token in it. Now we'll create the updater object. This object will be used to perform actions with our board. So we're going to write the command updater equal to telegram dot ext dot updater, and we'll pass the token and use context equal to true in it. First we will copy our token and pass another variable that is use underscore context, and that would be equal to true. And now we're going to get the dispatcher. We'll create a variable with the name dispatcher, and that would hold updater dot dispatcher. Now we'll add the functions to give our board some functionalities. We'll start with the start command. It's the first command usually given to the board. For that we will write define, that would be defining the function with the name start, and inside we will pass update and context. As we have used the use underscore context as true, we will use the context for some information. And when someone starts the conversation with a bot, what should be our first message? We will set the first message as welcome to Simplilearn. For that we will write update dot message dot reply underscore text, and inside we'll store a message that would be hello, welcome to Simplilearn. Next we will define another function that is help, and for that we'll write the command df help, and we'll pass the same update and context. And inside this function we will send the message with the commands that would be start, help, content, and the Python playlist or SQL playlist or Java playlist that the user wants to persuade or which course he want to persuade. So we will start with date dot message dot reply underscore text, and inside we will define all the commands. So we will go with the triple columns. So our first one would be start, and it would symbolize welcome to the channel, and our next command would be help only, and it would indicate this particular message. The next command we will define as content, and this would be about various playlists of Simplilearn. The next we'll start with the Python playlist. And if the user write this command to a bot, he will just direct it to the first video from the Python playlist. And next command we would write about SQL, and it would also direct it to the first video from SQL playlist. And the next up command would be about Java. And it would also direct to the first video from the Java playlist. And we would also set another command that would be contact, and that would hold the contact information if someone wants to contact to Simplilearn for further information. And now we'll define all these commands. For that, we'll write the function find content, and we'll pass update and context, and inside we'll just output to the users with the command update.message.reply underscore text, and the output that would users will see is we have various playlists and articles available. And now similarly we will update the next function. We will copy this so the token would be pasted here. We will copy the function, and our next function would be Python. So if the user type Python in the chatbot, so he will just direct it to the first video from Python playlist. For that, we will copy the link of the first video from the playlist Python and paste in the message.reply underscore text. And for that we'll write tutorial link and paste the link of the video. And now we'll do the same for SQL and Java. We will copy the function and change the name to the SQL, and copy the link of the first video of SQL from the playlist. And now we will do the same for the Java. For that, we'll copy the function and paste here and name it as Java. Now we'll move to the Java playlist and copy the link of the first video from the playlist and paste it here. Now we are done with the functions Python, SQL, Java, and we're left with contact. So we will declare another function. For that also we will copy the same function and name it as contact, and inside you can contact on the registered mail ID provided on the website. So these are some functions which we can add to the dispatcher. We will create a command handler to handle the certain command and map the function to it, and then add the command handler to the dispatcher. So first we will write the command. That is dispatcher dot add underscore handler, and inside we will write telegram dot ext dot command handler, and inside we will pass the name of the command that will be inputted by the user and the function name. For that we'll write the command, that is start, and the function defined by us for the command start is also with the name start. Now we'll copy this command and do the needful for all the functions. So here we will change the command, that would be Python, and the function name and the same for SQL, and same for Java. And we're left with the last command, that is contact. And in the end we'll write command updater dot start underscore polling. So it will check if our code is working or not, and updater dot idle, it is used when the user just enters the first command. So it will not exit the program, it will wait for user to enter other commands. We forgot to write a command for help. For that we'll copy the command, and write help. We'll save the program and click on the run button. Here we can see that the program is running fine. Now we'll move to the Telegram and click on our bot username. You can also search our bot username here. It's globally searchable. Now we'll click on the start. On the start command we have got the output, hello, welcome to Simplilearn. Now we'll input /help, and here we have output all the commands, that is /start, /help, and this particular message will appear when we click on the /help, or just write it here. When we click on /Python, we will get the first video from the Python playlist, and when we click on the /SQL, we will get the first video from the SQL playlist. And similar with the Java, we'll get the first video from the Java playlist, and when we click on the command /contact, we get the output, you can contact on the registered mail ID provided on the website. So we have done with our Telegram bot. We have created the Telegram bot successfully.
So guys, let's get started. So here's our first interview question, that is, given two arrays, write a Python function to return the intersection of the two. For example, if we have x equals to 1590 and y equals to 3029, then it should return 9 and 0. So how you will approach this problem by coding in Python? You can take your time and then you can come to the solution. So guys, in order to solve this question, we will have to create a Python function that will find the intersection of two arrays. And this function is going to use the set data structure to efficiently determine the common elements between the two lists. So guys, first what we are going to do, let us create a function first. So we are going to say the name def intersect, and you can just call it as arrays. Okay, and then let us give the two argument AR1 and ARR2. Pretty fine till here. Now after that, convert both of the list and sets to remove the duplicates and allow for intersection. So what we are going to do, we are going to create set1, okay, and this is going to be set of array1, okay. Then next what we are going to do, we are going to create a set of 2, okay, and this is going to be assigned to set of array2. Pretty fine. Now what we have to do guys, we have to find the intersection of both of the sets. So guys, we can give a variable name sets intersection. So sets, okay, and this is going to equal to set1, okay, dot intersection of set2. Very easy guys. And then we have to convert the intersection set back to a list before returning this list. So what we can do, finally, we can just return. So return list, and here we can give the intersection of the same. So now we have done that. Let us take an example of the same. So for example, we can take, say, x equals to 1509 and y equals to, say, 3029. And finally, we are going to call this as result. So res equals to, and finally, we can just call our function. So our function was intersect arrays. So we can just copy this and we can give the array's name, that it will be x, comma, y. Fine. And then we can finally ask to print the result. So in this way, we are going to find the intersection. Let us run our notebook. So we can see there are some errors coming up. So, okay. So we can see that the answer is coming 0 and 9. Pretty fine right now. So we have completed our first question. Now let us move to the next question. So guys, our next question is, given an array, find all the duplicates in this array. For example, we have 1, 2, 3, 1, 3, 6, 5, and we should return only 1 and 3. So we can see 1 and 3 are the only one which has been duplicated. So how you are going to approach this problem? You can pause this video for a while and then you can come to this video and then you can watch the solution. So guys, to find all the duplicates in an array in Python, you can use a dictionary or the collections.counter to count the occurrences of each element and then gather those with the counts greater than 1. So for example, I'm going to show you a dictionary. So what you can do, we can define a function first. Say, let's find a duplicate. So def find, say, duplicate, and in this we are going to take an argument array. Define. Now after that, let us declare a dictionary with name as counts. Okay, and let us create a list of duplicates. After that, what we are going to do, we are going to count each element in the array. So let us go to the for loop. So for num in array, okay, then if num in counts, okay, then what I'm going to do, I'm going to put this, that count num, or else what we can do, we can count on that num equals to 1. So finally what we are going to do in this code, that we are counting the occurrences of each element. So we are using the for loop and we are maintaining it with the count. Okay. Now, as you would have got the idea regarding this, so let me write this variable. Now I hope so till here you are clear with it. In the next, we are going to collect elements that appear more than once. So guys, for key and value in counts.item, if the value is greater than 1, what we can do? We can append that key. Okay, I'll show you right here what I mean. So here we can apply the for loop. So for key, comma value in counts, in okay, so for key value in counts.items, so if the value is greater than 1, okay, what we are going to do, we are going to append this list. So duplicates dot append with the required key. Okay, now what we are going to do finally, and finally we are going to return our duplicates. So finally this function is going to return duplicates. Now let us have the example usage. For example, we have this input array, say 1, 2, 3, 1, 3, 6, 5, and the result is equals to find slash duplicates, and we are going to put the input array. So now let us cross check the functions we have. So it is find duplicate. This is, we're going to exclude this. Now let us run this code. So it says there is an error. Okay. Now let us see what's the error in this. So it says for key and value in counts.item. Okay, so it says unindent does not match the outer end. So there is an indentation problem. Okay. So guys, as you can see all over here, we have given our duplicates 1, 2, 3, 1, 3, 6, 5. And we are finding the duplicates in this input array. And our result is 1 and 3. Very easy. So go through this question. This question has a high probability of being asked in the interview question. So don't miss it out. Now let us move to our third question. So guys, our next question is that you have to rotate a list to the right by k places where k is a non-negative number. For example, we have an input of 1, 2, 3, 4, 5 and k equals to 2. So your rotated array is going to look like something 4, 5, 1, 2, 3. Okay. So basically when k equals to 2, so 0, 1 and 2. So after this, all the numbers are going to come first, and then in the same process, like 1, 2, and 3 are going to go back. So it's a rotation problem, and let us see how we can approach this problem. So guys, in order to solve this problem of rotating a list right by k places where k is a non-negative, you can use a straightforward approach. Then this involves slicing the list and rearranging the parts. But here's the another way you can try it, that is by normalizing. So guys, since the rotating the list by its length, suppose it has a length of n, it results the same list. So you can normalize by k by taking k mod n or k percentage n, where n is the length of the entire list. So what is going to do, this is going to handle the cases where k is greater than n. Okay, so let us try to see the problem. So we have created a function called defRotate list, and I have taken two parameters, nums and k. Now here I am defining n as the length of the given list. So if n is equals to 0, I want it to return the nums, okay, the given parameter which we have given, okay, the length of the given list. So now after this we have to normalize. So in order to avoid like where k becomes greater than n. So k equals to k modulo n. So this is our normalization. And after this we are performing the rotation. So by rotation, by slicing, so rotated list equals to nums of minus k dot plus nums of k. So this means that till k you have to partition it, okay, and after post of k you have to do the partition. And after that we are returning the rotated list. So you can see in the input list we have 1, 2, 3, 4, 5, and here k equals to 2. So what it's going to return? So the given list, okay, so k dot means since 2 and post 2 and pre 2. So you have to take that into consideration. So guys, after post we are adding the pre. So for example, k equals to 2, so 0, 1 and 2. So these comes, so 4 and 5 is going to be put all over here. Then after that, pre of 2 are going to be placed. And finally we are concatenating it. So 4, 5, 1, 2, 3 is going to be our output. So let us run this program, and we can see we are getting the output 4, 5, 1, 2 and 3. A very easy problem. Okay. Now let us move on to the next problem. So guys, the next question is, given an integer array, find the sum of largest contiguous subarray within the array. For example, given the array A equals to 0, minus 1, minus 5, minus 2, 3 and 14. So it should return 17 because of 3 and 14. So there is a note also that if all the elements are negative, then it should return a 0. So it has given the case study. For example, you have to consider an integer array and you have to find the sum of largest contiguous subarray. So this is a subarray problem. Let us try to approach this. So for example, we have the input list 0, minus 1, minus 5, minus 2, 3 and 14. So we have to take a case on this and it should return 70. So guys, to solve this problem, you can use the Cadence algorithm, which efficiently finds the maximum subarray within the time complexity of O of n. And this algorithm maintains the running sum of maximum subarray found so far and updates it as it traverses the array. Additionally, to handle the case where all the elements are negative, so such that you want to return 0 in such a case, you can initialize the maximum sum as 0. So here's the Python implementation of the same. So guys, here's the solution to this problem. Let us define the function def max subarray, and which is going to take nums as the parameter. Now we are going to initialize variables to track the current sum and the best sum found. So current sum equals to 0 and maximum sum is also equals to 0. Then we have to traverse through the array and update the current sum and max sum accordingly. So for example, for num in nums, okay, then we have to update the current sum and reset it to 0 if it becomes negative. So if current sum is less than 0, then you have to put the current sum equals to 0 and then update it with maximum sum equals to max of, you can take a max function, then take max sum and the current sum. And finally, we are returning the max sum. So this is very easy. So basically what we are doing, so we are taking two variables, current sum and max sum. And we are traversing through this nums array and we are finding that if our current sum is equals to 0, okay, then we are updating our current sum such that current sum equals plus now. Okay, so we are adding the current sum with the given number, like the iterator number basically we are using. For example, if it is 1, so current sum will be equal to 0, so 0 plus 1 will be there. And then if it goes negative, so if current sum is less than 0, then we are putting it to 0. Very easy. Suppose if you have negative numbers in your array. So that covers this situation. Now I hope so you have got the idea regarding the same. And finally, we are taking the maximum of max sum and the current sum. Okay. So in this way, we are going to print the maximum part of it, which is 70. Now let us take this and let us try to run our application. So you can see we have printed 70. So this clearly covers the idea regarding this question. Now let us move to our next question. So guys, our next question is define tuples and list in Python and what are the major differences between them. So guys, this is one of the very basic question. So in Python, list and tuples both are sequence data types that can store collection of items. They are used to store multiple items in a single variable and have several similarities. But there are significant differences that affect how and when you should use each. For example, if you take a list. So a list in Python is a mutable or changeable ordered sequence of elements. Each element inside a list can be accessed, added, edited, or removed. And lists are defined by having values between a square bracket. For example, if we define a list, say list L, so which is equals to say 1, 2, 3, and also we can put hello. Pretty fine. And also we can add a boolean value, so let's add true. Now let us talk about the tuples. So a tuple in Python is an immutable or unchangeable ordered sequence of elements. This is very important, and once a tuple is created, you cannot change, add, or remove its elements. Tuples are defined by having values between parentheses, and this way we cover the definition of tuples. So for example, if we define a tuple, so it is going to look something like this. So t equals to, say, we take the parentheses and suppose we add 1, 2, and 3. So this forms our tuple. Now, if we talk about the major differences, we know that in lists are mutable, okay, and tuples are immutable. So that's a basic difference. Next, you can talk about their syntax. So like, if we talk about list, they use square brackets, whereas tuples uses parentheses. If we talk about performance, guys, then tuples are faster than list because of their immutable nature of tuples. Now, list being mutable, they are slightly slower as compared to tuple. Okay, and they also require additional operations for memory. So in this way, you can differentiate between tuples and list. Now let us move on to our next question. So guys, our next problem is on anagram. So it says, given an array of strings, group anagrams together. Okay, suppose we have strings like eat, tea, tan, ate, nat, bat. So our output should look like something like this. It should be ate, eat, tea, nat, tan, and bat. Okay. Now, to solve the problem of grouping anagrams together, forming a given array of strings, you can utilize a dictionary to help organize words by their signature. So guys, what's a signature? A signature can be formed by sorting the characters in each string, which ensures that all anagrams will have the same signatures. So for example, what we are going to do, we are going to create a dictionary. So you can use a dictionary to map each sorted version of a string such that the strings to a list of strings can be added, and when it is sorted, you can match that signature. Then you can use the sort each string. For each string in the list, you can sort the strings to generate its signature and add the original string to the corresponding list. And then finally, you can collect the results. So basically, here's a Python implementation of the same. So guys, as you can see all over here, we have defined the function named group anagrams, and we have taken arguments words. So here's our dictionary, anagram dict. Then we are taking the for loop, and finally we are sorting it, okay, with the empty string using the join function, okay, and we are using the sorted function. Then if sorted word not in anagram dictionary, then what we are doing basically, we are putting it into this anagram dictionary with the category of the sorted word which we have created. So this is the required variable. Okay. Now this will be equals to and word dictionary. Now finally, if this does not happen, then else you can put anagram dictionary in the sorted words and you can append that in the word. So these are the certain things where word is our iterator. Okay. So this is equals to a number which we are basically storing. So now finally we are extracting the list. So we are presenting these groups into a list. Okay. So finally the dictionary is converted into the list. So list anagram dict values, and finally we are returning our result. So here is our input words, and finally we are calling our function with this word as the parameter. So let us run this and let us see whether our output is coming or not. And we can see we are getting the output of the anagram words. So eat, tea, ate, tan, nat, and bat. So we had this as the anagrams are certain things, like suppose eat is there, so t is ending with t, so it is next word is starting with t. You can see the next word is ending with a, and here the next word is starting. So similarly tan and nat are grouped and bat are grouped. So what we have to do all over here, the entire logic remains the same, and it is here. So you have to create a variable all over here, sorted word, and let's say be empty, and you have to join it with the word. Word means in the given dictionary, whatever the word, like suppose eat, tea, tan. So initially we are putting it in empty words. Now, if this word, okay, if this sorted word is not in anagram dictionary, means it is not present in our dictionary. So we can just do what? We can put this in our dictionary. So we can take this parameter as sorted word, okay, and put that word in this. So similarly, like we are grouping in this case like eat and tea. Okay. Now else, if it is not present in our dictionary, so anagram sorted dictionary is appending that word. Okay. So here the assignment is happening and here we are appending it. So finally what results are eat, tea, ate, tan, nate, and bat. Very tricky question, has a higher probability to be asked in the exam. Now let us move on to our next question. So guys, our next question is, given an integer n and integer k, output a list of all combinations of k numbers chosen from 1 to n. For example, if n equals to 3 and k equals to 2, you have to return 1, 2, 1, 3 and 2, 3. So how is this going to happen? So guys, this is going to happen by generating all the possible combinations of k numbers from set of numbers ranging from 1 to n. You can use this. So there is a Python's iter_tools.combination function, and this function is designed to generate the combination without repetition based on the specified length. So how you can do this? So for example, you can import iter tool, okay, from combinations, and then you can generate the given combinations. So let me show you. So guys, as you can see all over here, I am importing iter tools from combinations. Then I am creating a function dev generate combinations. Nk is a given parameter, okay, where I'm creating a range from 1 to n. So range function I'm using, and I'm putting this from 1 to n plus 1. And I'm storing this into the variable or assigning it into a variable called numbers. Then I'm using iter_tools.combinations to generate all the combination of the length k. And finally, we are converting it into a list and storing it in the result. So in this function, basically what we are doing, so we can see there is a range 1 plus n plus 1. So this is basically generating the numbers from 1 up to n. And the combinations of number comma k, you can see. So in this line, so what this is basically doing, this is producing the combination of numbers in numbers, okay, taken k at a time. So each combination is returned as a tuple and all the combinations are stored in a list. So this output of tuples in the list represents the combination of numbers chosen. So if you need them in specific format like list of list instead of list of tuples, you can convert them accordingly. Now let us run our code, and we can see we are getting it in the format as 1, 2, 1, 3 and 2, 3. So this is generating the same, and So we are getting an output of list of all the combination of k numbers chosen from 1 to n. So in this scenario, I have put n equals to 3 and k equals to 2. Very amazing question, has a higher probability to be asked in the exam. Now let us discuss the next question. So guys, our next question is pretty interesting, and it says write a function to generate n samples from a normal distribution and plot them on the histogram. So guys, in order to solve this question, you need to know about normal distribution. So to generate the samples from a normal distribution, you can plot them on the histogram. So you can use Python's library called as NumPy for the generation of samples and matplotlib for plotting the histogram. So here's the implementation. So guys, as you can see all over here, we are importing NumPy as NP and we are importing the matplotlib. Okay. Then finally we are defining a function plot normal distribution samples, and here we have to take the 3 parameters. The first one is n, second one is mean, and the third one is standard deviation. We have initialized mean equals to 0 and standard deviation equals to 1. Then we are generating n samples from a normal distribution with specified mean, standard deviation, and with that we are going to plot the histogram. So it's more of a mathematical problem, but if you have a little bit idea regarding normal distribution, you can achieve this. So we can see there is a parameter n where the n denotes the number of samples, okay, and mean is there for the normal distribution, and similarly we have included standard deviation for the normal distribution. Finally, here we are generating the samples. So samples equals to, we are using the NumPy library, so np.random.normal, okay, and I have given LOC location equals to mean, scale is standard deviation, and of the size n. So it is very standard, and after that we are plotting the histogram with plt.hist. So I have taken samples, then bins equals to 30, edge color we have given black, and alpha equals to 0.7. And finally we are putting the title as histogram distribution sample. On the x level there is a value and y is frequency, and we have put the grid as true, and finally we are asking it to show it. Now let us run this. So we can see it has generated the histogram of normal distribution samples. Very interesting question. I hope so you are clear with it. Now let us move on to the next question. Now guys, let us take a question from Pandas, a very popular library. So the question says that what is the difference between apply and apply map functions in Pandas? So guys, in Pandas, the functions apply and apply map serve different purposes. Although they both apply a function along the x-axis of the data frame or in Pandas series, but here you can use them. So for example, in apply is used to apply a function along the axis of the data frame. So it can be either a row or a column. It can be used to operate on the entire row or a column at once, and this function is extremely flexible and can return a single value or a series or even a data frame. Then if we talk about flexibility guys, it works on a complete row or column and can be used to implement aggregation, transformation, and other operations that consider multiple elements at once. So for example, let me show you. So say we have this, import pandas as pd, okay. Then we can define our data frame. So df equals to pd dot data frame, and finally here we can give as a all over here, and we can give the value as list as 1, 2, and 3. Similarly, we can change the given thing as b, and we can change this value as 4, 5, and 6. And finally, we have closing this. So by applying a function to each column, say default axis equals to 0, so we can store the result something like this. So let us create the variable called result, and this is equals to say df dot apply, okay, and we can use our lambda expression. So lambda x, and here we can take x dot max, okay, minus x dot min. Pretty fine. So we are applying a function to each column all over here. And if we talk about like apply map, so apply map is used to apply a function to each elements of the data frame. So this method is available only for data frames, not for series object. That is the most important thing. And if we talk about element wise operation, so apply map operates element wise, and it is very suitable for operations that depend on the value of the single cell, and they do not need to consider other elements in the row or column. So guys, that was a basic difference between apply and apply map functions. Now let us move on to the next question. So guys, our next question is on strings, and it says, given a string, return the first occurrence character in it. So on none if there is no recurring character. For example, if the input is Python interview questions and the output is n. So as you can see, n is a recurring alphabet. So we have to find the recurring character in this given string. So guys, to find the first recurring character in a string, you can use a Python function that tracks the character you have seen as you iterate through the string. You can utilize a set to efficiently check if a character has appeared before. So for that, here's a simple implementation. So guys, as you can see all over here, we have defined the function first recurring character, and we are taking input string as a given argument. Now, here is a variable called scene, and it is stored as a set. Now let us iterate through each character in the string. So for char in input string, if char is present in this set, so what I want to do, I want to return the first recurring character. Then finally we are adding this character into the set if it is not already seen. And if it is not present, we are returning the none. Very basic for loop and conditionals we have applied. Okay. Now in this we are presenting the input string. Okay. And let us see what our output would be when we are calling the given function. So you can see we are getting output of n. So this is very basic guys, and I hope so you have got a brief idea regarding this. Now let us move on to our next question. So guys, as you can see, our next question is, given a positive integer x, return an integer that is a factorial of x. If a negative integer is provided, it should return -1 and implement the solution using recursive function. So guys, we have got a problem on recursion, and it is mostly asked in TCS or Accenture's interview question. So whenever you are having a technical round, so you are going to have a higher probability to be asked. Now let us see the solution of this question. So guys, to calculate the factorial of a given positive integer x using recursion and to return -1 for negative integers, you can implement a simple recursive function. So here's how you can do it. So you can see all over here, we have defined a function def factorial x. Okay. So if we are hitting our base case, means x equals to 0, what we are returning it as 1. And if the input is negative, we are returning -1 as indicated. And finally, we can see a recursive case. So if it is not hitting both of the cases, then we are basically returning x into x factorial x minus 1. So basically what it is doing, guys, so say if we put x equals to 0, so we know that we are getting its factorial as 1. Now we are getting factorial of 1. Now if x is greater than 0, say suppose we are taking 1, so 1 into factorial of 0. So factorial of 0 is 1, so 1 into 0 will be 1. Similarly, next if x equals to 2, so 2 into factorial of 1, so it becomes 2. So you can see we are going to get a series of multiplication. So in that way we can find this solution using recursion. So let us try to print the output. So we can see we are getting output as 120, -1 and 1. So we have finally completed this problem using recursion. Definitely try this problem, guys. One of the most frequent asked questions in the interview. Now let us move on to our next question. So guys, our next question is, given an m by n matrix with positive integers, determine the length of longest path of increasing within the matrix. For example, let us see. So guys, in order to find the longest increasing path in an m times n matrix of positive integers, you can use a technique called depth first search approach and combined with memoization. This problem is going to involve exploring all the possible paths from each cell and caching the result to avoid redundant computation. Now, So in this approach, we are using DFS with memoization. For each cell in the matrix, use DFS to explore possible increasing path starting from the cell. Then cache the length of the longest path starting from the each cell to avoid the recomputation. Then also go on the edge conditions, like you will only move to the adjacent cells that contain a higher value to ensure that the path is increasing. Finally, you have to implement these steps, so you can create a DFS function that explores all the 4 possible directions, like up, down, left and right. And it is returning the length of the longest path. And finally, use memoization table, a to-do list basically, to store the length of the longest path starting from each cell. Iterate over each cell in the matrix and you can initiate a DFS if the cell hasn't been explored. So here is the implementation of the same. So guys, as you can see all over here, we have created a function called def longest increasing path, and we have taken an argument called matrix. So if not matrix or matrix is present, okay, then we are returning it 0. And finally, we are defining our DFS function with I and j as the 2 given variable. So if it is already computed, then return the cached value. So if memo of I and j is not equal to 0, we are returning the given memo. Then we are exploring all the possible 4 directions like 0, 1, 1, 0, 0 minus and minus 1, 0. So it is denoting the up, left, right and bottom. And say we have initialized our maximum length as 1, okay. So in order to find the di and dj, means the distance, what we are taking the 2 variables as ni and nj, okay, and we are incrementing it with I and j. And then finally, we are using if ni is greater than 0, it is less than m, and nj is greater than or equal to 0 and less than n. So finally, at the matrix is also we are seeing, in this matrix, we are seeing that ni and nj should be greater than the matrix of I and j. Then finally, we are printing the maximum length. So using the max function, we are finding the maximum length and we are returning this DFS. And finally, we are storing the memo of I and j equals to maximum length. So which is basically our cached length. And finally, we are returning the maximum length. So you can see later on what we are doing, we have taken m and n and we are multiplying the length of the matrix into length of the matrix 0. So later on, we have created the variable called memo all over here. And in this, we are multiplying it with n, okay, for element at 0th index and in the range of m. And we have initialized our result equals to 0. Then we can start DFS from each cell for I in range of m, for j in the range of n. We can result equals to maximum result of DFS I and j. So here we can see the matrix of 9, 9, 4, 6, 6, 8, 2, 1, 1. So let us see what is our longest increasing path. So this was the basic idea regarding the code. The code can seem a little bit more exhaustive, but if you try to do it with the concept, it will be solvable. Now we can see the longest path it's showing is 4. So this is the output of our given problem. So let us go again with this problem. So here basically in this, what we are doing is we are traveling from 1 to 2, 2 to 6 and 9. So that has become the 4. Okay. So this is our longest increasing path. So 1 to 2, okay, then 2 to 6, then 6 to 9. So this is our maximum path we can follow. So 4 is the given output. Now let me go through this problem once again. For example, here we have taken a DFS function. Okay. So this DFS function is called recursively to explore each direction. It checks whether a move is valid, stays within the bound, or moves a higher value. Then you can see we have taken the use of memoization. So memo of I and j stores the length of the longest increasing path from cell I and j. So guys, this reduces the time complexity by avoiding the recalculating paths of the same cell. Then we are doing the result calculation. So we are iterating through each cell, starting a DFS if the longest path from that cell has not been computed. Then we are printing the maximum value obtained from all the DFL calls, and that is our result. So this approach is basically efficient for matrices where many values are not recomputed due to caching, thus making it a feasible for larger matrices. So that's the solution of this problem. Now let us move to our next problem. So guys, our next question is explain Flask, what Flask is and its benefits. So guys, as we all know, that Flask is a popular microweb framework written in Python. It is called micro framework because it does not require particular tools or libraries. It has no database abstraction layer, form validation on any other components where pre-existing third libraries provide common function. However, Flask supports extensions that can add application features. Like here we can say, suppose if you want to add simplicity, flexibility, okay, lightweight features, then you can use it. Flask is also extensible, that it can be extended with extensions available to additional functionality like object relational mappers, form validation, upload handling, and various open authentication technologies and several common frameworks related to it. Then you can also say it has a built-in developer server and debugger. So Flask also includes a built-in server and debugger, which makes it easy to develop and test your applications locally. So this is Flask and these are some of its benefits. Now let us move on to the next question. So guys, our next question is, what is the difference between list, arrays and sets in Python? And when you should use each of them? Very basic question, guys. So guys, in Python, list, arrays and sets are all container data types that store collection of items. Each type serves a different purposes and used in specific scenarios depending on the needs of the program. So for example, lists are one of the most versatile data structures in Python. They are ordered, mutable, and can hold a heterogeneous assortment of objects. Then if I talk about characteristics, lists are ordered, meaning that the items have been defined in order and that order will not change until and unless you change it. So guys, as you can see all over here, that lists are mutable, meaning you can change their content without changing their identity. You can also have a duplicate element in a list. So it is always advisable to use list when you need an ordered collections that can change and might include the duplicate entries. Suitable for the cases where you need to perform frequent read and write operations. Now if I talk about arrays in context of Python arrays module or the NumPy arrays are specifically optimized for numerical data and offer more storage efficiency and operations which are tailored to numerical processing. Like you can use NumPy's arrays in a situation when an extensive set of operations are for mathematical and logical based. Arrays are also mutable and ordered. So you can use arrays when you need to store large amount of numerical data for scientific computing or other operations that require efficient and compact storage with vectorized operations, like for data analysis, machine learning, or any task that requires efficient array computation. The next one is sets. So guys, sets are unordered collection of unique elements. They are like mutable and provide operations to perform common sets of operations like unions, intersections, differences, and symmetric differences. Sets are like unordered, so they do not record element in position or order of insertion. You can use sets whenever you need to ensure that an element appears only once in a collection. So ideal for membership testing, removing duplicates from sequence, performing mathematical set operations like union, intersection, symmetric, etc. So this was all about this question. Now let us move on to our next question. So guys, let us move to our final question. That is, what are some of the common ways to handle missing data in Python and which method do you prefer and why? So guys, as we all know that handling missing data is a crucial aspect of data preprocessing, especially in real-world scenarios where data incompleteness can skew or invalidate analysis. Python, particularly with libraries like Pandas and NumPy, provides robust methods for dealing with missing data. So here are some of the common strategies. The first one that is removing data. Okay, so like dropping rows or columns with missing values using dropna function. Okay, so you can use when this data set is too large or when the missing data is not significant and it is not likely to introduce bias. So in that scenarios, you can use it. There are certain drawbacks to it, like you can use valuable data also that could be critical for analysis. The second technique that comes up to my mind is imputation. So guys, when you're filling missing values with either a test statistic like mean, median, mode, okay, for numerical data or a frequent category for categorical data. This can be done using fillna or a simple imputer from sklearn.impute. So you can use it when the integrity is crucial and you cannot afford to lose data points. A drawback of this is that potentially it is introducing bias or affecting the distribution of the data. So using algorithms is a third part. Repeat. So the third one is predicting the missing values. Using algorithms to predict missing values based on other data in a data sets. Techniques can range from simple linear regression to more complex approaches like k-nearest neighbors or random forest. So when the missing values are substantial and there's a reasonable hypothesis that other variables can predict the missing values, so you can use this. So it is computationally intensive and can overfit if not properly tuned. Next one is using a constant to fill the missing data. So guys, filling missing data with a constant is not present in the data, like -999 for instance, like to differentiate the real data from the filled ones. So often used in modeling competitions or specific algorithms that can handle peculiar values and interpret them appropriately. The drawback of this is that it can skew the analysis if not handled correctly. So guys, these were some of the common ways to handle the missing data in the Python. Now, for me, I would like to prefer the imputation because imputation combined with indicator variables, especially for data sets where missing values are informative. So guys, in this way, it can yield a better result.
And with that, we have reached the end of this session on Python Developer full course. Should you need any assistance or any other resources used in these sessions like PPTs, datasets, Git links, Jupyter notebooks and others, then please let us know in the comment section below and our team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning.